Hey everybody, my name is Philip Walton, and today I want to start off by showing you a screen recording that I made of two different demos. Both of these demos look and function identically. Both have drop-down menus that smoothly animate in and out. They're both fully keyboard accessible. They both support light dismiss, and they both work in Chrome, Firefox, and Safari. These demos were both also generated using AI. In fact, they were generated using the same coding agent, the same model, and the same prompt. The difference, though, is the version on the left was generated using an agent in its standard default out-of-the-box configuration, and the version on the right was generated using the same agent, but with one extra thing installed. And I'll get to that later. But there is one more big difference between these two demos. If I open up DevTools and I zoom in here on the network panel, you can see that the version on the left loads 172 kilobytes, most of which is JavaScript, whereas the one on the right loads less than 3K and uses absolutely no JavaScript. And to be clear, that's 172 kilobytes over the wire, minified and gzipped, with all of the production optimizations turned on. And I didn't modify this code at all. This is what the AI suggested. Now, admittedly, this is a bit of a contrived example because no app is just a settings menu and nothing else. Once you add more features, you might need to add some more JavaScript. Still, I do think this raises an interesting question. Why are AI coding agents recommending a solution that requires almost 172 kilobytes of JavaScript when the same exact solution can be built in a way that requires no JavaScript at all and still works across browsers? So if you were at any of the talks earlier today, you heard a lot about this, a lot about how amazing AI is. And don't get me wrong, AI is amazing. Like, it truly blows my mind every single day. But that is just one side of the story. The truth is that while AI has transformed the software industry and it has enabled us developers to write code way faster than ever before, there is another side of the story. AI is definitely not perfect. And if you, like me, follow a lot of well-known front-end developers on social media, then you'll know that many of these folks are definitely not shy about pointing out just how not perfect these AI coding agents are, especially when it comes to writing HTML and CSS. And you know, these folks, they're not wrong. There have been so many amazing developments on the web over the past few years, and yet, if you ask a coding agent to go build something for you on the web, it's most likely not going to reach for the latest web platform features to do it, even if those features really are the best tool for the job. And this isn't all that surprising if you consider that most of the training data used by these models was written during a time when most developers had to support legacy browsers like Internet Explorer. But regardless of the reason, the reality is that for front-end web development, coding agents do tend to recommend legacy solutions, even when there are better, more modern alternatives. Another big problem we see with AI models is that they have a knowledge gap. Every model has a knowledge cutoff date, where any new developments on the web that occurred after that date are just not included in the model's training. In the past year alone, Chrome has shipped more than 50 brand new web features, but due to these knowledge cutoffs, many of these features are just completely unknown to these models. And while techniques like RAG and web search can help with this problem, they don't eliminate it entirely. If you ask a coding agent to use a feature that it's never heard of, it'll usually do a web search. But if you ask it to do something that it thinks it already knows how to do, then it'll often just reply confidently right away without checking for more up-to-date information. For example, here's some code that an agent generated after I asked it to build a tooltip using the new interest invokers API. If you look closely at the highlighted line of code, you can see that the model used the interest target attribute, which is not correct. Interest target was the attribute name when this API was first proposed back in 2023, but right before the API shipped in Chrome last fall, the name was changed to interest 4. And so that means that the code you see on the screen will silently fail when run in a browser, which will make it pretty hard to debug. Now, this specific problem is probably going to be fixed for this API in the next generation of the models, but the larger problem is not going away anytime soon. A third problem we see is how AI models make cross-browser support decisions. In our testing, AI is way more conservative than it needs to be when it comes to cross-browser support. It's understandable that these models or these tool makers would want to optimize for broad compatibility, but now that we have initiatives like Baseline, which includes compatibility data for nearly every web feature, there's really no excuse for not using it. Agents should not be making generic, one-size-fits-all browser support recommendations. They should be tailoring their recommendations to the specific needs of your project. So that's a quick overview of the main problems we see with AI coding agents when it comes to modern web development. To recap, AI coding agents frequently recommend legacy patterns even though better, more modern alternatives exist. Second, AI models have blind spots and either aren't aware of or have incorrect information about the latest web platform features. And third, AI models tend to make outdated, one-size-fits-all browser support recommendations. But the good news is that here in Chrome, we believe that these problems are all very solvable. And we've been hard at work on a solution that we're excited to share with you all today. An early preview, we call it Modern Web Guidance. Modern Web Guidance is a comprehensive and expert-vetted set of skills covering all of Chrome's best practices on building for the modern web. This package embeds decades of Chrome's web platform expertise directly into your coding agents. And because it's based on skills, it works with any AI coding platform. You can install Modern Web Guidance with this single command: npx Modern Web Guidance install. Or if you're using any of the IEs or coding agents shown here on the screen, you can find and install Modern Web Guidance directly from within these tools. So I know, right now, the market is absolutely flooded with new skills releases, and as a developer, it can be challenging to keep up, overwhelming even. It's also especially hard to determine which skills are good and worth using, and which skills are, let's face it, basically just slop. So I want to stress here that Modern Web Guidance is not your ordinary skills pack. This is something that we on the Chrome team have been investing in a ton over the past 6 months, and it's something that we're committed to investing in for the long term. So let's dive in and take a closer look at what's included and how it works. So Modern Web Guidance is comprised of 2 distinct levels of guidance. First, we have a set of high-level guides codifying the best practices for broad web disciplines like performance, accessibility, security, user experience, and many more. In addition to these high-level guides, we also have a set of very specific low-level guides covering web features that have been recently added to the platform. And we've seen that AI models just don't yet have a good understanding of how to use them properly. All of these guides have been created by members of the Chrome team in collaboration with a number of external subject matter experts that we've hired to contribute to this project. And because these guides focus on core web platform features, they will work regardless of whatever framework or stack you're using or anything like that. Now, before I dig deeper into the specifics of these guides, I want to give you all a quick overview of how the tool works at a high level. So when you're using a coding agent out of the box, the flow is pretty simple. The user types a prompt into the tool, the prompt is given to the AI model, which then produces an output response. If you're using Modern Web Guidance, then before the AI produces an output, it'll perform a semantic search locally within the Modern Web Guidance package to see if any of our guides match the use case in the prompt. If there are no matches, then those guides will get added to the context window. And if there are matches, those guides will get added to the context window. If there are no matches, the AI will respond as normal. Now note that this is a bit different from how most skills work, where each skill is a distinct skill.md file. With Modern Web Guidance, we expose a single entry point scale that has access to a CLI that does the search. And we do this because we currently have more than 100 distinct guides, and we plan to add likely hundreds more. So it just doesn't scale to expose these all as single top-level skill.md files. So let's take a closer look at what these guides look like. Now, I mentioned before that we have both high-level discipline skills and low-level feature guides. The high-level guides are very similar to the skills that you've probably seen before, but for the low-level feature guides, we took a different approach that I think is pretty novel, and so I want to talk about it. First, rather than focusing on the features themselves and documenting how those features work, instead, each of these guides focuses on a distinct use case that one of these features unlocks or makes easier to implement. For example, one of the use cases that we identified for the View Transitions API that's been unlocked was visually connect persisting elements across different page states or navigations by smoothly morphing their size, position, or other styling properties. For example, expanding a thumbnail image in a product list view into a full bleed hero image in a product details view. Now you'll notice that that use case doesn't mention the View Transition API at all. Instead, it describes a task that the developer might want to implement or to accomplish, where the View Transition API happens to be the best choice to implement it with. And this is really important because developers don't generally prompt their coding agents to use specific features. They might not even know that those features exist. Instead, they prompt their tools to implement use cases, and so we need our guides to match the prompts that developers are actually using. So the second aspect of each of these guides is that they're optimized for AI consumption. And by that, I mean that each guide is concise, it gets straight to the point, and it contains only the minimum amount of information needed for the AI to properly follow it. This is more token efficient than doing web search because even if the agent finds up-to-date and accurate information on the web, which is not guaranteed, it still has to read through all of that content, use all of those tokens, just to find the bits that are relevant to your use case. Or perhaps not, it might not find it. Our guides are already scoped to the use case, they're already vetted and tested for accuracy, and they're already locally on your device. So third, every guide, we include a section that documents our specific recommendations and fallback strategies to ensure that the implementation of the use case works across browsers. Now, I want to dig into that last part because this cross-browser fallback guidance is, in my opinion, the absolute best feature of this tool. So let me explain how it works. For each guide, we start by documenting the ideal implementation using the most modern solution available. For this part of the guide, we do not take browser support into consideration at all. We assume that any feature can be used, and we pick the best feature for the task at hand. And we do this because we want to support people who are experimenting with new features, people who are building extensions, Electron apps, building internal company tools, or really any situation where cross-browser support is not a major concern. We don't want AI tools to prevent people from using new APIs if their situation allows for it. However, if any of the features in the ideal implementation are not baseline widely available, then we always include a fallback recommendation, and whenever possible, we make sure that fallback recommendation works across browsers. The only exception to this is things like WebMCP, where there really is no cross-browser fallback. But in all of the cases, if there is a cross-browser fallback, we use it. And if there's not, we make it crystal clear that a feature is only available in some browsers, and we show how to properly feature detect for it. And the reason we take this two-layered approach, starting with the fully modern and then going with the fallbacks, is so that the agent can kind of pick and choose how to implement the use case based on your site's browser support requirements. And that brings me to the final feature I want to talk about in this package, our baseline integration. I said that we want coding agents to be able to customize the implementation based on your browser support requirements. And for this to work, two things need to happen. First, you need to tell your agent what baseline target or browsers you support. Agents can sometimes guess or infer this information from various config files in your project, but we think it's better to be explicit, and we recommend putting this information directly into your agents.md file. If you don't declare any specific browser support information, then the agent will assume baseline widely available. Second, in the fallback section of each of our guides, we include detailed browser compat data so that the agent can then determine whether or not it needs to use a particular fallback based on the browser support requirements that you put in your agents.md file. For example, if you're building an Electron app and you set in your agent.md file that you only need to support Chrome 144 and newer, then if the agent encounters a fallback for something like, say, scroll-driven animations, which ship in Chrome 115, then the agent can ignore that recommendation and just stick with the modern implementation. This allows the agent to custom tailor each guide's implementation to the specific browser support requirements of your project, rather than always having to take a lowest common denominator approach. So that's a quick overview of Modern Web Guidance, and I assume at this point, many of you are probably thinking, sounds great, but how well does it actually work in practice? So I do have some demos that I'm going to show, so you will get to see it working. But before I show those, I do want to address this question directly, because I think it's an important one. I think it's important that we, as an industry, are able to evaluate the effectiveness of the skills that we're using. When we started this project, one of the main requirements we had was to ensure that we had rigorous evals for every single feature that we used. As of now, our eval suite includes 554 distinct assertions covering most of our guidance, and we plan to expand that to full coverage before our stable launch later this year. And we run this full eval suite every single day against many of the popular AI coding models, which right now includes Gemini 3.1, Claude Opus 4.7, and GPT 5.5. Here on the screen, you can see a visualization of the aggregate results of all of these evals across all of these coding models. The number in green on the right shows the average pass rate of eval assertions for agents running with modern web guidance installed, and the number on the left shows the average pass rate for the exact same set of assertions, but this time from agents running without modern web guidance installed. And we call this the guided versus unguided pass rate. So as you can see, the guided pass rate, the guided agent performs meaningfully and noticeably better than the unguided agent. It's not yet at 100%, but we're actively fine-tuning both our guides and our evals because we want this number to be as high as it can be. So what do these individual evals look like? Well, they're effectively prompts that we give an agent, followed by a set of assertions or tests that we run against the agent's output. Here's an example of a recent eval from our scroll progress indicator use case. We run the prompt that you can see on the screen, along with the following assertions to test compliance with the guides. For this use case, the test checks to see that the implementation correctly uses scroll-driven animations rather than relying on scroll event listeners. As you can see, with this particular instance for this particular run, with our guidance, all the tests passed, and without our guidance, all of them failed. So this is a snapshot of how these models are performing right now, but it's not hard to imagine this changing in the future. At some point, as the models improve and as the browser landscape changes, we fully expect that many of these evals will start passing even without our guidance. So I mentioned that we run these evals daily. Our plan here is to watch this closely, monitor the results, and then remove use cases once we start noticing that the unguided version is consistently performing as well as the guided version in all of the popular models. This will allow us to keep the pack small, token efficient, and focus just on the features that are not new, or that are new and not well known by the models and not covered in the training. But also keep in mind that new features are shipping in browsers every single month, and knowledge cutoffs continue to lag far behind. So we believe this type of guidance is going to continue to be necessary long into the future. And speaking of the future, I now want to talk a bit about how we see this project evolving over time. For this early preview, we're launching with about a dozen high-level discipline guides and more than 100 detailed use case guides, but we're definitely not going to stop there. Our plan is to continue adding more guides to give us better coverage of the existing web platform, but we're also going to be covering new features as they land. In fact, our goal with this tool is to ensure that every single new web platform feature that ships in Chrome is covered by this tool by the time it lands in Chrome stable. If you take a look at chromestatus.com, you'll see that Chrome releases a lot of new features every single milestone. So this is definitely an ambitious goal, but it's one that we think is critical to support the ongoing health and success of the web in this new agentic world. We're also currently engaging with other browser vendors to try to get coverage for the features they're shipping as well. Okay, so to recap what I've covered today. First, AI models have a knowledge gap and blind spots. They recommend legacy solutions even when there are newer and better alternatives. Second, modern web guidance fills those knowledge gaps with vetted recommendations from Chrome experts. This helps ensure coding agents have a full and complete understanding of the modern web platform, with clear instructions on how to implement those features in a way that is compatible across browsers. And third, Chrome is committed to keeping modern web guidance up to date as the platform evolves, so that agentic coding will always be at the forefront of modern web development, rather than constantly lagging behind. And with that, who wants to see some demos? Demos? All right. I don't know if you guys can hear that sorry about that, my phone is going off. I was supposed to pick my son up from preschool right now, I guess. Hopefully my wife's doing that. All right, here we are. So I want to start here on this phone. I want to show you all an app that I'm building. Now, I don't know if it's not. How's the focus? Can you read it? Okay, this monitor's a little weird. Okay. So this is like an email application. It doesn't really matter what the application is. I'm doing a project here where I want to build a mobile website. And my goal here is to make the mobile website function when I'm using it on my phone as smoothly and polished and seamless as the native applications that I use on my phone. I think as an industry, like mobile first came out 15 years ago, and we got really good at building interfaces that look good on a mobile screen size, but we haven't really got good at building interfaces that feel good on a mobile screen size. So that's my goal with this. And so I was prompting Gemini, I was using anti-gravity, and I asked it to build something that looks similar to Gmail. And it did this. And then I said, okay, build me a sidebar navigation drawer with a hamburger menu, and when I click the hamburger menu, I want it to slide out. So it does that, and it looks okay. It kind of had all the links that I wanted, but there's one thing here that's missing, and you might be able to guess what it is. When I put my thumb here and try to slide it close, it's not working. Now, I assume everyone has experienced this at some point. You go to a mobile website, you try to slide the navigation drawer closed, it doesn't work. Literally every single native application supports this functionality. Pretty much no websites do. And so I want to change that. And the AI wasn't really helping me here. I asked it to do this, and I could keep prompting, but I wanted it to do that by default. So let's talk about how we could fix this using modern web guidance. So let's switch over to my laptop. I have anti-gravity here, and I want to talk through how I'm going to approach doing this, but I want to do something a little bit different. I have actually two versions of anti-gravity running. I have this anti-gravity in light mode. My editor's in light mode. This is how you tell the difference. And then, hold on. And then this is anti-gravity running in dark mode. If you look here on the right, it says unguided, and then when I switch back, it says guided. So I have two branches off a single branch. They're the exact same code base, and I'm running two versions of anti-gravity. One I'm going to say is guided, and one is unguided. So here in the guided version, let's go ahead and load up the terminal. I got it running, but I'm going to install modern web guidance. And so you can see I'm just running the command npx modern web guidance install. And it's going to go through the flow. Let me expand this so you can see it. It's going to install it. I'm just going to go ahead and click the default recommendations. I'm going to do it in my project. Proceed with installation. And so if you look over here, and actually let me go ahead and rerun the dev server. OK. So if you look over here, it added this .agents folder. Look in my project. If you've used skills, you're used to this flow. And if I open this up, you can see modern web guidance is installed here in the guided one. And then if I switch back to the unguided, there's no skills. So that's where we're starting. I also have 2 browser windows open, one in dark mode. This is the unguided version running its local dev server. And this is the guided version running its local dev server. They're both, like I said, they both started from the same exact branch. I can open up the sidebar, and I'm trying to swipe it close here. You can see it's like dragging behind, but the sidebar's not closing. So let's fix this. I have some prompts prepared, so you don't have to watch me typing. And let's go back into anti-gravity. I'm going to start with the unguided version. Oh, I'll also mention they updated all of our anti-gravities today. Obviously, you probably heard the announcement. So I'm going to try doing this with Gemini 3.5 Flash. Never tried that before. Hopefully it will work. If it doesn't work, we'll go back to 3.1. But I'm going to try. We'll see if it works. So I'm going to paste this in. I'm going to do it here, and then I'm going to switch back to the guided version, and then I'll read the prompt. So I say the navigation drawer in this app looks fine, but I don't like that it can't swipe to close it. Can you fix that? So we can see here what it's doing. Let me go ahead and close this sidebar. I'm going to zoom this over so we can kind of watch what's happening. So if you look up at the top, it is running npx, modern web guidance is doing a search command, which is what I mentioned. It's searching through the guide database. It found a guide. It looks like it found a guide. Can I move this over? Found a guide called navigation drawer. And so it's starting to implement that. And then if we go back and look at the unguided version, it's doing some things. Looks like this is already done. I'll go ahead and accept these changes. Let's go back to the guided version. Is that done? Looks like it's almost done because it's running the npx build. OK, look, that one's done as well. This is why I decided to do Flash, because it is quite fast. So I didn't want you all to have to sit here and watch this running. So here we are in the unguided version. Now this is an AI demo, so it's very risky. I don't know what's going to happen. So bear with me in case this totally fails. I'm going to click the hamburger menu and see what happens. OK, now I'm going to try to close it with a swipe. OK, so it did swipe to close. You probably couldn't pick up on what was happening because you don't see, like you didn't feel what I was doing. Let me do this again because something felt weird about this. I am dragging here. I don't know if you can see behind. I'm dragging this. OK, there it closed. I didn't pick my finger up. I put my finger down. I was dragging, and then I didn't pick my finger up, and it closed. So I've done this demo a couple times. It seems like Flash is doing a similar thing. What I'm pretty sure is happening here is that it is trying to detect the swipe gesture, and then it is calling a close function. But what I wanted to do is I wanted to literally like pin the sheet to my finger as I'm moving it. This is what I would expect. And so again, it kind of works, but it doesn't. It's definitely better than without it, but it's not quite what I want. So let's go back to the guided version and let's see how it did. Fingers crossed. OK, it opens up. I'm going to click. I'm going to drag, click, and drag. And so you might even notice here the backdrop is fading ever so slightly as I'm dragging. And this, because I know which guide it used, this is using scroll-driven animation to do that backdrop fade, and it's tracking with the scroll gesture. The dragging here is being handled using scroll snap points. So it's actually a scroll interface, which means it uses the browser's default physics and all of the hardware acceleration of scrolling. So I can swipe it to close, and I can swipe it like that, and that looks great. OK, but we got to do some more features, so let's keep moving. All right, I'm going to add this, copy this next prompt. Let's go to the unguided version, paste it in, and then go to the guided version, paste it in, and I'll read what the prompt is. OK, so the prompt is now add a message view drill down so that when I click an email link in the inbox, it drills down into the full email message view with a back button so that I can return to the inbox view. The message should also have standard email action buttons like archive, reply, star, etc. But don't hook those up yet, just get the back button working. All right, so modern web guidance is doing its thing. It's looking for some guides. Let's go back and see what the unguided version is doing. OK, it's still working as well. And so I can see here that modern web guidance is retrieving a guide called stack drill down. This is just the idea of the use case that it's retrieving. And if we have some time, I can. If it's not going to finish yet. OK, it looks like this one finished. I might show the guides if we have some time. But since it's finished, I'm going to go back and I'm going to check the unguided version to see what happens. So I'm going to click an email message in the inbox view, and I want it to show me the full message. OK, so show me the full message. It didn't animate or transition in. Like I mentioned, I want this to feel like a native application. Does the back button work? OK, the back button works. This is kind of a harsh transition. So let's see if the other one is done. And let's see. OK, it looks like it says, I've successfully integrated the stack drill down transition module into the main. OK, like it did it. It's using some of the kind of, it describes here what it's doing. Now let's go and check to see what it looks like. Again, fingers crossed. OK, so it worked. It smoothly transitioned in. I can click the back button and it transitioned out. Now let's see if I can swipe to go backwards. OK, I can swipe to go backwards. That's nice. I'm also noticing a little bit of parallax going on here as I'm swiping it, which is also done using scroll-driven animations. And actually, I'm looking up here in the navigation bar, and I see that when I click, it also updates the history. And then let's see if I click the back button, swipes back. OK, like I didn't have to know how any of this stuff worked. I just typed it into the prompt. Let's do one more thing. Let's just try to get a little bit of a cherry on top situation here. All right, let's go into the let me go back and accept these changes for now. OK, go back into the unguided version, and then again the guided version. All right, in the inbox view, make it so that I can quickly archive or snooze messages by swiping them left or right without having to open each one individually. So I don't know if you guys are like me. You have your email app. You get a lot of email that you don't care about. I spend most of my time on my email app just going like this, swiping, 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 all of the unread emails, or that way. I don't want to have to click into each of them individually. So, okay, it says this one is done also. Is this one done? Okay, this one's still working. So let's go check and see what the unguided version did. Okay, it's doing the same thing it did before, where it's not pinned to my finger, it's not dragging with my finger, but it is detecting a swipe gesture. And okay, it looks like it does support both. I'll be honest, I've done this demo a bunch. This is maybe the best the unguided has ever done, but it's still not exactly what I want. Okay, let's see if the other one is done. Switching back to the guided version. Okay, looks like it is done. All right, and let's check how that one did. Okay, much better. This kind of looks very similar to how Gmail looks. I can swipe it from that side, swipe them all closed. I can snooze it from this side. So this is great. But this is the kind of thing that you really can't know. Like, you watching me do this, you don't really know how it is. But I think if we switch back to the phone, I want to pull this up on my phone, and I want you to watch me doing it on the phone, just to get the full effect. Okay, so let's see. We click this out. Oh, you can hold on, see. There's that reflection. Okay, so I can swipe this closed. And this is the kind of thing where if I put it like halfway and I let go, it swipes back. If I do it more than halfway and let go, sorry, I wasn't quite more than halfway. It's a little bit hard for me to see because it's reflecting on my face. But yeah, so with scroll snap, the way that it works is kind of the same way that the native browser, the native like app physics work, where if you do more than halfway, it'll finish it, like snap to its snap point, which is great. If I click on a message, I can click on any of these messages, and then I think so it should work as well, like if I do the back gesture. Not very good at this. Okay, there we go. The back gesture on Pixel. And then if I, swipe through the emails, snooze. The whole thing feels really nice. Like, it feels really nice and smooth to me. And just to show that what I said earlier is not a lie, I have an iPhone right here. Refresh. Do the same thing. Swipe. Click into a message. The whole parallax thing. Sorry, I'm trying to get this. You don't see the reflection. It all feels very smooth. I feel like I can't tell this is not a native app as I'm using it, other than seeing the address bar down here at the bottom. So let's switch back to the slides. Oops. We pressed at the same time. All right. So to wrap up, in Chrome, we care deeply about the health of the open web, and we invest a ton into improving the platform so that developers can build better experiences and so that businesses that are built on the web can ultimately be more successful. But the truth is that improving just the web platform, it's not good enough. We have to actually improve the web. Because users don't visit the web platform, they visit the web as it exists today on the websites that they actually visit. So if we want to make the web better, then at the end of the day, we're going to actually have to make it as easy as possible for you developers to use all of these amazing features that Chrome is adding to the platform. And that's why we built Modern Web Guidance. But also, that's why we want to hear from you all. We want to make sure that this tool works for you and that it helps you build better experiences. So we'd love for everyone to try out this early preview and give us feedback. If you're running into problems, or if there are use cases that you feel are missing, then definitely let us know. The link on the screen here will take you to a site with information on how you can contribute and give feedback. And with that, thank you all very much.
Hi, I'm Miriam, a product manager for Flutter. Today, we're going to share 7 tools and techniques you can use right now to make your Flutter code more readable, scalable, and testable. I'm joined by Eric and John, who will help me demonstrate these techniques to build a checkout experience in our Dash Shop app, an exclusive online store for Dash gear, stuffies, keyboards, you name it.
These techniques will help you build your Flutter app with a scalable and maintainable app architecture so it can go the distance. And we'll also share some tools that you can use to add features to your app and some cool ways that AI can use them to assist you.
All right, let's dive into the code. The first technique is all about building a great UI, designed using constraints and not fixed sizes. Flutter makes it possible for us to have the Dash store available on any device and any screen with a single codebase. But with ease comes responsibility, as a wise bird once told me. It's our job as developers to ensure the UI is visually responsive while keeping the code readable and error-free. Designing using constraints makes your widgets flexible and more reusable than if they were using fixed sizes. That way, you can easily reuse them for mobile, desktop, or the web. Essentially, that boils down to 3 steps: abstract, measure, and branch.
The UI currently uses Flutter's flex layout with widgets like row, column, and flex to help make sure the widgets resize based on the size of the constraints. But when the screen gets too small to display everything or so large that there's wasted screen space, you need to swap out the layout with an entirely different one appropriate for the screen size. So the first step is to identify the UI widgets that need to change and abstract the underlying data they share. In this case, the card screen layout needs to change based on the screen size. We'll pass the data it needs to render in via the constructor parameter. The widget shouldn't care about where the data comes from, just that it needs to display it. Next, let's measure the size of your display area. Use media query size of for the entire app window or layout builder for the localized constraints. Since this is a smaller widget that we want to reuse, we'll use layout builder. Finally, we can read the incoming constraints that layout builder gives us and return different widgets based on the available size. To learn more, check out the layout docs linked in the description.
If our UI layout is broken or the app freezes, we could fiddle with the height of the container, hot reload, fiddle with the height again, hot reload again, or we could save some time and skip all of the guesswork by using DevTools to provide visibility into the app, such as the exact constraints that the parent widget is enforcing. Our second technique is use DevTools. Keeping accessibility in mind, let's make the images and the text in the checkout cart bigger so that they are more visible.
Let's see. That should be pretty easy. I'll open up Anti-Gravity and enter a prompt with the widget I want to change. Okay, so anti-gravity made the change. Now I'll tell it to reload. And we hit a classic issue, the dreaded layout overflow error. To help us understand what's going on, let's use DevTools to see which widget is causing the error. The Flutter DevTools inspector highlights these errors so we can see which widget is causing the issue. This row widget, which is overflowing. We can dig into the details ourselves, or we can use the Dart and Flutter MCP server to help us fix the issue. The MCP server makes Flutter developer tools available to AI assistants. To install it in Anti-Gravity, we'll open up the agent panel and select MCP servers under the additional options drop-down menu and search for Dart. Once installed, Anti-Gravity displays the available tools. When we run our app, our agent can connect to it directly. And once it's connected, the agent can read the layout error message using the Git runtime errors tool. Layout errors contain a lot of details that Gemini is really good at understanding. The agent knows how to use the hot reload and Git widget tree tools to help make sure that it fixed the layout error.
Mixing business logic and UI within a widget creates massive, unreadable, deeply nested build methods. By separating your business logic from your UI, your widgets become easier to reuse, modify, and test. So technique 3 is building reusable widgets.
As mentioned before, a widget should receive all the configuration it needs to render as arguments. It shouldn't have to modify or format any data. Its only jobs are to render data and listen for user events. As a rule of thumb, if your widget is importing low-level libraries, making remote requests, or interacting with a database, it's probably not reusable. In the Dashdoor app, when a user presses purchase, the widget doesn't turn around and call the payments API directly. So in order to keep a widget reusable and only focus on displaying the UI, that logic is deferred to a different object using a callback that is passed in as a parameter to the widget's constructor. When your widgets are reusable, you can leverage tools like widget previews. Widget previews is a developer tool that complements hot reload, enabling you to experiment with UI variations and states without running the full application. Rather than running an app, navigating to a specific screen, and getting the app into a specific state just to test button styles, I can write some widget previews for that button and pass them in, enabling me to quickly iterate on designs. This is straightforward since our widgets were built to be reusable. And if you're building with AI assistants, the Flutter team has published a skill, Flutter Add Widget Previews, that gives instructions to your coding agents on how to build previews for your app's widget catalog. This skill is published as part of Flutter's official skills repository on GitHub, and it provides instructions for agents that can be shared and repeated to reliably complete a task for you. We authored this skill by grounding it in our official documentation. This means that the skills are up to date and keeps our official docs as the source of truth. Each skill has a name and description that tell the agent what it should be used for and when to use it. The agent reads it in only when it's relevant to what you're trying to do. You can find skills published by the Dart and Flutter team on GitHub, so you can start using them for your own projects today. But we didn't just write the skill and call it a day. We've rigorously validated it with our evals framework to ensure it consistently works across use cases. Our goal is to consistently deliver tools to developers that help you build better apps. And with AI's rapid innovation, we want to make sure that each skill, MCP tool, and model change is making your apps better. So we're looking for ways to be more data-driven. In fact, we're experimenting with evals in public, so the code is open source and you can check it out at github.com/flutter/evals. So now you can see that we have a widget preview for our widget. Previews let you test widgets in their various states and see how they look when placed next to each other. And we can use our skill to create previews for all of our important widgets. So our widgets are looking good, but now we want to start using them in our app. And for that, we need to talk about app architecture.
Separation of concerns is one of the core fundamentals of software development. In app development, this generally manifests as a layered architecture. So the fourth technique is to bake a layer cake. We layer our apps using MVVM architecture. All MV something patterns have a similar layered architecture using 3 objects that are roughly equivalent from pattern to pattern: a UI layer, a logic layer, and a data layer. In MVVM, your UI is separated into views, which are your widgets, and your logic is in the view models. View models act as a gatekeeper between the UI and the data layer. This separation of logic and UI makes your code testable and more readable.
View models have 3 jobs: transforming app data into data that's ready to be rendered, telling the data layer when user interaction requires app data to be modified, and telling the UI when to rebuild. And for that, we use change notifier. In the Dashdoor app, the cart view model provides configuration for the cart screen and has properties like cart items and subtotal, and methods called add to cart and on purchase. On purchase is the callback referenced earlier that we pass into the widget. When a user presses the purchase button, the view model handles the local state, things like toggling is loading and calling notify listeners, but it defers the data mutation logic to another layer of the proverbial cake, the data layer.
Which brings us to our next technique, using the repository pattern. The repository pattern centralizes and abstracts data access logic, and it does so using objects called repositories. A repository manages the data in the data layer. It's the interface between your app and external data like server, database, or plugin. Specifically in our case, it exposes raw data from services to the view model.
This pattern is used to establish a single source of truth per data source in your app, and should be the only object that can fetch from or write data to an external source. When application data logic is isolated in this way, it makes your entire codebase easier to test and scale. If you want to try out these architecture techniques in your own apps, use the official architecture skill published by the Flutter team to make your AI agent an expert.
The sixth technique is to design for all platforms. What happens to your data layer when you need to use native features like payments? Flutter uses Dart, but platforms like Android and iOS expose these features using Kotlin and Swift APIs. Thankfully, Flutter enables developers to leverage native device features and third-party APIs through its massive ecosystem of plugins and packages on pub.dev. The huge win for developers is that plugins enable us to write Dart code that works consistently across all platforms, and the implementation details are abstracted away as a package on pub.dev.
Traditionally, to find the right plugin for payments, I'd leave my IDE, open a browser, hunt down the right package on pub.dev, and read through the documentation. But did you know that your coding agent can help you with that too? Let me show you. I've got my Dart and Flutter MCP server ready, so let's ask something like, help me implement a checkout experience that uses Apple Pay and Google Pay. The agent identifies the official pay package, and as you can see here, it's using the MCP server to securely interact with external data sources. In this case, the MCP server enables our agent to search pub.dev in real time, fetch the latest package documentation, and analyze the current workspace. This makes a big difference because including more context helps the agent write correct code. If we look at the results, the agent also wrote in the code to support Apple Pay and Google Pay in our checkout experience. Of course, if we don't like what the agent chose for us, we can reject the change and provide it with more context. Because the MCP server searched the package docs, the code correctly uses the latest API version rather than relying on training data. Here's what the checkout experience looks like on Android and iOS.
The new checkout experience is working great, but now we need to make sure it keeps working reliably. It's a good idea to add automated tests so we can know when something breaks. No matter how much we don't want to do it, our seventh technique is to write tests.
We've already eaten our vegetables and designed our app using good architecture patterns, so it's going to be much easier to add tests. First, let's add a unit test. Unit tests can validate the behavior of Dart code very quickly in parallel. They're great for testing individual classes or functions with different inputs to make sure they work correctly in isolation. Let's take a look at the cart view model to see how we can write a test for it. I can see that it takes a dependency as a parameter, so we'll want to mock that. And we'll use the new checks package like this. You might currently be using the matcher package to write test expectations like equals or is greater than. With the checks package, everything is strongly typed, so your IDE knows which checks are valid for the data type you're testing. We also have an agent skill to help you migrate from the matcher package to the checks package. Widget tests are great for testing, you guessed it, Flutter widgets. They also run quickly because they run without a physical device or an emulator, and can tap on widgets, verify the text that's on screen, and a lot more. Here's what the widget test for our button looks like. We can verify that it shows the correct values when we tap. Finally, let's use an integration test to verify that this feature works correctly on a physical device. Integration tests actually use the same API as widget tests, so you don't have to learn a new testing framework. And thanks to our MCP server, our coding agent can help with this too. Let me show you how that works. We've created this Flutter integration testing skill to help write integration tests. First, it enables Flutter driver, which enables the agent to interact with our app. From there, it runs the app and interacts with it to go through the user journey that we're testing on a real device. Finally, it captures those steps into an integration test that we can reliably run. Now our integration test can be maintained alongside the rest of our test suite.
So let's recap. We covered 7 techniques for writing really good Flutter code. Design for constraints, not fixed sizes. Debug using DevTools, build reusable widgets, bake a layer cake, use a repository pattern, design for all platforms, and write good tests. Whether you're writing out code by hand or iterating with your coding agent, we hope this helps you write Flutter code that is more readable, scalable, testable, and faster than ever. To learn more about Flutter's best practices and all of our developer tools, point your browser to flutter.dev.
Hi there, my name is Pierre, and today we are going to explore how Google Workspace and Google AI fit together to enable agents for everyday workflow and automation. The AI race is not slowing down, and the landscape is continuously evolving. It feels like there are major launches of models, concepts, tools, protocols, and frameworks every week. And we are now past the chats most people are familiar with. These innovations make it increasingly simple to build, deploy, and publish production-ready agents, whether it's for individual or for organization use. Think about it. What if you could have your own agent in a CLI automatically update drive files with the latest documentation as you work on issues? What if you could have your own agent that processes incoming Gmail messages for urgent requests and automatically blocks time in calendar? What if your organization could provide an agent that monitors Google Docs and notifies people in Google Chat depending on their roles? Well, Google Workspace and Google AI make that possible. Google's AI ecosystem is made of several layers that span from infrastructure to agents and applications. That makes it possible for anyone to integrate solutions of any shape from anywhere. You are a user, use pre-built agents. You are a builder, build with agent designers. You are a developer, develop agents with frameworks and tools. You are a service provider, publish agents in the Google Cloud Marketplace. You are an IT, restrict user access to trusted agents and tools. I think you got the point. But you know what? At the end of the day, all AI solutions are still pieces of software. Do they execute differently and rely on different technologies than before? Definitely yes, but their potential still depends on 3 core pillars like any other software applications: data, actions, and interfaces. Now, do you know a platform trusted by billions of users and millions of organizations for collaboration, productivity, and getting things done on a daily basis? That's right, Google Workspace. It comes with Drive to find, share, and manage files, with docs, sheets, slides, and forms to collaborate and co-edit in real time, with Chat and Meet to connect from any device, with Gmail and Calendar to stay on top of things, and many others, such as Classroom, Sites, Keep, Task, and Vault. Many of these applications became increasingly AI-assisted in the past few years. My 2 personal favorite features are the AI Overview, Thread Summaries in Gmail, and Ask Gemini that's available from the sidebar. If you are part of an organization, you might also have access to additional AI features with Gemini in Workspace. I personally rely extensively on Take Notes for me in Meet. I can now focus 100% on the discussion and catch up later if I have a meeting conflict. And when it comes to AI-native applications, Workspace added Notebook LM last year and Workspace Studio earlier this year. Notebook LM is an AI research and thinking partner, grounded in trusted information provided by users, such as financial reports, market analysis, or internal strategy documents. It can create resources in many formats, such as overviews, slides, or infographics. Workspace Studio, on the other hand, makes it possible for users to streamline and manage tasks by building, managing, and sharing personal AI-enabled workflows made of starters and steps. Here, I create a workflow that automatically sends me a daily news summary in Google Chat. See how the flow can rely on AI-powered steps? The Ask Gemini step relies on a web search to retrieve the recent news in this case, but it could rely on other sources and take more complex decisions as well. Also, this flow is mine, and it's editable, so I can control and adapt it as I see fit over time, like adding a new step. Now, what happens if the AI solutions provided from Workspace are not enough? In this case, you can join the thousands of existing Workspace developers and start building your own custom solutions. You can use a no-code approach with AppSheet, a low-code approach with AppScript, and a pro-code approach with any other tech stack. There are extensive APIs and libraries to retrieve data and take actions on behalf of users, such as accessing Gmail messages or creating calendar events. In this particular example, I have an agent development kit function tool that creates calendar events for users. Most Workspace application UIs are extendable using add-ons, so it's possible to meet the users where they are. In this case, the user opens the sidebar in Gmail to ask their travel concierge agent to plan their trip based on the information in the message that's currently open. Then, they can decide to move to chat if they have other ongoing discussions to take care of at the same time. Google is continuously releasing new model context protocol servers and tools for cloud and Workspace that you can rely on as well. They are dedicated to agents, and they are much easier and safer to use than building custom API wrappers. It's important to note that everything is client agnostic. Using Google's AI tech stack is not a requirement to build custom solutions that rely on these features. But if you do, it comes with products and tools that make it easier to build agents that integrate with cloud and Workspace. Developers can combine Gemini CLI and Anti-Gravity with Google-managed or custom FCPs to orchestrate workflows that bridge local development environments with real-time organizational data. Here, Anti-Gravity is configured with Workspace MCP tools so that agents and skills can rely on them when needed. For example, an agent could send a chat message to a given space after completing their task. Agent developers can rely on Workspace MCP tools as well. The ADK framework makes it easy to do that by registering the tools and by defining when and how to use them in instructions. The next layer of the stack is the Gemini Enterprise Agent Platform. It's the unified platform to build, deploy, manage, and scale enterprise-grade models and agents in production from Google Cloud. It comes with 150+ pre-built models, including Gemini models, and the possibility to use custom ones with tuning, training, and experimentation. The Agent Designer and Agent Runtime tools enable builders to create collaborative agents using open-source frameworks, sessions, memories, MCPs, code executions, and more. The governance and monitoring tools allow continuous observation, evaluation, identification, and tracing, and the search tools enable RAG, vector, and AI searches. In fact, in the context of Workspace, the agent platform search is a key integration point because of the connectors that are currently available for Gmail, Chat, Drive, Calendar, and People. With this, agent developers can search for users' business data at runtime by using the dedicated Agent Search API or Google-managed MCP server. The ADK framework makes it easy to do that by registering the tools and by defining when and how to use them in instructions, like we've seen before. Now, did you notice I did not talk about user interfaces yet? That's because there is none in Agent Platform. You need to use APIs and integrate agents with your own UIs. In the context of Workspace, we can use add-ons. And the Travel Concierge agent you already know is a great example of that. It's an add-on built with AppScript, and it relies on Agent Platform APIs to manage sessions and turns. We created this code lab if you want to learn more. It contains step-by-step instructions on how to build this type of agent. Check it out. In case you do not want to integrate agents with your own UIs, you can rely on the last layer of the stack. Gemini Enterprise aims to bring the best of Google AI to every employee for every purpose. Its web app is a key component to achieve that goal. But it's more than just a web app. Gemini Enterprise is a complete platform built to discover, create, share, and orchestrate agents across an organization, with secure foundation and global business context. It comes with governance for security and control, and it supports all kinds of agents. Agents developed using no-code, low-code, pro-code tools, agents authored by Google, the organization, partners, or third parties, and agents that can run from anywhere, whether they are built using Google's AI tech stack or not. In the Cloud Console, admins can set up data stores. Here is an example of Workspace data stores connected to a Gemini Enterprise app. Admins can also register agents running from any agent platform using the agent-to-agent protocol or the cloud marketplace. These agents can use tools based on Workspace APIs or Google-managed MCPs and rely on the authentication mechanism of Gemini Enterprise. In the Gemini Enterprise web app, on the other hand, users can interact with the agents, models, tools, and data stores configured by the admins. They can also create personal, no-code agents from the agent designer through prompting and manual editing. Here, I'm creating one that relies on Drive connector tools, for example. Now, what if you want to integrate Gemini Enterprise agents with Workspace application UIs? Well, the solution is similar to the one used for agents running on the agent platform. You need to use the provided Gemini Enterprise APIs. We created this code lab if you want to learn more about all this. It contains step-by-step instructions on how to build this type of agent. Give it a try. All right, everything I discussed so far is available, but you might be wondering what's coming next. There are a few things I recommend monitoring. Connectors and MCP servers. They empower agents with a growing number of tools. The A2A and Agent-to-UI protocols. They standardize agent communication and generative UIs for greater collaboration and distribution. Full duplex models such as Gemini Live. They unlock a new set of interactions and use cases. And last but not the least, skills. They are getting more popular, and they already prove to be a great complement to MCP tools for agents. I'm dropping a few more useful links here to help you get started. Have fun exploring all these tools and solutions. Until next time, see you online.
All right, it is great to see you all. I think most of you are here for the air conditioning, but nonetheless, this will be good for you regardless. So welcome. That was a great dev keynote earlier if you all got to watch, being able to see how much all of us could create software from prompts, from our voice, from context. How amazing is that with Anti-Gravity 2.0, with AI Studio? This is an amazing time to build, so we're going to have some fun today doing a lot with this. Now first, we just built this game in AI Studio. If you saw the dev keynote earlier, you saw that they were building games, doing all kinds of stuff. Let's have some fun. So when you build a game like this, you might click publish. You might deploy it to something like Cloud Run in Firebase. And hey, no credit card required as you start shipping your first 2 applications, which is amazing. We all love day one. Day one is amazing. You ship it, you feel good. But then there's day 2. There's real traffic. There's things that go wrong. There's edge cases you haven't considered. So what I'm going to do, though, is I want to introduce first my friends, Christine and then Denise are here to help me out. They've built some amazing things. Yes, they're both amazing. What I want you to do is take out your phone, scan this QR code, and let's play this game. Seriously. I want to see if it can survive I/O traffic. I have my doubts. Christina's job depends on this. There's no stakes here. It'll be fine. So what I want to see, let's try to play the game for a minute and see if you all can break it with load, or it'll be completely fine and your job will be safe. Either way, not a big deal. So we're going to go here. We'll look at the leaderboard, I think. We'll see. Oh, yeah.
We're going to go.
You're unbelievable at the game, Denise, so let's see.
Let's see if I could beat this.
It's looking good so far.
You only need to survive 10 seconds.
How's the leaderboard doing?
Okay. Let's go. Okay. All right. Let's see how the leaderboard's going.
Let's check out the leaderboard. See if we're holding on.
Uh-oh.
But I'd like to thank Christina for being here at Google. We'll give you your paycheck at the back. We'll pay out your vacation. We're very humane with that. No, it's great so far, but this stuff happens, right? Things can break. Day 2 happens. Load happens. Things like that. It's okay. So how do we have to think about a little more than that? Because if you ask most developers, where are you spending your time with AI? Guess what you're not doing? Day 2 stuff. Deployment, monitoring, fixing. Most devs are like, hey, I'm using it to build, document code. That's awesome. But not enough of us yet are making this part of our day 2 journey. So how do we think about that a little bit more? How do we actually take advantage of what AI can do for us on day 2? So over these next 30-ish minutes or so, we're going to show 3 agent-first workflows. These are going to take these prototypes and turn them into something more reliable, more production grade. We're going to use Anti-Gravity, Google Cloud, a number of components. Let's do something to make any of these fun vibe-coded apps something more legit. So we want to start with agent-first debugging. I mean, some of you might like debugging. It's fine. You're probably fun at parties because you talk about this a lot. But Denise, can you set the stage for us here? What's it look like to do real agent-first debugging?
Yeah, so I mean, when something crashes, most of the time you're going to have to go through all of these logs, and who really wants to do that? Because I know I don't. You know, you got to go look at your configuration, see if you made a mistake. You go look at the performance metrics to see if there's any issues with latency and everything, but nobody wants to do that. You know, so what if we took our agent, our agentic developer tool, in our case we're going to use Anti-Gravity, and what if we took that and we let it do the job for us, right? Why do all of that manual tasks ourselves? So it crashed, and we want to know what happened. So I am going to use, because I'm kind of lazy, I don't want to actually type it, I'm going to use a voice input and ask, find out what's wrong with DynoQuest. So going to kick it off, and notice how I did not actually tell it, where's my logs? Where's my DynoQuest service? I was able to do it all with just telling it what to do. And the reason why I was able to do that is because we have the Google managed MCP servers to be able to safely connect our agentic tool to MCPs in our Cloud Run and our services. And so by doing that, and as you can see, there's lots and lots of them available, we don't have to juggle with API keys. We don't have to go into the console and go click around and do all of that stuff. All of our data and our services from Google Cloud is available for the agent. So let's go back to Anti-Gravity and see, look at right there. So as I was talking, all of that happened, right? Like, would you normally be able to do that if you were manually debugging? Nope. So it told me that this is actually caused by a 503 service is unavailable. I think all of you putting it there put a lot of the issues onto a load. So going on. We know what the issue is now. We want to actually fix the problem. So I'm going to ask anti-gravity again. Can you look at the code for the DynaQuest game and fix what caused the issue? So here, send it through. And it is going to go and work and do all of that. But as it's going, Richard, why don't you tell us about the developer knowledge MCP? Because I think that's a great MCP for people to use.
Yeah, you mentioned, look, there's over 50 of those managed MCP servers you can use today, from everything from BigQuery to Cloud Run. One of them, which everybody should use, is called the Developer Knowledge API or Developer Knowledge MCP. What this is an MCP server that fronts over a dozen different Google Doc bases, from AI to Cloud to Firebase to all these different components. So you can just say, hey, I need something, and it goes and searches any of our docs and pulls back the latest version into your coding tool. So all of a sudden, you're not guessing, oh, am I using the wrong version, the right version? You're getting an 8 to 12 hour at the latest snapshot of the documentation into your agentic tooling. So it doesn't matter if you're using Claude Code, you're using Codex, you're using anti-gravity. Pull the latest of Google documentation into your tool and make it easy to use.
Yeah, I mean, that's very helpful because one of the problems is always using outdated data, like outdated information, and then your agent's not going to actually do what you want it to do.
Yes.
All right, so let's go on, and it looks like anti-gravity has finished, and it said that the issue was actually in our leaderboard, and it went ahead and made the code changes for us over here in the main.py file. I didn't have to actually do anything myself, I just let it go. And so typically what we would want to do is go and commit it to GitHub, and we're going to redeploy, and anti-gravity can do this for me. But because we have a few things up our sleeve later on, I'm not going to actually deploy it now so that we can show you something better later.
I like it.
Christina?
Sounds good. I know here in Google, we're all about transparency, right? And things like this happen, we wanted to make it out for people, right? So for those of you who kind of suffer through the game, we want to give you some treats back in the game. And as you know, what we have right here is Data Agent Kit. Data Agent Kit gives me some kind of visibility into my data source. The reason why I talk about data source is because I vibe coded this game 3 a.m. in the morning.
Well done. You're a trooper.
Right. This is where my dark circle came from.
That's your best time.
Yeah, sorry. But it got very fuzzy at the end. I kind of forgot where I store everything. And this is where this became very helpful because I was able to kind of figure out where things are without me needing to actually go in and figure things out. So what I'm going to do here, I have the Data Agent Kit installed in my anti-gravity right here. And let's go ahead and then start to head over to our anti-gravity. Right. So what I'm going to do is I'm going to ask our anti-gravity with Data Agent Kit to look through all my data sources and add the treats for you. As you can see, all the document databases that I have, because I've been vibe coding with AI Studio, and AI Studio directly uses, most of the time it goes to use Firestore as my database, and it's a document database. And to update it is not as simple as, oh, I'm just going to write a SQL. It's not as simple. Sometimes you have to write code to insert a document. So it's kind of a messy thing to do. So I want to use natural language. Let's head over here, and then let's go ahead and do it. Add 5 treats for all users. And I'm going to send it in. So what happens now is this Data Agent Kit, not only it has access to the MCP server, it also comes with skills. The skill has the know-how, so it doesn't just communicate to my server, it also knows how to do that properly. So as you can see right here, the agent actually wrote a Python file, and it wants to execute this Python file. And it doesn't just execute, because anti-gravity is aware of what's going on. It doesn't just want to go ahead and just run an application. It's not so secure. So it's going to ask for my permission, and I'm going to go ahead and run it. So it's going to answer 5 treats to 3 users. Awesome. We only have 3 users? Oh, I thought we had more.
I don't know, they crashed on 3 users. Huh?
Oh, that's right. Oops. All right, so let's head over to the DynaQuest and see if we have the treat added. Awesome. As you can see, we have added 5 treats to our user. And as for the announcement, because we want all of you to know that announcement is here, and with the announcement, it's even worse because I also forgot where I stored it, which is not a good idea to code at 3 a.m. in the morning. So what I'm going to do? I'm going to also ask anti-gravity to do it for me again. So here I am. I'm going to head over here and say, add an announcement with title, sorry for the crash, with a message that says they each get 5 treats. And I'm going to ask it to do it for me. So what this agent does is going to go through all my data store, and luckily this is not a very complex use case, so it was able to figure out where I'm storing my announcement. It will then create the document for me and even formulate a message for me. As you know, my English is not that good, so it's going to formulate a very nice story message so everybody can see. So for those of you who want to see the message, if you go over here and refresh the message, there you go. The message has been inserted into the document. Isn't that great, Richard?
That is amazing. You've redeemed yourself. So that was awesome. I mean, you're interacting with the database, doing things that not all of us have every skill, but you actually are baking skills into your workflow where you can do all these things. That's amazing. Those agent-first workflows, though, if you see that, this is a mindset shift, right? This isn't how we're all used to working. There's something new here. And part of this, too, is thinking about this new way to debug. We're connecting to live environments, pulling logs, iterating on this. So how do we think about this new approach and plan and use specifications, things like that? It's pretty exciting. But let's look at kind of this next piece. Now we have happy users. Hopefully, you can try it again and keep messing around with it. How do we grow the app? How do we fix it, optimize it, make it even better, add performance improvements? So our very second workflow we want to do is, how do we optimize? How do we understand user behavior? How do we fine-tune the game to make it even more competitive for players? And the log data might actually tell us what kind of dinosaurs people are making, playing, whatever. But instead of writing all the pipelines with ETL and analyzing data, there's probably a better way to do this with an agent.
There's always a better way. Why do we want to do this manually, right? Like, that's just time consuming. And so by doing that, it's like we can use the Data Agent Kit again. And here, Data Agent Kit is an extension for our IDE, and we can see that we can have access to all these BigQuery things. And so in addition to using the Data Agent Kit, we're going to be using the BigQuery MCP, as well as a custom agent skill that we built for this actual purpose. And here I have our skill open, just so it's not magic. You can see that we actually have a skill here, and it's going to lay out what it's going to do. This skill provides us a blueprint to automate a zero ETL analytics pipeline.
Wow.
So what it's going to do is it's going to create a log router sync to be able to stream the live logs directly into the BigQuery dataset. And that means no manual data plugging that you need to do. Then it's going to use the BigQuery MCP to be able to run a series of parallel queries and then just extract all that data that we got from the logs. And then lastly, it takes all of that data and it's going to create us an interactive dashboard. And so the question is, how do we run the skill? Well, we can run the skill directly in anti-gravity, and as you see the theme, we can do everything all in one place. But because this takes a little bit of time, because we have a lot of data there, I've run this beforehand, because I'm pretty sure right now at, 3:30 something, you don't want to be sitting here watching me run this. So I've run this beforehand, and all I had to do is tell it to run that report for my DynaQuest app, and then it told me the actual pipeline that I had shown earlier. And then it goes and says it created a log report, and it created our feature insights so that we know what we want from our next version, and it created an interactive dashboard. So let's take a look at the dashboard that we have, and here it is. Wow. So this was what was generated. So now we can see what the traffic overview, how many requests there were, how many server logs, and the win rate by dyno type. So I probably should have chose Speedy earlier, because apparently Speedy is a 54% win. I know. I did choose Tank. Well, at least it wasn't too bad. Balance was the worst. Yep. And then how many treats per outcome, and the top reused dinosaur. We could assume that if somebody uses this dinosaur a lot, it's probably a good dinosaur. But let's go back over here. So in addition to building this dashboard, you actually now have all of the data from BigQuery. And you can just go straight into anti-gravity and start asking it questions in natural language. No more need of getting like, how do I build my SQL query? I mean, it's been a long time since I've actually thought about all the select statements and all of that stuff. And go and ask it. But in addition to asking it information, you can draw the distribution graphs just straight here. So what's really nice about this is that you don't have to go click back to the console, do SQL queries, come and give my graph, and you can do everything all in one place, no context switching. And I'm pretty sure there's no way that, even though I said it takes a little bit of time of 9 minutes, there's no way you could have done this manually in that short period of time. So what do you think about that?
It's impressive. Let me be honest with you. How much of a data person are you? Like, was a lot of this just helping you do things with the skills and the tools where this isn't your wheelhouse, or how should people here feel like you're doing some pretty sophisticated things here?
It's been a while since I've been messing with SQL. We do a lot of coding more for the front end, but not so much of all this. So for me, thinking about how am I going to put these queries is just something I just don't think about from my everyday basis.
Amazing. So we went from millions of logs and things like that, or potentially into some sort of clear, actionable features in a couple of minutes. That's the sort of leverage you hope to get from skills and tools in this agentic workflow. If I were building an app a year ago, I might be intimidated. So I was asking you, it's a big query and doing these sophisticated queries, ETL pipelines, that's not my wheelhouse. But you're showing how using these skills and MCPs and tools, a lot of us can just get different work done, which is pretty wild stuff. And that data agent kit, should check that out. It's all managed. All those skills and MCPs get updated. You get the latest and greatest whenever we improve that. All right. So we've debugged, we've optimized with these agent-first workflows. I think let's go up a notch for that final demo. How do we think about an agent-first remediation, actually detect and fix problems?
Yeah, I mean, nobody wants to get, we all know crashes happen at any time, right? Like right now, there could be a crash at somebody's app right now. I hope not, but I'm pretty sure there is.
Yes.
And nobody wants to just drop everything that they're doing, or if it's in the middle of the night, Christina might be up at 3 a.m., but not everybody's going to be up at 3 a.m. to debug these issues. Nobody wants to be debugging. So what if we did all this stuff manually? And by manually, now I'm talking about us anti-gravity and doing it. It was faster, but we don't want to do that, right? We still have to go do it. So what if we did all of that 24/7 autonomously without us even watching? So we decided that we were going to build a self-healing system. So introduce to you our Dino agents. These are our custom agents, and of course they're called Dino agents because we have a Dino game. It got to go with the theme. And so these are our Dino agents. There's the remediation agent, the CI agent, and the CD agent. These are 3 custom agents that we built, and they all specialize in different tasks. We hosted these agents on Cloud Run because this is where our DinoQuest game is hosted as well. So by having it on the same platform as our actual app, we're able to get a secure, low latency, and cost-effective architecture. And this shifts all our manual troubleshooting into an intelligent and scalable assistant. These dinos, these agents of ours, use the Agent Development Kit, ADK, as our framework. And by using ADK, it saves us from writing a custom boilerplate for state management, tool routing, and retry logic. We also take advantage of ADK's skill toolset to be able to get the Dino's expertise, because we're able to load custom domain playbooks in order to codify all of that knowledge that they have into a repeatable workflow. And what's nice is that all of these agents are production-ready, observable agents. So we're going to see all our agents in action later, but let's focus on our first agent, the remediation agent. Our remediation agent is an always-on SRE and is able to catch and fix failures on its own and fix the root cause. So the way that it works is that our app is always going to be logging into our cloud logging. And that's by default, right? Whenever it sees an error, it's going to trigger our event arc and our pub sub. That is going to wake up our remediation agent, and our remediation agent is going to go and investigate the issue, and it's going to go fix the issue using Gemini. So after all of that is done, the remediation agent does its job, and it's going to go and open a GitHub PR with the fix, and it notifies you with Slack. So all you have to do is, oh, I got a Slack notification. You don't actually have to be at your computer. You could actually have it on your phone with your Slack. So all of this is an asynchronous, event-driven process that turns every error into an actionable job.
Awesome.
Do you want to show them how?
Exactly. That's how the agents work.
Yep.
So while you two are, talking right here, I deployed our Dino agents into the system, right? So, sorry, Richard, I have to break your app again. Again.
Just
Sorry.
back in my good
I love
graces.
breaking things.
All right.
I have to do it. So let's head over here and start breaking the system, right? But this time, I think we'll be fine because we have the Dino agents, right? So if we come over here and look in here, this is, by the way, there is a little code right on the left-hand side where you can see our Dino agents are working, right? So let's see. Looks like our system is working hard, trying to
It's working hard to crash.
right? Right. It's working really hard to crash.
Your 3 a.m. system looks like a fever dream.
I know, right?
That was pretty intense looking.
Ooh, looks like it didn't crash for some reason.
No?
Nope.
You can't break it on purpose?
I don't know if I can. Maybe it's trying to self-remediate.
Yeah, maybe it already helped and self-remediated while you actually deployed the agent.
Right, that's okay. So
learning.
we'll see how that goes. So, did the Dino press? Okay, perfect. It died.
It died.
All right, sorry,
Poor
thank you.
dinosaur.
So what you're seeing right here, feel free to watch this live. It's right here. This is how the agent works. So you have the remediation agent listening to all the problems. And I'm kind of just visualize it for you right here. So the remediation kind of comes up and work, and it figures out, your system kind of just crashed. So I'm going to help you remediate it. So that's why it went off and remediated. But not only it does that.
Yeah.
Remember what Denise was talking about, like it went off and fixing the code, right? So it went off and fixed the code. Not only fixes the code, it actually pushes things into our GitHub repository, right? So as you can see here, so I don't know, because our agent right here, you can see now, hey, it kind of breaks, right? So you can kind of see creates a leaderboard PR, so it tells us exactly what went wrong, right? It's cool. And it tells us, since something went wrong, I'm going to help you fix it. So it even creates a very nice branch right here that tells you, in this particular instance, this is the code that was fixed for you, right? So very nice. And in the Slack message, I'm also getting a message coming from the DinoQuest, which kind of tells us exactly what went wrong. Perfect, awesome. So I hope you are following us at this moment. So see, these agents are working. Did you see when you were looking at the monitor? Did you see that the agents starting to dance with each other?
Yeah.
That's the part where we have the A2A. So we are not just having one single agent. We have multiple agents. They're trying to work together. There you go. See that? They're working together.
Is that what that is?
That's
Yeah,
that's why I have the
that's-
swarms of agents working
that's intense.
together. See, they love working
Simmer
together.
down, agents.
Exactly. Perfect. Yeah. So that's it, Richard. So this is what we have so far.
Yeah.
As you can see, we have our agent. This is how it's built. So all this dancing, funny agents and all that kind of stuff was built with ADK.
Yep.
And also, it has everything that you need in order to make it secure. So every agent inherits IAM securities. So my CI agent doesn't go off and deploy things, and my remediation doesn't have access to build my image. So everything is inherited, so it doesn't go off and do crazy stuff. And also because we are accessing a lot of external systems, like the messaging system that we have back there, and also the GitHubs, we want to store all the secrets somewhere very secure. So this is why we're storing it in the secret managers.
Awesome. Isn't that amazing? That's awesome.
Yeah. Cool. Woo. And because of, thank you very much. I'm not impressed, but it's okay. Keep monitoring the agents. So if all the agents are deployed on Cloud Run, right?
Yeah.
And the Cloud Run, the good thing about Cloud Run is it goes dormant when we're not using it. And when there's errors, it wakes up. And after it wakes up, what does it do? It fixes bug for me. Yeah, exactly. It puts it into work, working hard for me, so I don't have to be, called in the middle of my date or my dinner with my friends. And then when it's done, it will then shut down, and you don't have to pay for it. Isn't that great?
That's the best.
So, I know money is great. I know all of you care about money much, but I'm pretty sure a nerd like you and hopefully me and hopefully you really like to see how agents are built, right? So this is one of the tools I want to introduce to you. That's how I built my agents. I built everything from ATK, and building from scratch is never easy, right? So you want to have some kind of tools to help you to how to build this. And I'm using something called Agent CLI. The Agent CLI, okay, let me put it on the top so everybody can see it. This is typing live, right?
Make it a tad bigger for everybody.
Yes.
Could you zoom in a tad? There you go. Thank you.
All right, so this Agent CLI it helps us to build, govern, also scale and optimize our agent. So do you want to see how I build agents? Right? Cool.
I do, yeah.
Awesome. But we don't want to be here all day, so I'm going to show you how to get started. Unless you want to stay here with me all day. Yeah, I'm sure. So let's create a new agent. And what do you want to call this agent?
Well, since we have dinosaurs and have this dinosaur theme, let's do a T-Rex agent.
You like the T-Rex name?
Yeah.
You don't want to spell
We're going to have to
brackets
think about what the T-Rex
I don't
agent is going to do, though.
We'll figure it out. We'll vibe it. Anyway, so code agents, since I feel like I've been talking for a long time, so let's just go ahead and create a prototype. And then let's go ahead and create, yes. So what it will do is going to create a boilerplate code that has everything there for me. So if you head over to T-Rex, and then let's see what's inside the T-Rex, it actually creates a lot of the things for me already. So it creates an agent code right here. So if you can kind of quickly see what's in the agent. So you can see it creates an ADK code. It shows you what is in agent. It shows you how to build an agent with instructions. So this is how your agent should behave, and also a lot of the tools that you can include in your agents. So it's all there for me. And as well as it includes all the tests. So I can use it to test and evaluate my agents.
Great.
Yeah, isn't it great? And also, we also have all the files needed to containerize it so I can deploy later on. That's great, right?
Amazing.
Awesome. So now we have all the agents ready. Let's go ahead and hand it back to you, Richard.
Yeah, so Agent CLI, check that out. Free, easy to use. You've seen Data Toolkit, a lot of these things, easy to use, tap into. So more than that, I want to highlight this. This is something you all have been asking for a long time. I'm sorry it's taken a while. But how do we make sure we have more control over our cloud cost spend? So coming very soon are these spend caps. These are in private preview, but these help you set and enforce budgets on the APIs for things like Cloud Run, Gemini APIs, and more. And what happens here is these particular caps pause traffic once your budget is reached. So you can't blow it up and then wake up in the morning and destroy your budget. So we're going to add this to more and more services, give you more confidence that you're not going to destroy your spending plans. Pretty good stuff. All right, so this was some great engineering. Agent CLI is pretty awesome as well. It's opinionated. Like you saw, it had a set structure for evals and certain code, so all those sorts of things. You can still customize that as you want. But now that we've stabilized this game, is it completely bonkers that maybe ask for another feature, another level, or something like that? We can do that, right? So can we ship this code on another branch and ship a new feature of the app? I'm not scared for you to do it because it keeps breaking, but we can try.
Why do you keep on asking her to do extra
I want to keep testing her. Raise the bar.
So yes, we definitely can. So we created our own autonomous CI/CD pipeline. You kind of already seen a lot of the details earlier, but before we're going to get into the details, CI/CD pipelines take a little bit of time. So we're going to kick it off first, and then we're going to talk about it. So this time, I'm actually going to kick it off on Slack, which means that I can kick it off at any time, anywhere. So here, I'm going to go in and do CI agent, run CI on branch level 2. So I'm going to kick it off. Oops, let's go show that at the bottom. So we're going to go on and start running this. But so what we did is that while this is all running, we're going to look at the details. And what we did was we had our last two agents that we showed earlier. We have our CI agent to be able to do our continuous integration. You want to go next slide?
Yep.
And so we have our CI agent with a continuous integration, and then that agent is supposed to remediate all of the issues that it has, as well as doing a security scan, as well as testing. Then we have our CD agent, which is our continuous delivery agent, and it deploys the app, it learns the deployment patterns, and it does monitoring with auto rollback. So if there's any failures with the deployment, it's going to roll back to make sure that our app is in a good place. So all of these agents talk to each other with agent to agent, A to A. And this almost makes it where it's like a team member collaborating. Rather than one agent telling some general agent some message to tell the other agent, it can actually talk to each other like normal human beings. We can also communicate with Slack, as you see. We were able to get notifications. We're able to kick it off from the pipeline from Slack. And we're using the Slack webhook that's available. And this, unlike static pipelines, these agents are very intelligent, and it can actually make decisions for us, so we don't always have to tell it what to do.
Cool.
You want to show all that?
Of course.
Yep.
And these agents were the two agents that we built so far, right? And there could be more agents in your environment. And if you want to put them to work together, you need to know where they are.
Yep.
And this is where we have the agent registry. And this is where we have, looks like our agent doesn't have a lot of friends. I mean, we'll give them some social work, maybe sometimes skills later, but these agents, we have 3 of them: CI agents, CD agents, and our SecOps agents as well. So if you look into it, so if you look into the registry, so these are the friends, and it tells you how to locate your agents, where do they live, how do you call them. And it also provides a personality, like knowing what this agent does, right? So this description of what this agent actually thinks and how it processes things. Not only that, it also provides you with all the tools it has access to. So now, if I want to use this agent, I know what other things I can do with this agent. So it gives you much more clarities onto things that you use and to do that.
Awesome.
Perfect.
Yeah.
Right here, so awesome. So if we look at our CI agent, right? So our CI agent is right here, and what it does, it actually takes in notifications, and it takes in things to do from my other agents. So it communicates with A2A, right? And it also takes messages coming from Slack, and it also uses a lot of things together, right? So it takes in decisions, it uses the skill to think about things, and then what it does, it uses this information that's given from the Slack messages from the other agents. It will determine if I want to run what kind of test. So if you have a lot of front-end code, it will do run front-end test. If it does, change some things, it will go through security, right? So that's what it does. So it's smart. It doesn't do a traditional pipeline, which just kind of does 1 and 2 and 3. It's not sequential because it thinks for itself. And then it's going to use a lot of the Google very well battle-tested services, like Worklog build that helps us to build images, and also artifact registry to help you hold the images as well, right? And after it's done, it's going to send the notification or message to the CD agent, and the CD agent is our release manager. When I was kind of coding this, when I was having fun with like running all these 3 agents, kind of they're running together, actually there's once where I made a small mistake, and the message, I accidentally deleted one of the revision, and the CI agent was telling the CD agents like, can you please deploy this image that doesn't even exist? You know what happened? The CD agent actually went back and tells CI agents like, hey dude, what do you mean? I haven't seen this message. And they went back and forth until they figure out what's wrong. And the CI agent reran the whole thing, and the CD agent eventually does the release. So it's very smart. I was very surprised. And you can see them kind of doing the dance back and forth as I was testing the image. It was super fun.
Oh,
so the CD agent gets it, sees the changes, look into all the changes in your code, and it decides on the risk score. The risk score is on how much what's the risk of deploying that into the environment and things can go wrong. So it will use that score to actually determine the canary release. And it will monitor this for a duration. And since this is a demo, we'll look for like 30 seconds. And then we'll deploy everything into production. So that's the whole process of our CD pipelines.
Wow, that's a pretty cool system. It's learning. It's scaring me, but the system learns. Yeah. That's great. So we showed that live, right? Throughout this session, we've seen examples of agentic tools doing different steps we see here. We plugged this into anti-gravity thanks to MCPs, thanks to skills, pulling in live log information, doing database queries. That's amazing. Now you can build your own agentic workflows. We showed you with that agentic CLI, agent CLI. You can build your own things here. And I don't know, we won't always spend all of our time on day 2. So if we can use these tools to use the platform that backs our agents, it just makes life a lot easier. So all the problem solving that we love as engineers hasn't gone away. It's just shifted around. We're doing design work, we're planning work, we're interacting with the systems. I think that's pretty amazing. So enough talking. Level 2 is shipped, right? You shipped it?
It's there.
All right. So if you scan this time, we can see who can play now in the apparently terrifying volcano for these distressed dinosaurs and see how this works.
You have to pass level 1 to get to level 2.
I got past level 1.
Yes, you have to pass level 1. Getting through level 1 is hard.
Shortcuts.
Yeah.
Left, right,
Yeah.
BA start. No.
We should have coded that in.
Awesome. So you can be playing that in your free time. But look, if you want to incorporate these 3 agentic workflows in your own applications, you can scan these QR codes and actually follow the tutorials, which has all the code that we demoed today. How awesome is that? They took everything they built and put this into a lab that all of you can run yourselves. So I'll keep that up for just a second. Because again, this shouldn't just be something we all watched here. It should be something, let's go try it. This whole event is about getting hands-on, building the confidence to go do some of this ourselves. So take advantage of those code labs and see what you can do. So let's go build. Let's go have some fun. And thank you for joining us today and staying cool.
Welcome, everyone. Hi, how are you doing? Okay, that's more like it. How's the energy in the room? I'm Shmonika Kashkaida. I'm a group product manager with the 1P team here at Google. And you might have seen Anshul early this morning.
I'm Anshul. I work on anti-gravity.
Awesome. And we're going to tell you all about what's new in Google AI Studio and anti-gravity. Just right before us, Amar and Paige, they walk you through all the experience in Google AI Studio. And now we're going to go one step deeper. Does that work for you?
That'll be fun. I think you're going to get started.
Let's get started. Are you guys ready? Okay, awesome. So at Google DeepMind, our goal is to build AI responsibly that benefits humanity. And everything that we do is always with this goal in mind. We always want to make sure that everything that we build, from the models, from the products, from the services, they always benefit everyone, and everyone has a positive experience with our technology, regardless of where you are at, where your language, anything. And with this very ambitious goal, we do so many different things at DeepMind, and we bring all the best and greatest to the market, and we now live in a very special time, where you can build anything. And in these times in which we can build anything, the rules of software development have been rewritten. The what and the how are changing dramatically, and how you react truly matters. And this is why at Google, we built a stack and we built an ecosystem that allows you to have tools for every different types of experiences that you're trying to build. And we have this very robust ecosystem that allows you to go from exploration to development to cloud deployment very seamlessly. And our products are always powered by the latest and greatest model innovation. So Google AI Studio is becoming a one-stop shop where you can find the models in the playground, agents, the build experience. And I'm going to show you that in just a second. But now we're building more of these product integrations. You've heard about the Google Workspace integration coming to AI Studio, the Cloud Run into anti-gravity. So more and more, the Google ecosystem is being built in a way that provides you with a solution, regardless of what you're trying to build. And we typically say that Google AI Studio truly is the fastest way to go from the fastest way to go from prompt to app, and it truly is like that. And I'm going to show that to you in a second. This is what Google AI Studio really is and what it looks right now. And it has evolved so much. Just a few years ago, we were showing Google AI Studio, and it has evolved from being a playground where you could try and test the models and the different capabilities, to now being a place where you can try not just your ideas, but you can also deploy your apps into Cloud Run. We've been bringing more of these product integrations, like I mentioned before, with Google Workspace, but also with Cloud Run for one-click deployment. And more, we are building a product that is very robust and is tailored and catered to you, so you're able to build anything that you want. And the team is building at relentless pace. When we say this, honestly, you have to trust me. Everything happens so fast. We're shipping new things almost every day, it feels like. And I just wanted to bring this list of all the things that we've announced here at I/O, just so you can see the sheer amount of work that goes behind these products that we all love and use on a daily basis. From the mobile app to direct deploy to the Play Store, to the Google Workspace integration, to the Google Anti-Gravity coding agent. There's just so many things that are coming every single day to our products. And a lot of that is a result of your feedback, the developer community, that tells us exactly what to improve and how we should keep improving the experience for you. But better than showing it to you on a screen, why don't I go on my laptop and show it to you how it actually works in the playground? Does that work? Okay. So let's do this. If we go to the playground, if you go to the laptop, okay, there we go. So this is what Google AI Studio looks like. And Paige and Amar, they gave you a very in-depth overview, so I'm not going to bother you with that, but I just wanted to show you the playground where you have our models, our new agents, and we have different agents coming to Google AI Studio. For example, one that I really like is the data analyst, and is the data analyst. There's a bunch of others that you can try, the customer support, the document processor, so many different agents for whatever use case you're trying to do. Now, this morning, you might have seen Josh showed Louis Cinnamon on stage. Do you remember? Yes, okay. So I was really inspired by his story and how he has to find a pet hotel in order to keep his pets safe while he's on holiday. So I had an idea. Why don't I actually build an a new business. And so I thought, I'm going to open a pet shop, and I'm going to have a place where we can have all the pets coming in and spend time at the hotel. However, I don't know anything about the pet shop business. Do you guys know anything at all? Anyone that can help me? No? Okay, good thing that we have agents in AI Studio, because I am going to ask for their help. And so I already have a prompt, which I also refined in Gemini app, and it's a prompt that is, I'm going to ask the research agent to do a bit of market research to see if my idea is actually feasible here in the Bay Area. So my prompt, I'm going to ask, you are a premier retail market research analyst specializing in the San Francisco Bay Area, Silicon Valley commercial landscapes. I'm planning to open an independent brick-and-mortar pet shop in the region. I want a comprehensive deep research, market analysis, and then I specified everything that I wanted the research agent to find. Target demographics, micro-markets, correlate pet ownership with demographic data, inventory strategy, recommendations, and everything. So I'm going to just basically paste my prompt into AI Studio, and I run this early today because, you know, Wi-Fi and live demos, and I have here, and this is basically what it looks like. I gave it my prompt, I saw the thoughts, I approved the research plan, it has all the specifications that I asked it to search for, and now it has given me a very, very in-depth report with step-by-step exactly of what I should do. Now, this is just one example of the deep research agent, but if you come here to this section, you have the max preview, which is better for overnight tasks, but you also have other types of agents that you can pick and choose, and everything is just available within the same section of your model selection. Now, let's say you want a very quick analysis instead of something that is actually very, very time-consuming. You come here to system instructions, you pick the persona that you want the model, the system instructions or the persona you want the model to impersonate, and you add a description. You can also add constraints, and they will do the research for you. So I click this one. I'm just going to basically paste the same prompt, and I will just let it run, and it's going to run for a while, which is absolutely fine. So while the agent is going to show its research, I keep thinking, okay, now I've done my research. It's a good opportunity to open my pet shop in the Bay Area. What should I do next? Find a place. Okay, that's a great one, but how will people know that I have a pet shop? Website. Someone said website. Okay, wonderful. Wonderful idea. And here is my website. Let's say that I went back home, started working on my website, on my inventory, and this is exactly what it looks like. What do you guys think? Now, fun fact, all these pets that you see on screen are actually our pets. So you can see Josh's dogs, you can see my little John, that's my pet. So this is all built with pets from Google, so I think it's like the most wholesome moment of I/O. And this is what the website looks like, very, very basic. What do I need now in order to improve my website? Come on, guys, feedback. We're developing a new product, we develop a new business, we need feedback. How can I get feedback very, very quickly? Okay, I'm going to show you. So this is what a new app that is coming to the Google AI Studio app section is coming very, very soon. And this is what it looks like. This is probably one of my very, very favorites. You can remix this app, and what it does is an agentic focus group. So it uses different agents to impersonate different types of user segments and audiences that you may want to attract with your own business. So this is extremely useful if you have an online business, if you are a startup, if you are a builder trying to identify your niche audience. You can basically, with the remix, just adjust where the persona might be within your business. For the purpose of this demo, I'm just going to keep like a skeptical CFO, a UX lead, a status seeker. So just very like generic personas. But I'm going to get my website, and I'm going to run it with my agent focus groups. And now while it's analyzing, it's going to basically give me a description, what's the sentiment analysis, what do they think about my website, and so I can tailor all these different, I can tailor what they tell me and get that feedback into the next iteration of my website. Now let's say I want to keep building my website. I already know, like, it's really cute, but it's not the very best one. A very cool thing that I can do is come to Stitch, and Stitch is perfect. I can just say create a landing page for my pet shop in the Bay Area, and let it run. It will run and come up with some design examples, hopefully. Maybe not. There we go. And if I'm happy with one of the design examples that Stitch came up with, I can simply export it into AI Studio, and I can keep building with AI Studio. So when I give, and it opens directly in the Build tab, and I can now say, build me an app with the screenshots that look like this, and it will just build a new website for me that is based off the Stitch designs that were based on my initial idea. So that's something really cool. Now I'm thinking, okay, so I've done my market research, I have my website, I've improved my website with my agentic focus groups, and this is what it looks like. So if you go here, you can see the analysis, the sentiment, the match radar for each one of the personas. So let's see, the busy executive says, while heartwarming, the current site forces a high friction, time-consuming adoption process, so things like that. And as you can see, it just changes based on the persona that I'm choosing. Okay, cool. So did my market research, built my website, improved it with focus groups. I wasn't really happy, built something new with Stitch, exported to AI Studio, kept on building. Okay, I think this business is going to be successful. What do you guys think? Oh yeah, okay, great. Now, what am I missing? Inventory, thank you so much. Now, my inventory. I've been doing my inventory in a kind of a basic way. I've been using a Google Sheet, and I have all the IDs, the different names of the pets, the animal type, the breed. I added pictures, but those pictures are also in like a Google Drive. I have the health status. Okay, it is good, but it could be a lot better, don't you agree? Wait a minute, Google AI Studio now allows integration with Workspace. How about I also build my next inventory management dashboard with Google AI Studio? Let's do that. Okay, so I go here, I go to the Build tab, and I say create a dashboard for my pet shop and allow for integration with Google Sheets for inventory management. Okay, and now it's going to build. Now, as you might have guessed, I have already preloaded it beforehand, so I'm going to show exactly what it looks like. I've given the model the exact same prompt, and I kept on iterating it just a little bit. So I improved some of the color scheme, so it would be a bit more on brand, based on the feedback that I had received from my agents. And while the model is thinking, it had asked me to integrate with Google Sheets. Let me just go scroll up, so I can show it to you in the history. Okay. Cool. So now let's give it a try, see if it works. It does. Awesome. I now have an inventory management tool completely integrated with Google Sheets, with Google Drive, and I can see the total number of pets, the number available, adopted, the health status. I can see the asset gallery, and I can basically manage all my different animals here. If I see something that is not right, so for example, if I try to find John, John is not available. John is my cat. I want to change that. Okay, move it to adopted. And the cool thing is that you have real-time updates both in the app and in the sheet. So if you change something here as well, needs checkup, it will change in the app. It will change in the app as well, which is really cool. Okay, I've done everything. Research, website, improve the website, build a new one, create an inventory management. Now my last step. What is my last step? Finding clients. Okay, very cool. So I go to AI Studio again because I'm like, okay, I need a strategy, and I don't know how to build that strategy. And I'm going to ask the model, create a marketing tool to help me with go-to-market for my pet shop. Give me 10 CTAs and help me optimize ads. Cool. So now the model is going to run my next prompt, and basically has just given me this result that looks like the dashboard that I want for my go-to-market strategy. So I can literally just come here, get the link of my website, and I am going to turn this into a growth strategy that allows me to then literally create any type of marketing assets. My hooks, my visuals, it can integrate with Nana Banana, with Veo, you can create a brand identity, a logo. So literally, Google AI Studio is becoming a one-stop shop for startups, for builders, for small businesses. You can manage and create an entire business, as I just showed you. And now I have my growth score based on my current website. I have a friction analysis, I have SEO and metadata analysis, all my campaigns in just one place, plus my ad simulator ready to go, ready to ship. Okay, so this is what I had to show you in Google AI Studio. There are a few very cool things that I would highly recommend you to test after I/O. Agents is definitely one of them. Customer support, data analysis, research, and anti-gravity in AI Studio. And then some of the new focus groups that will help you take your business to the next level. And one very cool thing that we brought into AI Studio is the integration with anti-gravity. And Anshul is now going to show you everything that is new with the anti-gravity.
Awesome. So give Joanne a round of applause. Cool. So I'm here to tell you a little bit more about anti-gravity. You probably heard about it a little bit throughout the keynotes today morning. But really was going to spend some time here today to give you a little bit of a kind of thought process as how we designed a lot of the new features in anti-gravity. But the big announcement today morning was anti-gravity 2.0. So when we released the anti-gravity IDE back in November, it's shockingly only been 6, 7, 8 months, something like that. We introduced it primarily as an AI-powered IDE. But in the anti-gravity IDE, we did have a second service. We called it the agent manager. And it was kind of our view of what would the world look like in an agent-first kind of world, right? If you think about it, if most of the time your agent's doing most of the work and your IDE is 70, 80% not your agent, something seems off. And so we started designing what does it actually look like. What happens when the entire UI starts focusing on the conversations you have with your agents, the management of all of your agents, and any kind of artifacts and communication that the agent does with you. And we're like, okay, we'll put it there. We won't make that the primary service. Let's see if people actually enjoy this, right? This is long before these kind of agent-first kind of paradigms became popular. The short answer was yes. And so it became pretty clear to us over the last few months that what we need to do is separate out just that agent-first service into its own standalone application. That allows you to just deal with the agents. And if you want to code with anti-gravity 2.0, you can use any IDE of your choice. But if you want to start using anti-gravity for more and more tasks beyond just coding, which you all have, now you have just one place, which is just truly dedicated for that. And so that's really what the end goal is, to build the agent-first platform that's built for the next era. And, okay, show of hands, how many people are a little bit tired hearing the word agents today? A little bit? Okay. I'm not going to make it any better, so I'm sorry. I'm going to talk a lot about agents, but really, how do we think about working with agents in a way that you can get the most done, you can stay focused, while also keeping security and permissions and all these things top of mind? We launched a lot, so these are all kind of like brand new things that we launched today. I think you guys found it a little bit exciting because you all took down our authentication services, but just how many people are trying to log in. It's all fixed now, so if you got some issues that way today, try again. Apologies. But there's really a lot that we're trying to do, right? We're trying to improve the core agent, the primitives that it has to do more powerful work, more quickly and more efficiently and better. But then we're also thinking about like, how the UI should actually evolve, so you're looking at agents and managing them appropriately. Because really, we believe in a world where you will have n agents working together across X different projects, and that's a completely different way of working. And hopefully that helps everyone and multiply what their output looks like. And then we added a lot of nice fun product features as well. So I'm just going to take you all to the laptop. Now, I'm not going to spend a whole lot of time actually kind of like, trying to build something. I'm not nearly as, good with that live. I think it's going to take a little bit more time than Joanna did. There is like a 20-minute demo that Kevin, my co-presenter during the dev keynote, put together that's online. That will show you every single feature in action. But what I really want to spend today is kind of walking you through the anti-gravity 2.0, showing a little bit of the lay of the land, and some of the design decisions that we took in so that you can get kind of internal kind of understanding of how we thought about building it, and therefore how you can actually get the most out of it as well. So as you can tell, I'm not sure, but anyone, does this look like an IDE? No, not really. Yeah, this is the kind of minimal kind of entry point to anti-gravity 2.0. It's you, your agents, and the conversations. So to kind of get started, this is like kind of a brand new laptop, so I just started a task earlier just to be able to highlight some of the pieces here. So in the middle is your conversations with the agents. Every agent, every conversation, you can have it, multi-turn, all those things. On the right, there's the side panel that has a lot of different pieces here, and I'll kind of walk through some of them. The first part here is sub-agents. So this is something that we newly added to the product. The reality is people are trying to do much more complex tasks with anti-gravity. And if you have one agent that's trying to do all the work, right, you might give it a much larger kind of vague task to go out there, and we've all seen LLMs get a little bit confused if it's trying to multitask itself. That's common. So what we want to do is make it possible for that main agent to itself determine that, hey, I have this well-scoped task that needs to get done. I should just hand that over to a sub-agent that's just focused on that one specific task. It can complete its work, and then it can report back when it's done with any kind of outputs that might be interesting for my main conversation. And why is this nice? It allows the main agent to stay focused, right, on whatever kind of big, large, vague task you gave to break it down. And it allows the sub-agents to be really focused, and it also allows for parallelization, right? If you have n tasks that could be done at the same time, might as well do them in parallel. Actually, let's kind of show this in action a little bit. So I'm going to just start a new conversation. We'll open up in a new project. So I'll talk about projects in a little bit, but you can also just run your own standalone conversations if you have that kind of idea on the side that you want to do it. I'm going to be pretty explicit just so you can see the sub-agents in action. But I can say, spin up a couple of sub-agents to tell me all the things launched in Google anti-gravity at I/O. So hopefully, if this works and the demo guys are with us, yeah, there we go. So what you just saw here is, really quickly, a couple of sub-agents being spun up, as I pretty explicitly asked in this kind of example. And if you actually look and you can click into them, you can kind of see what was that prompt that the main agent passed into the sub-agent to do, right? It will all happen in parallel, so I can go back to the main agent. And as you can see, the sub-agents are reporting back to the main agent, hey, I've just finished my task, here's some information as you asked me to. And the main agent can now take that information and synthesize that together, right? So this is a really simple example of sub-agents and actions. So that's not the only place that we try to improve the core agentic experience. The second one is we realized that okay, you're starting a new project. A lot of time actually spends in commands like installing packages, right, or doing updates. And your agents do all this exciting work, and then like boom, you're just waiting for 5 minutes, right, for all these packages to install or update. It turns out there's a lot of tasks like these that are just long-running commands that can actually happen asynchronously in the background. So asynchronous kind of processes and asynchronous task management is now kind of core primitive within anti-gravity. So I want to see whether or not that actually happened in this conversation I had over here. Let's see the work. Yeah, so you can actually see like running these installation commands actually happened in the background, and once it was completed, it kind of reported back that hey, this background task, this background command got completed. So this also will allow your agents, just like sub-agents allow you to parallelize. This is another kind of core primitive that we've added to make sure that your task can get done quicker. In fact, these two things actually compound with each other. Right? You can imagine the agent launching sub-agents in the background. It can do its work while it can continue doing its work. So actually what was happening here, if I remember correctly, all the installation was happening while the main agent was writing the code. And so by the end, the packages are ready, the code is ready, I can actually do that, just like that. Right, so these are some of the core primitives that we're bringing together. The third kind of core primitive that we added to agents was this idea of hooks. So these are kind of programmatic pieces that you can actually have your own custom script. And this is all defined in a JSON file, it's all in our documentation, where you can actually tell, hey, every time before you run this specific tool, or before you stop your turn, make sure you run this script. So what's a really good example of this? Maybe after every conversation, you want the agents to run some kind of validity checks that is specific to you or your company. You can define that in a custom script. You can register that as a hook for that stop command, and it will make sure that the agent will make sure that that's actually always called programmatically. So this is actually ways for you to be able to inject your own custom logic into the agent's behavior. So a lot of kind of abstract topics, but these are all ideas that we've actually tried to bring into Anti-Gravity 2.0 so the agents are more powerful in this space. So that's some of the agent pieces. But let's talk a little bit more to that. I was kind of going through this right-hand panel a little bit. We talked about sub-agents. We talked about background tasks. Actually, the NPM run that is still running, so you can see that that's up. What we also show is what we like to call artifacts. Right? These are essentially, if your agents are running for longer and longer by themselves autonomously, we want to make sure that they can communicate their progress to you in ways that you understand. Right? You can already see me kind of go through this conversation. I was like scrolling through, I'm like, what happened in this whole conversation? What happened where? It's a lot of text, and it's a lot of tool calls, and these agents are doing a lot. So that's not always kind of the best view into knowing what the agent did. So artifacts are essentially these ideas of, there could be markdown files, there could be code changes of, hey, this is something that I actually want you to look at that will actually tell you a little bit about what I'm doing, so that you can build your trust in the agents and you can know that the agents are going in the right directions. So for example, at the very beginning of this kind of task, it generated an implementation plan, right? So this is like, hey, this is what I'm planning to do, all that. The nice thing about all these artifacts actually is that you can comment on them. So whether they're text artifacts, visual artifacts, like screenshots, and that, you can leave comments. So this is kind of one where it's like, hey, this is my plan, this is what I want to do. If you're like, actually, no, instead of trying to battle with the agent back and forth, there's just some small nuance you want to do, just leave inline comments, and the agent will incorporate that as it continues doing its work. So this is kind of one way for you to kind of guide the agent. Other things happened, kind of had a walkthrough after it was all done, a task list, and of course also change some files, right? So I can go through all the files that changed. And one thing that we did in Anti-Gravity 2.0 that wasn't there in the agent manager and the IDE is that we made it a pretty easy flow to actually review your code also inline, right? So write some code, if you really want to get in there in the nitty-gritty, the entire review flow is now directly in Anti-Gravity 2.0. Cool. So those are some of the kinds of things on the right-hand panel, which is really your way of investigating into that agent conversation and knowing what's going on. But as I said in the beginning, I will say agent a lot. Our goal is that you guys are actually running many agents in parallel across all your projects. Maybe you have multiple ideas. You have the app that Joanna built. You brought it down locally and into Anti-Gravity, and you're like, actually, I have this idea, this idea, this idea. Our goal is that you should be able to fire all these agents in parallel, and it should work. So we spent a lot of time actually redesigning what does this left sidebar look like. It might not seem like a whole lot, but there's actually a lot of kind of ideas here. The first is this idea of projects. So historically, we had kind of agents tied to repositories. That was kind of the core primitive, right? You have a code repository, an agent that works on it. We decided to actually broaden that a little bit more. So project is kind of just a general purpose collection of resources that an agent can work on and you can apply permissions on. So what do I mean by that? I have like 2 app projects, I can go to project settings. You can actually connect multiple folders to the same project. So if you actually want your agents to be working across multiple repositories, you have a microservice-based system, whatever it might be, that's actually really easy. You now don't need 2 agents in the 2 different repositories to try to work with each other. You just create a project that actually allows those particular agents to access those extra repositories at the same time, and it'll be able to make edits across all of those. The other thing that we ended up doing is we ended up creating projects so that you can define settings and permissions at the project level, right? I think we all know that we've probably all seen things online of agents kind of going wild, deleting a bunch of things that you can expect to delete, and like how did I end up in this world? And really a lot of that boils down to that as your agents do more and more work, it's very natural for us to be able to just give more and more permissions to your agents. Right? Actually, stop asking me to approve every single one of my commands, which is the default kind of behavior for all these agents. And next thing you know, all your agents can do pretty much anything on your computer. As you probably guessed for how I framed it, that's not the most kind of secure way of going about building with agents. So what we're allowing to do with projects is for you to be able to define those permissions and settings at the project level. So that means only the agents within this project have these kind of scopes that are permissions. So you can specify which kind of files that you actually want to allow to access outside of the folders that you've connected it to. What are the kind of different review policies, the terminal commands. So for example, like you can say always allow these kinds of commands, never allow these other kinds of commands. And if you're working in repositories that you know have more kind of critical code, you might give fewer permissions and want the agent to ask you more frequently every single time it wants to run a command. If it's just kind of your to-do app, like here, you might say go wild, build something as long as it's not like RMRF or something like that, right? Like you'll give it a whole lot more permissions. So this is kind of the direction that we want to go to. This kind of core primitive of a project that we're introducing that allows you to kind of have group agents in ways that aren't just necessarily particularly tied to a single repository. It's actually tied to a whole lot more. So a lot of stuff to kind of explore here, and all the customizations, your MCP tools, your skills, all those things you can attach, and you can kind of see a breakdown of how you're using your tokens within the system prompts efficiently. Cool. All right, what else do we want to show around here? There's a bunch of other kind of fun little tidbits that are within the product. As you probably saw on stage in the developer keynote, there's now live audio transcription. I will say I don't think maybe every single Google Office has been well designed for everyone talking to their computers, but that's gonna be reality, I guess. But it's, I think there's research that talking is like 5x or something faster than typing, and so sometimes when I just have an idea, I'll just go and kind of talk to the agent. And one of the really nice things about the audio model here is it isn't just like one-to-one live transcription. It's actually using our latest audio models that will synthesize and remove all your filler words and make sure they have like kind of cohesive thoughts, so the prompts that you're sending to the agent are actually well-formed ideas. So all my ums kind of go away, which is great. Some more features that we added. Everything that I've shown so far has you kind of working synchronously with an agent, which is still a pretty important paradigm for people working with agents. But I mean, I think you guys all saw some of the stats with like Gemini 3.5 Flash like earlier today, right? It's a workhorse of the model. We've been using it internally for a couple of weeks, and it's been crazy. And on Anti-Gravity, we've been able to do further infra optimization so that it runs about 12x faster than frontier models. So we see somewhere up to like 700, 800 tokens per second being produced. So it's like you run it, and the thoughts kind of pass before you have time to look at it. So it's a really, really fast model, but at the same time, a very, very powerful model as well. Every benchmark and every single A/B test that we've run kind of internally with Googlers. And so with the kind of increased intelligence, it really got us thinking, like, okay, we're starting to definitely start moving to a world where people just want agents to run in the background for them, asynchronously. It shouldn't require me having to kick off every single agent every single time I have a conversation. In my day-to-day, I have a lot of tasks that I pretty much do on a regular cadence, right? Every morning, I will use an agent to kind of make a digest of kind of all the PRs that are open to review and like what's actually high priority, what's not, like all that kind of digest. These are kind of like really common things that we want to have on some kind of cron schedule, right? You launch a new job on GCP, you want to make sure that there's no issues, and realistically, if there are any issues, I kind of want an agent to first do a first pass of debugging what the issue is before I have to actually dive in. So these are all kind of common examples of where you want an agent to be doing something on a schedule. Kind of layer that to kind of talk about scheduled tasks. Not very clever. But that's pretty much the basic idea. The simple thing here is you just made it really simple. You schedule tasks, you enter kind of task name, like daily digest, you set the project so the agents that are spun up kind of on the schedule will obey all the same permissions and everything that you have for that project. On a daily schedule, 9 a.m. looks good. You put in your prompt, summarize our PRs or whatever, and you just add the scheduled task. And that's it. It's really that simple. And so those tasks, those agents will show up in your project as they run. You can check in whenever you want and be like, okay, that looks good. And because they're responding here, if you want to do follow-up questions, this is all conversation. You just go in there, you pick up a conversation, you continue. All right. I remember having this UI and someone's like, actually, what I really want is I don't even want to go to another panel. Can you just like have a slash command? So we introduced new slash commands. So there's slash schedule. So you can actually just describe in natural language, hey, every 9 a.m., put me digest, run in this project, and we will generate that schedule task for you. So explain natural language, don't need a form. Forms are, so I don't know, 2025, I don't know. But we have a few others that we put here. So often agents will come back and they'll ask you for feedback, like an implementation plan, something like that. But sometimes you're like, hey, just keep on pushing through. Don't ask me for feedback. Just make your best decisions and kind of get to an output when you actually think the job's terminated. That's what slash goal is for. So slash goal is like, hey, here's my goal. Just keep driving. You don't need my input. Just go for it. Slash schedule we just talked about. Slash browser. One of the favorite features when we launched the anti-gravity IDE was the fact that the agent is fully capable of spinning up a browser sub-agent of itself using the Chrome DevTools MCP to actually actuate the browser. So if you're building an app, the agent can go out, test the app itself, give you some feedback, and then take screen recordings. So slash browser essentially just tells your agent, hey, make sure you use your browser tools and the browser sub-agent to do that. Grill me is a fun one, which is like, I don't know about you, but I sometimes write the vaguest and dumbest prompts. So grill me just essentially is a way to like, hey, first ask me clarifying questions so that we get to a good point before you actually go out and start implementing things. I probably missed, honestly, quite a few features that we introduced here in Anti-Gravity 2.0. And I've not even talked yet about the Anti-Gravity CLI, the Anti-Gravity SDK, the Anti-Gravity agent, and the Managed API. So we're really trying to bring this agent and this agent harness that is being co-optimized with the Gemini models to you all in any kind of way that you find best. So if you look at all this and for the last 20 minutes you're like, Angela, I absolutely hated GUI, bring me a terminal. Don't worry, we have that covered. I just don't have time today. Try the Anti-Gravity CLI. And if you're a developer who's like, hey, these agents can do really powerful things, Gemini 3.5 Flash is a very powerful model. I want to start integrating that into my own projects. I want to do some kind of research on that. There's both, as I mentioned, the Managed agent within the Interactions API, as well as the Anti-Gravity SDK, which will allow you to actually take that same harness, but customize parts like the system instructions, the tools, all those kind of customizations of the agent, and allow you to kind of deploy that wherever you want to deploy. So a lot that's been announced in the last, 8 or so hours here at I.O., and I'm sure there's going to be even more that's going to be talked about. But I think we're roughly wrapping up on time, so I think we're going to start wrapping it up and let you guys get to the block party.
Yeah, I mean, I only have 2 last questions for you. One is, who's ready to build? Yes. And who's ready to go to the block party? Okay.
That was louder.
That was louder, wasn't it?
I don't know about that. We'll work on that one.
Yeah. I think we've seen so many cool things here at I.O. We share the latest and greatest from Google AI Studio and Anti-Gravity. As you could see, there's so many new updates and new features that we introduced today, and more coming soon as well. So keep the feedback coming, because that's how we can co-build these products together with the community. That's really important to us. I literally show you how you can build a new business entirely from scratch with AI Studio in like 20 minutes or so, and then you can take it to the next level with Anti-Gravity. So no better time than starting today.
And thank you.
Thank you so much. Thank you.
Welcome to What's New in Android Development Tools. I'm Jamal, product developer of the Developer Experience.
And I'm Tor, and I lead engineering for the Android developer tools and libraries.
Today, we're going to talk about the evolution of Android development tools. So, if you fully align to using AI agents as your primary way of developing, or if you're rolling up your sleeves and architecting every detail of your app, or perhaps you operate somewhere in between, we're going to touch on the latest updates to make you successful Android developers no matter how you develop. For this talk, I'll cover our recent roadmap, then Tor will go over live demo of the latest tools, and I'll come back for some latest updates. First, let me talk about our recent changes to our product roadmap you may have missed. Last year at Google I.O., we introduced Agent Mode, which jumped you from a development flow from just an AI assistant to a semi-autonomous agent that can generate code for you using the latest AI models. Since then, we got a ton of positive feedback from you. And based on this, the Android DevTools team has shifted how we create features going forward. We now create features for both you, as the Android developer, to be productive, plus the AI agents that you deploy in your code base. We know that for the majority of professional app developers, the goal is to publish your app or game onto Google Play and get into the hands of consumers around the world. We are continuing to invest in Android DevTools to help you be productive towards this goal. As an Android developer, you're ultimately accountable for your app code works. If your coding agent makes a mistake, or goes off course, and it impacts your business, we know this responsibility lies with you. So it's a trade-off. On one hand, you have speed, where you're weighing how fast can your coding agent generate code, and on the other hand, you're balancing accuracy, meaning how can you constantly test and validate your app code and not create technical debt. When making this trade-off between speed and accuracy, we believe Android Studio is still the best place to handle both agentic workflows and in-depth technical app development. While there are now many new ways to get started with Android development, which we'll show you today, using Android Studio is our recommended path for professional developers to scale their app across all devices in the ecosystem. So let's talk about a few feature updates you may have missed in Android Studio Otter. Off the top, we're making it easier to access the latest Gemini models right in Android Studio. For some time, we have supported enterprise accounts, now called Gemini Enterprise. Right in Android Studio, you can log in with your Google Workspace or federated corporate email address and gain access to corporate-approved and managed models via Gemini Enterprise. In Android Studio Otter, we now also support Google One, when you're developing on your personal Google account. So if you have a Google AI Pro or Ultra plan, you can log in Android Studio and access dedicated model capacity and Gemini models above the limited, no-cost default tier. For those AI power users who require even more quota above the Google AI plan user limits or need even more flexibility in model selection, you can also write a Gemini API key from Google AI Studio into Android Studio. Now we understand that we have a wide range of AI needs, and we're committed to making sure the tools of Android Studio are available to all Android developers. So in Android Studio Otter, we now allow you to bring your own model into Android Studio. Choose between a local or a remote model. A remote model selection feature is handy, or perhaps you might have a corporate mandated policy to use an LLM model. You can bring those right into Android Studio. Speaking of model selection, we now know that model capabilities are changing almost on a weekly basis. So we recently published Android Bench to help you decide which model to use. This benchmark does a couple things. One, instead of relying on generic coding puzzles or coding challenges, Android Bench is built using real-world Android tasks that you use day in and day out. Two, it drives developer choice. As LLM makers improve their benchmarks against Android Bench, it also drives a wider selection of models for you to choose from for Android development. In addition to proprietary models, this week we also added open models to Android Bench. This gives you even more choice when choosing the best model for you. Soon we'll be adding long-running tasks that might take you a day or two, and as well as agent evaluations. This way you can evaluate how various agent models perform across different other models. Learn more about Agent Bench and see the latest leaderboard by going to d.android.com/bench. Now, once you've checked out Android Bench and you need to use a local model on your laptop or a local area network, Android Studio has the option to point to a local LLM runner, such as Ollama or LM Studio. This allows you to download a variety of open, weighted models from the community. A local model we recommend with Android Studio, if your laptop can support it, is Gemma 4 from Google. It offers a couple things. One, it has native agentic tool calling, meaning it has built-in reasoning that makes it compatible with things like agent mode. Two, it's Android optimized. This model is trained on Android APIs and Kotlin programming. And three, it's integrated. We ensure this model works with popular runners such as Ollama and LM Studio. And like other open source models, you can run this local model completely offline and leverage your laptop security. Based on Android Bench, Gemma 4 provides very solid results in comparison to top proprietary models. Now, once you connect to either a remote or local model, it appears in the model picker in Android Studio, giving you the flexibility to switch between models while developing. In addition to model provider selection, we introduce features specifically focused on Android workflows and aspects that are unique to Android, such as UI. Now, many times it's hard to describe to a coding agent exactly what is wrong with your UI, especially visual elements. So now in Android Studio, you can right-click on Compose Preview and trigger a transformation right on the design surface to get the right context for the agent. For those of you who develop direct web links into your app, we have a new AI-powered Athlix assistant that helps you orchestrate the links, and then the tool uses AI to validate and connect those URLs to make sure they're working out of the box. Next, we added stable support for MCP servers, allowing you to integrate third-party tools into Android Studio's AI. We have a built-in gallery of some of the most popular MCP servers. So when you get input designs from Figma or connect to your Firebase database, you can directly connect the agent to those MCP servers inside of Android Studio. Also built in Android Studio is the Android knowledge base. This feature offers a few things. Number one, updated documentation. So as you release and document new Android APIs, you pipe those in right into Android Studio. Two, it's agent focus. You don't need to take any sort of extra work at all. Based on your question, the agent will figure out what context to use to answer questions or execute on results. And lastly, it's not only Android. We actually included Kotlin and Firebase knowledge into the knowledge base as well. Android Auto is one of the 4 small releases, plus a host of new features and stability fixes. Okay, on to Android Studio Panda. In this release, we spent time on the getting started experience. First, we added a new template for Android Automotive that streamlines the creation of driving optimized apps for Android Auto and Android Automotive. We also updated the Gemini API template, which is used to add Gemini APIs into your app. This template update includes integration with Firebase AI logic, which handles backend setup, and also minimizes the risk of leaking API key within your app. What is great about using built-in templates is that you can get up and running right out of the box without using any AI tokens. Now, if you want to take this a step further, we launched an agent-based new project wizard. With just a prompt, combined with a pay plan or API key, you can create a custom Android project that's adaptive, designed nicely with Gemini Nano Banana, with all the right dependencies. Once the app is generated, you can continue to iterate that with an Android Gemini agent built in. This release also includes Android skills. Now, this is important. Even with the latest model training and documentation, sometimes the agent needs a little bit more steering to execute on the right action. This is where Android skills comes in. We include about 10 or so skills on key developer tasks our current models fall a little short on, such as integrating the latest adaptive APIs or converting from XML to Compose. So, more about skills, go to github/android/skills. Lastly, we added agent planning mode in this release. This is helpful when you need a little bit more pre-thinking for the API model to work through for complex problems or multi-stage issues. In this model, the agent will create an implementation plan that you can review, and then the agent will execute on that plan. Okay, so that touches on the latest updates in Android Studio Panda. Similar to Otter, we have 4 releases and a myriad of consumer container releases in between. I would note this also includes a new permission model, but also have a live demo in just a bit. And this brings us to Android Studio Quail, which strikes a balance of the latest in intelligent platform enhancements, as well as refinements and product features that you'll see in the live demo in just a bit. Now, in addition to Android Studio, I'm also excited to talk about the launch of Android command line interface. We built it to be Android agent first. We found that LLMs had difficulty getting things right when building and creating Android apps. So we created this app to solve that problem. As command line tool is lightweight and acts as a programmatic interface from other processes on your system, including other LLMs, and also connecting right into Android Studio. The CLI also exposes Android skills and Android knowledge base, allowing LLMs to leverage the latest best practices and documentation. Lastly, you can seamlessly update CLI without the need of an external SDK manager. Now, we're using Android CLI to support LLM workflows. We're already seeing notable improvements in the model so far. Based on internal testing, Android development tasks were completed 3 times faster than when agents attempted the same task using only generic LLM tools. And we saw a reduction of LLM tokens by more than 70% when using Android CLI to create new projects when compared to using other generic LLM tools. So the skills package bundled into Android CLI, it's easy to add Android CLI to support a wide range of LLMs. Now, while Android Studio is the best place for professional app development, we're using Android CLI to extend and add new services for both developers and creators to build Kotlin Android apps. So for example, we just launched Android app creation on Google AI Studio, which enables you to create a quick prototype or personal app. With just a prompt, you can create a high-quality Android app that you can deploy right to your device. Now, behind the scenes, we actually ported the new project wizard from Android Studio and added CLI skills to power this new experience. And for those coming from other development backgrounds, Google Android Gravity is also a great place to start, since we now bundle in the Android CLI and Android skills. As your app grows with either AI Studio or Android Gravity, the Android CLI ensures you have an Android project that's easy and portable into Android Studio, allowing you to easily use Android Studio's and different tools to polish and scale your app to reach the whole Android device ecosystem. Okay, with these updates, we're ready to jump into some demos. Tor, take it away.
All right, thank you. So yesterday in the developer keynote, Valerina and Adarsh showed 8 new features for Android developers, and I can't top their demos. So instead, I'm going to show you something different that we're also working on. But be sure to check out those demos so you don't miss something new. All right, so I'm going to start on the command line, and we've had command line tools for Android since the very beginning with ADB, AAPT, DexDump, and so on. But we now have a new one, and it's basically a single command called Android. And like Git, it has a number of subcommands. So for example, Android info will tell its calling tool where the SDK is installed. The Android SDK tool will let it list or install SDKs. Here's a interesting command, a couple of commands, the emulator start command. It's been easy to start the emulator before, but this one will actually wait until the emulator is up and running before it exits, so you can chain it to something that then, for example, runs a shell command on the device. And yeah, sorry. And now I'm going to run Android Studio. Any guesses what running Android Studio will do? No, it's not going to launch Android Studio. This actually talks to a running instance of Android Studio, so you can expose all the cool features we have in Studio from other agents. And speaking of other agents, we now have the anti-gravity CLI. So what I've done here is I've created some journey tests. I just had anti-gravity do this as well. This is a list of steps to try in an app. And now I'm going to ask anti-gravity, actually I'm going to grab this prompt. I'm going to ask anti-gravity CLI to basically look at the files in that folder, try to run and verify that this works. And if it doesn't work, tell us what's wrong. So we'll start that. This is going to run in the background. While we do some other stuff, we'll check back in later. So we're branching out to support more surfaces for Android developers and new Android developers. So the next thing I'm going to show you is in the browser. So AI Studio, Jay already mentioned this. We can start creating native Android apps. So what I did here is I asked it to create a currency converter, which figures out the target currency based on where you are. I thought that was a really good idea. Probably been done before, but so this is now going to create a native Android app, built with Gradle, Kotlin, all of it. It usually asks me in about 10 seconds to pick a design, and it's going to run it on an emulator. I've already done this in advance, so here we got to restart the emulator. It goes to sleep after a while. But you can actually drill through all the code and let me see if it wants the design approved. Yes, here's the design approval. So we'll do that and we'll let it keep going. This is not really a place to keep iterating on your app. You have the idea, it makes the app, and you can publish it to the Play Store. If you want to keep iterating, you can now export the code, right? So you can get it all as a zip file and install it in Android Studio, or you can export to anti-gravity. So I'm going to do that. You can offer to create a bundle that has everything, and it's packaging it up, and it should send a launch command to my local anti-gravity install any second now. There it is, open anti-gravity. So here is the project that it has imported. So now we can, for example, say, critique this app, find bugs, fix them. All right, so that's going to go to. So we have AI Studio, we have anti-gravity, we have anti-gravity CLI, and of course we have Android Studio. So this week we launched Android Studio Quail 2 Canary, packed with features. We have completely rewritten the agent. We're calling it Agent V2. As you can see here, we have sub-agents and parallel tool calls and all that, and we are in the process of switching out the bottom to the anti-gravity SDK. So I've used the new project agent here to build my currency converter. And let me take you through some of the new features. So first of all, we have support for Gemma 4. So you can now go into the model provider. You don't have to install a third-party tool to use it. There's a new model provider. You can click to download the models that you want. I've installed several here, and now I can choose Gemma. And so we're going to set it to work on the task. So here is a screenshot from my currency app. There's this placeholder label, which is hard to read. So it'll say, please make the placeholder data only label red and bigger. All right, so that's Gemma. It's working already. Another new feature we have is support for running multiple things in parallel. So we can start a new conversation. Actually, we can also open it up in a separate tab, new agent tab. So we can give ourselves some more room, and I'll have this one show what we're already doing. That's Gemma on the right. So I'm going to say, where is the URI handler defined and used? So this is using Gemma 3.5 Flash, released yesterday. And so in a second here, it should be calling some semantic tools to find the code. You can see we now automatically pick topics for your conversations. And I guess the servers are strained. It looks like Gemma's already done, actually. That's cool. So we can take a look at what it did. So now we can see the label is red and bigger. So what we have for the screenshot test now, we officially support screenshots with a new library. We have instructions over here telling you all the steps you have to follow. Now, if you're lazy, you don't have to do that. So what I did was I actually had Gemma 4 do the conversion for me. You can see the conversation here. This was 31B. It trawled through, updated all my build files, created the tests, and so on. So we have these screenshots, and I have tests set up for this project, and we have a new feature to update the golden files. So all I have to do is say add update reference images. This now runs a rendering of the current behavior and shows a visual diff between the reference image and the new image. So we can sort of see, like, yeah, we expected this label difference. I'm going to check this in as my new golden image, and now the test should keep passing. All right, let's check in on our, it's really not happy. Try again. This is going to be a very short demo if the AI is not working. Well, maybe I'll give myself a new task. Maybe I'll try a different model. Where is the URI handler defined and used? And I will try our default model. Yeah, this one's happy. All right, so you can see here that a couple things. We have find usages and find declaration. So these are using the language smarts that understands that just because two things are called the same doesn't mean they're actually pointing to the same thing, right? Now, these are fast operations in a small project like this, but I use this agent on a code base with 15 million lines of code, and having an index makes a huge difference. You don't want to grep through all of that. One other thing to see is that we actually linkify symbols now too, so there's a pointer directly to the class, not just file names like before. So I can say, please implement this. So this is a class that is kind of unfinished, right? It has a big to-do in it. So I just asked the agent to finish implementing it. And so you can see that it did that, but we had this little warning here. And so the AI fixed the code, but then the agent, yelled at it and said, you introduced some new warnings in this code, right? There's a better method than what you called from the KTX library. Use that instead. So the AI immediately went, my bad, let me fix it. And so it's now corrected the code to the more canonical rule and fixed it. So that's pretty nice. Agents love to call shell commands. And so if I say, what's the current commit? This is probably going to run a shell command. It did. It called git rev parse. And notice that it didn't ask me for permission to run the git command. And that's not because I've given it control of my computer. I haven't. It's not because I've already listed anything starting with git or anything starting with git rev. It's because we basically parse lots and lots of commands, dozens of them. We know about hundreds of flags, and we've taught it what commands are safe and which ones are not. So here I can hover and say, this one is actually approved because we know it's a read operation in a folder we've already approved. If I were to say, check in the current changes, that's going to run some more git commands, some of them safe, like git status, git commit, not so safe. And so that one I have not asked it to proceed with. So I think that sort of makes it easier to work with this. For all the little things the AI likes to do, it's not going to bother me. And so I showed you the file critic earlier, and I want to show you something cool. This is a hidden mode we have for development, toggle show maps tool calls. Now we can actually see that what the AI did here, it actually called a shell command. It was actually a cat with a here doc piped into a new file. But we gave it the full IDE treatment with patches, with file critic. That's because, again, we parse the shell commands. And so when we see shell commands, sed, awk, perl, cat, ls, we actually translate them back into native calls so that we get that nicer integration. And we can get, in particular, the file critic, right? Because there's almost 3,000 inspections that we have in IDE from lint and IntelliJ inspections. And they're running before and after every file write so that we're constantly guiding the AI to do the right thing. One last note on the permission model is we have a sandbox. And so we support various sandbox environments. But one cool thing here is that, if you try to run a sandbox and you try to have a sandbox run Gradle, it's going to fail because Gradle wants to touch .gradle in your home folder, which isn't in your sandbox. Well, here, you can click on show command. Here we show you all the folders we've mounted, right? That includes the folders we've manually approved, but also things like the Android SDK. We put comments in to explain why. And the really cool bit is that you can edit this. So you can go in and add additional commands in folders if you want to read or write them, and then click Save as Custom Command. Now we run that instead, so you can have the sandbox more customized to do what you want. All right. So I find myself reviewing more and more code, whether it's from coworkers who are getting more stuff done with the agent or my own iterations with the agent. But I gotta say, I don't love reviewing code file by file in file system order. And so we set out to make this better. And so what I did now was I clicked in the change store action on a review this code. So that starts a new conversation with the agent where it's asked to review the work. It's a new conversation, so it's not influenced and biased by assumptions that already made, right? And this is not just for reviewing what the agent did. You can also use it to review CLs from random Git check-ins. And this is what I do now. When I get a long code review from a coworker, I cherry pick it and I use the review tool because it's so much nicer. So what I've done here is I go into the Git view and I can click on this review button, and then I get this report. So what this is the AI is reviewing the whole commit and summarizing what it is. This is not just a summary of the commit message. This is what the commit does. And if it finds problems, it's going to list them for me. And so when I'm in that early loop of I asked the AI to do something and I'm asking it to be reviewed, I'm not going to start reading this. I'm going to go through several cycles of this oh, yeah, well, you didn't do this. I want you to fix that. So I can choose the fixes I want and have it iterate. But when it is proud and it says this is a good commit, that's when I start reviewing the individual diffs because, my reputation's on the line if this is going to go to production or be sent to coworkers. So I want to look. So now what we've done is we've taken all the diff chunks because I'm going to sign off on every diff chunk, right? We take all the diff chunks, but we reorder them into logical groups. And then we sort them in an order that makes logical sense. So you start where it makes sense. So you can see I kind of get a tour here explaining what's going on. I can check off on each one of these, work my way through the diff. And I do this, with the really nice semantic syntax highlighting we have in IE that understands the difference between a local variable and a parameter, for example, right? Plus word by word diffs. And so to me, this review experience is so much better than doing it in a browser. All right, let me show you a couple more agents we're working on. We have the migration wizard. This was something we showed yesterday. This basically is an agent that has a combination of tools and skills and planning strategies. Now, importing an app like this takes a long time. I think this is over an hour, so it cannot be showed live. But I'll just kind of highlight again that there's a bunch of sub-agents that makes a plan, and I get this really long walkthrough at the end of all the things that it did. And so we try to preserve comments and the source structure so that you can keep these things in sync if you intend to keep developing both. Another migration wizard we're working on, which is arguably harder, is the Jetpack. It's the views to compose migration wizard. This is extremely important to us because we want you to stop writing code for views. Views are in maintenance mode. Compose is great. Please use it. But we know that it's really hard to switch. This is not like the Java to Kotlin migration when there was a button to convert one file at a time. So what I've done here is I've invoked migrate to compose. You can also go to a particular layout and right-click and say AI migrate to compose. And I'm in the middle of the migration here. It produces this report that we're looking at. And you can see here, it's highlighting a quick win and some high ROI. It's basically identifying all the things that have to be done to this app. You can actually see parallel tool calls on the right because it's now asking me things like, hey, which screens do you want to start? Should you directly replace it, or do you want to put a feature flag behind it? Do you want to rip out the XML? So that's the migration wizard. I keep saying wizard. That's the migration agent. And we're working with internal teams to make sure that all the Google apps are pure compose. And so giving us a lot of useful feedback, and we hope to have this out very soon. I'm an optimist, but really, we want this out as soon as possible. All right, changing gears a bit, let's talk about performance. So we have a brand new profiler. This is a standalone profiler. It's called the Android Performance Analyzer. And it is a really, really powerful system profiler, handles huge bulk data and all kinds of detailed information for investigation. This system trace profiler is also available inside of Studio. So let me show you some analysis over there. So let's see, where's the Now in Android? Here we go. Here is the I recorded 4 seconds of startup time in the Now in Android app with the Jank and startup time plugins. Here they are. And so we can see here that we have a really long startup, over 1 second. And so I could dig into the information, but I'm lazy. I'm busy. So what I'm going to do is click on this button and say, why is my app startup so slow?
As you can see here, the Android startup map and time by time frames and the complete profile. So this is what is kind of cool here. It's automated, so that's what performance engineers and efficiency engineers spend their most of the time on, and automating this will fix many of the time-taking small issues that can always be taken care of by an AI.
It's over 1 second. And then we'll launch off an agent dog to analyze this. And so what this should do is activate a skill. It's going to activate a skill, hopefully. Yeah, wow. It's going to activate a skill that knows how to do Perfetto trace analysis. It's going to download a trace processor, and it's going to then test out theories. we'll leave this running for a bit in the background and see if things get better. Meanwhile, I'll show you a couple more things in the system profiler. So the trace capture here is way more powerful than in Studio. Here you can set up a number of different CPU probes to be recorded, a huge number of GPU counters, and Vulkan layers. So one of the interesting options, which I'm connected to an emulator, doesn't have it, but on newer devices, they can capture screenshots. So if we zoom in a bit here, you can see we actually have, let me zoom out a bit. We have screenshots recorded. This is a game. So you can kind of see what's going on in the app. So if you're wondering why there was a drop frame, you're like, oh, that's when we loaded this massive model. It helps orient where you are. So this is a system trace. We're going to have a frame profiler coming out very soon too in this standalone profiler. All right, let's see if, no, we're not having luck with AI today. So a second feature we're working on is related to memory profiling. Okay, it's finally going here. Prophetic trace analysis got loaded. We're also working on memory tools. Memory is in very high demand right now, if you read the news. And so it's very important as developers for us not to waste it. So we've integrated the popular and powerful leak canary tool. So what I can do now is start running my app under leak canary analysis. So you can see it launches my app. And there's this counter here, 0 retained objects. No leak so far. That's good. Now I inserted the leak. That was the commit we reviewed earlier. And so when I rotate the device, we're going to start seeing leak canary detecting some leaked objects. You can see, yeah, it's already found 3. So we're going to go ahead and force a dump. So now the leak analysis happens, and we fetch a report. And I can now start drilling into the leak canary data and figuring out what the leak is, or you guessed it, click fix with agent. All right, so now we're kicking off an agent run. So we have multiple running in parallel here. Start analysis and leak analysis. This is going to try to figure out what the leak is and hopefully fix it. So while that's working, let me show you that we're done something else for memory, and that is the new R8 configuration analyzer. So when you build your projects with the latest AGP, 930 alpha something, we are going to have R8 emit this report. And what this report does is it tells us about all the keep rules, not just the ones that you have in your project, but the ones you inherit from all the libraries you're using. Because some library dependencies are going to bring in these super broad keep rules. They're going to keep lots of classes. And so we see right here that we have this rule is actually responsible for keeping a lot of classes. I can click on it to see exactly all the classes that are brought in. And I can also see which library brought this in. Now, in this case, this was actually a local rule in the Androidify project. So we should definitely rip that out, although it makes for a good demo. All right, let's check back in on the, OK, so it looks like it has diagnosed the leak. We can take a look at its fix. And we can review it here, or we can use the change review tool. Looks reasonable to me. Startup analysis is still going. That's OK. Let's also check in on the anti-gravity job. And it looks like anti-gravity CLI has actually done a bunch of verification and has found some key findings. And I'm a bad reader. Put my glasses on. Yeah, it found some stuff that we should probably fix. OK, and let's also check in on AI Studio. That was the old one that we exported. This is the new one. OK. Yeah, I'm not sure where it went. All right, so the last thing I want to show you today is to give you a sneak preview at something we're working on. It's called Light Build, and it's a new build experience for simple Android apps. So what I'm going to do is create a new project. And in the template here, I have this option, Light Build Preview. So I'm going to press Finish. I'm going to count to 3. 1, 2, and that's it, actually. It's done. So yeah. If you create a project in Studio before, it wasn't quite that fast, I can tell you. So this is still using Maven dependencies, so we can look at them. Maven dependencies. But the difference here is that we actually also have all the resolved dependencies checked into the project. This is a bit like a locked file. It's not enforced, but you can enforce it. And that means that the IDE and the IDE can instantly download or check all the transitive dependencies. It doesn't have to gradually discover as it inspects POM files down the line. It's also nice that when you add a new dependency, you can see exactly how much you just pulled in. Now, this is fully declarative. There are no executable build files. It's all data, and that's really great for tools. That's how we can have this kind of a project experience. We don't have to run the build in dry run mode to see where things are, what we still call Gradle sync, right? Like with a Turing complete build language, this is hard, but this is all data, so we can do it. It also means that we can do compatible updates. Just data. We can read older versions, so we're going to do that. And of course, it's good for agents. That's why we did it. Now, I will say that this is not meant for pro developers, right? This is meant for the kinds of simple apps that people are creating that you've seen me create today. Let's also do a command line build just to prove that it works. I'm going to wipe the cache just so we can see some of the downloads again. Android build. And so this is actually running a Gradle build behind the scenes, although that's an implementation detail. We can always invoke it with the right setup to make sure that it's fast and incremental. And this is going into closed preview today, but we're going to hopefully open it up based on their thumbs up to public canary very soon. I'm hoping a matter of weeks. With that, I think we're going to do some more updates.
All right, thanks, Tor. So it's great to see how the suite of Android dev tools continues to evolve to meet your development needs, from AI Studio to Android Studio, or even more places than before to create a great Android app. All right, before we wrap up, I have a few more updates to share. So in Android Studio Quail, we also added Android developer verification support. Meaning when you get ready to publish your app bundle, we'll check from your app namespace and validate it and make sure it's registered before you publish it to Google Play. Now for wireless debugging 2.0. We are continuing to invest reliably when using ADB over your Wi-Fi network. So with the Android 17 device and Android Studio Quail, you can now change networks, restart your laptop, and your Android device will still stay connected. Pretty cool. With the latest version of Android Studio, we now bundle in the R8 skill. All you have to do is ask the agent in Android Studio to create and optimize R8 in your app. And that's it. The agent will then suggest code changes to make sure you have the most optimal R8 configuration. So using R8 is not just useful for obfuscating code, it also streamlines your code and reduces ANRs. So for example, mods will reduce over 35% of the ANRs just by updating the R8 configuration. And lastly, with the latest update of Jetpack Compose, we now have a new debugging mode for you manually to tweak and manually inspect your shared element transitions. Okay, as we head into recap, we chose space features that are agent-first workflows and workflows require even more hands-on architecting and intervention, but also consider making you more productive as an Android app developer. To orchestrate multiple. Thanks for watching and feedback.
I will
Oh, I'm so happy to be here with you all. I'm so grateful for your time.
Taking a break for my coffee run. I've had this whole protein shake in routine in the morning, and I will just take a break for my coffee run, and we'll be back in a couple of minutes.
Welcome to What's New in Android Development Tools. I'm Jamal, product developer with Developer Experience.
And I'm Tor, and I lead engineering for the Android developer tools and libraries.
Today, we're going to talk about the evolution of Android development tools. So, if you fully aligned to using AI agents as your primary way of developing, or if you're rolling up your sleeves and architecting every detail of your app, or perhaps you operate somewhere in between, we're going to touch on the latest updates to make you successful Android developers no matter how you develop. For this talk, I will cover our recent roadmap, then Tor will go over live demo of the latest tools, and I'll come back for some latest updates. First, let me talk about our recent changes to our product roadmap you may have missed. Last year at Google I/O, we introduced Agent Mode, which jumped you from a development flow from just an AI assistant to a semi-autonomous agent that can generate code for you using the latest AI models. Since then, we got a ton of positive feedback from you. And based on this, the Android DevTools team has shifted how we create features going forward. We now create features for both you, as the Android developer, to be productive, plus the AI agents that you deploy in your codebase. We know that for the majority of professional app developers, the goal is to publish your app or game onto Google Play and get into the hands of consumers around the world. We are continuing to invest in Android DevTools to help you be productive towards this goal. As an Android developer, you're ultimately accountable for your app code works. If your coding agent makes a mistake, or goes off course, and it impacts your business, we know this responsibility lies with you. So it's a trade-off. On one hand, you have speed, where you're weighing how fast can your coding agent generate code, and on the other hand, you're balancing accuracy, meaning how can you constantly test and validate your app code and not create technical debt. When making this trade-off between speed and accuracy, we believe Android Studio is still the best place to handle both agentic workflows and in-depth technical app development. While there are now many new ways to get started with Android development, which we'll show you today, using Android Studio is our recommended path for professional developers to scale their app across all devices in the ecosystem. So let's talk about a few feature updates you may have missed in Android Studio Otter. Off the top, we're making it easier to access the latest in Gemini models right in Android Studio. For some time, we have supported enterprise accounts, now called Gemini Enterprise. Right in Android Studio, you can log in with your Google Workspace or federated corporate email address and gain access to corporate approved and managed models via Gemini Enterprise. In Android Studio Otter, we now also support Google One when you're developing on your personal Google account. So if you have a Google AI Pro or Ultra plan, you can log in Android Studio and access dedicated model capacity and Gemini models above the limited, no-cost default tier. For those AI power users who require even more quota above the Google AI plan usage limits or need even more flexibility in model selection, you can also write a Gemini API key from Google AI Studio into Android Studio. Now we understand that we have a wide range of AI needs, and we're committed to making sure the tools of Android Studio are available to all Android developers. So in Android Studio Otter, we now allow you to bring your own model into Android Studio, choosing between a local or a remote model. A remote model selection feature is handy, or perhaps you might have a corporate mandated policy to use an LLM model. You can bring those right into Android Studio. Speaking of model selection, we now know that model capabilities are changing almost on a weekly basis. So we recently published Android Bench to help you decide which model to use. This benchmark does a couple things. One, instead of relying on generic coding puzzles or coding challenges, Android Bench is built using real-world Android tasks that you use day in and day out. Two, it drives developer choice. As LLM makers improve their benchmarks against Android Bench, it also drives a wider selection of models for you to choose from for Android development. In addition to proprietary models, this week we also added open models to Android Bench. This gives you even more choice when choosing the best model for you. Soon we'll be adding long-running tasks that might take you a day or two, and as well as agent evaluations. This way you can evaluate how various agent models perform across different other models. Learn more about Agent Bench and see the latest leaderboard by going to d.android.com/bench. Now, once you've checked out Android Bench and you need to use a local model on your laptop or a local area network, Android Studio has the option to point to a local LLM runner, such as Olama or LM Studio. This allows you to download a variety of open, weighted models from the community. A local model we recommend with Android Studio, if your laptop can support it, is Gemma 4 from Google. It offers a couple things. One, it has native agentic tool calling, meaning it has built-in reasoning that makes it compatible with things like Agent Mode. Two, it's Android optimized. This model is trained on Android APIs and Kotlin programming. And three, it's integrated. We ensure this model works with popular runners such as Olama and LM Studio. And like other open source models, you can run this local model completely offline and leverage your laptop security. Based on Android Bench, Gemma 4 provides very solid results in comparison to top proprietary models. Now, once you connect to either a remote or local model, it appears in the model picker in Android Studio, giving you the flexibility to switch between models while developing. In addition to model provider selection, we introduce features specifically focused on Android workflows and aspects that are unique to Android, such as UI. Now, many times it's hard to describe to a coding agent exactly what is wrong with your UI, especially visual elements. So now in Android Studio, you can right-click on Compose Preview and trigger a transformation right on the design surface to give the right context for the agent. For those of you who develop direct web links into your app, we have a new AI-powered App Links Assistant that helps you orchestrate the links, and then the tool uses AI to validate and connect those URLs to make sure they're working out of the box. Next, we added stable support for MCP servers, allowing you to integrate third-party tools into Android Studio's AI. We have a built-in gallery of some of the most popular MCP servers. So when we get input designs from Figma or connect to your Firebase database, you can directly connect the agent to those MCP servers inside of Android Studio. Also built in Android Studio is the Android knowledge base. This feature offers a few things. Number one, updated documentation. So as you release and document new Android APIs, you pipe those in right into Android Studio. Two, it's agent focus. You don't need to take any sort of extra work at all. Based on your question, the agent will figure out which context to use to answer questions or execute on results. And lastly, it's not only Android. We actually included Kotlin and Firebase knowledge into the knowledge base as well. Android Auto has been the 4 small releases plus a host of new features and stability fixes. Okay, on to Android Studio Panda. In this release, we spent time on the getting started experience. First, we added a new template for Android Automotive that streamlines the creation of driving optimized apps for Android Auto and Android Automotive. We also updated the Gemini API template, which is used to add Gemini APIs into your app. This template update includes integration with Firebase AI logic, which handles backend setup, and also minimizes the risk of leaking an API key within your app. What is great about using built-in templates is that you can get up and running right out of the box without using any AI tokens. Now, if we take this a step further, we launched an agent-based new project wizard. With just a prompt, combined with a pay plan or API key, you can create a custom Android project that's adaptive, designed nicely with Gemini Nano Banana, with all the right dependencies. Once the app is generated, you can continue to iterate that with an Android Gemini agent built in. This release also includes Android skills. Now, this is important. Even with the latest model training and documentation, sometimes the agent needs a little bit more steering to execute on the right action. This is where Android skills comes in. We include about 10 or so skills on key tasks our current models fall a little short on, such as integrating the latest adaptive APIs or converting from XML to Compose. To learn more about skills, go to github/android/skills. Lastly, we added agent petting mode in this release. This is helpful when you need a little bit more pre-thinking for the API model to work through for complex problems or multi-stage issues. In this model, the agent will create an implementation plan that you can review, and then the agent will execute on that plan. Okay, so that touches on the latest updates in Android Studio Panda. Similar to Otter, we have 4 releases and a myriad of consumer container releases in between. I would note this also includes a new permission model, but also have a live demo in just a bit. And this brings us to Android Studio Quail, which strikes a balance of the latest in intelligent platform enhancements, as well as refinements and product features that you'll see in the live demo in just a bit. Now, in addition to Android Studio, I'm also excited to talk about the launch of Android command line interface. We built it to be Android agent first. We found that LLMs had difficulty getting things right when building and creating Android apps, so we created this app to solve that problem. As command line tool, it is lightweight and acts as a programmatic interface from other processes on your system, including other LLMs, and also connecting right into Android Studio. The CLI also exposes Android skills and Android knowledge base, allowing LLMs to leverage the latest best practices and documentation. Lastly, you can seamlessly update CLI without the need of an external SDK manager. Now, we're using Android CLI to support LLM workflows. We're already seeing notable improvements in the model so far. Based on internal testing, Android development tasks were completed 3 times faster than when agents attempted the same task using only generic LLM tools. And we saw a reduction of LLM tokens by more than 70% when using Android CLI to create new projects when compared to using other generic LLM tools. So the skills package bundled into Android CLI, it's easy to add Android CLI to support a wide range of LLMs. Now, while Android CLI is the best place for professional app development, we're using Android CLI to extend and add new services for both developers and creators to build Kotlin Android apps. So for example, we just launched Android app creation on Google AI Studio, which enables you to create a quick prototype or personal app. With just a prompt, you can create a high-quality Android app that you can deploy right to your device. Now, behind the scenes, we actually ported the new project wizard from Android Studio and added CLI skills to power this new experience. And for those coming from other development backgrounds, Google Anti-Gravity is also a great place to start, since we now bundle in the Android CLI and Android skills. As your app grows with either AI Studio or Anti-Gravity, the Android CLI ensures you have an Android project that's easy and portable into Android Studio, allowing you to easily use Android Studio's and different tools to polish and scale your app to reach the whole Android device ecosystem. Okay, with these updates, we're ready to jump into some demos. Tor, take it away.
All right, thank you. So yesterday in the developer keynote, Florina and Adarsh showed 8 new features for Android developers, and I can't top their demos. So instead, I'm going to show you something different that we're also working on. But be sure to check out those demos so you don't miss something new. All right, so I'm going to start on the command line, and we've had command line tools for Android since the very beginning with ADB, AAPT, DexTemp, and so on. But we now have a new one, and it's basically a single command called Android. And like Git, it has a number of subcommands. So for example, Android info will tell its calling tool where the SDK is installed. The Android SDK tool will let it list or install SDKs. Here's a interesting command, a couple of commands. The emulator start command. It's good luck with AI today.
Oh, I'm so happy to be here with you all. I'm so grateful for your time. Here's what I need you to do for me. If you can, place your hands on the sides of your seats right now. Because I want you to hold on, because we're about to go through an exciting journey on what's new in Angular. If you are excited to know what's coming up, please make some noise. Oh, look at this. This is amazing. You folks are absolutely outstanding. In case you don't know me, my name is Mark. I am the DevRel lead on the Angular team here at Google. And I just want to say thank you to all of you for being in the room with me, and thank you to everyone at home who's watching and following along. Now, here's something interesting about how we've been working on Angular. See, we've worked to position ourselves as a solid foundation for building what's next on the web. And during our time together, we're going to spend time talking about 2 main pillars, or 2 main areas of focus. The first thing we're going to talk about are Angular's API updates and how we've changed the API surface. And then the second thing, which I know a lot of you are excited about, especially if you're here at I/O, you know there's a lot of talk about AI. Well, Angular has a very compelling AI story as well. So by the time we finish hanging out together today, you'll understand how Angular is improving that API. You'll also get a real good feel for where we've expanded our AI story. And then this is also very interesting to me. How is Angular reaching beyond the traditional developer experience to target even more users? Now, if you are ready, I need all of you to give me a big yeah! How is this my job? I can't believe I get to do this. This is amazing. All right, let's talk about these API updates. One of the things that we are so proud of on the Angular team is our ability and our reputation for changing and evolving Angular. If you use Angular today, it is not the same Angular from 5 years ago. It's not the same Angular from 3 years ago. We've worked really hard to build that trust and that reputation. And we've delivered updates across the API surface. I mean, if you just think about what we've done with signals, you think about what we've done with SSR, I mean, there's a lot of work. But a place that I'm really, really excited about is how we've improved the template story. We've launched things like let, we have the defer syntax, and our expanded and revamped control flow. But please believe we didn't stop there, because Angular templates are very, very good. Let's take a look at what we've done with something that's actually not as popular when people think about control flow and major updates. But let's talk about the switch statement. Now, here's a standard example that you may see in the code that you write today. We're using an order status property, and then there is a display message for each of these statuses. But if you notice, 2 of these display the same thing. And I can already hear you at your keyboards, at your desk saying, oh, this feels like something. It feels verbose. It feels like boilerplate. Can't the team do something better than this? Well, guess what? We can. And let me tell you what we can do. Now we've introduced multiple case matching with switch statements. So if you have multiple statements that have the same output, you can now make the code a little bit more concise. And this feels good, but we can go better, because we did something else here that is really, really fantastic. What about if you're using a union type when you're writing a template? You see, we use 3 of these types in our example, but what if they contain more types? Now, this is where some very small but annoying bugs can come up in your code, because if you're working on a union type, and then that union type changes, well, then your UI is what? It's out of sync. And that's one of those things where you might not think about until it bites you, and you're spending a lot of time debugging. Or you're using your agent to debug and you're burning tokens. Either way, you don't want to have to experience this. We can do better here. Now we have something called exhaustive text for switch statements, where if you add the default case and use the never keyword, you'll get something really fantastic, a compile time error. Now, this compile time error means that when you are authoring your code, you find this bug way beforehand, saving you time and frustration. Now, that was a lot of talk about a switch statement. So what if I switched up? Okay, you got it. You got it. You got it. When you're writing Angular templates, one of the things that we know developers want to do is, they just want to inline functions. Because you may have a function or some logic that you want to implement, but you don't want to have to create another function in your TypeScript class. And you're like, oh, just make it easy for me to inline this. Fine. Now you can do that. You can inline arrow functions in your templates. But before you start writing your long, really complex functions, let me give you a few guidelines. This is for small, short, quick functions. Okay? Anything that's long running belongs in your TypeScript class. But if you have something quick, like this update, you can definitely do this here. And if you're worried about the impact on change detection, don't. I know that in the community, there are two schools of thought. Some people say, don't call functions from the template. Some people say it's fine. I work on Angular team. I'm going to tell you something. It's fine. For short functions, it's fine. Friends at home, look at this face. It's fine. All right. I want to share some feelings with you. Is this a safe space for me? Yes. Okay, it's a safe space. I want to share some feelings. And I want to share some feelings about template errors. I find them to be very annoying. Not only are they annoying, they can be very difficult to deal with, especially if you have a crashed change detection cycle. Because what happens, your screen goes blank, your users have a bad time. And in Angular, it feels like we should have a better solution. What do you all think? Yes. I am not convinced. What do you all think? Yes. Okay, that's what I was saying. You need a better solution. Fine. Then meet boundary. All right. Excellent. I'm so happy that you're happy. Let me tell you more about what boundary is. By the syntax, some of you in the room and at home already figure out that this is for error boundaries in Angular templates. Let me show you what the problem is, and we'll show you how it actually works. You see, your application may have a component or directive that crashes your entire change detection cycle and leads to that infamous blank screen. And you're kind of out of luck right now if that happens. So let's go through an example so you can see it very closely. Now, in this example, we have some code, and then we have the rendered output in the browser. Now, here is a promotional widget for free shipping. Now, if this crashes because some bug made it into it, it really shouldn't stop the entire checkout flow. But it could, because here's what you may end up with if it crashes. And what's the problem here? Well, over time, you may lose users. And if you're working especially with something where revenue is involved and your application suddenly has less revenue, that's not what you want. So now you can add boundary into the template, and it gives you a way to isolate the errors in that particular code so the rest of your component is still work. But we can take this further because you can also have a backup UI, a fallback UI. And what makes this really awesome is to think about what it can open up in the future. You can even think about really cool things like what if you do intentional retry logic if your component crashed? It's very, very exciting. This will be landing as developer preview in Q3 2026. And you know our policy, we don't give you exact dates on Angular team. We work on it until it's ready. But we've been working on this. The team is really excited about it. And you'll see even more information in the upcoming weeks. Yeah. Oh, the applause. You can never clap enough for me. Please understand that. You can clap as much as you want. You can always clap. All right, now let's talk a few more API updates that we think you will like. Signal Forms has made a splash in the Angular community. It's our new robust form solution because here's what we did. We took the best parts of reactive forms and strongly typed forms, then everything you loved about template-driven forms, plus everything that you love about signals, and mixed it together to create Signal Forms. And you all have signaled that you love it. Here's an actual quote. Thank you. Here's an actual quote. Okay, no one actually said I said that, but it doesn't make it untrue because we've got incredible positive feedback about Signal Forms and how it's transforming the way you compose forms in Angular. Now, some friends may not have had experience with it because it's been in developer preview. So let's walk through a quick example. Here's how you start. First, you define your model with a signal. Then you import the form function, and you pass in that model to the form function. Now you have a Signal Forms. You have it right there. But you can take it further and provide things like a schema. And in that schema, you can do things like validation. And you can use our built-in validators. In this case, we're using the required validator that says that the schema payment type is required. But here's what makes it really interesting for you as developers. Your use cases are much more robust than this. So what about a custom validation? So here is an example of me defining a custom validation using the validate function. And what does this one do? It checks if the value of website starts with HTTPS. We pass in the fields that we want to match against, and then the function. You understand this logic. This is just TypeScript. But check this out. This is the error that you return if it doesn't match. So you get to decide what the kind of error is and what the message that the user can see. And if it works, you return null. Now, we've been working behind the scenes since we first announced it. Here's some of the things that are new about Signal Forms. One, full set of documentation. So we've improved the documentation. We fixed a lot of bugs. You all have been trying it and letting us know what you think, and we've been working really hard to fix those bugs. And guess what? Now we have full support for Angular Aria and Angular Material. Yeah. This is the time for spontaneous applause. That's right. No, this is really, really exciting. And Signal Forms will be stable in Angular v22. So you can use this with confidence in your production applications. I find Signal Forms to be a bright spot for Angular. But another bright spot is Angular Aria, our fully accessible and fully customizable set of UI directives and patterns. Now, Angular Aria as a concept can be a little difficult to grasp. So what helps me usually is a good example. So let's take one. Here is an Angular Aria toolbar without any styles applied. This is right out of the box, the basic HTML that we provide. Now, this in its current form is fully accessible and ready for you to apply logic to. But let's make it more fun. My goal here is to turn this into a neon sci-fi theme for my users. Let me show you how we do that. In the component template, this is what some of the markup looks like. This is a bit abbreviated. But notice that there's the NG toolbar and the NG toolbar widget. You need both of these directives to enable all the accessibility features that you're hoping for with Angular Aria and using the toolbar component. Now, how do we make it look nicer? Well, you apply the skills that you already have. Your CSS skills are what you use, your styles, your design system, whatever you do, where you work, you just apply it. So you can see here in this example, I'm applying things like gap display, padding, border radius, etc., to make the look that I'm going for. So let's see how it turns out. And this is what you get. Now, there is no magic behind the scenes that I didn't show you. All the code for this you can find on things like Angular.dev, for example. We have exhaustive code examples of how you can style Angular Aria components to meet your needs. Here's how we've improved it since the original introduction. One, the APIs are stylized, and a lot of the things that you all as a community have asked for, we've taken care of. Signal Forms fully support it. And this is a big one. You wanted to test. So now test harnesses are available for Angular Aria components and directives. Yeah. Oh, so spontaneous. I love it. Thank you, thank you, thank you. That's so great. And I just showed you the toolbar. Remember, Angular ARIA patterns, we have at least 11 patterns available. We're working on more. And you can take these patterns and create what you want for your users. And again, you bring the styles, you bring the business logic, and we bring the accessibility that helps you to serve all users no matter how they use the web. Angular ARIA, another feature that will be stable in Angular v22. In our mind, we want to bring as many of the trusted APIs that you use for your application to stable so you can build with confidence. Not only is there signal forms, there's Angular ARIA, but our asynchronous reactivity APIs are now moving to production. Resource and HTTP resource. So stable all the way through. And again, you can have the confidence that you want as a developer. You can learn more about all these updates on angular.dev. All right. I love it. Thank you. Okay. The moment many of you have been waiting for, what is Angular's updated AI story? Did you know that last year, on this very stage, I stood up here so proud, filled with joy to announce angular.dev/AI, which is the home for AI and developers using Angular. And since then, we've expanded our story significantly. Let's talk about how developers can build with AI right now. AI has changed so much. If you think about 6 months ago, the world has moved so rapidly since then. We thought MCP was great then. Then there was a little time we were like, do we need MCP? Now MCP is stronger than ever, but now we have agents because we have so many technologies that we can use to build fantastic applications. And the stream of new ideas does not stop. So the Angular team, what we're doing is trying to think as thoughtfully and meaningfully as we can about how do we empower you as developers to build apps with agents, with your AI tooling, and all the ways that you like to build. And the first piece of that formula is Angular MCP. MCP, or Model Context Protocol, is a way for giving agentic environments the tools that they need to accomplish tasks. Now, Angular MCP comes with some special tools already. There's things like the AI tutor. It could look for examples to give to agents in order to be able to write more modern code and find best practices. Lots of tools, but we've added some new things that we think you'll really love. When I have been writing applications, one of the hardest things for me is having to rely on ng build as the way that the server gets built. And depending on your agentic tooling, that workflow can feel a little disjointed. So now we've added MCP tools, one for devserver.waitForBuild, which allows an agent to build, wait for the output, review the output, and then use that output to influence what the agent does next. Along with that, we have devserver.start. Perhaps the agent wants to start the dev server to run it in the browser or do something for you. Now you have control from an MCP server to do that. We also have devserver.stop to be able to stop the server from the agent's point of view. But that's not all. Look at all the tools that we have to empower you to build what's next for the web using Angular MCP. The AI tutor, all the new dev server controls. There's the modernized tool that can help you to identify places where you can modernize your Angular applications. There's the on-push migration. There's just so many more things, and we're constantly thinking about what else we can do. If you want to get started with Angular MCP, here's what you run. ng MCP to get the configuration to add to your agentic environments. But let's take this a little bit further. See, I found in my development experience is that when I mix MCP servers and tools, I can create something really, really special, a really special developer experience. So what happens when you use Angular MCP with Chrome DevTools for agents? Let's take this example prompt that I ran. I want to update the homepage of this application because I want to show performance showtimes, like at a theater. But I want to take a screenshot of the homepage to verify the changes. Why do I want to do that? Has anyone here ever asked an agent to do something, and then it said that it did it, but it didn't do it, and then you go in this loop, you're like, hey, I asked you to do it. It's like, oh, you're absolutely right, and it still doesn't do it. Okay, so now I'm asking for an extra step. Well, verify that you actually did something using a screenshot. Let me show you what the workflow would look like. First, you use Angular MCP to build the application. Then the agent can use the start command to start the application. Then we can turn control over to Chrome DevTools for agents to actually go to the browser. That's where it starts to get really special. And then you can even ask Chrome DevTools for agents to snap a screenshot. Now, this is just text. This is not as exciting. Let's watch it in action. So in this example, first I'm entering the prompt into the CLI tool. All right, now as the agent is thinking, it's going to start to figure out, well, which tools do I want to use? All right, so it read through the code, start to make some code changes. See, there it was already using the wait for server, so it can get some of the output, so it can influence what it does next. Then it opened it in the browser to verify, but then here I go, I actually want to see the screenshot. Now this is with a small application. Think about what you can create when you combine multiple MCP servers to do these advanced agentic workflows. Because now there's no denying whether or not the changes I requested were done or not. That's a lot of power for the future of how you build. If you want to get started with Angular MCP, here's where you can go. Angular.dev/AI/MCP. Then if you want to check out Chrome DevTools for agents, head over to github.com/Chrome DevTools/Chrome-DevTools-MCP. The next piece of the story are agent skills. I actually love agent skills as a mental model for me to understand how to empower agents to cover the gap between the training data and the new APIs. For example, with Angular, as we talked about before, we're always updating our APIs and we're expanding the surface, but training data happens at a time that we don't get to control. But with agent skills, we've been able to do things like give it the skills it needs and the tools for things like Angular ARIA and signal forms so you can get modern Angular applications. The first skill I want to just highlight is our Angular developer skill. Now, Angular developer skill covers the essentials for building modern Angular applications. But here's what's awesome. It's not just a dump of the documentation into a skill file. We optimize it down to less than 140 lines of code. And because we're using progressive disclosure, only the parts of the skills that are needed are loaded at that time. And if more things are needed, more context is needed, we provided a set of reference files that are only loaded as needed. That's Angular developer. What about our other new Angular skill? Well, there's Angular new app. Let's say you've heard a lot about Angular, but you are using a new agentic development environment. You don't have anything set up. Well, you can use the Angular new app skill in conjunction with Angular developer, and the Angular new app will configure your environment to use Angular. But that's not it. Now, some of you in this room are actually, and watching at home, some of you are contributors to Angular and you like to open pull requests. But one of the things that's really hard is to know where to start. Well, we've set up a list of contributor skills that you can use to understand the mental models required for the agents and for humans to become contributors of Angular. So glad you like that one. So you can check it out. And I've read through these, and I've actually found them to be helpful for me because Angular's API surface is vast and robust. It's hard to know everything. But these help me to understand where to start if I'm wanting to make a change. So check out the contributor skills in the Angular/Angular agent directory. All right, Angular skills are available today, so please use them in your development environment, wherever you do your agentic workflows, and let us know what you think. If you have any issues that come up or any feedback you want to share with us, like how much you love it and how great it is and how you can't wait for us to make more, definitely open the GitHub issue. We would really love to see it. All right, let's talk about vibe coding. Now, we've seen a big boom in the development space of this new community of developers. They call themselves builders. Now, these are people who want to bring their ideas to life, but they don't have the same skills of code to do that. But you know what? I feel like this. If you are building great apps, you are welcomed with us. You can use Angular to build your next great idea whether you know how to code or not. And here's how some of the ways that we've made that happen. We worked really closely with the Gemini Canvas team for the web app, where you can specify in the prompt the technology that you want to use, which is Angular in this case, to create an application. Now, my kid plays sports, and we have to rotate who brings the snacks. But some of these parents are not rotating. I'll be honest with you, I'm tired of bringing snacks all the time. All right, so we're gonna have an app that's gonna help us keep track of who brings the snacks. Now, here are the results that I got from that single prompt, and I'll tell you, this is just the beginning of what you can do from this vibe coding experience. You can take this code and chat with Gemini to extend it still in Angular, or you can go and download the code and make changes yourself. You can take whatever environment that you want. It is your choice, however you want to work. What about in Google AI Studio? They just released a fantastic suite of new advancements in their vibe coding experience. So let's talk about something you can do here. First, if you want to get started, in the configuration panel, you get to select your technology. So you can pick Angular from the configuration panel. And check this out. As a parent, I got a lot of bones to pick, so here's another one. I'm just airing out all my feelings. Y'all said it was a safe space. When I learned math, especially multiplication tables, I wrote them over and over again until I memorized them. My kid's teacher tells me I have to quiz him with math facts all day, which means I have to walk around like, hey, son, what's 5 times 5? What's 4 times 8? Nobody wants to do that. I don't want to do that. So luckily, I'm a genius, and I have tools that can empower my genius ideas. So here's my prompt. I need a math facts app to help my third grader improve multiplication skills. Now make it use flashcards and keep track of the progress of specific facts that they struggle with. Now here's my one-shot results. Okay, this is just a one-shot. I did not edit this more. Right? But I can also refine this app in the browser. I can update it, or again, I can chat with Gemini, and I can add tools like Firebase. I can do so many things from the browser. See, I want you to think about the power of vibe coding beyond what it means for who gets to code or not. Think about what you get to create. Because this is the opportunity to bring those things that you didn't have time for. And now you have the tools that empower you to create great applications. And then you can take something vibe coded in Google AI Studio, bring it into your IDE, and continue the work. Because I know you're Angular professionals, and I know you got all the skills. So use all the tools to your advantage to create the next great application. What an incredible time to be an Angular developer. With the power of our expanded API surface, you can see the things that we're doing. We have a new boundary coming up. We've improved our templates. That doesn't only benefit you as developers. We've added things that benefit agents because agents have their way of coding. Like, oh, that actually makes sense. We should add this. And now even the agentic workflows are smoother. We've expanded our AI story with the MCP tools and the new Angular skills, and we really hope that you will try out. And then think about the integrations that we have with teams like Gemini Canvas and AI Studio to enable developers to build applications in the web in Angular. A powerful framework for building scalable web apps. Now you can build in a web app. What a time to be alive. Angular continues to be a rock-solid foundation for building what's next for the web. And Angular version 22 will continue this story and announce even more features that will be available to developers. Version 22 launches the week of June 3rd, 2026. So be sure to tune in. If you want to learn more about the things I'm talking about, and you want to be tapped in with what's coming for Angular, be sure to head over to angular.dev. And thank you for hanging out. You all have been fantastic. Get out there and build great applications. See ya.
Hey there, I'm Mark.
Hi, I'm Khan. And I'm Annie. Here's something interesting. When people try clothes on in a fitting room, they're way more likely to buy them. But online, you're kind of just guessing. Honestly, my shopping cart is always full because I never know how things will look on me.
Or you end up with a stack of return boxes sitting by the front door.
Okay, cutie. But don't worry, that's exactly why we're building this project today. In this workshop, you're stepping into the shoes of a developer at ThreadCon, a fictional yet fun retail brand that conveniently has an app that's been built with Flutter. And you will be building something really cool, a virtual fitting room, plus a styling experience, all powered by backend agents. The idea is to help shoppers see how clothes actually look on them and get help creating fully styled outfits. But we're not just throwing agents at the problem. We're building them properly using ADK, Agent Development Kit, and Gemini models.
These agents will need to talk to our product catalog and edit user-provided images, which could eat a lot of memory quickly. We'll be coordinating multiple agents with ADK and depending on ADK's artifact storage and structured data support to feed clean, concise responses straight to our Flutter app to power a smooth and almost magical shopping experience.
And not to mention fewer trips to the post office.
Right? By the end of the workshop, you'll have a virtual fitting room that lets shoppers see how clothes look on them, plus a virtual styling agent that will help these shoppers pick out great outfits for any occasion, powered by Flutter, ADK Go, Cloud Run, and the Gemini family of models. If you're not familiar with the technologies that we're using in this workshop, no worries. The concepts that we'll talk about are transferable across many of the other frameworks and tools you'd use to build an agent-powered app experience. So you just kick back, relax, and watch the workshop, or you can code along with us by heading over to the code lab available here.
Okay, so we're building 2 user journeys today. First is the virtual fitting room. The virtual fitting room enables online shoppers to see how a particular article of clothing might look on them. Let's scroll through and find a product that we like. Oh, Alex Dash Hot Reload Letterman jacket. We'll tap the virtual try-on button. Now I'll pick this photo of myself that I conveniently have available on my phone. It'll take a moment to load. And now we get to see how that Letterman jacket would look on me. I can also change my picked image. Since this one is a casual at-home photo, I'll pick another picture in a different setting. Next is the virtual styling flow. If I'm shopping for something specific, like a special occasion or destination, like Google I/O in Mountain View, California, I can hit submit. And I'm presented with a carousel of outfit options that I can scroll through. I can provide some feedback on the outfits, and our styling agent will adjust the outfit items accordingly. When I find an outfit that I like, I can add all the pieces for that outfit to my bag by hitting add to bag, and then continue on through to the checkout flow. Here's a high-level overview of what the user journey for these flows look like behind the scenes. First, to generate the virtual fitting room image, and second, the styling flow to recommend curated outfits.
Now you've seen what the app can do. Let's pull back the curtain and look at how everything is vibe together. At a high level, there are 2 main pieces. First, a Flutter frontend. This is a cross-platform app that runs on web, iOS, and Android. Second, a Go backend. It's a single binary running on Cloud Run built entirely with ADK. These two talk to each other over plain HTTP. The backend exposes the ADK REST API, and the Flutter app calls it using the HTTP package. On the backend, we have 4 agents working together. In our Flutter app, we call agents directly. The fitting room agent for try on, the stylist agent for outfit suggestions. Both of these agents can delegate to a catalog agent to look at products. And the stylist agent has one extra power. It can directly use the image generation tool, just like fitting room agent.
so it doesn't need to go through another agent to generate outfit images. Both Flutter services, ADK Fitting Room service, and ADK Styling service follow the same 3-step pattern. Step 1, session. A session is how the backend tracks conversation history, shared state across multiple turns. The Fitting Room creates a new session every time. But the styling service is different. It reuses the same session ID. This is what allows the agent to remember your feedback and refine suggestions instead of starting over. Step 2, run the agent. This is where the magic happens. Both services send a post request to the run endpoint. Inside the request, we include app name, session ID, a new message. That message contains a parts array. Each part can carry different types of data. Text for instructions or context, inline data for images encoded as base 64. So for example, the Fitting Room sends both user photos and product images. The styling services send text like location and location plus an optional user photo. Step 3, fetch the generated image. Instead of sending large images directly in the response, we use artifacts. When an image is generated, it gets saved to Google Cloud Storage. The agent returns only a reference name. Then the frontend makes a separate GET request to fetch the image. This keeps responses lightweight, fast, and predictable. The REST API, sessions, and artifact storage are few of the convenience built into ADK. Next, let's go a little deeper at understanding how ADK actually works. Now let's talk about ADK itself. ADK, the Agent Development Kit, is an open source framework from Google for building, orchestrating, and deploying AI agents. You can think of it like a toolkit that can turn Gemini models into agents that can actually do things, not just answer questions, but take actions, use tools, remember context, coordinate with other agents. And in our case, we are using ADK Go, so everything runs in Go on our Cloud Run backend. So you may wonder, why not just call the model? Well, you could call the Gemini API directly, but once you need to look up products, generate images, suggest outfits, you need structure. And that's what ADK gives you. It handles tool calling to invoke real functions, multi-agent coordinations for agents delegate works, sessions and memory for persistent context, dev UI to inspect and debug. It is the difference between a raw model call and a production-ready system. And how does an agent work? At its core, every ADK agent follows a simple loop. It receives a message, it thinks about what to do, it decides call a tool, delegate to another agent, or respond directly. Then it returns a response. And this loop can repeat multiple times within a single interaction. Agents don't just think in the moment, they remember. Each session has a shared state, a key value store, or agents can read or write to it. And that's how coordination works. For example, the Fitting Room agent generates an image and stores the artifact name in state. The styling agent reads that same value and displays it. No direct communication needed. State acts like shared memory. The runner is what executes everything. It gives a message, it handles tool calls, delegation, state updates, streaming response. In main.go file, we build our agents and pass them into the ADK handler. This also gives you the ADK web UI, where you can chat with agents, inspect events, view artifacts, debug everything. When you're ready, the same binary deploys to Cloud Run. ADK also gives you callbacks. Those are hooks at key moments. For example, before 2 rounds, after model response. In our implementation, we use a callback to automatically save user-uploaded images as artifacts, so they show up in the ADK web UI for easier debugging. Not all agents are the same. ADK gives you a few types. LLM agent is standard, custom agent if you want to add full control, workflow agent orchestrate other agents, and most of the time, you will use LLM agent. When you use multiple agents working together, that's where workflow agents comes in. ADK gives you 3 flavors. Sequential agent runs sub-agents one after another in order. Parallel agent runs sub-agent at the same time. Loop agent runs a sub-agent repeatedly until a condition is met. For most use cases, including everything we're building today, you will reach to the LLM agent. In our app, our styling agent coordinates with the styling room agent, which in turn coordinates with catalog agent. And that chain of delegation is what makes the whole experience feel seamless to the user, even though multiple agents are doing different jobs behind the scenes. Now that we know what ADK is and how it works, let's look at exactly how we implemented those agents for our virtual fitting room and styling features.
Let's take a look at the implementation of our agents. The running of the agents is done with main.go, where we construct our agents and pass them all to the ADK launcher. The launcher allows us to use the development web UI, which lets us see more of what's happening behind the scenes. You can also use the ADK as an API if you prefer. Each of our agents has their own directory, so they exist in their own Go package. You may notice there's an instructions.md file in each agent directory. Because the agent instructions can be long and are often written with some markdown formatting, we write these prompts separately and use Go's embed package to make the contents available inside the code. The Go compiler inserts the contents of the file in the specified variable for us automatically, so there's no need for big multi-line strings in the middle of our code. Let's take a quick look at each of the agents we're building. First up, we have a catalog agent. This agent has access to our existing catalog of products. We do this by giving our agent a couple of tools. The list products tool lets our agent query our product database, returning structured data. Our implementation reads a YAML file, but this tool could connect to an existing database or API. It's just a Go function. The get product image tool reads the product image data from a cloud storage bucket. Here's how we create the catalog agent. We provide some agent metadata like name, description, and instructions, as well as the necessary tools. Function tools like our list tool have a name, description, and of course, the function itself. The function signature determines the input and output structure of the LLM is expecting. Here, we're using list product args for input and list products results for output. We can try out the catalog agent directly with the ADK development UI. From the dev UI, we can ask questions about available products like, how much is the Flutter hat? On its own, this agent can be integrated into our e-commerce site or app to provide chat assistance, but it becomes even more useful when we integrate it with our fitting room agent. The fitting room agent creates pictures of the user wearing some of our products. To make these images, we give our agent the fitting tool. This tool calls Gemini 2.5 flash image, asking it to add our products onto the user in the provided image. To do this, the fitting room agent needs access to our catalog agent and the get product image tool. Creating the fitting agent looks a lot like our catalog agent, just with a larger set of tools. The load artifacts tool is built in and allows us to load data from ADK's artifact storage. You can also see here that we're turning the catalog agent into a tool using agenttool.new. We're also using a before model callback to save the user's picture to artifact storage. The agent can then load the picture from artifact storage when needed. Just like with the catalog agent, we can chat with the fitting room agent in the ADK development web UI. We'll upload my picture and ask the fitting agent to show me with the Flutter hat on. And there it is. Our last agent is the styling agent. It provides product suggestions to the user based on a scenario. Like the fitting room agent, our styling agent needs access to our catalog agent, so it knows which products are available and appropriate for our event. The styling agent uses the same tool as the fitting room agent to show the user in a selection of products. As with the fitting room agent, the generated image is saved as an artifact, and the name comes back in a structured JSON response, so the front end can fetch the image directly. You may notice that our styling agent has the same tools as our fitting room agent, but the agents have different instructions. The styling agent instructions tell it to search for products that are right for the user's specified event or location, where the fitting room agent only uses the catalog to find product pictures. All of our agents can be served from the same binary. Once we're production ready, this binary can be deployed to Cloud Run just like any other. Now that we've built and deployed our agents, Khan will walk us through integrating our agent functionality into our app.
We can start running the app with Flutter Run. Flutter is multi-platform, so this particular app can run on web, iOS, and Android right out of the box. If you want, you can set up your Android or iOS dev environments, but the fastest way to get started, since most folks already have a web browser, is to run the app in your browser, like Chrome. Making the app responsive is outside the scope of this workshop, so let's scale our window down to mobile dimensions. Right now we have just the standard shopping app, but no worries, we'll get our virtual fitting room and styling features built out in no time. Before we write any new UI, let's level set on architecture. Flutter is declarative, meaning the UI is a function of the app state. Instead of imperatively changing the UI, we'll update our state models, and Flutter will automatically know how to rebuild the UI based on those state variables. To manage the state and decouple our data from the UI, we use providers. A provider encapsulates the app's data, things like the user's uploaded image, the AI-generated image, the literal loading state, the list of curated outfits, and so on. We construct these providers at the top of our app's widget tree, so we can access them from anywhere in the app. When a request completes and returns some data, it's then stored in the provider, which then notifies the listeners below it in the widget tree. In other words, any component in the UI that is subscribed to that provider is immediately and efficiently rebuilt to display the new data. Speaking of data, we have these ADK fitting room and styling services already built out that we use to fetch data from our ADK backend. The ADK fitting room service implements this fitting room service interface that has a generate try-on image method. It takes a user image and product image, then returns the generated try-on image. The ADK styling service implements the styling service interface with two methods: get styling suggestions, which takes a styling request and returns a list of outfits, and refine with feedback, which takes a string of feedback and returns a list of outfits. As Andy mentioned, these service classes are solely responsible for shuttling data back and forth between our client app and the ADK backend using HTTP requests. They manage building and sending requests, then receiving and parsing responses into data classes that our app can understand. If you look at our providers, we have methods defined that calls these services whenever it needs to get new data. We're abstracting the UI from the business logic and the business logic from its data source. If you zoom out and look at the front-end app architecture, we're essentially following a model view model architecture, otherwise known as MVVM. MVVM has clear separation of concerns, multiple different components with distinct responsibilities, well-defined interfaces, boundaries, and dependencies, making our app more testable, maintainable, and scalable. Okay, with the architecture out of the way, let's get into building the UI. We'll open the product screen and add a virtual fitting room button right next to the Add to Bag button. We'll just initialize our try-on provider with the selected product and push our next screen. The try-on screen acts as the core state machine for our virtual fitting room flow. Inside the screen, we use an animated switcher to route between three distinct phases: asking for a photo, loading, and displaying the final fitting room image. If this syntax looks a little different, it's because we're using Dart's pattern matching syntax. It's one of my favorite Dart features. Now let's build out the choose your image screen shown in that initial state. We already have some scaffolding, so we'll just add an upload image button. When pressed, it'll call process try-on, which brings up an image trigger. As soon as the user selects an image, the app sends off a request to generate the fitting room image. Let's hot reload our app and make sure that works. Perfect. Now on the fitting room screen, we grab the generated try-on image from try-on provider and display it in the center of the screen. If you're new to Flutter, that expand widget is just telling the framework that we want that image to fill as much space as possible. Notice the change image button in the app bar. It's already built into our scaffolding. The button is conditionally shown if a user has already selected an image. When the user selects a new image, it immediately kicks off another request to process try-on. At the bottom of the screen, there's already an Add to Bag button. We'll add our Style Me button right next to it. The button's on-press callback is the Show Style Me form function that has conveniently been predefined. Just for good measure, we'll also add a little bit of spacing in between the two buttons. Let's take a quick look at what the Show Style Me form callback actually looks like under the hood. This function triggers a bottom modal sheet containing a form. The form asks for contextual inputs like location, occasion, and additional notes. There's also some form validation to make sure that either location or occasion is present with the user's request. When the form is submitted, the bottom modal sheet returns a style request payload. Looking back at the Show Style Me form function, you can see that it passes the style request to the styling provider so that our agent can process it. It then pushes the final Style Me screen so that the user can see their curated outfit results. We can hot reload the app to make sure that the Style Me request collects the right info and navigates us to the styling screen. Sweet. Finally, we made it to our last screen. Our agent responds with a list of outfits, each containing a generated outfit image, styling commentary, and a list of items that make up that particular outfit. We want to display these as a list of outfit cards. The scaffolding for the screen already provides the consumer and animated switcher logic that we need to listen to the styling provider and animate between states. Notice how the consumer specifically wraps our main layout. This means when the styling provider updates, only the widgets below it are rebuilt. It won't unnecessarily rebuild the static parts of the screen like the app bar. Okay, let's write the logic that determines which state gets rendered to the screen. Jumping down to the animated switcher, we'll use a sequence of ternary operators to check the styling provider state dynamically, similar to the fitting room screen. First, we check if the provider is currently loading, and if so, return an app loading indicator. Then we check if the list of outfits is empty, falling back to an app empty state. And finally, when there's a list of outfits, we throw them straight into our swipeable outfit carousel. This animated switcher now triggers a fade and scale animation between the child widgets whenever the UI state changes. Let's trigger a hot reload, and you'll see that the carousel populates with a couple of outfit cards. And here's a neat detail. There's an Add to Bag button that is already built into the card components, so we can throw the entire curated outfit into our bag with one tap. But developing your personal style isn't a one-and-done interaction. It's iterative. Let's give our shoppers a way to give their feedback on the generated outfits. We'll add a feedback chat bar at the bottom of the screen as an overlay. For the callback, we'll pass the feedback to our styling provider so that it can ask our agent to update the list of outfits and update our state. Remember, because the animated switcher is a consumer of the styling provider, the cards are automatically rebuilt to reflect the new outfits. Last but not least, for the final polishing touch, we'll add an info button to the app bar. For our callback, we'll call our pre-built Show Styling Brief Details method. This method brings up a dialog containing the user's original styling request, just in case our shopper forgets their style request, because, well, they have a short memory like me. Let's hot restart our app and make sure that we've got the full try-on to styling flow working. We'll find an article of clothing that we like, tap the button for the virtual fitting room, pick our photo, wait for it to generate our virtual fitting room image. It'll take a moment. That looks good. Now let's tap the Style Me button, enter our style request, submit, wait for it a moment, and take a sec. Swipe through the outfits. Let's submit some feedback. I forget what our original styling request was. Let's check out the info dialog. Okay, yes, right. I like this outfit. So let's throw it into our shopping bag and check out. Sweet, it all works. Of course, one of my favorite party tricks as a Flutter engineer is, well, remember that this entire flow now runs on iOS, Android, and web, without any extra work on our part.
So there you have it. You've built a virtual fitting room that lets shoppers see how clothes look on them, plus a virtual styling agent that will help them pick out great outfits for whatever occasions they need. All powered by Flutter, ADK, Cloud Run, and the Gemini family of models.
Hopefully that means ThreadCount will see more sales next quarter.
We hope you enjoyed this workshop and feel more confident about building a full end-to-end agent-powered app experience. If you want to walk through and build out this app yourself, the code lab for this workshop is here and in the video description. If you build out this app, please let us know in the comments how it went and if you have any questions. Is there anything else that you would have added to the app? Thanks for joining us.
Happy Google I/O!
Hello, and welcome to this session, Build and Deploy Full Stack Apps with Google AI Studio, Cloud Run, and Cloud SQL. I'm Justin Mahood, a Group Product Manager for Cloud Run, and today I'll be joined by my teammates Sarah Ford and Shambu Hedge. Last year, we enabled the deployment of vibe-coded applications from AI Studio to Google Cloud, but those were AI-powered front-end applications only, with no back-end servers and no databases. Deploying a full-stack application in a traditional fashion may involve some friction. So, for example, deploying a full-stack app typically involves setting up a GCP project, installing command line tools, and adding a credit card. But today, we are excited to introduce frictionless full-stack deployments for non-traditional Google Cloud customers. That means deploying applications that include a front-end, a back-end, and a database to Google Cloud. But beyond just adding capabilities, we've decided to offer a bundle of these cloud services for customers who are not traditional GCP customers. So today we're announcing that all you need is a Gmail account to vibe and publish to your own URL a given number of full-stack web applications. No Google Cloud experience or Google Cloud project is needed, no G Cloud installation, and no credit card or billing account is required to get started. You can use either Firestore or Cloud SQL for your database, and you'll also get end-user authentication. Just publish, and your app is hosted on Cloud Run and ready to scale. Now, to talk more about the developer experience, or better yet, the vibe coder experience, I'm going to turn it over to my teammate, Sarah.
Hi, I'm Sarah Ford, a developer relations engineer on the Cloud Run team. Let's talk about some of the tools and resources you'll need to run your apps. You can build multiple apps and deploy without any time limits for however long these apps are available. You'll have logs and metrics directly from your deployed applications. A Cloud SQL database gets created in seconds to power your application. You'll have access to environment variables to make quick modifications without rebuilding. And lastly, you'll be able to pause, resume, or delete your applications. Now let's talk about what comes next. For example, you share your website. Now your friends, family, social media followers start using it. You can also publish your apps to make it available broadly. If your app starts doing well and you want to productionize it, there's a one-click option to onboard to a regular Google Cloud account, where you can add your credit card, provide payment, and then use the full flexibility and power of Google Cloud with full set of features. I'll turn it over to Shambu, a PM on the Cloud SQL team, who will show you AI Studio in action by creating an app at no monetary cost and deploying an app to Cloud Run using Cloud SQL as a database.
Hi everyone, I'm very excited to show you how to go from a simple idea to a fully published app using Google AI Studio. Today, we are going to build an app powered by a Cloud SQL for PostgreSQL database. This app will be hosted on Cloud Run. Here is the best part. This all happens behind the scenes. We don't need to write a single line of code. Instead, we are going to vibe code it. With just a few conversational prompts and a couple of clicks, you will see an app come to life that you can immediately share and publish. Let's dive in. Welcome to Google AI Studio's build mode. This is our canvas to start building the app. Let's say I want to build a neighborhood tool library to make it easy for my neighbors and me to share everyday items like ladders, drills, and cameras. I'll start by giving the agent my vision. I just need to enter a prompt. Build an app for a neighborhood tool library. The app should allow people in the neighborhood to list tools, to lend or borrow. Create a basic homepage that lists all the available tools. Right away, the AI Studio agent gets to work. It knows that to build an app, it needs to persist data, so it selects Google Cloud SQL. We instantly get a Cloud SQL database, provisioned and ready to go. The AI Studio agent creates the initial database schema and sets up the tables for us. Using Cloud SQL helps in implementing many useful features such as logins, profiles, smart search, and other helpful things, as we will see later in this demo. Now you can see that the preview of the app is loaded on the right side of the screen. Now let's add sample data to this app. I'm just entering the prompt, generate sample data for this app, and insert it into the database. Just like that, our app is populated. If you have your own data, you can also just upload a file or share a Google Drive link, and the agent handles all the data loading. No SQL queries required. Next, let's make it easy for users to securely manage their own tools. I'm entering the prompt, set up email-based authentication so users can log in. The agent instantly builds out a login flow and handles all the necessary database filtering to ensure data privacy between users. It also updates the Cloud SQL database schema to create a users table and make other changes to implement end-user authentication. Now I'm logging into this application. Now let's watch how easy it is to iterate. I want to add an actual borrowing mechanism, so I'm going to just add a prompt. Add a borrow button to each tool card. When clicked, it should link the current user to the tool and update the tool status to borrowed. Then create a My Garage page that shows tools that the user owns and the tools they are currently borrowing. Once I enter this prompt, the agent updates the database schema, updates the app logic, and pushes the UI changes to the app. Now you can see the borrow button in the app preview. Once I click on the borrow, the tool gets linked to my profile in the database. Now let me go to the My Garage page to confirm it. You can see that all the 3 tools that I borrowed are linked to my profile because these records are updated in the Cloud SQL database. Now let me try listing a tool that I have. I'm adding a can opener. Once I add it and add all the details, this tool gets stored in the database and now it is visible in the app. As the tool library grows, users will need to find things quickly. So let's add a smart search feature. I'm entering the prompt. Update the search bar to make it smart. Users should be able to search even when keywords don't exactly match. To make this work seamlessly, the agent uses database features, including advanced features such as PostgreSQL extensions, to power the search. For example, a fuzzy search is implemented to enable the search based on approximate matching of keywords. A semantic search is also implemented to enable natural language searches based on the intent. Let's see it in action. I'm now searching by making intentional spelling mistakes in the keyword. You can see that the relevant result power drill is shown even if there was a spelling mistake in what I searched for. Now I am adding a natural language question in the search. Is there a tool to open the can? You can see that a relevant result, a can opener, is shown in the result. We could easily build these smart search features on the data as this app is powered by the Cloud SQL database. And we are done. Our app looks amazing, it's fast, and it works well. Now, with just one click, I can publish this directly to Cloud Run. I can also share this app with my friends, family, neighbors to try it out. And if I want to add new features tomorrow, I can jump right back into AI Studio and keep iterating. That is how quickly you can go from an idea to a live database-powered app. Now, it's your turn to try it out. Thank you.
Thank you, Shambu, for the demo. We invite you to get started with your vibe coding journey today by visiting AI Studio. Thank you for watching our session.
Hi everyone, welcome to our technical session on supercharging your Android media experiences. I'm Bassam, a product manager for Android Camera and Media. Joining me today are Nevin from Developer Relations and Kal Yang from our engineering team. We're thrilled to show you how Android is evolving to help you build more engaging experiences for our users. Let's get started. Our relationship with media has fundamentally changed. It's no longer something we just consume, it's how we create, how we connect, and how we live. More and more, we see how media is a vital element of Android. And as that relationship evolves, we also see that our users are deeply engaged with their media, as they use their devices to watch, listen, create, share, and connect. This is why we want your media to feel effortless. Every video you watch, every song you hear, and every story you love should be delivered with brilliant, uninterrupted quality. With that comes a promise to also be your creative partner, making it simple to capture your life as you remember it and craft the stories only you can tell. We strive to deliver media that you don't just see, but you can step inside. To deliver on that vision, we are focusing our investments across key, high-impact areas. First, we are continuing investments heavily into quality, power, and performance, ensuring Exaplayer helps you deliver the most power-efficient media experience on Android that is consistent, reliable, and lag-free. We're also focusing on end-to-end creator journeys, enabling applications to take advantage of our leading-edge intelligent camera with our seamless Camera X toolkit and Media 3 editing libraries that unlock magical experiences for our most creative users. Finally, we are investing in immersive experiences our users can feel. As content breaks free from the flat screen, we are building the definitive platform for spatial media. Using our open-source Eclipse engine, we will enable you to capture and play back spatial content on your Android devices. As we build on our core investments, we are proud of the innovative features we have brought to the ecosystem. Working really closely with partners like Meta, we've been able to bring experiences like low-light boost to the hands of many users. We're also bringing more innovative AI features like Magic Eraser and Studio Sound to the platform to enable the most creative users to have the tools to express themselves freely. Besides all the experiences we are enabling, we're incredibly proud to see continued adoption of our Jetpack libraries. We'll share more on how these libraries can help you take advantage of the latest camera and media features on Android throughout this talk. To dive into the details, I'll pass it off to Kal Yang and Nevin.
Thanks, Bassam. When we talk about being able to capture in any scenario, we mean giving your users the power to grab the perfect shot every time without friction. We're committed to bridging the gap between system capabilities and in-app features with Camera X. Camera X abstracts away the complexities of the underlying camera hardware, providing a consistent and powerful API surface. Let's look at what's new. For example, starting with version 1.5 of Camera X, you can capture uncompressed, unprocessed DNG images for maximum creative flexibility for pro-level editing. On the video front, we've introduced a widely anticipated feature, high frame rate capture. You can capture fast-moving action at high frame rates and encode it as is for exceptionally smooth video, or directly encode it at a lower frame rate for
dramatic slow-motion video.
For code samples and details on device compatibility and limitations, check out our blog post for this feature. Modern camera experiences will often combine multiple features, but how do you know if a device supports HDR video and 60 frames per second and preview stabilization all at the same time? The new Feature Group API in Camera X removes the guesswork. The Feature Group API currently supports HLG10 HDR video, 60 frames per second, preview stabilization, and Ultra HDR image. You can provide a prioritized list of features, and Camera X will determine the best combination supported by the device, enabling them in order of your list. You might consider using this API to create a settings UI that disables toggles for unsupported options. For more guidance, visit our Feature Group blog post. Moving on, next, let's take a look at Low Light Boost, a powerful feature for brightening the camera stream in real time for previews and recordings. Instagram recently added support for Low Light Boost to help users capture memories at night with as much authentic detail as possible. With Camera X, implementing the hardware-accelerated AE mode of Low Light Boost in your capture flow takes just a single line, calling the camera control.enable Low Light Boost async API. Check out our developer documentation for guidance on how to enable the software implementation of Low Light Boost as a fallback solution on devices where Low Light Boost AE mode isn't available. So far, we've covered how Camera X can adapt your capture experiences to different environments, from fast action to low light. But users also have a variety of devices now, including foldables, tablets, headsets, and glasses. So it's more important than ever to build a camera experience that can seamlessly adapt to new form factors. Here's Kal Yang to show you how.
Camera X already includes the tools you need to build adaptive capture experiences that enable users to make the most of their devices. Make sure to use the Camera X Viewfinder composable to automatically manage reconfigurations, aspect ratios, and scaling to prevent stretches or stuttering previews. This works out of the box, saving you from writing device-specific workarounds. Here, I have some sample Camera X code for setting up a preview use case, and it's important that we store the service request from Camera X as a state in our view model. We can then pass the service request into Camera X Viewfinder, and it will handle lifecycle management, recomposition as needed. While we're on the topic of helping users make the most of their devices, here's something cool. We can use the JPEG picture-in-picture library to give users the ability to multitask while recording with Camera X. Going back to our Camera X Viewfinder example, we'll add an instance of basic picture-in-picture from the JPEG picture-in-picture library. We'll also create a function that updates the picture-in-picture params based on where our camera preview is positioned on the screen. And finally, in our Camera X Viewfinder, we'll call update source rect hint when it gets positioned. Now, whenever we want to enable this, we simply call enter picture-in-picture mode on this activity.
For example, this might be useful for reading a script while recording.
And finally, looking ahead, Camera X is at the forefront of new format support with the addition of motion photo. Later this year, you'll be able to use Camera X to implement motion photo capture capabilities in your app, which are already supported for editing and playback in Jetpack Media 3.
Speaking of editing, next we'll show how the Transformer APIs in Jetpack Media 3 are designed to make creative and complex editing easy. A major focus for Transformer has been to enable more complex editing workflows, and the APIs now have support for multi-asset editing. Multi-asset editing refers to the suite of tools necessary to composite multiple input media items into a single output video. This could include, for example, concatenating items one after the other, overlaying them or arranging them for simultaneous playback, and applying operations that span multiple items. In Media 3, you can apply effects and transformations to media with the Effects API, preview the fully composited compositions with Composition Player, and finally export the creation to an output video with Transformer. To apply effects to a single media item, you can create an edited media item, which groups a media item with a list of video effects and audio processors to apply to it. You can arrange multiple edited media item instances into an edited media item sequence, and layer multiple edited media item sequences together into a composition. There are some editing options, like HDR behavior, that you can apply at the composition level. You can then play this composition with a composition player to preview your edits, or pass the composition into an instance of Transformer to export a video with the edits baked in.
On top of this, Transformer is packed with new features and improvements, including faster trimming with edit list metadata, so you can quickly create high-quality, shortened video clips by marking the start and stop boundaries using metadata instead of re-encoding the clip. New input format support, such as Android Professional Video for professional-grade editing control. Media 3 Muxer as the default rather than Platform Muxer for more consistent behavior across devices. And a more intuitive API for speed adjustment and frame rate setting as part of the edited media item builder. One developer taking advantage of Transformer is Adobe. For their upcoming Adobe Premiere app, Adobe used Transformer as the foundation of their media editing infrastructure to reduce their maintenance costs and ensure greater compatibility across the Android ecosystem while maintaining the flexibility they need to use their own custom graphics pipeline. Beyond Transformer, to help tackle video encoder fragmentation across the diverse Android ecosystem, we're also introducing the new CodecDB module in Media 3. This project leverages extensive testing from real devices to provide data-driven, chipset-specific recommendations for optimal video encoder settings. You can use CodecDB's recommendations to achieve better and more consistent video quality across devices at a target bitrate, all while avoiding device-specific issues. Here's an example where we've encoded a video with default settings on the left and with CodecDB's provided settings on the right. See if you can notice the improvement that CodecDB's recommendations have had. We can look at a single frame for side-by-side comparison. Notice the reduced blurriness in the branches of the bush, the sharper lines in the building, and clear delineation between the mountain and the sky. With CodecDB, the API is designed for you to express an intent rather than a granular configuration. In this example, we're optimizing for high-quality recording, but could instead request settings for use cases like live streaming or social media posting. We can also outline any constraints we're aware of, for example, the video resolution, specific codecs to consider, and a target quality level. And if by chance CodecDB doesn't have the data needed to provide a recommendation, we can also define a fallback configuration. At time of recording, the API is still actively in development, so please refer to the latest documentation for up-to-date guidance.
Looking ahead, we're also developing advanced on-device AI-powered effects to help redefine mobile storytelling for users and empower developers to ship premium AI-driven experience across Android ecosystem. The first of these features that we're excited to introduce is image and video enhance. This model includes tone mapping, denoising, deblurring, and super resolution capabilities. These can be valuable, for example, by enabling to deliver smaller or low-quality media to save on storage and bandwidth costs, and still restore image and video to high quality at the time of delivery. We've been partnering with Instagram Edits app to test this feature, and we'll be rolling it out soon. To give users more creative control, we're also eager to bring Magic Eraser capability to apps through these effects. Magic Eraser leverages on-device models to intelligently remove unwanted objects or distractions from the picture and fill in background. And finally, to enable clearer and more professional audio in videos, we're launching Studio Sound. This is an AI-empowered feature designed to improve audio quality by distinguishing between different audio sources like speech, music, and background noise. User can then reduce distraction and boost the key sounds. I'll pause here for a moment so you can hear the difference creators can make with this feature.
Baby, please don't cry. We're coming for your dinner. Baby, please don't cry. We're coming for your dinner.
To make it straightforward for you to access this new capability and more, we are delivering them through a standard interface in a new Media 3 AI effects library. That means you can adopt the feature once, and we will take care of all heavy lifting to dynamically use optimal implementations at runtime based on device capabilities. This is helpful because this feature can come from different sources to take maximum advantage of the software and hardware they run on. For example, they could be implemented in software for broad reach. They could be released as a new feature in Android platform for deeper system integrations, or they could be a hardware accelerator model for optimized performance. The new AI effects module in JPEG Media 3 will abstract away this complexity, so you automatically get the best experience, even on devices update, to provide more optimized paths. This framework is a powerful and extensible interface that enables you to stay on the cutting edge and adopt the latest advance for Google research with minimal effort. We're excited to bring these advanced capabilities to your apps and eager to see the delightfully creative experience you can craft with them. Please stay tuned for an upcoming release of JPEG Media 3 library that includes these APIs.
Finally, let's talk about the last crucial piece, playback. Jetpack Media 3's ExoPlayer is the recommended solution for media playback in Android apps, and we continue to invest heavily in making it more efficient, reliable, and feature-rich. Let's run rapid fire through some of these improvements.
We've heard your feedback on improving the user experience during seeking. ExoPlayer now has a new scrubbing mode. Enable it with ExoPlayer.set scrubbing mode enabled. This optimizes performance for frequent user-driven seeks, like dragging a seek bar, resulting in a much more smoother experience. If you have a scrubbing UI, you should additionally configure the seek tolerance values. This allows ExoPlayer to be more efficient decoding frames while seeking. In this example, we are setting the tolerance to 8 dp before and after the seeking position, which allows ExoPlayer to find an optimal frame to seek to within that range.
Last year, we announced the Player Surface Composable, and we're continuing to add more Compose UI elements to the library, including button and stakeholders for playback controls like play, next, mute, and shuffle, a stakeholder for playback progress that can be used to create a progress indicator, and Content Frame, a composable that helps handle scaling an underlying player surface while maintaining its aspect ratio, and also has an easily enabled shutter to hide the playback content. We've also introduced the new UI Compose Material 3 module, which provides components with Material 3 design styling. This includes individual components such as playback control buttons, position and duration text, and a progress slider that allows seeking. Here, you can see the Media 3 Compose demo app, which uses the new top-level player composable. This provides a basic player UI layout with customizable slots to add controls.
Preloading content is key to faster startup times, especially for short-form content. We've enhanced our preload manager with caching support and improved memory management.
We've also introduced new APIs for frame and metadata extraction, which have better reliability and format support than the equivalent platform APIs.
For remote playback, Media 3 now has enhanced caster support with the new Caster Player API. This player implementation acts as a drop-in replacement to ExoPlayer for seamless transitions between local and cast playback, handling playback state management on your behalf.
We're also happy to announce that Eclipse Video is launching on Android. Eclipse Video is a next-generation HDR video format that provides exceptional color and stunning imagery across a diverse set of devices. Android is the first operating system to adopt this new standard. Eclipse Video removes a class of issues plaguing existing HDR videos today, such as unpredictable light levels and inconsistent rendering across devices. We've updated ExoPlayer to provide out-of-the-box support for playback, so you can deliver high-quality HDR videos to your users with little to no effort.
In addition, with how much time users spend consuming media on their phones, we're putting extra focus into power saving and reliability for playback use cases. And you can explore some of these work-in-progress improvements in Media 3 main branch, including PCM offload. For apps with audio-only screen-off playback use cases, enabling PCM offload can result in up to 25% battery savings based on our lab testing data. Dynamic scheduling, which allows the CPU to adapt how frequently it wakes up based on workload. Renderer pre-warming, to efficiently prepare resources needed for playback ahead of time for lower startup latency. Stuck player detection, to give you more signals if the player ever gets stuck in buffering or playing state without making progress, helping you identify and fix issues.
So to recap, Jetpack Camera X helps you build powerful and consistent camera experiences to capture in any scenario. Media 3 Transformer makes creative and complex editing easy and performant, and Media 3 Exit Player delivers efficient and reliable playback.
Exactly, and together, they supercharge your Android media experiences.
We can't wait to see what you build. For more information on anything we covered, check out the latest documentation and samples linked in the video description below.
Hi, I'm Sivan Silva. We're thrilled to talk to you today about bridging worlds with the Android XR SDK across XR devices, including XR headsets, wired XR glasses, and AI glasses. Last December, we introduced our Developer Preview 3, which brought new APIs for building augmented experiences on AI glasses. As shared in December, AI glasses are the exciting new form factor coming to the Android XR family. AI glasses with and without displays connect existing apps and users to the world around them with powerful audio and conversational experiences. Today, we are excited to announce Developer Preview 4 with even more updates to our developer solutions for XR devices across both augmented experiences on AI glasses and immersive experiences for XR headsets and wired XR glasses. Also, our core libraries, including XR Runtime, Jetpack Scene Core, and AR Core for Jetpack XR libraries, are officially moving to beta soon. This is yet another milestone we have achieved together with your feedback and input. It has been super exciting to see the amazing experiences you all have been releasing in Galaxy XR. To support this momentum, we've introduced new features designed to deepen immersion, making headset interactions feel even more natural, and giving users more ways to watch, create, and explore. An example of these capabilities in action is the incredible work from Simply Piano XR, which takes the #1 piano learning app into a whole new dimension, letting anyone play the songs they love with guided lessons and personal feedback on a real or even virtual piano. Keys light up and finger numbers guide every note within a fully 3D environment built for Android XR. Also, Oh My Galaxy is a spatial mixed reality arcade puzzler that transforms your room into an interactive galaxy. Designed for a broad XR audience, it combines natural hand tracking with physics-based gameplay to create a playful, immersive experience that showcases the power of Android XR. Today, we'll be covering our main updates, starting with augmented experiences for AI glasses, and then immersive experiences for wired XR glasses and XR headsets. We would also like to announce our Android XR Developer Catalyst program. Developers can apply to get access to pre-release hardware, including Xreal's Project Aura and the AI Glasses Developer Kit via our open application process. But more on that later. Now let's dive into augmented experiences for AI glasses. Since launching in December, there are a number of partners that are currently exploring XR's capabilities. This includes partners across shopping, health and fitness, media like Spotify, Melon, and 30 Ninjas, education through Pearson, and real-world exploration and mobility with Uber, NeighborMap, TMap, Get Your Guide, and Aira. We are also working across messaging apps such as Line and KakaoTalk. To learn more about the augmented experiences our partners are building, I'll hand it over to Yasmin.
Thanks, Sivan. Together with XR, Line's mission is to bring closing the distance into the real world. Hands-free messaging and instant photo sharing enable real-time communication with less friction on your phone. For example, imagine that you want to share a special moment with someone that's far away. You'll be able to see the same scene as if you were both there together. And with KakaoTalk, where users can experience the future of connection as KakaoTalk on AI glasses seamlessly merges your digital and physical worlds through intuitive voice-activated messaging and hands-free real-time notifications. Designed for always-on professional, the tech-savvy shopper, and the socialite on the move, these experiences liberate you from your mobile screen while keeping you deeply anchored in your social circles and daily activities. Finally, Neighbor Maps, Korea's leading digital map service, brings hands-free walking navigation to Google AI glasses. Powered by precise pedestrian data and natural voice guidance, it delivers a safe and reliable navigation experience anywhere. Naver is also bringing more services to Google AI glasses, including shopping and Papago translation. With the latest round of updates, we continue to expand the capabilities of Jetpack Projected, Jetpack Compose Glimmer, and AR Core for Jetpack XR for augmented experiences. Jetpack Projected allows you to configure and set up your applications for AI glasses. First, let's look at how you prepare your app to interact with the XR device. The Device Availability API consolidates critical signals, including wear state and connectivity, into the standard Android lifecycle state values. This API can help you manage audio routing, hot word activation, and know when to expect user input based on when the XR device is available. To simplify your testing in the Jetpack Projected library, we're introducing the Projected Test Rule API, available in the new Projected Testing artifact. This API automates the setup of the projected test environment, letting you write clean, reliable unit tests without the boilerplate code. And you can now launch your projected activity onto AI glasses using voice commands with Gemini. To make this work, you'll need to head into your Android manifest file and add the XR Projected Launcher Category Intent filter. This tells Gemini which projected activity to launch from their AI glasses. Turning to UI, we continue to expand Jetpack Compose Glimmer with visual refinements and new interactive components. Out of the box, Glimmer theme provides additive safe colors, shapes, depth, and spacing primitives for optimized glasses UI. Adjusting optical size can make fonts more legible and readable. We are now including Google Sans Flex with refined font styling in our Glimmer components to improve legibility on optical see-through displays. Beyond these basic primitives, we're also introducing several interactive components. With the voice input indicator, you can provide users visual feedback when the microphone is active and in use. Stacks that are designed to show only one item in a group at a time, hinting at additional items above or below that work with the glasses touchpad. Title chips, this component, when used in conjunction with your cards, gives better context and categorization to the content displayed. Button groups allow you to provide multiple actions in a minimal footprint. You can provide just icon buttons, label buttons, or if you want to get really excited, you can provide buttons with both. The button group will automatically overflow off-screen and scroll as you move focus. With these additions, we're optimizing input in Jetpack Compose Glimmer to work seamlessly with a unidirectional touchpad. The emulator update features a new AVD creation and pairing wizard, which allows you to automatically launch and pair glasses and companion phone AVDs in a single flow with a persistent Bluetooth pair connection. We are also introducing environment customization, where you'll be able to add your custom photo to visualize your UI in a custom environment. And to help you create your augmented experience, we released a new skill to build display AI glasses with Jetpack Compose Glimmer. Ask Gemini to build a display AI glasses activity to get started with an Android Studio. As you bring on your users to AI glasses, a seamless onboarding flow enables users to take full advantage of these capabilities. To help you build and design your AI glasses experiences, we are updating our design guidelines to include onboarding best practices and new UX resources to implement in your app. head on over to Google AI Glasses Design to learn how to design seamless experiences between your phone and AI glasses. To learn more about developing augmented experiences, tune into our other I/O Talk, Extend Your Mobile App for AI Glasses to get into the technical details. Now, to share the latest in immersive experiences, I'll hand it over to Elijah.
Thanks, Yasmin. We've been hearing from both you, our developers, and end users about how excited they are for Galaxy XR. We continue to invest in immersive experiences, and we've been working hard at accelerating the frequency of updates. When it comes to building immersive experiences, we know you generally take one of two paths. If you feel most comfortable with Android Studio and Kotlin, we've made major updates to the Jetpack XR SDK. We're also introducing exciting changes if you feel most comfortable in real-time 3D engines that support OpenXR. Today, we have major updates for both, starting with our developers who are leveraging our native Android libraries. For native Android development, existing Android libraries are available, and we've also introduced powerful native libraries, XR Runtime, Jetpack XR Scene Core, AR Core for Jetpack XR, and Compose for XR that allow you to create differentiated immersive experiences. 3 of our libraries in our Jetpack XR SDK are officially moving to beta soon, XR Runtime, Scene Core, and AR Core for Jetpack XR. As part of this developer-centric refinement, we've completely streamlined the stack, removing legacy Guava and RxJava 3 packages in favor of a modern, performant Kotlin-first architecture. Let's talk about Scene Core. You now have more granular control over physical-based rendering. You can utilize GLTF introspection to examine and modify properties like pose, PBR-based materials, and textures. You can also inspect animation nodes and subnodes and run animations to blend digital objects indistinguishably with reality. Scene Core now also supports custom meshes, which allows you to use code to build shapes on the fly. This makes apps much smaller and allows them to create infinite, unique environments, like a landscape that grows as you walk, without ever running out of content. In Compose for XR, we've expanded our follow modes by adding new billboard behaviors for your spatial panels or any entity. We're also thrilled to introduce native GLTF support directly in Compose. This means enhanced layout support, such as automatic sizing based on your layout constraints. It also provides support for more complex GLTF interactions. You can now finally control animations with pause, seek, and playback speed adjustments, and easily place XR content like spatial panels relative to specific GLTF nodes. Under the hood, AR Core for Jetpack XR is unlocking massive potential. Features like depth maps, eye tracking, hand tracking, hit testing, and local spatial anchors are all hitting beta. These features power perception capabilities in your application that make users feel more connected to their surroundings by having virtual content blend with the real world in a more natural way. We are also providing an early preview of the Geospatial API for wired XR glasses. The Geospatial API will allow you to create immersive XR experiences that are tied to real-world locations and AR navigation experiences that guide users with precise walking directions. The Geospatial API works in any area covered by Google Street View and Visual Positioning Service, which are available in over 87 countries. In Android Studio, the XR Glasses emulator now provides a more realistic optical see-through wired XR glasses experience, thanks to environment dimming, added display transparency, and blended background environments. Feel free to check it out. Now, let's talk about that second path. For those of you whose workflow is centered around building with real-time engines, we are committed to making sure Android XR is accessible to the popular engines you all love and have requested. Today, we're announcing the official launch of our Godot vendor plugin. And alongside it, we're also releasing a developer preview of our Unreal vendor plugin. We're incredibly excited to see what both of these passionate developer communities will create on our platform. We know that the number one pain point for engine development is the slow build and wait iteration cycle. Our goal is to ensure Android XR provides a frictionless path for you to bring those experiences to your users. To solve this, today we're introducing the Android XR Engine Hub. This is a unified desktop application designed to be your central command center for XR development. The Hub houses a much requested feature called Direct Preview. Direct Preview allows you to see changes you make in your engine editor live on your headset almost instantly. Because the Hub is completely engine agnostic, this instant iteration cycle works whether you're building in Unity, Unreal, or Godot. It enables you to quickly iterate and test your ideas. And we want to ensure that regardless of which engine you use, your apps still feel like a natural cohesive part of the Android ecosystem. That's why we're introducing the Android XR Interaction Framework, or AXRIF. It bridges a UX gap between engine experiences and the Android system, bringing the native Android XR input, gestures, and interactions that users expect directly into your engine apps with minimal additional work. Starting today, you can use our plugin for Unity to seamlessly integrate AXRIF with new or existing XRI-compatible apps. But a truly cohesive ecosystem isn't just about how an app behaves, it's also about how it looks. We heard your request for bringing our design language into your 3D workflows. The Mixed Reality Toolkit for Unity, MRTK3, now supports material theming, allowing you to easily skin your favorite MRTK3 components with the familiar material design look and feel. And to ensure your worlds sound as immersive as they look, we're releasing an updated Android XR Audio SDK for Unity today, with support for other engines coming soon. To round out our Unity support, today we're also releasing an updated extensions package to further streamline your development. Finally, as we build these diverse engine experiences, we're looking at how they coexist. As a member of Chronos, we are collaborating to extend OpenXR to allow multitasking, enabling multiple engines to run within one single scene simultaneously. This means you can run OpenXR and native Jetpack XR experiences at the same time. Users can interact with your native Android application, and this can send information to a 3D scene. A developer who's leading the way on some of these new features is the NBA. As you can see here, they're building a live tabletop companion for games streamed on NBA League Pass in their Android XR app, allowing them to use native Android UI and OpenXR engine experiences all within one scene. Soon, fans will get to experience and appreciate NBA action in a whole new way on Android XR, and as big fans of the NBA ourselves, we couldn't be more excited. I'll now hand it over to Sivan to close us out.
Thank you, Elijah and Yasmin, and thank you all for your incredible input and feedback as we build this platform together. Before we wrap up, I want to reiterate how thrilled we are to see the amazing experiences you are already building and publishing for the newly launched Galaxy XR. The device is publicly available right now, and the developer momentum we are seeing is absolutely incredible. We are deeply committed to continuing our investment in XR experiences. With every new device that enters the Android XR ecosystem, your opportunities to reach new users and build groundbreaking apps multiply. And the best part? The efforts you put into building for immersive experiences today will seamlessly set you up for success on our upcoming form factors such as Xreal's Project Aura. To help you get hands-on with the future of this hardware, we are thrilled to open applications for the Android XR Developer Catalyst program, which includes Project Aura. Starting today, you can apply to get access to an Xreal Developer Kit or our AI Glasses Developer Kit over the coming months. It is an amazing time to be an Android developer. With the Jetpack XR SDK moving to beta soon, new Jetpack Compose Glimmer components, and robust engine support, the tools are ready for you. Get inspired by open source examples on the Android XR experiment site. We've updated our Unity showcase samples with a variety of new experiences, including depth-based scene meshing and building blocks for calling Gemini APIs using voice and camera images, as well as Jetpack XR SDK experiments, showcasing an immersive personal museum, a spatial audio sound explorer, dynamic 3D models, and more. Head to the Android developer site for full documentation, and when you're ready, apply for the Android XR Developer Catalyst program to start building. Have a great I/O.
Hi everyone, thanks for joining us today. My name is Lydia, and my colleague Feline and I are product managers at Google Play. Together, our teams have been working on a range of exciting updates designed to help you grow your businesses and maximize opportunities for your apps and games. And today, we're going to give you the inside scoop on all of them.
There's a lot of features to cover, so we've grouped them into 3 main categories. First, we'll talk about the features that save you time. We'll show you how to streamline your day-to-day tasks, from managing custom store listings to running experiments, so you can focus on building great experiences and let new AI-powered tools do the rest. Next, we'll dive into reporting and insights. These are the tools and features that show you where to focus your effort for maximum impact, like the new reporting tools in Play Console that give you actionable guidance at exactly the right time in your app's lifecycle. And finally, we'll focus on monetization tools, including the latest ways to boost your bottom line and reduce friction in the purchase journey. These updates are designed to work together to help you grow your business at every stage. So let's get started with a look at our first category, saving you time. Customized store experiences are one of the most effective ways to engage and attract users, but we know that creating them can be time-consuming. So we've streamlined content creation and testing for your store listings, so now you can drive those big results in less time. We've also made it easier to customize the lending experience by language by giving you the ability to import translations with Gemini. To submit translations for your listing, you no longer need to copy-paste them. All you need to provide is a structured document and we'll pre-populate the store listing forms for you. And for those of you who are new to custom listings or just need some fresh ideas, Gemini can help with recommendations and help you deploy your new custom listing with just a click. When Gemini identifies a new growth opportunity for your app, you'll see it in the recommendations section on the Grow Overview page, along with a custom listing to capture that opportunity that you can deploy right away. Last but not least, we've made it easier to transfer developer account details when an account owner moves on. With the new self-serve account owner transfer process, the current owner of the account can initiate a transfer to one of their team members. After proper verifications, you will be able to complete the process easily using Play Console. These are just a few examples, but together, all of these improvements add up to a lot less time spent on admin and a lot more time to focus on what matters most. Which brings us to the next batch of updates, enhanced reporting and insights to help you figure out where to focus that time, including helpful guidance and tools to understand and optimize your performance, connect the dots, and maximize your ROI on Play. Starting at the top of the funnel, we've made significant improvements to the console's Grow Overview page. This includes new metrics to give you a consistent and comprehensive view of your growth funnel, from reach to acquisitions, first opens, engagement, and retention, all in one place. You'll also be able to see both user and device rollups for many of those metrics. To give you even more insight, we're also launching traffic source as a dimension across these metrics and others, including monetization. So for example, if you want to know what proportion of your engagement is driven by Explore acquisitions, or how your user retention compares across traffic sources, now you can find out with just a few clicks. But it's not just metrics themselves we've improved, we're also giving the reporting API a major upgrade, so you can consume all this data in a way that works for you. Until now, the API has only supported Android Vitals metrics, but we're in the process of adding not only console growth and monetization top-line metrics, but also content performance metrics. We're also offering an MCP server. Together, these updates will allow you to access your console data programmatically or using agents, and seamlessly integrate it into your own datasets and workflows. As a friendly reminder, access will depend on specific program requirements and account eligibility. Following last year's launch on the Play Console statistics page, Gemini-powered chat descriptions have now expanded to the reach and devices, store performance, and revenue pages. This brings critical, automated insights to your most vital charts, helping you interpret performance data more effectively at a glance. At the same time, we're also making it easier to compare and aggregate your data by standardizing more reports. Store listing reports will now be consistent with the way we report on other content, such as promotional content and YouTube videos. You will see updates to the way we count visitors, unique installs and opens, as well as pre-registrations and respective click-through rates, so you can more easily compare those metrics across different types of content. Speaking of clicks and click-through rates, we're also making an important update to the way we calculate this metric on Play. As Play Store drives more and more discovery pathways, we will move to indirect attribution for all store content, so we can capture more complex user journeys and provide you with deeper insights. All of these improvements, from new and enhanced metrics to better and more consistent reporting, will help you get a clearer, more detailed picture of the value of all your content on Play. But those aren't the only reports and metrics we improved, so now I'll pass the mic over to Feline, who can tell us all about the improvements to our monetization metrics the team has been working on.
Thanks, Lydia. So to complete your ROI analysis, the Monetize with Play overview is the core destination. We've made some awesome upgrades to this page to give you an even clearer view of your revenue drivers, along with new insights. Let's check it out. Firstly, one of our newest AI features in development that you can take advantage of. You've told us that you spend a lot of time navigating in between all of the reporting pages to find what you're looking for. Well, why not see how effective your current monetization strategies are with a single click of the button using AI? You don't need to analyze multiple pages or even manually enter a prompt. Just click to see the latest insights on your buyers, conversion, churn, and pricing. Sign up to our early access program today. Earlier this year, we added the ability to track your cart conversion rate right within your core performance metrics, making it easier to optimize your conversions. Because Play's global presence extends across the whole Android device ecosystem, we recommend using the premium user device segment for benchmarking your performance. You can get a deeper understanding of user behavior and your user's intent to purchase by segmenting by other dimensions such as countries and buyer type. We're giving you more granular insights into the purchase journey with new metrics on network health, user intent, and payment processing, showing you exactly where friction exists so you can continue to optimize. Besides these new metrics, we've also given you more ways to understand your impact. Earlier this year, we launched a new value insights carousel, which highlights ROI that you might already know about. For example, you might see how user-facing features like purchase verifications and payment reminders have increased purchase-ready users, which in turn led to an increase in your first-time buyers. Or, if you offer subscriptions, how many subscriptions have been recovered for our churn reduction features, such as resubscribe and payment decline recoveries. And this is just the start. We'd love to hear which insights you find the most useful, so please like the insights that you find more valuable to see more like them in the future. For finding your app's biggest opportunities, our tailored recommendations at the bottom of the Monetize with Play overview are focused on ways in which you can maximize your ROI. We've used Play-wide data to prioritize the ones we think could benefit your business most, so go take a look today. So, thinking back to the app lifecycle, now that you've taken advantage of all the amazing ways to save time in growing your app and understand your ROI, the next step is to think about your ever-growing success in monetization. With that in mind, and to wrap things up, let's look at some of the newest tools to support your monetization strategy and reduce friction in the purchase journey. One of the most amazing things about Play is our huge global audience, and this is only getting bigger. Recently, we reached over 880 million purchase-ready users around the world. That's more than 1 in every 6 people on Earth. To help you reach this incredible audience, we've continued to expand our support for local payment methods in emerging markets, including Africa and South America, and added card networks in Asia, the Middle East, and Nordics. We've also enabled users to buy in Mongolia and provided developers in Kyrgyzstan and Kosovo with the ability to monetize, enabling the Play ecosystem to grow even further globally. For merchandising across Play Store surfaces, we've streamlined the console experience with a single unified merchandising flow to improve your efficiency and ROI. And even better, you can optimize those offers with the Play Billing Lab testing app, which makes it easy to test how your offers are shown to users on Play surfaces. And speaking of offers, why not encourage your users to stick around and remind them what they love about their subscription while offering your subscribers a discount from within the Google Play cancellation flow? By engaging users at a critical moment, it's a great way to help you keep more subscribers. We're also partnering with developers, payments, and gifting partners to source offers for Play users, which will be automatically presented when they're ready to pay. No hunting for codes or waiting for a cashback for the user, and no extra work for you. Win-win. We've heard from you that churn can be challenging to solve for, so we've been looking at multiple ways to help you with your churn rate performance. First, we're streamlining the checkout experience for one-time products and subscriptions, starting with UPI. Buyers who use this payment method will now see a single screen checkout, so there's less time for user hesitation when they go to purchase. This is only the start, and we'll be rolling out our updates to other payment methods later this year. To improve your involuntary churn rates, we've enabled backup payment methods. Now, if a user has insufficient funds on their primary card, we can automatically charge the next payment method within their wallet. We've also rolled out dynamic grace periods with subscriptions. Using our personalized machine learning models, this feature turns grace periods into a precision tool for reducing churn. Instead of a single fixed grace period for everyone, our system can identify a high-value user and grant them a longer window to fix their payment without them losing access to your app's content. This intelligently reduces involuntary churn, all while maintaining a premium user experience. And next, we want to extend our flexible tooling to managing your purchases. We've introduced the Dynamic Purchases API, which lets you define all product metadata at runtime instead of predefining your products on Play Console. Finally, with more flexible pricing, you can now set product prices of up to $8,000 in supported markets. For more details, be sure to check out the Play Console Help Center. Don't forget that the quickest way to get access to all of these monetization features, including subscription churn reduction tools, pre-orders, auto top-ups and more, is by integrating directly with the Play Billing library. This also helps you to avoid the functional limitations often found in middleware SDKs. To fully unlock the power of Play's billing platform, including the latest tools and features announced today, we strongly recommend upgrading to the Play Billing Library 9.0, available at the end of May. As a reminder, we will continue to support each major release of the Play Billing Library for 2 years. This means support for version 7 will end in November 2026, and you'll need to upgrade before you can publish new versions of your app. And that's it for our session. We hope you enjoyed learning about the latest ways to save time, gain deeper insights, and boost your bottom line with Play. We've certainly enjoyed sharing with you. Thank you for spending your time with us, and for all of your amazing work with Google Play.
Hi everyone, I'm Karen, and today I'm joined by Aaron to talk about the latest developments of on-device Gen AI and Android. In this talk, we'll cover why and how you should consider on-device AI use cases for your app, AI Core Developer Preview, a new way for you to preview the latest on-device models and improve your overall development process, MLKit Gen AI APIs that help you bring most use cases to production, along with new capabilities like speech recognition and improvements to Prompt API with caching and structured output, and Lighter TLM to help you enable even more customized use cases. Let's start by talking about why you should consider on-device Gen AI in your apps. On-device Gen AI refers to the ability to process prompts and data directly on a device without sending data to a server. Since the server is not required, this offers a few advantages. Sensitive user data can be processed locally on the device. Functionality of the model does not depend on internet connectivity, meaning the model can output reliable results even with spotty or no internet connection. And lastly, there's no additional cost for each inference, since everything runs on the user's hardware. With these advantages, on-device makes a great solution for use cases like handling sensitive user data, such as banking or medical records, personalization to build tailored experiences for your users, such as customized summarizations of news articles tailored to a user's specific interests, and scenarios that require a smaller context window and compute power, such as translating short sentences or classifying content into specific categories. Building these types of differentiated use cases elevates the experience for users, and Google is committed to making this possible for you on Android with access to models like Gemma and Gemini Nano. Gemma is a collection of state-of-the-art open models built from the same technology that powers the Gemini models. On supported Android devices, Gemini Nano builds on Gemma's architectural foundation and is further optimized for maximum battery and performance efficiency. This means that prompts you write for Gemma 4 today will automatically work for the next generation of Gemini Nano models when shipped on flagship devices. To make it easy for your apps to utilize the capabilities of these powerful on-device models, we provide a complete stack of production-ready solutions. First, for the majority of use cases, MLKit Gen AI APIs offer the most direct path to production. These APIs provide access to Gemini Nano, with Android OS automatically managing model updates so apps are always using Google's most powerful on-device model. Alternatively, if your app targets niche domain areas, Lighter TLM allows you to manage and run small customized models on user devices. Let's dive first into MLKit Gen AI APIs that allow you direct access to Gemini Nano. On supported devices, Gemini Nano is deployed and managed through AI Core, an Android system service. By using Gemini Nano through AI Core, apps gain advantages such as optimizations based on the device hardware to enable lower inference latency and reduce power consumption, no extra effort in managing model deployment, including updates to the Gemini Nano model, and built-in privacy and safety. AI Core is designed to isolate each inference request. This means that requests are handled independently and processed from one app at a time to mitigate the risk of data being exposed to other apps that use AI Core. Input data and the resulting outputs are never stored anywhere on the device. To give you a more concrete idea of the developer journey when integrating MLKit Gen AI APIs, let's see what it takes to go from prototyping to productionizing use cases. With AI Core Developer Preview, you can now test both production and preview models of Gemini Nano, allowing you access to the latest capabilities of Gemini Nano before it's launched to production. Using the app, you can download models, explore new use cases by testing prompts, and have control over developer settings such as bypassing quota limits. Preview models are currently available for testing on AI Core-enabled devices from Google and select device manufacturers. To further improve the developer journey when prototyping with preview models, we've introduced the Model Selection API. This API allows apps to target preview models for their Prompt API integration in order to test the full code path of a new model. When initiating a model to make inferences through Prompt API, you can now specify the target model. By providing the ability to download and prototype with preview models such as Gemini Nano 4, we hope you can get a head start on refining prompt accuracy and exploring use cases before the models launch on consumer devices. To get started, check out the step-by-step instructions at our official documentation. Next, after prototyping and refining prompts, it's time to implement use cases directly in your app. MLKit Gen AI APIs makes this easy for you by providing out-of-the-box quality through a high-level interface. For common use cases such as summarization, proofreading, rewriting, and image description, last year we introduced APIs that require no prompts and just a few lines of code. To add on to these popular use cases, we recently unlocked on-device audio experiences with MLKit's speech recognition API. This API transcribes audio content, either from the device's microphone or an audio file, to text. On supported devices, the API will use the on-device Gemini model. And on all other devices, developers have the option to use a traditional on-device speech recognition model. This means that the API is compatible with all devices running Android 31 and above. With the on-device Gemini model, MLKit's speech recognition API provides the following benefits: higher quality transcriptions for languages such as Arabic, Indonesian, Dutch, and more. Less storage required. The traditional on-device speech recognition model requires downloading a single model between 100 to 200 megabytes for each language the user uses. However, the on-device Gemini model only requires one small LoRa adapter to transcribe all supported languages. And a more friendly developer API for streaming audio capabilities. Start implementing speech recognition API in your Android apps today with guidance from our official documentation.
Now, if your app wants to implement a user journey beyond predefined use cases just discussed, or you want more control over the output, we recently introduced Prompt API. Prompt API allows you to send any natural language request to Gemini Nano by accepting text and images as inputs and emits a text output. The versatility of this API has enabled Adobe Photoshop to utilize it in multiple ways to improve the user experience from start to finish. From the beginning of the creation process, the app is able to intelligently rename images during imports and exports. This use case is enabled by Prompt API's multimodality support with image inputs. While editing assets, users often have to manage multiple layers in Photoshop. Using Prompt API, the app is now able to automatically rename unorganized layers as actions in the Layers panel. And finally, the app generates a caption and hashtag for the direct-to-social sharing workflow. It's been exciting to see the different ways apps have used Prompt API to fully embrace on-device Gen AI for use cases such as translation, classification, user content inspiration, and much more. And since Prompt API's initial launch last year, we've made a couple of key improvements to help you further productionize your use cases. Let's talk about the new APIs that make it easy for you to maximize performance and quality so you can ship your features to users. The first is prefix caching. Prefix caching reduces inference time by storing and reusing the intermediate LLM state of processing a shared and recurring part of the prompt. For example, if a prompt contains a long prefix portion that's the same for every request, the prefix caching API can pre-process this to save overall inference time. To get a better idea of the efficiency prefix caching can provide, for most devices, inferences were on average 2 times faster for prompts with a 1,000 token fixed prefix and a 100 token dynamic suffix with prefix caching enabled. And on Pixel 9s, it was 4 times faster. There are 2 ways to enable prefix caching, with automatic or manual cache management. With automatic cache management, the app is only required to define a shared portion of a prompt, whereas manual cache management gives apps more control on cache creation, querying, and deletion. For more information on how to enable prefix caching, including code samples and storage considerations, check out our official documentation. Next, to improve the accuracy when requesting specific output formats and ease the overall developer workflow, we've introduced Structured Output API. This API allows apps to define object classes to be returned as outputs from Prompt API requests. For example, imagine we want to implement a use case where we extract information from a short email to create a calendar event. Using prompting, we could craft a long prompt in plain English with specific instructions about details to extract from the email, such as the title, date, and location of the event, and include an example JSON object we want as the output. However, this approach is error-prone and can return inconsistent results. The output may be an incomplete JSON object, or the returned JSON object may not have all the fields we requested. With Structured Output, we can now define a calendar event data object and use generate type content when making an inference request. Generate type content will take a Kotlin data class marked as generable to better understand what the expected output should be. Inside the generable, you can further define guides to specify how each field in a data class should be generated. This approach with Structured Output reliably returns consistent results and makes code simpler with Kotlin data objects that integrate seamlessly into your Android codebase. To get started, visit the official documentation for using Structured Output with Prompt API. Lastly, to remove the guesswork from prompt engineering, we introduced Automated Prompt Optimizer, or APO, targeting on-device models. APO is an advanced tool for developers seeking to maximize quality by utilizing a well-prepared evaluation set. It helps you automatically find the optimal prompt by taking the guesswork out of manual prompt engineering. Using server-side models such as Gemini Pro and Flash, it proposes improved prompts, uses datasets and evaluation metrics you provide to measure variations in results, and finds the best prompt for your specific use case. To try out an early version APO, check out the official documentation on Vertex AI. Now that we've seen the ways MLK Gen AI APIs can enable different use cases in your Android apps, let's hand it over to Erin, who will dive into how Lighter TLM can help you unlock even more use cases.
Thanks, Karen. MLKit and AI Core are incredible for getting AI features running out of the box. But what happens when you need a custom solution unique to your needs? What if you need to run a highly specialized model or maximize reach on a wide variety of Android hardware? Beginning a custom solution starts with choosing the best model for your use case. You may want to use an open source model such as Gemma, or bring your own. For the best Android performance, always use the smallest possible model that reliably solves your use case. We'll demonstrate fine-tuning a specific task using Gemma 270M, a highly efficient 270 million parameter model. Let's imagine a real-world scenario. Maybe you're building an agri-tech app for farmers in rural Maharashtra, India. Your backend provides agricultural insights and weather warnings in English, but you need to translate this information into Marathi so your users can actually understand it. You need the model to capture the actual nuance of the language, specifically the Varhadi dialect, local farming colloquialisms, and regional slang, but it needs to run offline due to rural farms and regions with no connectivity. Gemma 270M can solve this, but it will perform much better if we fine-tune it for this exact dialect. Start by curating a specialized dataset, or grab a conversational English to Marathi dataset publicly available on Hugging Face that provides the model with thousands of paired sentences. You can fine-tune directly in a Google Colab notebook. Using community tools like the Hugging Face TRL library and SFT trainer, you load your regional dataset and train the model until it reliably generates accurate, localized translations. Once your model speaks the local dialect, convert and quantize the model into a format optimized for the constraints of mobile hardware using the Lighter TLM command line tool. This tool transforms your fine-tuned model and converts it directly into the Lighter TLM file format. Check out the Lighter TLM CLI documentation for more information on how to convert your model. When you are ready to integrate your custom Lighter TLM model into your own app, you can use the Lighter TLM API to manage sessions and run inference natively in Kotlin. First, you initialize the engine with your model path and preferred hardware backend, like CPU, GPU, or NPU, and load your model in the background. From there, you instantiate a conversation object, which automatically manages the context window and chat history for you. Finally, to give your users that fast typing effect experience, you can use send message async. This returns a Kotlin flow, allowing you to stream tokens directly to your UI as the model generates them. Getting your model up and running on your own developer phone is a huge win. But how do you guarantee your custom model will run smoothly across the ecosystem, even on older devices? The Google AI Edge portal automates this by benchmarking your Lighter TLM file across a fleet of over 100 real physical Android devices hosted in Google's labs. So then you can see how your model performs across all these devices before you ever even hit production. Even though we are using Gemma 270M as an example today, it is important to note that this flow with Google AI Edge works for any open model. And to recap, when you need a truly custom experience, like an offline translator for regional dialects, Google AI Edge and Lighter TLM are your solution. And by packaging your fine-tuned models in the Lighter TLM format, you reach beyond the newest devices, scaling to a broader and more diverse range of Android devices. If you're ready to get hands-on, we have 3 great resources for you to check out. To learn how to train your own custom models, head over to the Gemma Cookbook. When you're ready to drop those models into your app, the Google AI Edge documentation has everything you need, from API references to performance evaluation tools. And if you just want to dig straight into the code and test out different open source models today, download the AI Edge Gallery app on the Play Store or fork it on GitHub. We hope this overview gives you more confidence when implementing on-device Gen AI with MLK Gen AI APIs for the majority of turnkey solutions and Lighter TLM for more customized use cases. We're excited to see the different ways you will bring on-device Gen AI to your Android apps. Check out the resources linked in the video description below on everything covered in this talk to get started.
Hello, I'm Ben, the Developer Relations Engineer working on Navigation 3, and I'll be joined by Clara. In this session, we'll be covering everything you need to know about building adaptive layouts for your app with Navigation 3. After a brief refresher on the core concepts of the library, we'll cover what's new in the 1.1 release. That includes a deep dive on scene decorators, which can be used to add common UI elements such as top and bottom bars around your app's main content. To close things out, we'll take a look at how Navigation 3 is expanding to Wear OS and give you a preview of what we're working on for 1.2.
Hello, I'm Clara. First, let's go over some basic Navigation 3 concepts. Navigation 3 was built from the ground up with compose state as a fundamental building block. This means that it fully buys into the declarative programming model. You change the state you own, and we react to that new state. To start, the navigation backstack is just a regular list that you fully own. The backstack contains keys which can be of any type, and each key in the backstack maps to a nav entry that contains a composable content. As you add and remove keys on the backstack, navigation reacts by recomposing the content based on the current keys on the stack. To set this up, define your nav key and create a backstack with the key. In this example, the key extends the optional nav key interface. Then, invoke the nav display composable and pass in the backstack. Now, nav display also needs to know what content the key maps to, so you need to pass in an entry provider. The entry provider is responsible for providing a nav entry for a given key. In the nav display, call the entry provider DSL and add entries with the nav key and the associated content. And that's it. Nav display will first decide what to display, and then it calls your entry provider with the key to get the correct entry. In this example, the entry provider will return the home nav entry for the home key. By default, navigation will render the nav entry associated with the last key on the backstack. But what if you want a more complex layout? For example, what if you want to display multiple entries at the same time? This is where the scene interface comes in. A scene controls which entries are displayed and how they are displayed. This means that the same nav display can be used to show entries in different layouts, such as a dialog, a side-by-side list detail, a horizontal pager, a bottom sheet, or just a single pane. But how does the nav display pick the correct scene to show the entries? It does that by asking each of the scene strategy instances you pass to it. The nav display goes through a list of scene strategies in order they were added to the list, and the first strategy that returns a scene dictates the entries to display and the layout to display them in. Nav display will then invoke the return scene to display the actual content. The list of strategies can be modified, and nav display will just recalculate and display the new scene. Now, how does the scene strategy decide whether to return a scene or not? One of the ways is by evaluating the entry's metadata. The nav entry has a metadata field, which is a map of string key to any values. Nav entries can opt in to be displayed by specific strategies through adding the metadata defined by a strategy. This gives entries control over how it wants to be displayed. In this example, the entry opts in to be displayed as a dialog. In our 1.1 release, we listened to your feedback and made several improvements to our APIs. In the past, scene strategies used to be passed in as a chain of strategies linked by a then infix. However, it was named as a singular scene strategy, and the then infix was not discoverable. So, in 1.1, we renamed the parameter to a plural scene strategies, and now it takes a list of strategies. But remember that order still matters here. As mentioned, the first strategy that returns a scene becomes the dictating strategy, and strategies are evaluated by the order they are added to the list. Next, in 1.1, we also improved the metadata APIs. As mentioned, the metadata is a map of string to any, which is not very type-safe. Also, the keys are commonly declared as string constants, so they are not readily discoverable. So, we improved them by adding a nav metadata key interface and a metadata DSL. Now, when you define a metadata key, the key can optionally implement the nav metadata key interface. You'll notice that the interface has a type parameter. The parameter represents the type of the data that is associated with the key. This means that when you define the key, you are also declaring the type of data it expects. This helps ensure you store the correct data type. With the nav metadata key, you can now use the metadata DSL. The DSL is a type-safe map builder that provides a put function, which accepts keys that extends the new key interface and the value associated with the key. The DSL returns a map of string to any containing the data you added with the put function. And you can use a plus operator to combine metadata maps. This allows you to declare modular, reusable metadatas, which you can mix and match to create the final metadata for a given entry. With the DSL, you can also write conditional logic to determine the final metadata that you want to add. Another new feature that was added in 1.1 is the support for shared nav entries. Nav display now animates shared entries as shared elements when you use shared transition layouts. As mentioned, nav3 can render multiple entries on the screen at the same time. And sometimes, the same entry can be shared between different screens. For example, consider a two-pane app with a screen displaying entry A and B. The app then navigates to a new screen with entry B and C. In this case, the two screens share entry B. Let's see what this looks like in an actual app. This app shows two products side by side on the screen. When you navigate to the next product, the product currently on the right moves to the left, and the new product is now displayed on the right. It works as expected. However, you'll notice that there is no transition animation when the entry moves from right to the left, and there is a flash on the right side. This is because an entry can be only displayed on the screen once. So the entry on the right side is dropped immediately when the screen is recomposed with that entry now on the left. In 1.1, we improved shared nav entries by animating them as shared elements. This allows a shared entry to exit the old screen and enter the new screen with a single continuous transition. Let's go back to the same app. Now you can see that as you navigate to the next screen, the product that is currently on the right side slides smoothly to the left. As mentioned, support for shared entries is added in 1.1, so all you have to do is apply shared transitions. Let's see what the code looks like. First, wrap nav display within a shared transition layout. Then, pass the provided shared transition scope to nav display, and that's it. Now, when the screen transitions from one to another, any shared nav entries between them will be animated as a shared element, resulting in a smooth transition. Now, back to Ben to explain scene decorators.
Finally, 1.1 introduces scene decorators, which allow you to modify the scene calculated by your app's scene strategies. Scene decorators can be used to add UI elements such as top app bars or navigation bars or rails that you'd like to add at the scene rather than nav entry level. To illustrate this API, let's walk through the process of implementing a basic scene decorator that applies a border around the scene it decorates. To start, we'll define a border scene class that takes in a scene as well as some configuration for the border that it draws. Since border scene implements the scene interface, it needs to override the key, entries, previous entries, and content properties. Because border scene just wraps this input scene, it has the same entries and previous entries. For the purposes of this example, it can also copy the input scene's key, but more on that later. As for its content property, border scene uses a box with the modifiers necessary to create an outer border. And within that box, it calls the input scene's own content composable. Now that we have the border scene class, we need a way to use it. This is where the scene decorator strategy interface comes in. We'll create the border scene decorator strategy class as our implementation of the interface. This interface has just one method to override, decorate scene. Unlike the calculate scene method of the scene strategy interface, decorate scene can't return null. Instead, if the input scene shouldn't be decorated, you just return it as is. When determining whether or not to decorate a given scene, a scene decoration strategy can consider the metadata of its input scene, its nav entries, as well as any other state that it can access. The last step is to create instances of your scene decorator strategies and supply them to your app's nav display using the scene decorator strategies parameter. Now, when we run the app, we get a result like this. Just like we want, the borders are applied around all of the nav entry content, regardless of whether one or multiple entries are being displayed at a given time. Let's take a closer look at what's happening under the hood in these two configurations. When the window size is narrow, the two-pane scene strategy returns null during scene calculation, because there isn't enough space to display two panes side by side.
Nav display then falls back to a single pane scene strategy, which returns a single pane scene. In the scene decoration phase, the blue border decoration strategy takes in that single pane scene and returns a border scene that wraps it. The returned blue border scene is then passed as the input to the red border scene decoration strategy, which wraps it in another border scene. Now, let's look at what happens when the window size is wider. In this case, the two pane scene strategy returns a two pane scene, and the scene calculation phase ends there. The scene decoration phase follows the same flow as before, just with the initial input being a two pane scene instead of a single pane scene. An important thing to note from this example is that the class of the scene returned after scene decoration can remain the same, even when the class of the scene returned during scene calculation changes. This is noteworthy because nav display animates transitions between scenes when a key derived from the class of the current scene and its key property changes. This can cause unexpected behavior when introducing scene decorators in an app where different scenes use the same key, such as in the nav recipes list detail sample. In such a case, one solution is to provide an initial scene decorator strategy that copies everything from the calculated scene except for the key, instead using one derived from its class and key. This lets the following scene decorators just copy the key of their input scene. Following this approach, the list detail recipe now behaves like it did without any scene decorators. Now that we've covered the basics of scene decorators, let's see how they can be used for some more practical purposes. We published recipes in the nav3 recipes GitHub repo that demonstrate two use cases. The first shows how to create a scene decorator that adaptively switches between showing a bottom navigation bar or navigation rail based on window size. And the second shows how to create a scene decorator that can display an entire scene in a dialog. We can't get into all the details in this video. Here's a high-level overview of what those recipes demonstrate. In the responsive navigation recipe, we show how you can use Compose's movable content and shared element APIs to ensure that only one instance of a composable, in this case, the nav bar or rail, is composed at any given time. We also demonstrate how a scene decorator can consider states such as the current window size class when determining how to decorate a scene. In the dialog scene decorator recipe, we show one way that metadata can be used to determine if and how a scene should be decorated. And that's it for what's new in Navigation 3 1.1. Now, I'll hand it back to Clara to share updates on Wear OS and what's coming next for Navigation 3.
Support for Navigation 3 goes beyond mobile devices. Available today is a nav3 integration for Wear OS with swipe dismissible scene strategy in Wear Compose Navigation 1.6 stable version. Simply add Remember Swipe Dismissible Scene strategy to your nav display, and the entries will be displayed in Wear material components. It also comes with full support for swipe gestures. Beyond the 1.1 release, we're also working on a couple new features for version 1.2. Yes, we heard you. We will be adding APIs to support deep links and APIs to pass events or state-based results between destinations. Currently, we have recipes to show sample implementations of both features, but we are graduating these recipes into APIs to make it easier for you. So there's still more to come.
Thanks for joining us today. We hope you've enjoyed learning how Navigation 3 can make building adaptive UIs easier than ever. To view the recipes mentioned in this talk, as well as many others, check the link in the description. And last but not least, if you have any feedback or feature requests you'd like to share with us, please reach out through the GitHub or issue tracker.
Hello, everyone. It is so good to be here with you. Today, we're going to talk about all the exciting updates the Material Android team has coming down the pipeline, and how these updates can help you build beautiful, premium, and adaptive apps with Material. For years, we've been on a journey to redefine how we build UI on Android. We've seen Jetpack Compose grow from an ambitious idea into the engine behind the world's most beautiful apps. As Android's modern declarative toolkit, it's designed to simplify and accelerate UI development with less code and powerful native tools. I'm Kendrick, a software engineer on the Material Android team, and I've been lucky enough to see this evolution firsthand. Today, we're reaching a definitive milestone in that journey, one that marks a new chapter for Android developers. We've reached a major milestone with the stable release of Material Views 1.14. This release brings new expressive components to the Views system. But you may have noticed a change in momentum. While Compose continues to accelerate, our updates for Views have become more focused. That's because, for the last few years, we've been preparing for a fundamental shift. To tell you more about where we're going next, I'll hand it over to Naomi.
Thanks, Kendrick. Hi, everyone. I'm Naomi, a software engineer on Material Android. To build effectively for the future, we have to focus. As of today, we are officially all in on Compose. Moving forward, our team is transitioning to exclusive support for Jetpack Compose and will be moving all of our efforts to the Material Compose library. This means that Material Views 1.14 will be our final stable release for the Views library. We know how much you've built on Views, but there has never been a better time to migrate to Jetpack Compose. If you've been waiting for the right moment to go Compose first, this is it. With the upcoming 1.5 release in the second half of 2026, promoting M3 experimental APIs, Material 3 in Compose is officially going stable. In addition to Material 3 going stable, we're also introducing our Material 3 expressive components. M3 expressive APIs form an expansion pack to M3. You can opt in to using them to deliver more premium experiences.
We've taken your feedback to heart, and we're going to show you how we're making Material 3 on Compose more expressive, performant, and adaptable. We'll be diving into new Material 3 expressive component features that bring more personality and motion to your UI. The Styles API, our new approach for performance, simplified, state-based styling. Enhanced adaptive integration to help your apps feel at home on any screen size.
Last year, we showed tons of cool new expressive components such as the floating toolbar, new progress indicators, button groups, and more. Building on the success of last year's expressive components, we're expanding the kit to be more versatile than ever. Our lists have evolved into two variants, including a sophisticated segmented visual style, and introduce more interactivity by supporting clicks, toggles, and different selection states that automatically transform the container. The best part? If you're already using the standard list item, moving to a segmented look is a seamless swap. Let's look at these two list variants, standard and segmented, in code. First, we have our standard list. Individual items are separated with horizontal dividers, and each list item has parameters for a selected state, content, and icons. Now, the segmented list. By simply switching that list item out for a segmented list item, and adding a touch of gap spacing with the vertical arrangement specification on the list column, the framework handles the rest. It automatically manages the adaptive corner shapes and color updates, giving you a completely different visual DNA. Search received a major visual refresh, combining with the app bar to introduce dedicated slots for navigation and actions that live outside the search container, with exciting animations that make the experience feel more interactive. Let's walk through some code for the search component. We've introduced a new app bar with search composable that introduces dedicated slots for content before or after the search bar. Navigation icon provides a slot for things like a back button, and the action content slot provides a slot for icons like filter or voice search. We've also introduced new expanded search bars like expanded dock search bar with gap that you can use in conjunction with app bar with search to smoothly animate between the two.
Building on the menu component, we're introducing refined submenu motion and a broader palette of shapes and color styles. We've also added gaps, a new layout feature that provides visual breathing room and flexibility. Now, let's take a moment to walk through an example of using the updated menu component. We start with a flat list of drop-down menu items. While functional, a flat list quickly gets crowded and lacks hierarchy as an app grows. To add structure, use drop-down menu group. This visually separates items like modifications from navigation, with menu defaults.group shape automatically handling the rounded containers. To make the menu expressive and stateful, use the check parameter and checked leading icon. This swaps the icon from outlined to filled when an option is toggled, providing instant, clear visual feedback. You asked for more tactile inputs, so we're delivering. Meet the new, highly interactive time picker, soon to be updated for our expressive design system. We're debuting a dedicated scroll-based input component that powers a new tactile variant for time selection. Designed as a standalone primitive, it also gives you the power to bring that same precision scrolling to any number-based interface in your app. All of these expressive components are already available as experimental APIs in the 1.5 alpha release.
What else is in the pipeline? Well, we know you want your apps to feel unique. That's why we're integrating material components with a new experimental Jetpack Compose Styles API to enable deeper customization than ever before. This update will help you break out of the grid, move past the defaults, and build premium, engaging experiences that reflect your brand's specific identity. Style is a new paradigm for customizing elements and components that evolves beyond traditional modifiers. It is designed to unlock deeper and easier customization. The Styles API offers significant benefits, improving overall app performance by skipping the composition phase during style updates and simplifying the creation of cohesive branded experiences. You can check out the Building Custom Design Systems with a new Styles API talk to learn more. We're integrating the Styles API with material components to offer an easier and wider degree of customizability than before. Here's a sneak peek. Let's say you want a button, and you want it to have a navy blue background that animates to a lighter blue when pressed. Right now, to achieve this, there's a lot of boilerplate you need, like manually keeping track of the pressed interaction state and creating a new button colors class. Now let's say you want the background to be gradient when pressed. Currently, there's no out-of-the-box way to do this with material buttons. With styles, it's easy. With the upcoming integration with the Styles API, this will all be possible simply by passing in a style that sets these properties as input to the button components. Styles makes customization easier and unlocks new customization that was previously not supported. These updates are coming soon to material components.
Now, being premium isn't just about aesthetics. It's about how your app behaves across the entire ecosystem. We know that building for foldables, tablets, and desktops has historically been a challenge. The Material Adaptive Library is now integrated with Navigation 3, simplifying the development of layouts that scale across large screen devices. For a long time, building adaptive layouts meant switching navigation frameworks, making it complex to manage navigation into and out of adaptive sections of your app. To solve this, we've deeply integrated the Material Adaptive Library with Navigation 3. This is a game changer. It means your navigation logic and your adaptive layout are finally speaking the same language. Scaling your UI from a handheld phone to a large screen foldable is now a seamless, simplified process within your Compose code. One core piece of this integration lies in Navigation 3's scenes concept. Instead of navigating between isolated destinations, Adaptive can benefit by thinking in terms of visual scenes. With the Adaptive Navigation 3 artifact, we're making it easier to use the list detail scene strategy. This is essentially the brain that sits between your navigation backstack and your UI. It looks at the entries in your backstack, and based on the available screen real estate, automatically decides whether to show a single pane or a side-by-side list detail view. To make this work, simply tag your entries using listDetailScene.listPane or listDetailScene.DetailPane. Because the navigation library now understands the intent of these screens through that metadata, it handles the heavy lifting for you. And because this is built directly into the navigation state, you get predictive back support for free. When a user swipes to go back from a detail view on a foldable, the library knows to transition the detail pane away while keeping the list active. It's fluid, it's intuitive, and most importantly, it's one single source of truth for your entire application.
This session isn't just about a library update. We've listened to your feedback and are committed to making Material 3 more robust, more flexible, and significantly easier to implement in your daily workflow.
As you can see, we've been busy making Compose expressive, performant, customizable, and adaptive. You can check out some of what we discussed today in our guidelines, design kit, alpha code, and API documentation.
If you're migrating from Vue to Compose, check out our guide to help you out. Or if you want to learn more about Styles API, read our overview. Both are available on the Android developer site.
We're so excited to see what you build. Read about Material going Compose first on our material.io blog. Share your work and feedback with us using the hashtag M3Expressive on social or by tagging @GoogleDesign on Instagram and X. Stay tuned. This is just the beginning. We have more updates coming to Compose in the months ahead.
Last but not least, if you enjoyed our session, be sure to check out Bradley and Liam's design talk, Make Material Your Own. Thank you.
Hey everyone, I'm Don, and this is Jose. Today we're going to talk to you about building adaptive UIs, specifically for mobile and large screen form factors. So generally, when you think about building an adaptive UI, you think about how it looks on different form factors. You start with phones, which is still definitely the most important form factor, but then you consider tablets, foldables, laptops, desktops, TV cards, and a whole bunch of other form factors. Form factors represent an abstraction for a device's size and capabilities. And they give us a shared vocabulary that makes it easy to discuss how our apps should look on a given class of devices. After all, we all know what a tablet is, right? Okay, so let's test that. Hands up if you think this is a tablet. Okay, about 75, 80%. So like we're mostly in agreement there. Okay, so same question. How about this? Do you think this is a tablet? This is like the same device, charging dock with a keyboard and mouse. So, okay, so I'd say that was about 50% of you. So last one. How about this? Do you think this is a tablet? Okay, maybe 20%. Okay, so it turns out we don't all agree on what a tablet is. This is kind of fun though. So let's do another one. Is this a phone? Okay, so like it's definitely a phone when it's not plugged into that monitor, but does it become something else when it's connected? So my point here is that we don't all agree on what form factors are. Devices can have multiple form factors, they can switch between them instantly, and they sometimes don't neatly fall into a form factor category. And this means that form factors aren't quite as useful as we once thought they were for designing UIs. Also, creating form factor-specific UIs can lead to branches or entire code bases with lots of repeated code and like loads of maintenance requirements. So a better approach is to design and develop for UI capabilities, such as window size and pointer type. And this allows you to create an optimal UI regardless of the form factor. And with the APIs and tools that we're going to show you today, it doesn't have to be a costly investment, and you never know, it might actually be fun. All right, so in this talk, Don will focus on the adaptive APIs, and I'll show you how you can implement the changes using AI agents. The good news is that AI agents make this a lot easier and a lot faster. You can adapt layouts, create regression tests, refactor code, and migrate to modern APIs. And in this session, we'll talk a lot about new APIs. The problem is that models might not know about them yet. And that's why we need to complement large language models with fresh knowledge. If we do this, then the accuracy improves a lot. For that, we've released 2 key resources that you should know and use as Android developers. First, the knowledge base, which is a collection of thousands of up-to-date articles, mainly from Android's documentation, but also Firebase, Google Play, Kotlin, Google developers, etc. And also, we released the official Android skills. Skills are modular instructions to help LLMs understand best practices and execute specific workflows. They are a lot more opinionated than regular documentation, as they contain specific instructions for agents. The knowledge base and skills are available in both Android Studio and the Android CLI, so you can use them from any agent. If you don't know what the Android CLI is, it's a collection of tools for agents that let you manage your SDK and emulators, deploy apps, and also lets you search the knowledge base and install skills. Today, we are announcing an adaptive skill. It's an opinionated guide to help you make your UIs adaptive. You can download it from GitHub or using Android CLI. So now, with all of these resources, can you adapt a whole app in just one prompt? Can you just ask the agent, make my app adaptive? It depends a lot on the app, but one thing is clear, the change is a lot better and in the long run faster if we go step by step and we have a clear plan. Yeah, that's right. So the more you know about the tools and APIs, the better your prompts, the better your plans, and the better your code reviews. Plus, agents can make mistakes, so you need to be able to review any generated code. So in this talk, we'll give you the guidance and API information you need to get high-quality code from your AI agent.
All right, let's switch to the laptop. Done. There you go. So for this talk, we're going to be using this app that I vibe coded. It's called Paparazzi. It shows pictures of pets. It also has a messages tab to talk to other users.
Yeah, it wouldn't be Google I/O without someone showing you a new chat app, right?
Exactly. And it has a pet of the month with a simple list for now.
Yeah, and just to be clear, we know that all pets are the best. It's just a demo app, so.
Exactly. So this app looks fine. It's just a sample app made quickly with a simple UI architecture. But let's unfold first. You are probably seeing some issues already. By the way, I cannot recommend the foldable emulator enough. It's super handy to be able to rotate and unfold to check multiple screen sizes with just one emulator. But let's see what happens if I rotate it. It's not great. However, this is the reality of lots of apps. And now that the portrait restrictions are being lifted, we really should focus on making this better. In case you don't know, in Android 16, you can't restrict your app to portrait anymore. All right, let me open the agent here and send a prompt just to show you how skills are activated. So I'll just say, make my app adaptive for now. So it's important to know that I previously installed the adaptive skill that you can see here. And immediately, the agent, or the model in this case, has decided to activate it. You can see it here. So if I open it, it's over here. We're not going to show the agent running the whole task. That's like watching paint dry. But all the prompts that we're showing in this talk have been run multiple times in an automated way, making sure that they always yield the same result. And they've been run with Gemini 3 Flash in Android Studio. All right, let's switch to the slides again. Cool. So even though we don't recommend this in a real app, let's just try this prompt with our sample app. Make my app adaptive. Once finished, the mobile version looks the same as it already looked fine. On a foldable, it now looks a little better. We have a navigation rail instead of a bottom navigation bar. And it even created a list detail layout for the messages tab. In a bigger window, it's making better use of the available space.
Yeah, I mean, it looks pretty good, right? And all this in just a single prompt. Are we done?
Yeah, let's go home. No, this is the classic vibe coding illusion. Doing things from scratch or to a simple app like this one is a lot easier for models because they can just make generic decisions. However, more complex apps have more screens, different layouts, more customization, and there's just some decisions that you or your UX team should be making. For example, if we open the app on mobile in landscape, we see that there's very little space for the pictures. So the skill definitely helps, but if you ask the agent to make your app adaptive, but it's much better if you use it to support you along the way, going step by step.
OK, so instead of using a single prompt and hoping that the AI agent kind of does the right thing, we need a plan. And in fact, you can use the adaptive skill with your agent to create this plan. So the first thing we need to do is make sure our code base is ready for adaptation. And this means migrating all views to Compose. We announced that Android is now Compose first, meaning that going forward, all UI development should be done in Compose. And the view system libraries are entering maintenance mode. Plus, virtually all the APIs you'll see today are Compose. So basically, use Compose. Next, you should you should migrate to Navigation 3. And Nav3's superpower is that it natively supports multi-pane layouts without changing the backstack state, which makes it perfect for adaptive layouts. Next, if you don't already have them, add tests to verify how your app looks on different form factors. These allow you to easily verify any UI changes. And you'll probably also need some behavior tests to make sure that nothing breaks when you're going through this process. So with that out of the way, you're then ready to start making your app adaptive. And for this, it helps to understand the process. So you use UI capabilities to drive decisions about your UI. And UI capabilities include things like window size and pointer types like mouse, touch, and stylus. And it also includes things like the type of keyboard being used and many other capabilities. And these capabilities can be used to change your UI at different levels. So at the app level, you can change your overall layout to display a bottom nav bar on a compact window width and a nav rail on wider screen devices. You can also adapt your main content layouts from single pane to multi-pane. And lastly, you can make lower-level UI components adaptive, like lists, grids, and buttons. For example, by making a grid of photos or cards with an adaptive number of columns. Now, these aren't hard boundaries. You can and should adapt your app at any level that is appropriate. So, right, we've got a plan. Let's get to work. If you're still using views, migrate your screens to Compose. And you can wrap views inside Compose components if you don't want to do a full migration, but you should still consider it because, as mentioned in the last talk, we've got a skill for migrating views to Compose. And this skill can also help you create a plan, set up dependencies, deal with theming, and migrate layouts. And the models are actually really good at doing this, so using this skill can save you an awful lot of time. So once you've migrated your screens to Compose, we can get started with the Nav3 migration. And guess what? we've got a skill for that as well. The nav3 skill contains a migration guide that converts nav2 apps to nav3. It includes a whole bunch of code recipes, including multiple backstacks, conditional navigation, and dependency injection. So it's a super useful skill to install if you're using nav3. All right, that's all our migrations done. And the next stage would be testing. So,
all right, glad you asked. So any big change, really, needs a solid testing strategy. It's important to make sure that we don't break anything that already worked. And while we're at it, we'll add tests to make sure that the new features work across all the form factors. So first, we're going to make sure that we have a good testing strategy. And guess what? We have a skill for that. The testing setup skill is an opinionated way to add multiple types of tests to your app, and it's a great way to get started. You can use it to add tests in general if you have no testing strategy at all. It has good defaults that we recommend. But given that we're making a lot of UI changes, we're going to focus on enabling screenshot testing. Of course, you should also have UI behavior tests, unit tests, etc. In our sample app, we are using Compose Preview screenshot testing, which is handy because you can compare multiple window sizes very quickly with just one annotation. These are the specs that we're using: phone, phone in landscape, foldable, and desktop. But of course, you can customize that. Creating preview tests is extremely easy. You can right-click on a composable in Android Studio to generate its preview with the agent, and we'll handle all the mock data, etc. So if you don't have them already, add screenshot tests before making any changes. That way you'll track the progress, and also you'll be able to find problems in the future across all of your form factors. OK, great. So that's all our prep work done.
OK, cool. So now we can actually get to the fun part of actually making our app adaptive, starting with adaptive layouts. So I first wanted to share how we're thinking about you, the developer. And believe it or not, we do spend a lot of time thinking about you and what you need from our APIs. So we know that some of you just want a ready-made, out-of-the-box solution that works with your existing code base. Some of you want a good starting point for customization and extension. And some of you just want to build something from scratch. And our intention is to provide APIs and guidance for all of these approaches. And we know we might not have complete coverage right now, but this is just to let you know kind of how we're thinking in future. So let's talk specifically about the APIs that we have for adaptive navigation areas. So for an out-of-the-box solution, you can use the Material Navigation Suite scaffold. To customize or build app-level layouts from scratch, you can use Nav3's new Scene Decorators feature. And these allow you to wrap your main content with other content like navrails and bars. So to customize an existing decorator, we have a recipe on the Nav3 recipes repository. And you can build your own by implementing the Scene Decorator strategy interface. And we have a whole load of fresh documentation on this.
All right, so we can finally start making changes to our app. Let's try this prompt. Make the navigation area adaptive. The skill contains a section about navigation with scaffold, which is what you should use when you don't need customization. And this is the result from the prompt. The bottom navigation bar is replaced by a navrail in a larger screen. And now that you are familiar with the APIs involved, you can check that they're being used correctly.
OK, so moving on. On larger screens, you can display related content side by side in multi-pane layouts, which can be a lot more convenient for users than going back and forth between screens. So there are two canonical multi-pane layouts. There's list detail, where the list and detail screens are shown side by side when the window width is large enough. And there's also supporting pane, where supporting content is shown to the side or underneath the primary content when you have enough space, and in a bottom sheet when there's not as much space. So both these are supported in Nav3 through the use of scenes. You can use material scenes for an out-of-the-box solution. You can use the recipes from our recipes repository as a starting point for customization. And lastly, you can implement the scene strategy interface to build something from scratch. And there's a dedicated Nav3 talk with Ben and Clara released yesterday that covers all the latest features of Nav3, including the much-requested deep links feature, which was released yesterday. So I know a lot of you have been waiting for that.
OK, so let's use the agent to do this for us, since we know that we have some list detail relationships in our app. The first one could be the pictures feed. However, I don't think that a list detail layout makes sense here. In a large screen, you want to use the screen real estate to browse through more photos at the same time. And when you select a photo, you probably want to see it as big as possible. But that's a product decision. It depends 100% on the use case. Maybe you want this. That's fine. So let's be explicit about what we want and go step by step. Let's convert the messages screen to a list detail layout. Also, it's better to be specific in the prompt rather than leaving it up to the AI. So you might want to decide now if you want to show maybe the first conversation or instead a placeholder when no conversation is selected yet. Let's go with a placeholder that says select a conversation. And this is the generated code. The list detail scene strategy contains a detail placeholder, so the model uses it thanks to the skill. And here's the result working as expected. But that's not all. Again, to save time, after big changes, I like to ask the agent to build, generate screenshot tests, or even deploy the app to the emulator, navigate, etc. But wait, does your agent have the skills to manage emulators? Well, obviously, we've got a skill for that. The Android CLI has an emulator manager, and with the skill, you can say things like deploy to the emulator, and the model just knows how to do it. If you want to know more about Android CLI, check out the developer tools doc.
OK, so that's our app layouts been made to be adaptive, which is great. So let's now look at how we can make individual UI components adaptive. So first, anywhere that you're using a list or a grid with a fixed number of columns or rows, you should consider using an adaptive column count. And you can use any of the lazy grid layouts for this. Then, when specifying the column count, you can use grid cells adaptive. And this takes the minimum column width and creates as many columns as it can in the available space, and any remaining space is distributed equally throughout each column. So our feed screen is actually a prime candidate for this. It currently always shows 2 pictures per row, which is fine on mobile portrait, but on the foldable, as you can see, it doesn't really scale very well. All right, so this is something covered by the skill. We have a section on making lazy lists adaptive. So what prompt do I use to do this? Make this layout adaptive? Yeah, this might work, but it would be much better if you are specific about what you want. So show 2 columns on portrait phone, 3 on a foldable, 4 or more on bigger screens. However, you don't have to tell it to use the grid cells API, but it's important to know what's possible, so you know that a prompt like this will work first time. The model is smart enough to calculate that a minimum size of 180 dps is what we need to match those constraints. And this is much better now. Now it adapts to the size, showing a different number of columns depending on the space. Yeah, definitely much better. But if you rotate that phone to landscape, you can hardly see that first row of images. In this case, we should hide that bottom nav bar when the user scrolls to make more space for the content. All right, let's just do it. Make the bottom bar collapse on scroll when the height is compact. This is a very common pattern, so let's see if a model is capable of it. And now it's looking better, but what happened here? There's too much padding at the top. We're drawing behind the camera.
And bottom navigation went transparent for some reason. It's almost as if the model didn't have the skills to go edge to edge, which with the new APIs. And you're not going to believe this, but there's an edge to edge skill. Combining this one and the adaptive skill, you'll be able to implement collapsible top and bottom bars. And of course, it includes all the basics of edge to edge, including troubleshooting and what not to do. So let's install the skill and go edge to edge. Make lists go edge to edge, collapse top, bar, and scroll, and show it again when the user scrolls all the way up. That's important because there's two modes. When the height is compact and the user scrolls, collapse the navigation bar. I like to include multiple tasks in one prompt when they are related. That actually saves time and tokens because the agent doesn't have to figure the context twice. But you can split it into if you want. So with this information, the model can come up with the relatively complex compose code needed to make all of this work. And of course, it did the right thing. And now a user in landscape can see 2 full rows of pictures using all the screen space. There's no custom landscape layout, just some code to make the same layout adapt to different configurations. So let's continue.
OK, so in that last prompt, we introduced the concept of using a UI capability, the window height, to make a UI decision, collapse the bottom navigation bar. And this is a very common pattern, and it's used under the hood by the adaptive layout APIs we saw earlier. For example, the material list detail scene strategy uses window size to determine when there's enough space to create a list detail scene. But what if you want to get access to those capabilities yourself, so you're in charge of making those UI decisions? Well, here's how you can do that. So the most important property that you want to get access to is window size, and you can access it directly using local window info. But it's often more convenient to work with window size classes. These are opinionated viewport breakpoints that help you design app-level layouts for typical scenarios. You can use materials predefined window size classes, or you can define your own using window size class. So another important capability is how the user is pointing to your UI elements. And this is important because a mouse pointer is much more precise than a finger. So when using a mouse, the target areas for UI elements can be smaller, and you can create a denser UI. Now, there's plenty more UI capabilities, including device posture for foldables and laptops, and whether a physical keyboard is attached. And the APIs for all these capabilities have been around for a long time and are spread throughout the Android API service. Many of them are pre-composed, which means sometimes they require kind of a bit of massaging to get them to work nicely with Compose. And this is why we are introducing a new experimental API called Media Query. Now, it's inspired by the CSS Media Query API. So if you're thinking, why is it media? Is that to do with like video or audio playback? Well, media refers to the type of device that the UI is being rendered on. So this API currently has capabilities for window size, pointer precision, whether the device has a microphone, camera, keyboard, and how far the user is viewing from the screen. So if you want to try it out, here's how to use it. So the media query function accepts a lambda where you can access these UI capabilities, like pointer precision, and it returns the same type as the lambda. So the media query function will recompose whenever one of the underlying UI capabilities accessed inside this lambda changes. So you can rely on media query to recompose any dependent composables. A convenient pattern here is to have your lambda return a Boolean. For example, in this code example, we're returning true when the primary pointer has fine precision. And we can use this to make your UI elements smaller. So when a less precise pointer is being used, like a touchscreen, we can make our UI elements larger. Now, you'd usually do this by customizing the style for the UI element. And we actually have a new API to do this, the style API. And if you want to know more about this, then stay in this room, because the talk after ours talks all about this. So anyway, back to media query. For rapidly changing values, like window size, and this can rapidly change when you're running your app on a desktop and the user's drag resizing that window, you would use derived media query. And this allows you to say, I'm aware that my state is dependent on a value that is rapidly changing, but I only want to recompose when the derived state changes. So media query is very much an experimental API. Please do try it out and file issues and let us know what you need from it.
All right, so even though it's experimental, the documentation for media query is available in the adaptive skill and the knowledge base. So if you ask the agent to use it, it will fetch the information. So let's try it out. Let's say to the agent, reduce the padding of pet filter chip to 2 dps when the pointer precision is fine. It uses the write media query construct that is only updated when necessary, and then we can just assign paddings. And this is the result on a device with a mouse or a trackpad, such as a laptop. The filters will be a little bit smaller.
Cool. OK, so we have a couple more experimental layout APIs to share that can be extremely useful when you're creating adaptive UI. So first up is Flexbox. Now, Flexbox lays out items in one direction, and it can resize its children to fill the available space. You use the Flex modifier to access Flex's properties, and here we're using the grow property to have that central child grow when there's any extra space. And this is particularly useful in places like top hat bars when you want a single item to grow and everything else remains fixed. So Flexbox can also wrap items onto new rows when there's not enough space, and you use Flexbox's config parameter to configure container behavior like wrapping here. And this is very useful when you have child items of differing size, and you can wrap them onto new lines. So this is really only scratching the surface of what Flexbox is capable of. So yeah, check it out and see how you can use it. OK, so let's continue making our UI components adaptive. Now, our designer wanted to show all the filters in the feed when there's enough space for it. So right now, we're showing a single scrollable row. So some of these filters are actually going off the screen. So extremely conveniently, this feels like a job for Flexbox.
No problem. Let's ask the agent. In the feed, the filters should be shown in a scrollable row, but from 600 dps width, wrap them so that they are shown in multiple rows. Note that I'm using 600 dps here instead of a window size because I'm talking about container size. And this is the result. Now, the code is a little bit more complex, but it does exactly what we asked for. Depending on whether it's wide or not, we wrap or we apply a horizontal scroll. And this is the result. We have a Flexbox that wraps on large screens.
Nice. OK, so Flexbox is great for one-dimensional layouts, but for complex 2D layouts with items that span both rows and columns, we have another experimental API called Grid. And you configure it the same way as Flexbox with a config block for the container. And in this example here, we use the column and row functions to define a 3x3 grid with 100 dp cell sizes, and we can also specify the gap between the rows and columns. We use the grid item modifier to access grid's features like spanning across multiple cells. So here we're using row span and column span to make that green box fit into 2 cells wide and 2 cells high. Now, grid is great for situations where important items need to be larger, but everything still needs to be aligned to the grid. And it just so happens we have the perfect feature for grid in our app, which is the top pet screen. Currently, it is showing all of the pets the same size, but what I think would be cool is if we have that very important first place pet take 4 times the amount of space as the other pets. Okay, so this is like my vision. We can have a 2x4 grid on mobile portrait, and then on larger screen devices, we can switch to a 4x2 grid.
Beautiful.
We'll see.
All right. So again, we don't need to tell the model exactly how to use the API. We just need to describe what we want. So make the top pet screen adapt to different window sizes. You should always show pen number 1 using a 2x2 grid cell, while the rest take up 1 by 1. And the grid cell should be 2x4, 4x2, depending on the available space. So here's the code. Again, it's a couple of very easy to understand if statements, and then we just calculate the cell size. And here it is. It correctly interpreted what I meant with available space. So we're done here.
Yeah, I mean, it looks so this is my idea, and I'm not a designer, I'm an engineer. So just try and imagine how good this would look in the hands of an actual competent designer. Okay, so we're done. Hopefully you can see the power of these new APIs and that making your app adaptive doesn't have to be a load of work. So if you are interested in going from mobile portrait or wherever you are on your adaptive journey, this is where you should start. So all of the skills that we've mentioned will help you bring your app into kind of the adaptive world. So start with migrating screens to compose, and even if you have to wrap views, then you can use the navigation 3 skill to migrate from nav 2 to nav 3. You also should add tests, and then you can start asking your agent to make. Okay, so we're done. Hopefully you can see the power of these new APIs and that making your app adaptive doesn't have to be a load of work. So if you are interested in going from mobile portrait or wherever you are on your adaptive journey, this is where you should start. So all of the skills that we've mentioned will help you bring your app into kind of the adaptive world. So start with migrating screens to compose, and even if you have to wrap views, then you can use the navigation 3 skill to migrate from nav 2 to nav 3. You also should add tests, and then you can start asking your agent to make your layouts adaptive, preferably 1 by 1, and preferably with detailed prompts and even mocks produced by your UX or product teams. Lastly, definitely check out the repository for skills. We're adding new skills all the time, and we currently have skills for the Android Gradle plugin, performance, for camera, and a whole bunch of other very useful skills for Android development. And if you want to learn more about how to use these skills, you can check out the Develop with Android Studio talk, which is actually the talk before ours.
All right, so to end this talk, we'd like to say that it's absolutely awesome that a complete beginner can create a prototype app in 2 minutes. But what users really care about is quality. Apps that they like them. Apps that don't ask me to log in every time I use them when there's no reason, that work in dark mode, that support edge-to-edge, and of course, then I can use on multiple devices in any configuration. That's quality. I just want to be able to rotate my phone while I'm filling out a form without having to start over. That's also quality. And AI agents and LLMs can be incredibly helpful in producing high-quality apps, as long as you know what to ask for. So with AI, a good developer will create a good app, and an excellent developer will create an excellent app. That is not changing. So now it's the time to make your apps adaptive. We understand that you still need a little bit more QA, maintain a little bit more code, but the investment is considerably lower now, and the return keeps growing every day. So you're not going to get there in a single prompt, but it's so much better now. You might even have fun. Thank you.
Hi everyone, and welcome to Building Custom Design Systems with Jetpack Composer's new Styles API. My name is Rebecca, and with me today on stage we have Megan
and Chuck.
We've seen how Android is evolving to support different device form factors, and how apps are increasingly wanting to stand out from the crowd with their own custom design system definitions. We understand that every app is unique. Many apps use material from a full material-based design system to a full custom design system. And if you fall somewhere in between the spectrum, we are building a framework that works across this. JetSnap, one of our very first examples we released in Compose, has always been a great showcase of building something custom in Compose that leverages material components under the hood. But its design system has always had its own unique definition, in that it has used a very broad usage of gradients throughout it. The component designs have typically been slightly different from the components that material design offers out of the box. It's used gradients in various different ways, such as this filter chip that has a gradient border for the normal state, and press state is a solid gradient. Separately, when looking at material components, they come built in with really great defaults, and this is why we love using material. It handles all of these complexities for you, such as accessibility standards, right-to-left positioning, various different interaction states, and components generally look great out of the box. But as we've seen, our designer has given us something that's a little bit more custom. So how would you typically go about this? For this filter chip example, you've likely tried importing the material filter chip, and then immediately tried to set a background color that's a gradient when it's selected. And at this point, you probably see that the API was only designed with a single color in mind, and it doesn't support the brush type. You may, at this point, probably do one of a few things. In this case, I set the colors to transparent, and then surround the chip in a box, and use modified background on the box to try and actually set the gradients instead. Then moving the filter chip to be within this box. Things are looking okay with this, until we actually try and run them. We can see that we also need to apply the shape to the container too. Not only that, but we also need to build in our own logic to handle pressed and selected states now. So at this point, you might have also decided it was time to fork the material source, or create your own version of these components. In JetSnap, we created our own components. However, this means our app is losing all of these benefits of material. So we've been working on something new that we want to preview with you today, called styles. Styles are a new mechanism in Jetpack Compose for customizing elements. They're designed to separate form from function and unlock easy state-based styling, along with some added performance benefits. The Styles API has been released in version 1.12 of Compose Foundation as experimental, with materials adoption in the APIs coming soon. You'll see this is a big shift in how you interact with components today. We will show you how Styles helps customize your components in an easy-to-use way through a refreshed version of JetSnap. Still using gradients, just a tad more subtle. I'll give it over to Megan to tell you more.
Thank you, Rebecca. So let's hop into it. Like we said, we're giving JetSnap a makeover using the Style API, but you might all be asking, what's a style? A style is an interface that defines the appearance of a component. A style is a specialized modifier that automatically gives performance and reusability benefits. And I really want to stress that styles are not here to replace modifiers, but instead here to replace parameters that are related to visual properties. Let me show you what I mean. As we mentioned in this talk, we were going to be working with JetSnap, which is a custom implementation of button to achieve the gradient effect. And as you can see, this definition of button has many different styling parameters, disabled state, shake, border, etc. But with styles, we can replace all of those lines with a simple style parameter, which provides a standardized set of properties that can be set on any component. Okay, so now you know what a style is, let's see how you would use a style. There are two use cases for adding styles to your components. One is creating a custom component and making it stylable, and the other is using a composable that has a style parameter. So let's look at how to make a custom component stylable. Under the hood, JetStack's button is implemented as a row that is clickable. And in order to make the button stylable, you can add a stylable modifier. And then you would add a style parameter to your method signature so that implementations of the custom button can use the style parameter to customize their implementation of the button. And it's always recommended to provide a style parameter on design system components in the same way that you always apply a modifier. Then you'll pass in style state and the style parameter into the stylable modifier. And we're not going to get into style state right now, but we will get into it later in this talk. And now our custom button is ready to use styles. The other use case that you would use is to style a component that has a style parameter, just like the button we just created. Within JetStack, we're going to be using the custom implementation of the button. And here's what it looks like with nothing in the style block, and let's add some styling in. So here's a list of all the style properties that are available, and as you can see, it's quite comprehensive. Don't get lost in the weeds, it's all in documentation. And we're going to use the background property to update the background to be light gray. In the style block, we add background and pass in light gray, and it's that easy to modify our component using the style property. Of course, yes, we're barely scratching the surface here, and we're going to be going over how to go from what we see here to this button with gradient, animations, and state-based styling using the style API in this talk. But before we can get into all of that fun, we have to get into the fundamentals of style. Okay, guys, come on. yeah, that's what I want. Okay, fundamental one is that style properties override one another. Second is that style properties are inherited. Third is that styles are reusable. And fourth is styles are mergeable. So we're going to demonstrate all four of these while styling our new JetStack button. Going back to our button code, we've already used the background property to change the background color to light gray. And just as easily, we can also set other properties on the button. Syntax-wise, we can just add a new line per property. No commas needed. We'll add width, height, shape, font weight, and text alignment. And then let's also add an external padding of 32 dp. And then if I wanted to modify only the top padding, I would add external padding top with 16 dp. And you may expect this to give you 32 dp plus 16 dp of padding, but instead you only get 16 dp of padding on top. And this is because style properties override one another when the same property is set twice. The button has 32 dp of padding, but since external padding top is the last defined property for the top padding, it will override the top padding, making it 16 dp. If we did this with modifiers, it would add the two paddings together, giving us a top padding of 48 dp. Now, in JetStack, we also have a custom text composable that accepts the style parameter. And with that in mind, you may be asking, why are we setting font weight and text align through the button when we could set it through the text style property? After all, these properties affect the text, not the button. So let's investigate text align. If we remove the text align from button style and instead add it directly on text style, we do get the same intended result. And depending on our use case, we would set text align on the button level because certain text style properties are inheritable. By setting the text align on the button level, the text content inherits the text alignment from the parent composable. It doesn't make so much of a difference when there's only one child composable. But if we instead pass this column of text composables as a button content, they would all inherit center text align. But then, if you added direct text align style parameters on a text composable, that would take precedence over the inherited parent composable. Here, add and cart are overriding the center text align, and 2 is not, so it's still inheriting the button's text align. The lowest item on the precedence totem pole is the parent-defined styles. And then, if you provide a modifier on your component that sets the style, that will have a higher precedence than the parent-defined style. And then finally, setting a direct style parameter has the most precedence. Again, this is only for certain text style properties which are inheritable. So now what we have is a really nice button style, and we may want to use it on multiple buttons in our app. So we can create a style object called button style, and in that block, we can add the same properties that we added to the button style block. And then we can replace all of the button style property with button style. And then, because styles are reusable, our style can be passed into multiple different buttons and provide styling for them. So now we've added a new style called gradient style for our more special custom styling like shadows and gradients. In it, we can add a drop shadow and an inner shadow. And then if we replace button style with gradient style in our button style block, we lose everything from button style. We lose the width, the height, the shape, the padding, and the text alignment. But what we actually want here is a combination of both the button style and the gradient style. And to do this, we'll use style merging. In the style parameter, we will pass both button style and gradient style by simply adding another argument to the style constructor. Now we can properly see shadows from the gradient style, which adds so much dimension to the button. And now let's add the background gradient. In our gradient style, we can add a brush using a linear gradient. But wait, if you remember, we do have a background defined in button style, and then again in the gradient style. But the gradient style is the background that we're seeing. This is because gradient style comes after button style when we pass into the style parameter. Remember when we covered style properties being overridable, that the last defined style property is the one that wins. Since gradient is passed in second, its background property is defined last, so that's what we see. If we switch the order of gradient style and button style, then the gray background would be what the user sees. We still see shadows because gradient style is still being applied, it's only the background property that's overridden because it's defined twice. Note that because styles are overridable, the gradient background replaces the gray background instead of having gray underneath. And also syntax-wise, you can use the infix then operator to combine styles together as well. So in this section, we learned about the style fundamentals of being overridable, inheritable, reusable, and mergeable, and use those fundamentals to build this beautiful gradient button. Yay! Now let's talk interaction states and styles. So we do have this beautiful button styled, but we want to add styling based on the different interaction states. The styles API comes with a couple of states built in by default. Default state, when no interactions are happening, pressed state, hovered state, and focus state. Hover and focus are triggered on devices that have either a mouse attached, and focus is also triggered on devices like TVs that have D-pad navigation. It's good to define all of these styles. It's good to define all of these states for each interactable element, as your users will be using your app with various different device configurations. So we already have button style and gradient style passed into the style parameter, and we could add our state-based styling through a style object, or we could add an inline style block by adding a block after the parentheses, which we decided to do. And in that block, you can add a press block. In our press block, the syntax is the same as within a style block. In order to define the style when the button is pressed, we will add a background property and set it to light purple. And now you can see that when it's pressed, it turns to light purple. Now let's add hovered and focused. Hovered is a lavender background, right here, and then focused is a light purple border. Wait for it to go. And all of our states, yay! So that's basically all you gotta do to have your state-based styling for pressed, hovered, and focused. Back to Rebecca. Now let's chat briefly about animations and styles, my favorite topic. We were able to add state-based styling, which adds so much to your app, but the transition between the states isn't as smooth or as elegant as we would want it. It simply snaps to the end state without any smooth transition. To ease between these different states, you can surround any style property with an animate lambda, and this will perform an automatic transition between the start and defined state within the lambda block. In this example, we set the inner shadow initially to have a 0 dp offset, and then when it's in the hovered state, we change the dp offset inwards of -6 dp and -2 dp. We also move the drop shadow in the same way, resulting in this delightful shadow movements animation on hover. We can add many different properties to be animated here though. For example, we can also animate the background color to make the buttons change on hover. The nice part is that this cleans up having to track state changes yourself and creating all of those various animated state variables that you may have previously needed to create. To customize these animations, you can also pass in an animation spec into this animation block. Here we pass in a tween spec with a longer duration, just to see the animation slow down a little bit. But we can supply in any other animation spec that you'd like. Now I'll pass it off to Chuck for the next section.
Now let's talk about custom style states and why you'd want to use them. Let's go back to our button definition where we define the style state and pass it into the stylable modifier. What is that style state anyway? The style state represents the current state of the UI element, which is used for tracking the interaction state, like pressed, hovered, and focused, and it's used for state-based styling to select the different style properties based on that state. It allows linking the interaction source to the style itself. Without linking up the state to the style, the code would still compile, but when you press the button, nothing would happen. This is the definition of the style state. The class definition, you can see that there are some states that are built in. You may have noticed at the very end, there's a get operator. This get operator enables custom states, because the style state is a map from the style state key to a value. Let's look at an example of how this might be used. In JetSnack, we wanted the add to cart button to look different when we're loading something or when an error occurs. Here we have an updated design for what the different states should look like. Note the design for loaded isn't changed. That makes sense, it's our default. But the design is different for loading and error. To implement these designs, we need to somehow communicate the loading state to the style so we can change the button's look to match the design. This is what custom states are for. To create a custom state, you first need to create a type for the state. For JetSnack, we wanted to track the states of loading. So we created an enum class that has 3 values that we're interested in: loading, loaded, and error. Next, we needed to create the corresponding style state key. The key is used by the component to record the current state of the loading state into the style state, and later we'll use that same key to read the style in the state itself. When creating a style state key, you need to provide a default value. This should be the value when the state is not special. In our case, it's when we're already loaded. So we use loading state.loaded as the default. To allow style to read this custom state, we need to add an extension function to style scope that will only execute its block when the custom style state or the custom state is loading. This, for example, is how the pressed is implemented. It only calls its block when isPressed is true. The style scope is the receiver scope of the style lambda, and it introduces the style properties such as padding, background, and border. By extending it, we allow loading to be used to customize the style based on its loading state. The style scope contains a helper function called state for extension functions like loading to use. It requires a key, a block, and an active expression. The key is the key we just created, which is the loading state key. The block is the block parameter. We just pass it on through to state. The block parameter sets the properties that are unique to the loading state. And finally, we have the active lambda, which returns true when we're in the loading state. In this case, we just compare the current state to loading state.loaded, or loading, and that is, we'll set the properties that are unique to the loading state. We can then add another extension function when we're in the error state, which we're going to call loading error, which follows the same pattern as loading. We now go back to the button and update it to take the loading state and communicate that back to the style. First, we update the button to take a loading state as a parameter. We make the default loading state.loaded, which matches our style state key. Next, we need to update the style state with the loading state. This is done in the same expression that creates the style state. The remember updated style state takes a trailing lambda, which is called whenever the button is recomposed. We use the loading state key to record the loading state into the style state. Now we can customize the button. Here we have a simplified version of the full button, which covers focus, pressed, and hovered. We can now update this to change the look of the button when we're in the loading states, using the extension functions we just created. This is how the style state lambda allows us to override the values of loading and loading error, just as we do pressed, hovered, and focused. Now remember, these are the designs we wanted to implement. And we implement those designs by changing the color from light orange when we're loading, and when we're in the error state, we change it to light red. And there, we have implemented a custom state-based styling. Just like looking at it. Anyway, by extending the style state to add loading, now any component that uses style can also use the loading state. For example, this can be used in the JetSnack card or the filter chip. Now this is fine for states that are common across many components, but clutters the scope with a bunch of style state functions that may not apply to a particular component. For example, neither the JetSnack card or the filter chip update the loading state. The loading and loading error state function should only be available when the loading state is applicable. Ideally, we would want to make loading a syntax error when it's used in a style of a component that doesn't have a loading state. This is what custom styles allow us to do. A custom style allows a component to restrict the style scope to only the properties that are appropriate for it, and also control which extension functions are available. In our case, we would like to control when loading and loading error are visible. Let's see how that is done. Creating a custom style starts by creating what you want to be visible in the scope. For a button, we just want to control how the style is extended, not restricted in any way. So we make the loading style scope inherit directly from style scope. Next, we create a custom style, loading style, using the scope we just created. We then update the extension functions we wrote to extend this new scope instead of style scope. Now these extension functions will only be usable inside of a loading style and are no longer valid in style. Lastly, we go back to the button and we update it to use the new custom style. As the custom loading style is not actually a style type, you need to convert it to a style before we pass it to the stylable property, so we call toStyle on it. Loading and loading error now can be used to customize a button, but not when customizing a filter chip, which is exactly what we wanted. Now you may ask, what's the cost of all this power? Well, surprisingly, styles are usually cheaper than using the corresponding modifiers. The main reason for this is styles make it much easier to use composed performance best practices. Let's take a look at the best case example. This code is changing the border color of a box and setting a couple other properties. All the benchmarks we've written are much like this, a component implemented with modifiers and the same component implemented with styles. In this benchmark, styles had approximately 70% fewer allocations and used up to 2.3 times faster to render the next pixel. To see how this is done, let's take a closer look at how styles work. Styles are a modifier that only affects layout and draw. When a layout property such as content padding changes, only layout and draw run. If a draw property such as background changes, only the draw phase runs. For the benchmark above, only the draw phase was running to update the next pixel. The performance benefit for styles really comes from three things. Styles are created in composition, but they're only evaluated after composition. As explained earlier, this shifts the work done by a modifier to a later phase of compose, allowing composition to be skipped when a style changes. Styles also use a single modifier. This reduces the number of allocations needed for the same functionality. And there are no animations created during composition. They're only created when they're needed, which reduces the cost of creating the composable in the first place. The border benchmark is a very targeted benchmark to highlight what styles does best. In a more real-world example, we've already seen improvements. In a prototype of materials button implementation, we switched to a style-based version, and the allocations reduced by approximately 37%, and the button was 1.6 times faster to render the next pixel. Now, back to Rebecca to talk about theme.
Thanks, Chuck. So far, we've learned a great deal about styling and compose with the new APIs. Let's take a look at how you can integrate this into your themes. As mentioned at the start, we know that there is a spectrum of material adoption that your app can have, and the way in which you adopt styles in your theme may differ depending on your level. So, how can you actually adopt styles? The way styles should be integrated with your app is through your theme, by exposing a style object that wraps your default styles for your components. This is a new layer that sits on top of the current subsystems that your design system may provide. For example, in JetSnack, we have colors, shapes, and typography defined at a theme level. We now introduce a component default style layer into our theme, which is a group of styles that accesses the subsystems for tokens for colors, shapes, and typography. Then our button composable would use the default style from the theme over directly accessing the subsystems like it used to before. Now when the button is rendered, it will resolve the style using the precedence hierarchy that Megan spoke about earlier, and by taking the incoming style parameter on the button, the theme's button style, and the inherited attributes up the tree to resolve the computer style for that button. So if you're not using material design, you can try styles in your own design system today. If you are in one of these two camps, you're either not using material at all, or you have a custom theme that wraps material components. Our recommendation is to use styles within your own theme components, and when material components expose a style parameter, you can use that in your wrapped component definitions. Let's take a look at the JetSnack example. This app has its own custom theme, and it uses some of the material components. So we already have our own custom theme set up, with the subsystems like colors, typography, and shapes all being different from material. So to adopt styles, we add our new JetSnack styles object, exposed as a property on the theme that exposes the static object. We also add style scope extension functions to be able to easily access the subsystem tokens in the style themselves. Styles can access composition locals. Then, in our JetSnack styles object, we create the default for a component. For example, we remove the button style that we defined earlier into this class, and we switch the hard-coded colors to use theme-level tokens from each subsystem. For example, the background here is set to a linear gradient brush, using the list of colors defined in our custom design system set of colors. This means that the style will automatically change when the subsystems are switched out. In this case, we're switching from dark to light mode, the colors will automatically adapt. Within our design system component definition, we now access the theme-level styles, and resolve the effects of style by combining the incoming style parameter with the themed style, making our button themable. Now we are able to easily use this button and customize it by passing in an additional style to override particular parameters. In this example, we are passing in different shapes. This combined with this default style set at the theme level. You can see that there is also correct light and dark mode theming of buttons since it's using the underlying composition locals. So what about the case when you are using material components? Material is adopting styles within the UI components, which will be available in future releases, starting with Material 3. If you're still using Material 2 components, we encourage you to migrate to Material 3 in the meantime. When using Material, you might be using the whole Material design system, and in that case, you just use the style parameter when it's offered on a component. If your design system is Material 3 based, but you have one or two global differences, you'll then be able to override them at the theme level. With material components that expose a style parameter, you'll be able to customize these components to your heart's content. For example, this Material 3 button will provide a style parameter on it, so you'll be able to use material components without the need of forking the implementation, and instead customize it to your requirements, with a custom background, shape, padding, etc. This allows you to change other properties on a material component that you previously may not have been able to change before. You can learn more about how material is evolving to ensure you benefit from material whilst bringing your own customizations. Check out this talk. Back to Megan.
So we've talked at length about the Styles API, how you can get set up, integrate into your themes, but there's also a way to make your themes adapt to different device characteristics. We've introduced another experimental API called Media Query. What this API provides is a simple way to access window characteristics, which can unlock building only one theme to use across a device spectrum. The API works hand in hand with the Styles API to provide easy-to-use queries that can change styles based on device properties. Let's look at a quick example. So with Android being able to adapt to more and more devices, you may want to know how you could easily add support for these different adaptations. For example, if you have a mouse attached, your pointer position variable now reports fine pointer position, meaning that you have ability to click on smaller device targets. To change a style property based on a media query, you can use the example as follows. It returns only a single Boolean value, and the style will be invalidated and be re-resolved after composition when the conditional changes. Here, you can see this set of buttons changes padding and size when on a device with a mouse plugged in. The button right at the bottom, let's try it again. The button right at the bottom overall looks smaller, even though we are using the exact same composable. The style will now automatically adjust based on device properties. And you can learn more about the newest media query APIs at the link right here. And be sure to check out Make Your UI Adaptive with Android Studio's AI agent, or ask Donna Jose right here. That's check. Can you send Donna for you?
I'll stand.
At this point, you may be asking yourself, when should you pick a modifier versus a style? As we've seen, there's some overlap between the two different systems. As a reminder, styles are not meant to replace modifiers, but are instead meant to replace the parameters related to visual properties. When comparing the two, modifiers are designed as low-level capabilities, and are still the way to work with behaviors, semantics, additive properties, and complex layouts, whereas styles are a high-level modifier designed for visual appearance, individual sizing, and themable properties. Styles are a level above modifiers, and they're built on top of modifiers. Looking at the logic, modifiers are additive where styles are override. For theming, with modifiers, it can be quite challenging as they're not designed to be elevated to the theme level, whereas styles, using them in a theme is by design. Looking at performance between the two, this is nuanced, of course, but styles by design skip composition, whereas modifiers often require all three phases. And with regard to animations, modifiers need separate animation primitives, whereas styles have animations built in. So when you choose a style or a modifier, well, choose a style when you want to override the defaults for an existing component, perform high-performance interactive state animations, or to define theme-wide sets of properties for a component. And choose modifiers for behaviors like clickable or other gestures to define unique one-off layouts, or if you need to have additive properties on your composable. Now back to Rebecca to wrap us up.
And with that, we'd like to encourage you to try out styles in Compose, and let us know if you have any feedback on the APIs. As a reminder, the API is experimental and subject to change as we receive feedback from you. We have an extensive set of documentation that are really available at this link. Additionally, if you'd like to try out the new styles skill with your own agent that can assist in the migration to use styles with your own custom design system, or just the basic usage in Compose, you can access the skill at the following link, or download the skills using the new Android CLI. Thank you so much for joining us. Check out the resources links, and let us know what you think of the styles API.
AI has made development for the web easier than ever, and we see this reflected in how developers are building and utilizing Chrome extensions. With the rapid pace of development that AI enables, it is crucial that all parts of your ecosystem provide a great developer experience, which will be the focus of today's talk. Welcome to Elevating the Chrome Extensions Developer Experience. I'm Kevin Bay, Product Manager for Extensions Platform. We're excited to share with you today the latest updates in the world of extensions. First, we'll talk about exciting updates to the Chrome Web Store and the extensions platforms that streamline your developer experience, before sharing tips on how you can leverage the latest tooling like MCP servers to build Chrome extensions easier than ever. Let's dive in. We're amid one of the most remarkable technology transitions of our time, and how we're building for the web has fundamentally shifted. With AI, coding has become more approachable, something we see reflected in our Chrome extensions developer community. Over the last year, monthly developer registrations have more than doubled. AI isn't just changing how we build, it's inviting a whole new wave of developers to the extensions ecosystem. The number of extensions that use AI also continues to rise. 17% of all extensions that were created for the Chrome Web Store last year use AI. And we're excited to give our growing developer community another boost. This year, we will open up developer registration to over 120 additional countries. With such momentum in our developer community, streamlining the developer experience is more important than ever. Let's talk about it. Many extensions are the result of close collaboration and teamwork. The first step to support this has been the introduction of our group publisher memberships many years ago. This allowed multiple team members to take actions on the developer dashboard on the same extension. However, in cross-functional teams, the actions that need to be taken vary widely. One person needs to be onboarded to the dashboard. Another is looking to upload the latest extension update, while a third only needs to review the latest metrics. The feedback across many of our conversations with developers has been clear. In a modern workflow, all or nothing access is a security concern and an operational headache. Managing an extension successfully means providing access to the right actions to the right people on your team. Today, we're making a big step forward with the launch of expanded member roles and permissions to the dashboard. Going forward, you will be able to invite other team members into different roles on your publisher. Now, you can grant the right access to the right people with a single click. The member tasked with onboarding someone to the developer dashboard can do that as an admin. The one asked to submit a new update can do so as an item manager. And the team member who only needs to review metrics can see them through the viewer role. Additional members can be invited to your publisher without going through developer registration, and can be done at no cost. Expanded member roles and permissions are already live on the Chrome Web Store developer dashboard. Check it out. Now let's talk about making publishing more flexible. Last year, we launched a private Chrome Web Store experience, allowing organizations to create their own extension marketplace. This allows Chrome administrators to curate which extensions are presented and available to users within their enterprise, giving them a clear indication which extensions they can add to their Chrome browser. It's been exciting to see the adoption of this experience since the launch last year. Offering a curated store for enterprises was an important step, but our goal at Chrome is to constantly improve the user experience and invest in our extension ecosystem. So we're excited to be sharing another improvement we made: enterprise publishing for external organizations. Extensions with a focus on enterprise use cases are not only created by in-house developers, but also by amazing external developers that build bespoke solutions for many enterprises. These developers had only two choices on how to distribute their enterprise extensions. Either publish it on the public Chrome Web Store, requiring other mechanisms to gate access, or share them directly with enterprise admins to deploy them via group policy, device management, or local install. This led to fragmented deployments and an extra operational burden, and we're looking forward to improving this with enterprise publishing for external organizations as a new option. With this feature, an external extension developer can generate an approval link and send it to an enterprise administrator of another domain. If that admin then grants the approval, the external developer can now publish their extension across domains. This is done in a way that maintains full control for enterprise admins on what gets published and which extensions are available to their users. This simplifies the development workflow for any external developer building extensions for enterprises, and the best thing is, it's already available. Now, I will hand it over to Oliver to share more about exciting platform updates.
Hi, I'm Oliver Dunk, Developer Relations Engineer for Chrome Extensions. As we continue to add features to the Chrome Web Store, we know it's important to keep investing in the platform too. Over the last few years, we've doubled down on our commitment to building a cross-browser web extensions platform. Through our participation in the Web Extensions Community Group, we meet with developers and other browser vendors regularly, and we work to make the implementation of web extensions more consistent and more capable in all browsers. The contributions of community members and engineers from Edge, Firefox, and Safari have significantly influenced the design of APIs we've brought to the group over the last year. And we've implemented features in Chrome that were first proposed by others. Since Chrome was the first browser to implement the current web extensions model, extension APIs are made available on Chrome Global. For example, to create a tab, you can use the chrome.tabs.create API. When other browsers implemented these APIs, they also introduced a browser global, so you can use browser.tabs.create instead. Chrome is still supported by other browsers as an alias, so you can take an extension written in Chrome, which uses the Chrome global, and run it elsewhere. It's clear to us that a single shared global is better for everyone, which is why we're excited to be introducing support for the browser global in Chrome. For most extensions, this is available now. We're really excited about this because it makes it even easier for you to build cross-browser extensions. You can learn more in our documentation, which includes guidance on when and how to migrate. As part of this work, we also identified an opportunity to modernize the browser.runtime messaging APIs. To receive messages in your service worker from another part of your extension, like a side panel, you can add a listener to the browser.runtime.onMessage event. Previously, to respond to these messages, you could update your listener function to receive the send response callback as a parameter. Then, when you have a response, you can call the function to return it to the sender. If your call to send response happens asynchronously, for example after awaiting a promise, you need to return true so that Chrome knows to keep the messaging port alive. In newer Chrome versions where the browser global is available, we now support returning a promise instead. You can use this as an alternative to the send response function. Chrome will wait for the promise to resolve and respond to the sender with the resolved promise value. This is already supported in Firefox and Safari, and so we're excited that developers can now use it in Chrome too. Support for the browser namespace and promises and runtime.onMessage are also provided by Mozilla's web extension Polyfill, which many developers have used up to this point. You can continue using the Polyfill, and it will deactivate itself in newer versions of Chrome. We've published more guidance on how to update your extension following these changes, which you can find in our documentation. These changes make it easier for you to write code as a developer, and they also make it easier for agents to write cross-browser extensions on your behalf. But we think it can be even easier. We're publishing a skill that gives agents guidance on the newest APIs and best practices for building Chrome extensions. If you're not familiar with them, skills are files that Anti-Gravity, Gemini CLI, and other AI coding tools let you add to an agent's context. They give your agent domain-specific knowledge that they can load as needed. This is one part of the guidance we're publishing for modern web development more broadly, which you may have heard about in another talk, Unlock Modern Web Capabilities in Your AI Coding Workflows. Models like the Gemini models are getting increasingly powerful. In fact, in internal testing, we found that they could build many extensions from our set of evals in a single prompt. However, the guidance we're publishing helps improve the quality of extensions you can build with AI in tools like Anti-Gravity even further. Firstly, it teaches them about the latest APIs, which may have been released after the model you're using was trained. Next, it makes your agents have access to all of the best practices our team has learned over the years building Chrome extensions. And finally, it keeps track of information that you might need to submit your extension to the Chrome Web Store, making distribution even easier. Let's talk about that last one in more detail. As part of the skill, we ask your coding agent to create a Chrome Web Store.md file that keeps track of all the information necessary to submit your extension to the Web Store. If you've ever tried to submit your extension to the Chrome Web Store, only to realize you still need to fill in justifications for each permission you've requested, that just got a whole lot easier. In this example, I asked to build me an example extension using the cPanel API. Since I need the cPanel permission, my agent creates a Chrome Web Store.md file with a justification. When submitting my extension, I can check if this justification is appropriate and copy it straight into the developer dashboard after making any necessary changes. You can learn more about how to install the skill and get started in the Chrome for Developers documentation. But what about testing and debugging your extensions? I'll hand you back to Kevin to tell you about another way we're giving new capabilities to coding agents.
Now let's talk about testing and debugging. We're thrilled to announce that the Chrome DevTools MCP server with skills now officially supports extension debugging. For those who haven't heard about it yet, MCP is a universal bridge that brings the full power of Chrome DevTools to coding agents. With this MCP server, coding agents can launch Chrome and debug live websites. When we launched it, one of the first questions we received was, can we also use it to debug extensions? And this is finally possible. With the latest versions of the Chrome DevTools MCP server, it is now possible for your coding agents to also install and debug extensions. Let's look at a quick example of how this streamlines the workflow. In this demo, we asked Gemini CLI as our coding agent to build a simple Hello World extension that opens a pop-up when an extension icon is clicked. As you can see, the agent doesn't just write the code and stop there. Once the extension is built, the agent also automatically launches a fresh instance of Chrome, installs the extension, and clicks the action button to trigger the pop-up. It then inspects the pop-up page's DOM to verify that it actually includes the Hello World message and is rendered correctly. And the agent confirms Hello World verified. While this is a simple example, the real power lies in how this handles more complex scenarios. For instance, a coding agent can now autonomously debug service workers and side panels. This is all made possible because the Chrome DevTools MCP server can now perform a robust set of programmatic tasks. It can install and uninstall extensions, list all installed extensions and reload them, and it can trigger extension actions. Most importantly, it can now inspect every surface of your extension, from the pop-up and side panel to the service worker, helping to verify that your code works as expected. With tooling like this, creating extensions is easier than ever, even for personal use cases. We hear more and more about developers using AI to create personal extensions just for them, through which they customize Chrome to their liking and streamline their individual workflows. If you'd like to learn more, check out this IO talk about Chrome DevTools MCP. The rapid pace of technological progress requires a streamlined developer experience. With today's announcements and tips for the Web Store platform and AI tooling for extensions, we are pushing forward towards our overall goal at Chrome. Remove the friction from your workflow so you can focus on what truly matters, building incredible experiences for your users. We're excited to see how you leverage these new capabilities and can't wait to discover what Chrome extensions you build next.
Hi, I'm Matthias, Developer Relations Engineer for Chrome Tooling. In this session, I'll walk you through the most recent updates in Chrome DevTools for our AI innovations, but also beyond. We are going to take a look at how DevTools with AI Assistants now supports agentic conversations, how updated UX and UI help you trace Gemini's actions and reasoning in DevTools with structured walkthroughs, how DevTools now helps you to debug more areas of web development with the help of AI and new capabilities, and does so considerably quicker with concise answers and insights you can hand off to your coding agent. And lastly, we are going to look at what DevTools continues to excel at, giving you intuitive tools to debug the web's newest features. Now, let's dive in. Before we look at what's new, let's bring everyone to the same page. Over the last couple of years, we brought the power of Gemini to many common debugging journeys across DevTools. We call those features AI innovations, and there are 4 of them. Console Insights, explaining warnings and errors in the browser console. AI Assistants, which allows you to chat with Gemini directly from DevTools. Code completion and code generation through Gemini in the console and sources panels. And lastly, auto annotations, which helps you understand complex performance traces by suggesting labels for trace events. Find and enable all of those features in the DevTools settings under AI innovations. And if there's one you shouldn't miss, then it's AI Assistants, because we gave it a major revamp. Let's look into the updates. In the first iteration of AI tools, conversations were based on simple turns, almost like in a game of chess. You would write a prompt, then it was Gemini's turn with an answer. Based on this answer, you would write the next prompt, and so on and on. This is not how your everyday developer tooling works. Agentic coding tools like Gemini CLI or Anti-Gravity continue to work, code, and debug based on just one prompt. They're agentic. We now bring the same power of agentic conversations to AI Assistants in Chrome DevTools. Let's look at an example. You can open AI Assistants in Chrome DevTools with the shortcut in the top right of DevTools. This opens the AI Assistants panel in the drawer. Through a new context selection agent, you can immediately ask starting questions with the whole page's context. Based on your original prompt, more specialized agents will take over and find the relevant context in DevTools. So for example, without thinking further, you can prompt, how can I improve the performance of this page? To reasonably answer a question like this, both humans and AI require a performance trace for context. So Gemini in AI Assistants goes ahead, reloads the page, and records the trace for you, and after that's done, immediately starts analyzing the trace, focusing on the core web vitals, LCP, INP, and CLS, and their related performance insights. Once Gemini has analyzed all performance data, it will give actionable advice to improve the most impactful core web vital metric of your page. In this example, the LCP image load is above 2 seconds, and in total, I'm wasting almost 2 megabytes of image resources, so I got some work to do. If you've been using AI assistants before, you might have noticed something else with this example. We made Gemini's responses considerably shorter and more concise to help you get to action quickly instead of sitting through walls of text. On average, we reduced the number of words generated by Gemini to answer your prompt by 68%. Those improvements will help you diagnose complex issues that previously required multiple conversation turns and manual intervention with just one prompt. For quicker and more confident debugging, Gemini doing more for you is great, but from conversations with developers we know you still want to be in charge and understand what is going on. So we spent some extra time and care to make sure you can follow Gemini's reasoning about your website with structured walkthroughs. To see how they work, let's go back to our previous performance example. So Gemini recorded a trace for us and summarized its findings. Now, the new agent walkthrough helps us to take a look behind the scenes. When you click Show Agent Walkthrough, a step-by-step walkthrough opens in a split view inside the AI Assistance panel. Key steps inside the walkthrough are displayed through specialized widgets, easy to comprehend at a glance. For example, as part of Gemini's performance investigation, it has looked at the core web vitals recorded during page load. And by clicking the Reveal button in the widget, you are immediately brought to the place where that information is coming from within DevTools. This makes it easy to follow Gemini's steps in DevTools and replicate them yourself too. To start, we added 6 different widgets for various debugging journeys in DevTools. They will surface computed styles, core web vitals, simplified DOM trees, LCP breakdowns, first and third-party performance summaries, and more. And with a click on Reveal, they'll bring you to the original data source in DevTools, seamlessly connecting agentic results, enabling further human investigation, and giving you a tour of DevTools as a bonus. We already briefly touched on conversation context. You don't need to select a specific element, network request, or source file to start a conversation with AI assistants. DevTools finds the right context for you. And AI Assistants now has more access to tools and sources to find relevant context to answer even more of your questions as we expanded its scope and capabilities, and will continue to do so. For example, do those infamous circles ring a bell with you? Those are scores coming from Lighthouse, which AI Assistants now also has access to. This enables a whole new category of questions. Let's look into an example. Now, you can ask AI Assistants, how can I improve the accessibility of this page? With the new agentic capabilities, Gemini and AI Assistants will try to record a Lighthouse audit, and similar as for performance, will give you actionable advice based on the Lighthouse accessibility audits. For issues like color contrast, you can ask the agent to perform a quick fix on the inspected page, and verify its own fix afterwards with a prompt like, please fix the color contrast and verify the change afterwards. That's great for a quick gut check, but how to transfer those changes to your actual code base? Let me introduce Copy for Your Coding Agent. Let's get back to our example. Clicking the Copy for Your Coding Agent button at the end of any conversation summarizes all investigation results and potential fixes from Gemini, adds context where the data is coming from, and condenses everything down into a ready-to-use prompt. You can copy this prompt, take it out of DevTools, and paste it to your favorite coding agent, maybe Antigravity, like in this example, or any other, and let your model of choice take care of the rest. While we worked a great deal to expand the capabilities of AI assistants in Chrome DevTools, there will be some topics it just can help you with, like deciding what's for dinner. But if you think a capability is missing, let us know in the comments below. Something the Chrome tooling team was always proud of is to swiftly give you tools to build with the newest web platform features. No matter if it was view transitions, new CSS ad rules, like starting style, CSS carousels, corner shape, the new masonry specification, you could debug them all with DevTools before they became baseline widely available. And we will continue to celebrate additions to the web platform by supporting them in DevTools. And there's one feature you can add to the previous list, WebMCP. WebMCP is a proposed web standard which enables websites to give AI agents visiting them specialized tools. This helps AI agents to interact with websites more streamlined and efficiently. You find the new tools for WebMCP in the Applications panel by selecting WebMCP in the sidebar. From here, you can inspect defined tools, track invocations, or invoke them manually to debug results without going through an agent. To learn more about WebMCP, get all the details from my teammate Casper in a session, Build Your Website for the Agentic Era. Now, let's wrap up what you learned in this session. We looked at DevTools' new agentic capabilities, allowing you to debug faster and more holistically. While the AI walkthrough with widgets, make sure you stay in the driver's seat. AI Assistants breaks out of its former boundaries and now helps you debug and improve even more areas, like accessibility. And if you prefer to do the improvements with your coding agent of choice, you can hand your debugging results to it using Export for Agents. And with the new WebMCP debugging capabilities, we stand by one of DevTools' core values, to swiftly give you the debugging capabilities for an ever-evolving platform. All these features are available today. I encourage you to head over to the DevTools settings, enable the AI innovations, and see how they transform your own workflow. Thank you for watching, and see you next time.
Good afternoon, Shoreline. My name is Thomas Steiner. I'm originally from Germany, but I live in Spain now. And I've come all the way from Barcelona to here to talk to you about building new features using built-in AI in Chrome. In my role as developer relations engineer on the Chrome team, I travel a fair bit. And while I certainly enjoy it, I can't claim traveling to be my job. But I want you to introduce to someone whose actual job is to travel the world. The following story is not true. However, it could be. But all the code samples and all the APIs that I mentioned are very much true and exist in Chrome today. After the talk, you'll be able to start coding with those APIs and build out your amazing app ideas. And for each of the fictitious chapters of the story, I will have some real-world partner mentions for partners who actually implemented with our APIs. And at the end of the talk, I will have a very real surprise for all of you to take home. You will first hear about the Summarize API. Next, I will talk about the Prompt API with structured output and with multimodal input. I'll continue with the Writer and the Rewrite APIs, and then the Translate API. Now, let's get started for real. Meet Maya, a travel blogger from Sydney who recently traveled to China and was stunned by the Chinese wall. Her partner in crime is a shock from Hyderabad, likewise a travel blogger whose most recent trip led him to Rio. Together, they run a very successful travel blog called Trailblazers, on which they document their trips, share travel tips, and build a community. Being active travelers themselves, they know that data isn't granted. Roaming fees can be very expensive, hotel Wi-Fi can be incredibly spotty, and sometimes being offline can even be a deliberate choice. All this is why they created their blog, Trailblazers, as a static site. They use a static site builder called Build Awesome, formerly known as Elementy.
Build Awesome makes sure that they ship great performance over the wire, without unnecessary bloat or heavy JavaScript dependencies. This isn't to say that the Trailblazers block does not use JavaScript at all. They do use JavaScript where it makes sense. For example, for their share buttons. But Build Awesome forces them to think about the content first. This all pays off. The Trailblazers block reaches a Lighthouse performance score of 95, and their users love it, no matter if they access the site from a 5G network in the heart of the city or from a really shaky Wi-Fi connection in a hostel somewhere in the middle of nowhere. The one thing they disliked about Build Awesome was that there was no visual editor. Whenever they wanted to write a new blog post or modify an existing one, they had to open up their IDE and edit Markdown code, but there was no immediate visual feedback loop, and adding multimedia content like images was tedious and annoying. And this is where magic happened. Apart from travel, Maya and Ashok share another common passion, web development. Last year, they went to Google I/O, where they met Julia. Julia is one of the Trailblazers' longtime guest bloggers. Together, they had a fantastic time at the event. When they heard about built-in AI in Chrome, they looked each other in the eyes, and it suddenly clicked. These APIs were the missing keys they'd been looking for without knowing it. As a quick reminder, the advantages of built-in AI are at hand. With the AI model running on the device, sensitive data never needs to leave the user's browser, which means huge benefits from a privacy perspective. When there's no server involved, this also means that running the AI model can happen entirely offline once the model has been downloaded. And you always get great performance thanks to hardware acceleration on your device, so in some cases, you might even beat the performance of the cloud. For the full background, see my I/O talk from last year, where I cover these advantages in full detail. Back to the Trailblazers blog. Within a couple of weeks, the three collaborated on what they called Build Awesome, the missing editor. Julia was the main coder, and Ashok and Maya were customer zero, so Julia would create a blog post editor that exactly catered to their needs. First and foremost, it's an almost what you see is what you get editor. You author posts in Markdown, and the live preview immediately gives you a feeling for how the rendered output will look like on the blog. You don't have to remember the Markdown image syntax. Instead, you can just drag and drop images where you want, or place them at the current cursor position, and the editor will take care of the correct markup automatically. Of course, it has a gorgeous dark mode too, so they can edit new blog posts wherever they are, even in a shared dorm without blinding themselves or waking up the entire dormitory. All right, let's talk about the first built-in AI API and how it's used on the Trailblazers blog, the Summarizer API. Julia, Ashok, and Maya take great pride in their hand-grafted blog, but even they are not immune to the occasional writer's block. This is why they've integrated with a built-in AI API that shipped in Chrome 138, the Summarizer API. In the editor, they use it in two flavors. First, to suggest titles for the blog post, and second, to make the tedious task of writing the meta descriptions a little easier. The actual code behind this feature is slightly more involved, but essentially, it all boils down to the following logic. First, we get references to the blog post text and the headline. As we're expecting a new headline from the AI, we delete the existing one. Next, we create a summarizer. Assuming an English blog post, we set the expected input languages to just English. We format the model with context in English. So we like I set the expected context languages to English. We want the headline to be generated in English, so we set the output to the language accordingly. The type of the summary should be the headline, and our preference is speed, which means internally a smaller AI model is used. Finally, we provide the model with some context, completely that it should create click-inviting, not click-baity headlines. All we need to do now is call the summarizer's summary streaming method, passing it the blog post text, and then iterate over the chunks as they are returned by the resulting readable stream, and append the chunks to the headline. The meta description generation works almost the same. The only difference is the type, which we now set to teaser, and the shared context, which now hints the model at writing SEO-friendly text. The Summarizer API is available in desktop Chrome and Edge as a version 138. As a real-world partner, the Drupal AI team's new CK editor uses the Summarizer API to give editors full control over AI-driven content like SEO tags and description generation. Next, let me show you how the Trailblazers blog uses the prompt API with structured output for tag generation. Based on the blog post's text, the AI model can come up with tags that allow for grouping of similar blog posts. For example, all blog posts, or all blog posts about cities, or all blog posts about Barcelona. Optionally, you can limit the tags to a predefined list of existing tags. So how does it work? Internally, this feature is powered by the prompt API with structured output, so the model returns a predictable response format. For this, the prompt API uses JSON schema. In this case, it limits the model to a predefined set of tags that it should return in a JSON object with a tags key and an array of tags as its value. You can see an example response object in the lower right corner. It's a JSON object with a tags field and the tags adventure, Australia, and beach. Limiting the response to a list of enums prevents the model from coming up with new tags, and we can also be sure that the response will always be a JSON object in the requested shape. Now for the actual implementation. We first store the JSON schema in a variable called response constraint. Next, we get the text of the blog post for which we want the tags. Then we create the session with the AI model. For this, we call the language model's create function. We pass it the expected inputs and outputs, which in both cases is an array with just one entry, an object with a type of text and an array of languages, in this case just English. Finally, we call the session's prompt method with the textual prompt to create the tags for the given blog post, which we then pass to the model. We pass the model the JSON schema as the response constraint option. This causes it to return the result in exactly the shape of the JSON object, so we need to parse it using JSON parse. Now we can display the tags in the editor. Of course, the user can add additional ones or delete not fitting ones. The prompt API launched for desktop Chrome extensions already back in Chrome 138 and for regular web apps in desktop Chrome 148. The online site Cafe24 uses such a tag suggestion system in production. When an editor creates a product page, they can choose from AI suggested tags for the page. Jerry Young Lee, the group leader of their product generation group, shared how built-in changed their quality. He told us, by processing images and text together with a single on-device call, we turn simple tags like blue dress into SEO-critical context like summer date look, blue midi dress. For us, multimodal wasn't just an additional feature, it was the key result to quality. You've just seen the prompt API with structured output. Now it's time to show you the prompt API with multimodal input. The Markdown syntax is known to be hard. I can't even remember the regular link syntax, let alone the image syntax. Also, while the Markdown image supports alt text, it doesn't support image captions. This is why Julia, in the Trailblazers editor, decided to change things. You can just add images using a file open dialog, or even paste an image at the current cursor position. What happens in both cases is that the image will be marked up as a proper HTML figure, with an AI-suggested alt text and an image caption that both can be easily adjusted if they don't fit. So, how does it work? Again, as with the tags before, the secret is a JSON schema. This time, it's even a bit simpler. We just ask for a JSON object with an alt and a caption property. This will make the model return something like an example in the lower right corner. Now, as before, we store the JSON schema in a variable. Next, we create a session with the LLM, but this time we need to pass it one additional expected input type of image. We set the system prompt and brief the model to act as an alt text and image caption library. And finally, we create the session. Now we can actually interact with the session. The prompt is a bit more involved as it's multimodal, but the first part of the prompt is just a regular text prompt. The second part then is the actual image. As before, we pass the response constraint, that is the JSON schema, as a parameter. This call will then return a JSON object that we need to parse before we use it in the editor and put it in the figure markup. Drupal CMS has implemented alt text generation for images that follows the pattern you've just seen in the code samples before. From the prompt API use cases over to writing assistance, using use cases with the writer API. This is for a written blog after all. The editor that Julia built for the Trailblazers team is fully responsive, so the team can use it while on the go. A cool feature Julia has built based on the writer's API is Help Me Write. Often, Ashok or Maya would jot down some bullet point notes into their phone to recap the day to not forget what happened. The Help Me Write feature would then take those notes and expand them into a full blog post draft that I could then refine and build upon. The call logic is rather straightforward. First, we create a writer instance, providing it shared context about the writing task, that is, to expand bullet points to a more detailed blog post. The expected input and output language is English. Next, we create a stream by calling the writer's write streaming method, passing it the bullet points for the blog post. We then iterate over each chunk and append it to the blog post draft. Now, if you actually tried using the built-in APIs on mobile, like an example I just mentioned in my story, you would say, wait a minute, these APIs are only supported on desktop. And this is absolutely true for the moment, and we say so in our docs. We need a way to run this server if the built-in APIs are not available. We call this hybrid inference, and this is where Julia's skills came in again. Julia is a developer from the Trailblazers team who coded the blog post editor. She used Firebase AI Logic Hybrid SDK to run hybrid AI in the cloud through intelligent routing, if on-device isn't available, like on mobile. This code snippet shows you how easy and smooth it is to connect your API to your app. You initialize your app with your Firebase config, choose a backend and inference mode, like prefer on-device, and then you can run AI prompts against the local model or a configurable model in the cloud. Firebase AI Logic Hybrid SDK with AppCheck is a recommended approach for production use. Created on top of Firebase AI Logic Hybrid SDK, Julia built two experimental polyfills, the prompt API polyfill and the built-in AI task APIs polyfills. These polyfills allow her to just code against the API shape of the respective built-in AI APIs. On currently unsupported platforms like on Android, the polyfills would kick in automatically and provide the AI functionality, backed by an AI provider of choice, like Firebase AI Logic. On supported platforms like on desktops, the polyfills would just do nothing. By going to a cloud, of course, you lose the privacy advantages of built-in, but in Trailblaze's case, that's acceptable. If you're interested, you can find the experimental prompt API and the built-in AI task APIs polyfills on NPM. The Write API is available as a dev trial on desktop Chrome. You've just seen Help Me Write in the Trailblazers blog editor. Cyber Agent in Japan has released a very similar feature to their Amoeba blogging platform that makes the AI suggest the next sentence based on previous input. It's a feature their power users really, really love. When it's writing, there often also is rewriting. Let me show you how the Trailblazers blog uses the Rewriter API. You can have an entire blog post rewritten, for example, to make it more casual or shorten it. But I can also highlight just a part of a blog post, like for instance, an AI-generated image caption that you're not quite happy with. The Rewriter API is pretty similar to the Writer API. You first create the Rewriter. The options passed here are the shared context, so the API knows that this request is about rewriting a blog post. The tone should be more casual, the format should be markdown, and the length should be shorter. Expected input and output languages are both English, and next, we call the rewrite streaming function, passing it the to-be rewritten text. The final step is then only iterating over the readable stream and putting the rewritten text at the right place by replacing the input text. The Rewriter API, just like the Writer API, is available as a dev trial in desktop Chrome. You can also find rewriting assistance in Cyber Agent's Amoeba blogging platform. Highlight an existing sentence and ask the AI to rewrite it. You can then fine-tune the result until you're happy with it. You all here likely speak different languages, and some of you might even use translation to listen to my talk. So let's dive in and see how the Trailblazers blog uses the Translator API to create content for a global audience. The Trailblazers blog started in English, but has since gained support for Spanish and Japanese. English is a language that Maya, Ashok, and Julia mainly author their content in. But thanks to the Translator API, they can machine translate drafts of their blog posts in Japanese and Spanish that then get reviewed and edited by native speakers. The main logic is this. First, you create a translate object with the desired source and target languages. English is the language that the team authors their blog posts in, and in this example, we call the translate method to get a Spanish draft that will then be reviewed by a team member for accuracy. The Translate API is available in desktop Chrome and Edge as a version 138. The Policy Bazaar team in India has a pretty similar setup. Their main content is authored in English, and they offer dynamic translation to common Indic languages based on the user's location. When the user chooses Bengaluru, the translation language is set to Kannada. When they choose New Delhi, the translation language is set to Hindi. For Maya, Ashok, and Julia, the Trailblazers blog is more than a hobby. They want it to be a friendly community of travel enthusiasts. Let me show you how the Trailblazers team uses a prompt API with structured output, this time for building this friendly community. An important part of community building are comments. This is why they decided to add a comment section to the blog post, but use AI to avoid harmful, disrespectful, or just plain illegal comments from showing up. When a possibly abusive comment is being posted, it's flagged and sent for manual moderation to the team. For this feature, they use a prompt API with structured output. Harmful. We start again with a JSON schema. This time, we want an object with two properties. One called classification, which is any of the strings safe, illegal, harmful, or language, and the other is just a short reason, which can be shown in an error message to the user. Then we create a session with the language model, with a system prompt that tells the model to act as a block comment moderator. Next, we call the prompt method, asking the model to review a given comment, and of course, passing it the response constraint from the previous slide. This then gives us the classification and the reason. If the comment is safe, they can post it. Else, we show an error message to the user. The Japan Knowledge Search Team, Japan's largest community-driven question and answer platform, uses a very similar setup to classify questions to the product that might require manual moderation. In this screencast, you can see the post-moderation dashboard that the moderation team uses to help them make a decision before deleting a question. As I said some slides ago, for Julia, Maya, and Ashok, their blog post blog is more than a hobby. Over the years, the Trailblazers blog has become their main source of income. At the end of each blog post, they have a number of affiliate links to partners that they collaborate with. The first collaboration is with Trip.com. A travel blog, of course, hopefully makes you want to travel. What's closer than having a Visit Valencia search for flights link on the Valencia blog post? Trip.com is trialing a new feature using the prompt API to make it easier to navigate their flight options with an AI summary of available options. Not everyone is happy to organize their travel themselves. This is why the Trailblazers team has arranged for a collaboration with Plate, who provide the connection to a classic travel agency. Plate leverages the Chrome built-in AI API to process face-to-face conversations at the physical tour desks, entirely on-device, ensuring sensitive customer data remains completely secure. As the conversation happens locally, the prompt API acts as a real-time mentor, guiding the agent's questions and instantly curates tailored travel activities. By combining human empathy with a secure local AI, they make every customer interaction smarter, faster, and more personal. Check this out.
Helping you plan your trip.
Yes, that's us. We're looking to plan an overseas trip together.
Wonderful. Let's figure it out. It depends on the package, but what range are you thinking per person?
We'd like to keep it around 450,000 yen per person if possible, including flight.
The final collaboration is with fashion store Nightcart. The Trailblazers team found that people really loved the blog's photography, and they were asking for t-shirt prints with the best blog post hero images. So Julia created a playful widget where the user can pick their favorite t-shirt color or have AI suggest one for them. And this is where Nightcart comes in. They have an image search feature on their page where the user can take a picture, and the prompt API would then suggest interesting products based on the extracted colors, brands, and many other signals, all on the client side without ever uploading the picture to the server. As I said in the beginning, the Trailblazers story did not happen in real life, but you can come and experience the Trailblazers blog in real life. Point your browser to goo.gle/trailblazers and give it a spin. And remember, at the beginning of my talk, I promised you a very real surprise for all of you to take home. As I said, the Trailblazers story could well be true, and in fact, you could be the person to make it true, because the technology behind the Trailblazers blog is real. We extended the 11 base blog by the Build Awesome team. Use the template behind our Trailblazers blog to build your own website. Go to Google/starter-extended-blog, click on Use Template, and you are ready to go. The template design is pretty bare bones on purpose, so you can style it to your liking, as I did with the Trailblazers blog. And it has all the AI features integrated that I've shown in my talk. So let's recap what we've seen. I showed the Summarize API, the Prompt API, and the Twin Side API, all ready to go and shipped in Chrome. And I showed you the Writer and the Rewrite APIs, which we're currently working on. And there's a hidden champion that I didn't really mention, but it's silently just doing its job in the background, supporting all the other APIs. It's the Language Detector API, but it's used to detect the input languages for all the APIs that I've demonstrated. Our partners around the globe build these APIs into products that you love and use every single day. And I hope you start creating with them too. If you start building with the built-in AI APIs, a quick reminder that we maintain TypeScript types for all APIs. Find them in the @types/DOM Chromium AI package on NPM. And of course, check out all the built-in AI docs that the team wrote. To hear about the latest developments in built-in AI, join the early preview program. And with that, thank you very much for coming with me on this journey. Check out the Trailblazers blog, goo.gle/trailblazers. Build upon the Google Static Extended blog, goo.gle/static-extended blog, and read our docs, goo.gle/built-in AI docs. But above all, happy grading with built-in AI. Thank you very much.
So over the past several years, Google has been driving an incredible pace of innovation in AI. And when you look across this timeline, you will see an evolution of models and modalities, all the way from Gemini to Gemma, Theo, Imagen, and Omni that was announced just yesterday. So what's incredible about this timeline is that it's not just the cadence of these releases, but the breakthrough capabilities that are being unlocked with every launch. Things like multimodal understanding, reasoning, and agentic workflows. So today, we want to go one layer deeper and talk to you about what powers these models. And not just from a silicon standpoint, but from a full software stack standpoint. And talk to you about some of the tools that you can use as you build, train, fine-tune, serve state-of-the-art models on Google Cloud TPUs.
Okay, awesome. So as you know, there's roughly 4 stages to building a large language model. First, you would design your neural network, and to do that, you'd use a framework like JAX. Then you have pre-training, post-training, and inference. In pre-training, you're teaching the model basically to predict the next token. In post-training, you're teaching the model to be useful. You can do something like supervised fine-tuning to teach it to follow instructions, and then you can do something like reinforcement learning to teach it to reason. And then after that, you need to serve the model to users, or do inference. And what's really cool is if you look at this chart, you can look at roughly where the intelligence is coming from. And what's really cool recently is you'll see that a lot of the intelligence is actually coming from inference. And if you think about why that is, it's because now we have thinking models that are consuming lots of tokens as they reason over your problems. And so what's cool is we have these 2 distinct phases of compute. We have training compute, and we have inference compute. And the needs are a little bit different. And we've designed our hardware stack, our CPU stack, with that in mind.
Yeah, so as Josh mentioned, as you can see here, there is a clear separation from like an architectural standpoint between systems that specialize in training workloads and those that specialize in inference workloads. So TPU v8 is our latest generation of TPUs that we announced at Cloud Next, and TPU 8P is highly optimized for large-scale training workloads. So the focus here are things like maximizing your throughput and scaling efficiency. And TPU 8I is great for inference workloads. So the focus are things like low latency and cost efficiency. So we are moving away from one general-purpose system into hardware that is specialized for the needs of different types of workloads. But hardware is just one part of the puzzle. So let's talk about some of the software tools that we mentioned earlier.
Awesome. So in this talk, we'll take you through a bunch of software that you can try at home. We're going to start with inference, because we just talked about how important that is for thinking models. A really cool thing to say about inference, pre-training a model from scratch takes a lot of compute. But if you're working on inference and also post-training, that's absolutely something you can do with the free TPUs that are available in Kaggle or on Colab. So we'll start with a demo of serving Gemma 4 using VLM on TPUs, and then we'll move into another demo of doing some post-training with a different version of Gemma using Tunix, which is our lightweight post-training framework. Then quickly we'll go through MaxText, which has high-performance reference implementations of all sorts of large language models implemented in JAX, and these will scale out of box to thousands of chips, which are super cool. And then we'll talk about frameworks for actually building models. So JAX, which is used to build Gemini and Gemma, and then we'll talk about Torch TPU, which is really cool. It's new software we're working on to make it really easy for you to run your PyTorch code on TPUs without code changes.
Awesome.
And to get started, Rob will give it a demo on VLM.
Yeah, I will do a quick intro, and then you have to hold for like 5 minutes for the demo.
Oh, sorry, I jumped the gun.
No, let's start with inference. So LLM serving is no longer just about compute. In fact, at scale, some of the harder problems are usually memory management, scheduling, and hardware utilization, and also being able to abstract away all of these complexities. This is where VLLM in. Let's talk about some of these challenges, and then we'll talk about how VLLM helps you address those. So as context lengths grow and concurrency increases, KV cache management becomes one of the biggest bottlenecks in inference. So VLLM uses page retention. It virtualizes KV cache into fixed-size blocks. So this tremendously helps improve utilization. But this is just the foundation, and there are several optimizations on top as well. For example, prefix caching is ideal for agentic workloads and conversational workloads. The idea is for several requests to have one common prefix. So instead of the system having to repeatedly calculate KV cache, it can simply use whatever was previously calculated. So let's talk a little bit about scheduling now. Inference traffic is highly irregular. You are constantly dealing with different prompt lengths, generation times, arrival patterns, and so on. VLLM uses continuous batching. So instead of using static request level batches, your system dynamically schedules token level work at runtime. This obviously helps with scheduling, but also helps a lot with hardware utilization, which brings us to the third bucket that we were talking about. So these workloads are ideal, especially on TPUs. These workloads benefit a lot from memory layouts and hardware-aware execution strategies. And these work naturally with VLLM's execution model and helps you maximize throughput. So the beautiful thing about VLLM is also that all of this is exposed through a unified inference backend. It supports both PyTorch and JAX frameworks, and also helps you run your workloads on both GPUs and TPUs. It also supports a wide range of model architectures. So the goal here is portability and helping developers choose the framework that is right for them, and also being able to move across hardware backends very easily. So the key thing here is that as a developer, you are never having to rewrite your application layer or serving stack. So with this intro, now let's see VLLM in action. Over to you, Rob.
Thanks, Grija. That was a great intro about running inference on TPUs. So in this demo, I'm just going to show you how easy it is to get up and running the latest Gemma 4 31 billion parameter model on TPUs. So I am running this notebook on a virtual machine that has 8 Trillium chips. So we can use TPU info, which is a package for letting us see how what the chips are on the machine. And utilization. So we can install VLLM TPU just with pip install VLLM TPU. However, I am running this model, and we recommend running these models using our pre-built Docker containers. This makes it super easy, so you don't have to install all the different packages and dependencies, and it will just run out of the box. We do also have a TPU recipes repo for various models that are supported on different chips. This is not the full extent of models supported for VLLM on TPU, but it's a good place to start if you're looking to run some models on TPUs. So in this Docker compose file that I've written, there's a few things I want to note. First is that I've enabled profiling. I'm going to show you this later, but this allows us to see the low-level execution that occurs on the TPU. It's not great for running in production, but when you're debugging, it's really helpful. I also set tensor parallel size to 8, and that's really all you need to do to make sure that it's run across all the TPU chips. And I'm also using the Gemma 4 tool call parser, and I'll show you later how that works. So just to show you here that we do have a Docker container up and running with the latest nightly build of VLLM TPU. And checking out some of the logs here, we can see that it's successfully booted up. And I started this up earlier just to save us from waiting for the compile time. But we're running the 31 billion parameter Gemma 4 model, and these commands let us know that the process is up and running. So I'm also going to, just during this demo, show these logs here at the bottom here in our console, so we can see what's going on. There we go. So now as we call the model server, we can see some of the stats running. Just to show you here, again, using TPU info, now we can see the memory utilization across all of our chips is nearly maxed out. Now, this model could actually fit on 4 chips, but we're using 8 because a lot of times you want to have a lot of overhead for the KV cache that your model might need to consume. And then from here on, it's really, the great part about the fact that we're using VLLM is that the front end of your software design is going to be pretty much the same as if you were running VLLM on a GPU. So you can have the same front end software written, and you can change the back end hardware that you're running on, and it should operate pretty much the same. So let's just send a single query to see, ask it to write a haiku about Google Cloud TPUs. But we want to do more than just sending a single request. And Grija mentioned this before, but one of the really great things about what we built into VLLM on TPU is this thing called ragged page attention. So this really does a lot of things. It eliminates the KV cache memory fragmentation. It enables continuous batching, so it's really good with asynchronous requests. And then it has a bunch of custom-built kernels that are specific for running on TPUs. And one of those is the fact that automatically will change between running from prefill heavy to decode heavy type of workloads. So a prefill heavy workload might be a really long input like images or long context, and then requesting a smaller output. And decode would be a smaller input requesting a really long output. So we're just going to send 2 simultaneous requests, 16 asynchronous requests to VLLM running on TPU, and it finished relatively quickly. But since we have profiling running, we can now go over to our profiler and actually see all the low-level execution here. This is really helpful if you're tuning your model, or if you want to really get in, if you're a power user and you're going to be writing your own kernels, xprof allows you to really explore all the execution on the TPU. All right, so just to put this all into context of an actual application that you might want to build, I'm going to show how we could build a food logging assistant. So the idea here is we have an image and some text about some food that we might take a picture of. We want the agent here, Gemma4, to identify the contents, and then query a database to get all the nutrient information, and finally generate a summary. So Gemma4 is great for this because it's multimodal, so we can send it encoded image of some food like this, and ask it to describe the contents of the food. And Gemma4 is really good at doing this sort of summarization. So here we have a complete breakdown of the food in that bowl. And then Gemma4 is also really good, been trained to work really well with tool calling. So tool calling, here I'm just going to simulate a fake nutrition database that we want to give the model access to. And all we have to do is define this lookup nutrition tool and send it in our request to the endpoint, and then the model knows that it has access to this nutrient database that it can call. So if we call it and ask it for the calories in a bunch of different foods, we can see that the model has then called the tool a number of times. So just to wrap it up and put it in to show you in full view, I've vibe coded up with Gemini this front end for what it might look like. And you can just run a query here. See how it's iteratively as an agent using those tool calls to call the database, identifying the different things in the image. And then we can look this over, we can tweet it, and log it. And later I'm going to show you how we could fine-tune a model to do something very similar. So now I'm going to turn it over to Josh, who is going to talk about some of what's new in DLM on TPU.
Thanks for this.
Thanks.
Okay, so what's new in DLM? Can we switch back to the slide, please? Thanks. Okay, so lots of reproducible recipes on GitHub. Rob showed you, super cool. Another really cool thing I wanted to mention, and this is one reason I've loved working in open source all these years. We got a really
Hey folks, was off for a break. In India, there's this huge culture of lassi and buttermilk. So, yeah, having the high protein buttermilk right now. Let's continue with the TPUs on the multi-token and diffusion style speculative decoding and other recipes.
Amazing PR from UCSD, and this is for diffusion-style speculative decoding. If you're new to speculative decoding, the idea is kind of crazy. I remember when I learned about it, I was like, wait, that's kind of wild. The idea is, if you have a very large model, it's computationally intensive to predict the next token. In speculative decoding, the idea is that you have a smaller model, and the smaller model races ahead, and it predicts tokens, basically guessing what the larger model is going to say. And for various reasons, it's actually faster to have the large model verify the output from the smaller model than it is to actually predict the tokens. So it's a crazy idea. Now, usually when you do speculative decoding, you do it autoregressively, which is just a fancy way of saying one token at a time. And if you're doing it that way, there's still a slowdown because it's one token, the next token, the next token, the next token. What this pull request did, it's diffusion-style speculative decoding. So instead of predicting the next tokens one at a time, you predict them all at once using a diffusion model, which eliminates that bottleneck. And then we incorporated this into VLM TPU inference, and we got about a 3x speed up on a bunch of tasks. So it's like super cool, like hugely grateful to, it was, I believe, Professor Zhang at UCSD, so super awesome. Anyway, open source is great. So now let's take a quick look at Tunix. And Tunix is our post-training and reinforcement learning framework. It's lightweight. You can also absolutely use Tunix at home with the free TPUs on Colab and Kaggle. And we just wrapped up a really cool Kaggle hackathon with Tunix. We got like thousands of participants. It was really cool. And the idea was to take an older model of Gemma that didn't know how to reason, and then teach it to solve math problems and show the reasoning traces. So it was like super cool. One really nice thing about Kaggle too is there's a whole bunch of example notebooks you can check out. So all the folks that submitted their projects, that basically serves as this like huge knowledge base. So it's a really good place to learn. So Tunix is state of the art. It supports a whole bunch of stuff. It's like really awesome. Here's just 3 quick things it supports. So SFT, and that's something you can do to say like to teach a model to follow instructions. That typically would be the first stage in reinforcement learning pipeline. After that, it supports a whole bunch of reinforcement learning stuff. Like Rob will show a demo of gRPO in a sec, which is something that we used in the Kaggle hackathon. It also supports knowledge distillation, which is another one of these crazy ideas. So oftentimes, if you have a big model, a question you could ask is, can I train a smaller model that has similar performance to the large model? And one way you can do that, often when you're training the large model, you might be training it to predict the next token. So the signal you have to learn from is the next token right or is it wrong? But after you have a large model trained, you can actually use the large model to train a smaller model, and you have a richer signal. Because when the larger model predicts a token, you want the smaller model to predict the same token. But in addition to knowing the token, you can actually see the probability distribution from the larger model. So you get not just the token that it predicted, but you can see the scores for all the other tokens that it could have predicted. And that's a much richer signal that you can use to train a smaller model faster to have good performance. So there's like all sorts of these like really cool magical ideas, and Tunix supports that too. It also supports some really like new, cool, and advanced stuff. So if you're interested in agentic workflows, so the idea would be like, let's say that you wanted to train like a software engineer model, like a software engineer agent to actually solve real problems on GitHub. Now you have these very long-running agentic workflows, and Tunix supports post-training for those as well. We've got a bunch of cool examples on GitHub that you can check out. It's like super cool. And now Rob's going to show a demo of gRPO with Tunix.
Thanks, Josh. Okay, I'm back. So previously, I showed how we could, out of the box, use Gemma 41 billion parameter or 31 billion parameter model to run as this food tracking assistant. But what if we wanted to ensure that it works in all the different scenarios that we wanted to? And what if we wanted to use a smaller model that might be more efficient, that we wouldn't have to run on as much hardware? Well, in this demo, I'm going to show you Tunix, which is our library for fine-tuning and doing reinforcement learning on models on TPUs, and it uses JAX underneath the hood. And we're going to fine-tune a 4 billion model parameter to do the same thing as what we showed in the previous one. I'm going to quickly walk through the steps, so not to get into too much of the details here, but we're going to define the 2 different models that we need for this, the actor and reference model. Then we're going to set up a data set using Grain, which is Google's data pipeline library. Then we're going to set up some scoring rewards. And finally, we're going to train the model and then put it in production. All right, so again, I'm going to show here on TPU info that we're running on a machine with 8 chips. And then we're going to define our actor and reference models. So with gRPO, which is group relative policy optimization, which is the technique we're using, we actually want 2 copies of our model. We'll have our actor model, that's the model that we'll be updating the weights of to make better at our task. And we have our reference model, which we use to make sure that the actor model isn't deviating too far from the original model. And creating these and distributing these across our TPUs is super easy with Tunix and JAX. So I'm just going to do that here. And then we can see, after this is running, that the memory use does have them sharded across all 8 of our chips. We do leave a lot of overhead here, memory, because doing these reinforcement learning type of training jobs does require a lot of memory usage on the TPUs for doing these training rollouts. Next, I'm going to create the data set that we'll use to train this on. And the great thing about reinforcement learning is we don't need a large labeled data set, but we do need to simulate what the model will see as it's acting as the agent in our program. So with Grain, we can import an existing Hugging Face data set. I'm using the Food 101 data set, which has over 100,000 images of food. And then I'm adding a pre-processing step, which will then simulate what the model might see when it's acting as our agent. And then we can use Grain's map data set to pipe these all together so that it will efficiently distribute this to the different chips as we're training our model. Just to show you here is one of the examples, some yummy looking pizza there, and then the input prompt and an example of what it might see when it needs to find all the different ingredients in this food. So now that we've set up our data set, we actually will define some rewards. Instead of having strict labels here, we'll just define rewards that the model will try to optimize against. And for this, I had a number of those, like making sure it correctly called the tools, that had a correct response from the database, using this thought process, and also correctly formatting the output at the end of the process. But the real thing you need to know about this is the important part if you're designing these, to really think through how to make these rewards reach what you want your model to end up acting like once it's trained. OK, so here's the power of Tunix. At this point, we've created our actor model, our reference model, our data set, and our rewards. And all we have to do is use this reinforcement learning cluster, and Tunix will take care of all the distribution, coordinating the actor, reference, and rollout across all of our TPUs. And then lastly, we create this trainer, and we train on it. So we provide this cluster, our rewards we defined earlier, and we train on our data set. Now, this does take 30, 45 minutes to run all the way through, so I'm not going to actually do that in this demo. But we are going to look at some of the metrics and results. And this great thing about Tunix, it handles all the logging of checkpoints and allows us to easily go into TensorBoard and see on different experiments how our model is responding to that and how it's actually improving, achieving the rewards that we set up. All right, so lastly, let's just jump back over to this example UI, and I'm going to switch from Gemma 4 to using our fine-tuned model. Now, the great thing about this is the model is much smaller, so I'm able to run it on a single Trillium chip instead of the 8 or 4 that it would require for the larger model, and then it works. Thanks. So now I'm going to turn it over to Grija again. She's going to talk more about MaxText.
It was a cool demo. Thanks so much, Rob. Awesome. Let's talk a little bit about pre-training. So one of the things that you will notice across both post-training and pre-training is that the challenges are pretty similar. You're still dealing with distributed systems, execution, and memory efficiency, or checkpointing, and so on. So the real question becomes, how do you make frontier-scale training much more reproducible so your developers are not always having to start from scratch? This is where MaxText comes in. MaxText is an open-source reference implementation that helps you train large-scale foundational models on TPUs. But MaxText is much more than a simple framework. It gives you a lot of battle-tested training configurations across a wide range of model families, like Qwen, Mistral, Gemma, DeepSeek, and so on. So the idea is that your developers are not starting from scratch and can instead use these battle-tested recipes and adapt from there. Under the hood, MaxText is powered by JAX and XLA. JAX offers the functional programming model that helps you with model definitions and parallelism strategies. And XLA helps with compilation and also helps you with distributed systems execution in a very optimized manner on TPUs. And the combination is great because it allows you to take the same training workflow and go from a single host experimentation all the way to multi-pod production runs. And you don't have to worry about changing your code structure or your training workflow. MaxText encodes many of our hard-learned lessons in large-scale training into these battle-tested recipes. So the idea is to make large-scale training much more reproducible, accessible, and just less infra-heavy, so you can just focus on model development. We talked about some of these updates a little bit just now. So MaxText supports, like I said, a wide range of model families, all the way from Qwen, DeepSeek. Gemma 4 is our latest one. There's a couple more that's landing pretty soon as well. It also has some robust capabilities like multi-token prediction and performance-enhancing capabilities like support for custom kernels and multi-tier checkpointing. There's a link up here to our MaxText repo, which hosts all of our recipes, so please do check them out. Now that we've talked a little bit about the different tools you can use at different stages of the model development lifecycle, let's spend a few minutes talking about frameworks. Josh, you want to come over and help us with this?
Yeah, I'm back. Thanks. OK, so one thing that can help when we're talking about TPUs, maybe we could have showed this earlier, it's nice to just visualize to get a sense of the scale that we're talking about. Could we switch back to the laptop, please? And I'll show a quick demo. So we have a TPU visualizer, which came out a couple months ago. And if you're brand new to TPUs, I just want to show you what this can look like really quick. So with this particular generation of TPU, and just for visualization, we happen to have a V5P selected, it's okay. What we're looking at here in red, that's a Linux virtual machine. So you could use something like Google Compute Engine, spin up a VM, and then in this case, the blue, we've got 2 TPU chips attached to that. So it's just one machine you can SSH into, you've got 2 chips. What's cool about TPUs, of course, is you can attach more chips. So now we've got 4 chips attached. And there's lots we could talk about, but just a couple things to glance at. You can notice that the TPUs are directed connectly to each other. So in the blue at the top, the TPUs can actually send data back and forth without going through the virtual machine itself. And that's for speed. And there's all different kinds of configurations. So a really common one would be a cube. So this is a 4x4x4 arrangement of TPUs. And what's cool in a cube here, there's different types of connections between the TPU chips. There's copper when they're super close, and there's optical when they're a little bit farther away. But the goal, and the reason we have lots of connectivity like this, is we want to minimize the distance between different chips in the cube or the cluster for fast interconnect. Anyway, TPUs scale up really, really fast. Oh, by the way, of course, here we've got a whole bunch of virtual machines. So now, obviously, we've got a lot of them. When you have a lot like this, we've got all sorts of software, which is out of scope for this talk, but you can use things like Kubernetes to help you really manage a cluster like this. And then what's cool about TPUs in this generation, whoops, this is just a pod slice. So now we have thousands and thousands of chips that are all connected together. And the scale is just wild. Like, it's almost like, I'm a Star Trek fan, so this reminds me almost like of the Borg. This is actually a little bit less than a pod, but what's interesting is, beyond this scale, then we move into like a data center network. And so you can have many, many, many pods like this connected together. And the idea is that I just want to show you, like, when you think of a TPU, you can think of like one chip that's plugged into like a Linux VM. And you can also think about almost having like an ocean of compute. And what's really cool about the software stack and our frameworks, a lot of them are designed to make a lot of the magic that goes into all this complicated, like, oh my god, like, how do you coordinate thousands and thousands of chips? And like, how do they all talk to each other? And how do you do that efficiently? And how do you make sure that all the chips are working at the same time so none are idle and all that stuff? Things like MaxText and JAX handle all of that behind the scenes for you. And you can optimize it. But we've done a huge amount of work to make a lot of that transparent. And so with something like JAX that we'll talk about in a minute, you can write code that feels like you're working on a Linux VM, but really that code can be running on something like this, which is absolutely wild. So it's super cool. This is you can find this in the TPU docs on Google Cloud. It's also bit.ly/TPU-viz for visualizing. Okay, let's switch back to the slides, please. Thanks. So I just wanted to say very briefly. So we'll talk about JAX and Torch TPU in a second. Beneath both of those is our open source compiler called OpenXLA. And the main thing I wanted to say about this is this does a lot of the magic, which makes all that interchip communication possible without you having to think about it. So this is sort of the, it's just this super powerful open compiler. We've actually got like a whole upcoming conference on this that I'll talk about in a bit if you want to go much deeper. But yeah, OpenXLA is awesome. It does a lot of stuff for you, makes your life easy, which is what I want. Okay, here's the clicker.
Awesome. So now with that little bit of foundation, I think talking about JAX and PyTorch will make a lot more sense. So let's start with JAX. Gemini is built on top of JAX, and the reason is because JAX offers a very clean programmable model that's great for large-scale ML systems. At its core, it's just like NumPy with some composable transformations. For example, grad automatically lets you compute gradient computations using simple Python functions. JIT helps with tracing and compiling using XLA and converts your Python functions into optimized accelerated programs. There's also VMAP that helps you express parallelism cleanly, and so on. So as you can see, at its core, JAX is pretty minimal in the sense that you're writing simple, straightforward Python functions and then progressively adding transformations to it to make it more differentiable, vectorized, compiled, and scalable across accelerators. So instead of having to learn a heavy, large framework, all you're doing is writing straightforward Python functions and progressively adding transformations like we talked about. So you can see here, JAX is pretty minimal, like we talked about at its core. And so what makes it great is the ecosystem around it. In real-world systems, you need much more than the composable transformations that we talked about because you need things like optimizers, data pipelines, checkpointing, and so on. This is where the ecosystem comes in. It's a set of libraries that provide the higher-level model-building abstractions for a variety of things like we talked about. For example, Flax is a very popular neural network library that provides these abstractions to help you with modules and parameter management. It's especially useful when your model stops being a simple Python function and starts having things like nested loops and recurring blocks. A couple of other examples, like for example, Orbax is great.
Just brief information about the stuff that I have been working on TPUs. So I've been using V6Es, specifically the 8 and 64, and others too. So on a couple of projects for the continuation of Expedition TinyIA, that was with Cohere Labs. So me and a couple of folks from the team, my team, have been working on this for a bit long, and yeah, we have plans for publishing some blog or a research paper if something comes out of that. Currently, we are in the pipeline of curating datasets. So you can get more information about that on my YouTube streams. Let me show you guys my go to my YouTube's /@Cataluna84, and there's this live button, and there you can find the raw worklog. So these are 40 videos on the different aspects of gaming and the couple of projects that I have been working on. There are like 6 different projects that you will find in these streams. So like I have recently started broadcasting on Twitch just as an experiment, because all my coding activities and development activities and research and workflow that I do with anti-gravity and others will go on YouTube live. But this kind of analysis that I am doing right now with YouTube and Google I/O specifically, as an experiment, I'm streaming it live on Twitch right now. And the games that I play, that is the EAFC 26 and others. So yeah, the whole ecosystem kind of is built on top of JAX here, and flags, optags, and others. Their JAX ecosystem and their XLA compilers on TPU. So like I'm currently using PyTorch right now, but have to use JAX next.
Great with checkpointing and state management. Grain is great for input pipelines and data loading and so on. So you get the idea. JAX is pretty minimal, but together with its ecosystem, it's ideal for large-scale ML systems. We'll also quickly touch on Torch TPU, like Josh mentioned earlier. This is a complete ground-up rebuild of the PyTorch stack on top of TPUs. And we are building this in close partnership with Meta because we want to stay aligned to the overall direction of PyTorch and of the community. I'll talk about some core principles that we are building this around to give you an idea for how this is going to shape up. The first one is that it's fully native, meaning there are no new APIs. So if you know PyTorch, you already know TPUs. The second is around portability. So the idea here is to help with rapid experimentation, so researchers and developers can just run models right out of the box, and you're not dealing with upfront portability issues. The third is making sure there are well-lit paths for performance using things like Torch compile and profiling tools and kernel support. And the fourth is just making sure we are closely aligned with the ecosystem and enabling all PyTorch developers to easily run their workloads on TPUs. Many ML developers are using CUDA and PyTorch workflows today, but with increasing heterogeneous backend systems becoming a reality, we want to help developers to easily move their workloads onto TPUs without requiring them to rewrite their application layer. In many cases, the actual code changes that are required are pretty minimal, as you can see. And if you're interested in learning more, stay tuned and sign up to our newsletter so you can keep up with the updates here.
Thanks, Vijay. OK, also, one last really cool project before we wrap up. So this is Kinetic. It's a new project from the Keras team. And what I really like about this is it's designed to make running your code on TPUs a lot easier just using a decorator. So as you can imagine, when you're setting up stuff on Google Cloud, there's some DevOps work involved. And what Kinetic does is it handles that for you. So it can go ahead and it can set up a cluster that's ready to run your code on TPUs without you having to configure a bunch of stuff manually. So really nice new project. We've been doing some hackathons and some sprints. It's been really popular. So I think it's neat. Check it out if you're a Keras fan and you're interested in running code on TPUs easily. OK, we covered a lot of really cool stuff. And as you can imagine, for anything like VLM on TPUs, MaxText, Tunix, Torch TPU, JAX, you could get almost a degree in this stuff. There's a lot of really cool things to learn. And so we have a really cool upcoming conference. It's called the AI Systems Dev Lab. And what this is, it's really an opportunity to hear directly from the engineering team. So we have a lot of really good, really amazing, deep talks from a lot of software engineers, a lot of product managers, and folks building the software directly. And they will go really deep on all this stuff. So it's a great place to learn more. And if you're a power user, it's really the best introduction to all this that you can get. Join us if you'd like. All the talks are going to be recorded, and we'll upload them to our YouTube channel after. Yeah, so thank you very much for your time. We really appreciate it. And here's some links to learn more.
Hello, everyone. How are we doing? Everyone good? Everyone staying cool and hydrated? If you haven't, now take a sip of water. We'll have some really cool demos for you today. We're building agents with the Gemini API. Now, this is a dynamic session, so if you want to, you're very welcome to follow along. In Google AI Studio, that is your easiest way to get an API key for the Gemini API. So if you go to ai.studio, in the bottom left corner, you will find the get API key function. And you can use that to follow along with the code examples that we will show you today. Google AI Studio is really the best place to get started with all of the Google DeepMind models. It's our playground for you to test out all the different models and capabilities. So I invite you to follow along. There's no setup required. There is a generous free tier. You can start experimenting. And you can also set up billing and manage your spend, like spend caps. That's all built into AI Studio. Now, the power of Gemini really lies in its multimodality. So that's both on the input side. Gemini is really good at understanding system instructions, text, code as well, but also images and audio and video. So Gemini is really, really good at understanding all these different modalities and reasoning over them, which is really cool. And on the output side, we can also generate a lot of different modalities. You probably are familiar with Nano Banana. Everyone loves generating images, editing images. But also with Gemini TTS, you can generate speech. Or with VO, you can generate video. There will be a great session after this one as well, which will look more at the Gen Media models and that side of things. But now, let's talk about Life. Gemini 3.1 Flash Life is our latest multimodal real-time conversational model. Many of you have probably already used it. If you've talked to Gemini in the Gemini app, that is the Gemini 3.1 Flash Life model, powering your conversations there. Also, if you've gone to the backside of this stage and talked in the phone booth to the 1-800 app idea demo, that is also powered by Gemini 3.1 Flash Life. Now, let's have a little look at a demo. This demo was vibe-coded in Google AI Studio, so you're very welcome to scan the QR code as well, and you can remix it also in AI Studio. Now, remember those times where you would call up the radio DJ and you would ask for a song, you would request a song? So that's really the same idea here, but our radio DJ is Gemini Life, and Gemini Life has a tool and can make a function call to the Gemini API to use Lyria 3 to generate a 30-second clip on demand. So let's have a look at that.
Oi, oi, in context. Welcome to the live jukebox. You're live on air, ready to craft an absolute banger. So what's the master plan for today's tune, mate? Need some synthwave vibes or maybe something more jazzy? And what sort of story are we spinning in the lyrics?
Yeah, actually, can we get like a really high-energy reggaeton song about all the awesome developers here today at Google I/O?
Boom! High-energy reggaeton for the Google I/O devs. I love it. That's going to be massive, mate. So we're talking tech, code, innovation, maybe a shout-out to all the brilliant minds hanging out at I/O. Tell me more. Any specific tech trends you want thrown in the mix? Come on, big man, let's make it legendary.
Yeah, let's maybe do some vibe coding with Google AI Studio and also some agentic coding with anti-gravity.
Right, hold tight. That's going straight to the top of the pops. Expect an absolute banger with all that vibe coding and agentic coding goodness. We're talking high-energy reggaeton meets top-tier tech. It's landing soon, mate.
Siente la energía de este fiestón, la gente en Google I/O pierde el control. Vibe coding con Google AI Studio, la creatividad es nuestro delirio. Agentic coding, yeah, that's the new flow. Con anti-gravity we put on a show. El futuro es hoy, no hay comparación. Developers listos para la acción. Sube, sube, sube la emoción. Esto es Google I/O, la generación. Go Google I/O, la sensación. Go Google I/O, pura innovación.
All right, that was very cool and very glad as well. Big round of applause. I don't speak any Spanish, but our interpreter does. That's amazing. Thanks, DJ, as well. Cheers.
Wicked. Glad you enjoyed him.
Okay, as you can see, live demo is always a challenge, but very glad this one worked out so well. My Spanish is a bit rusty, but it sounded pretty good to me. Okay, we can go back to the slides. So this demo is powered by the Gemini Life API. And the Life API enables low latency, real-time voice and vision interactions with Gemini. So you can see here we have a stateful WebSocket connection, and over this connection we can send text, audio, as well as video frames to the model, and the model will understand the images, but also the physics behind the video and understand kind of what is happening in the video frames. And then it can reason over that, it can execute function calls, and it can reply back in real time using audio as well as providing the text transcript for both the input and the output text. Now, this works seamlessly across 90 different languages, currently in preview. So this is really cool because it's a native audio model, so we're going speech to speech. So the model can very seamlessly switch between all these 90 different languages and provide a very seamless experience. We can also interrupt the model. You saw this earlier, the DJ was very talkative, so I can barge in. We have the tool use, so we can automatically use Google Search rounding as well, where we can pull in real-time information from Google Search, or we can give it our custom tools, like in this example, where we gave it access to the Gemini API to generate our custom music track with Lyria. And then we can get the audio transcription. So again, we're not going through text here. The model is going sound to sound. So we're actually running the transcription on both the input and the output audio, and then providing the text for that. We also have a really, really great partner ecosystem for the Life API. So you can use it in Firebase, of course, but also really great third-party partners like LifeKit, Daily, and PipeCat, which is a great open source framework as well, Software Mention, Vision Agents, Vox Implant, and of course the ADK you can also use to build these real-time conversational experiences and bring them to production quickly. Now, a lot of talk. We also had a demo already, but for you, the easiest way to get started with the Gemini Life API is in Google AI Studio. So let's go over there now. So AI.studio. We paid a lot of money for that domain, so I appreciate if you use that one. And then we can see there's a ton of new tools here now. But we can go to the Life API. So in the playground, we can find all the Life models, and here's Gemini 3.1 Flash Life Preview. So we can choose from a bunch of different base voices, like
got a project in mind?
Puck here, for example. I like Puck, he's great, so we'll use him, and then we can simply start our real-time conversational session here. Hey Puck, how are you today?
I'm doing pretty well, thanks for asking. Enjoying the flow of conversation. How about you? Anything interesting going on?
Yeah, actually, what do you think of my outfit?
The olive green shirt looks nice, and the blue tee underneath is a good contrast. I also see the hat you're wearing. Looks like a casual, comfortable look.
Yeah, what does it say on the cap, actually?
Ah, now I can see it. It says AI.studio written across the front. That's pretty cool.
Ja, aber was ist das denn auf Deutsch?
Auf Deutsch würde man das KI-Studio nennen. AI steht ja für Artificial Intelligence und das übersetzt man mit künstlicher Intelligenz.
不好意思，我不会说德文，你可以说中文吗？
是的，我会说中文。你想聊些什么呢？我们可以继续聊帽子或者其他你感兴趣的话题。
Ah, 谢谢。So as you can see here, we can ingest the video frames of our camera, and the model can see our outfit. Luckily, Gemini likes what I'm wearing today. Gemini can also obviously understand the text that's written in the images and extract that and reason over that. And we can seamlessly switch between the languages, and we get our speech transcription, so that's our input transcript, as well as our output agent transcription here, which is great. Now, we also have some really cool Life API examples in GitHub. So if you want to get started and see all the different capabilities that the Life API has, you can get started here in the Google Gemini GitHub org with the Gemini Life API examples. And so I prepared that already here for us. So I pulled down this example. And there's different examples. We can actually connect directly to the Life API from the client side using ephemeral tokens. So ephemeral tokens are short-lived tokens that we can issue on the server side and then provide to our client to directly connect to the Gemini Life API. So let's do this here. Now, I'm not the greatest designer, but this is just for you to see all the different functionality. So you can see here we can connect to the Gemini 3.1 Flash Live model. We can give it some custom tools here. We can enable the transcription, and then let's just connect. OK, the system is ready. Hey, can you hear me?
Yes, I can hear you loud and clear. How can I help you today?
Yeah, I have some code example here, but I don't really know what it does. What does this do?
That code sets up a tool called Show Alert. It looks designed to display a message in a pop-up window to the user with a title and whatever message you specify. Are you curious about how to use it or something else?
Yeah, maybe let's try that. Let's show an alert. Hello, Google I/O. Did that alert show up?
Yep, it worked. The alert box saying Hello, Google I/O should be on your screen now. Did you see it?
Yeah, that's great. Actually, can you change the background color to green, please?
Sure, the background of the page should be green now. How does that look?
Yeah, that's great. Actually, is that green? Can you see that?
I can see the change in your screen share, and yes, the background is now green. Is that the shade you were expecting?
Yeah, that's a great shade, but actually, let's switch it back.
No problem. I've changed the background back to white. Anything else I can do for you?
No, that's it. Thanks so much, Gemini.
You're very welcome. Glad I could help. Feel free to reach out if you need anything else.
There you go. So that is a really snappy experience when we're connecting directly from the client side to the Gemini Life API. And now finally, we also have Gemini API skills. So these are coding agent skills that help you develop with the Gemini API. So we specifically have a Gemini Life API skill that you can install in Antigravity or your coding agent of choice, and it'll help you work with real-time voice and vision applications and make that a breeze for you. Now, the Life API lets you build real-time conversational experiences centered around voice and vision. But of course, there are many different ways that we interact with models and agents, and that's why we've built the Interactions API. It's our new unified API to interact with models and agents alike. And I'm excited for my colleague Philip to show you what you can build with it. Thank you.
Everyone, my name is Philip, and I'm part of the Interactions API team. So if you have feedback afterwards, if you have questions, please let me know, send me a message, wherever. And as Thor already said, the Interactions API is our new unified interface to interact with models and agents. And you can see here the code snippet. Both of them look very similar, right? We have a client interactions.create call. On the top one, we have a model, in this case, Gemini 3 Pro Preview. On the lower one, we have an agent. So basically, you decide, okay, do I want to interact with a model or do I want to interact with an agent? Then I have my input, who won the last Euro, for example. It's a very common Google search model type of question, so I probably don't need a super application for it. I define my tools. And then on the lower one, I have a very more complicated research topic, so research the history of the Google GPUs. What's new for agent is this environment equals remote feature. That's something we launched yesterday during the developer keynote. That basically gives the agent and Gemini a fully remote sandbox where it can run code, and we are going to play around with it later a bit, build our own agent. But what makes the Interactions API additionally unique is that it has server-side state management. So if we are going to look at some code examples on how you would implement it before the Interactions API with generate content or with other APIs, you always need to maintain this client-side array of history with the user terms, the model terms, which can become very big. You don't know if you maybe cut out at a different turn. And with the Interactions API, it's very simple. You make your first call. In this case, hey, my name is Phil, and in the outputs you get back an ID. And the ID can be used for the next turn. So in the follow-up turns, when I ask the model, hey, what is my name? It has all of the context from the previous turn. So you can think about it that we on the server side stack all of the context together, and that all it takes to basically build a multi-turn application. You just pass the ID and then you continue the text. And also the Interactions API supports the audio generation feature. So if you like what Thor showed about generating generating speech, you can use the Interactions API with our Gemini 3.1 Flash TTS preview model. It is the same API interface. We have our model, we have our input, we have a response modality, so we want to generate audio in this case, and then we have a generation config because I like core more than Puck as a voice, so I configured my speech config. I can define the name, and then all it takes to make is the same API request, and it's for all modalities or all features we support in the Gemini API. So for image generation, using Nano Banana Pro, I define my model, I define my input, I want to generate an image of a futuristic city. I have a generation config here, I want an image in an aspect ratio of 9:6, and the image size should be 2K, and I make the call. So every one of the snippets looks very similar. That's helpful for us humans to read it, but it's also helpful for the agent to build it, right? If you have comment pattern, we and agents, it's much easier for us to complete those. And let's look at another tool example. So that's Toolio. So when we build an agent, right, what are the key components? We have a model, which is our brain. We need tools or hands for the model to interact with the environments, and then we need an environment or a loop. And to build a very client-side simple agent with the Interactions API, we need to define our function or a function schema. In this case, we have a file incident of type function. We create a JSON schema, so which parameters or properties do we expect the agent to create. And then in our Interactions API call, we have a tools field, and in the tools field, we do not only or cannot only provide our custom functions, we can combine the server-side tools from the Gemini API. So the Gemini API comes with server-side tools for Google Search, Google Maps, URL context, where you don't need to do anything on the client side. So all happens on the server, and you can now combine them. So in this case, when you make a request, the model can decide, so hey, wait a minute, I first need to use Google Search, and then need to make the custom function call, and the Google Search happens automatically on the server side. If it decides to generate a function call, it returns to you as a user, and then you can handle this on your client side. And a very big change for the Interactions API to become agent native is like how we approach the data model, right? All of the LLMs in the beginning were mostly created or used for chat interaction. So we had a user turn, then we had a model turn, then we had a user turn and a model turn. And with agents, those didn't feel right anymore, right? We have function calls, we have the environment responding, we have listening, we have client-side tools, we have server-side tools, we have compaction. So all of those different kinds of steps were not just user and model turns. So with the Interactions API, we moved to a steps data model, meaning that each individual action inside of an interaction is its own step, and we have like a user input step, but then we have like a function call, a function result, other individual steps. So you no longer need to define role user and then provide the function results, which felt a bit weird to me at least. You have like a dedicated action for like a function result, and we can see in the code snippet basically that's a response from a model. So it has a dedicated thought log with a summary, a signature, and then the model has its output there. And what's very important is like we separated a bit like what is content representation and what is an action or a step. So our thought has a summary of type text, but it can also be of type image. Same, a model can output a text or can output an image. Okay. So let's talk about the anti-gravity as a remote agent. So together with the managed agents in Gemini API, we launched a new hosted agent. When we launched the Interactions API in December, we launched our first managed agent, which was deep research. And yesterday we launched our second managed agent with anti-gravity preview. That's available for all of you. So if you are curious after the session to try it out, you can go to AI Studio. You can try it directly with UI. We are going to do this or via the API. And the anti-gravity agent is powered by the same harness as the anti-gravity IDE. So we are basically unifying the same agent harness across all of our offerings. It has a rich set of tools. So it can do code execution, file system, operation, web search with Google Search, URL context. It can use agent skills. And I think for me at least the most exciting feature is like this environment. It gets its own computer basically. So until recently, or if you use a coding agent, it always acts on your client and your machine, so you might not be able to work at the same time. But or what if you want to scale your agent to your customers? How can you provide one computer per customer? It's like very challenging because you now start to need to manage infrastructure. And with the new managed agent feature, every agent becomes its own small little box where it can do its work, and it can come back to you. You can like interact with the environment, download the files, access the files. So that's very, very exciting for me. And the environments are persistent, so you can like create an interaction and you get back similar to the interaction ID and environment ID. And in the follow-up turn, you can provide the environment ID to the call again, and then the agent continues to work inside the same environment. But what if you want to use the environment with a different agent? So maybe you have a research agent who's researching the history of Google TPUs, and then you have like an app builder agent. You want to, of course, provide the research to the app builder, and you can share this with the environment. So the research agent can run on the same environment, and then you can provide the environment ID to the app builder, which can then like read the same files the research agent created and build the app around it. So we no longer have only context share inside of the history. We can also now share context on the environment via persistent files. And then in addition to this, you can like not only download files during the execution, you can also scaffold your environment, so you can provide files from a GCS bucket, from a GitHub repository. So if you have your skills in a GitHub repository, you can make them directly accessible or via inline. And those files are not part of the model input, they are part of the environment. So it's not that we run into like this context limitation. If you upload like a heavy video or like a big image, the model can of course read them from the file system, but they're not directly part of the file system. So what it takes to create your own agent, you can use the anti-gravity agent, or you can create your own small little agents, which you can then invoke via the idea. And all it takes is an agent.create call. You can give it a name. So in this case, it's a data analyst. You define your base agent, the anti-gravity preview in this case. You can provide system instruction, then you can scaffold the environment with like, hey, I want to provide my skills from my GCS bucket. And after you create it, you can directly use that data analyst ID to interact with it. But what if you need to install certain CLIs, certain binaries? You can do this by using the agent to scaffold its own environment and then use it for creation. So you can like on the right side, yes, you can like say, hey, please install pandas, create my Python environment, and then you have the environment ID, and you can provide this environment ID when creating an agent. And every time you make a new request to this new agent, the environment is forked and it has all of the pre-installed libraries available for you as like a clean, fresh environment. Okay. In addition to this, we also launched a small CLI for the Gemini API, which makes it super easy for you to give your coding agent basically access to the Gemini API. Yeah, you can see it on the GitHub repository, and now let's look at some demos. Go. So I'm in AI Studio, and with the anti-gravity agent, we launched a new tab or experience. So in the playground, you now can switch between models and agents, or you can go to the model picker, where we also have the agents available, where you can interact with the deep research agent or with the anti-gravity agent preview. And in the middle, we have 6 different cards. One of them you might have already seen during the developer keynote. That was the AI Talk Radio, where we generated this awesome AI Talk Radio show from Hacker News. We have a data analyst, we have a customer support, and we pick the anti-gravity preview, and then we have some prompt examples. So in this case, I want to create a weather dashboard with the prompt like, hey, fetch the current weather and the 3-day forecast for London and Ankara, and then create an HTML dashboard, and then I click run. And now what happens on the server side is it spins up its sandbox, its coding environment, and then it starts working on it. It takes a little bit of time on the first request. Why that's working? Oh, it's already working, so we see the thoughts. Okay, we need to use the weather in, and then it runs a command. Okay, it curls our API for London, it continues the thinking, it makes more tool calls, it writes a Python script, another Python script, and all of that was initialized with a single API call. So we are not handling any tool use loop on the client side. It's all running on the server, one single API call, and then like waiting until it's done. And you can scaffold those environments on AI Studio as well. So if you want to, for example, add a source, like upload a skill or something additional, you can do this here. But much more important, at least for me, is like, okay, how can we provide credential in a secure way, right? If we give our agent a sandbox where it can execute and run code, that feels very dangerous. What if I provide my API key and the agent decides to use it to, I don't know, run 100,000 calls to the model, or what if I provide some other credentials to like more personal information? And to solve this, we created a proxy around the network, around the sandbox, so the agent will not have access to the API key, but it can make API calls. So if we can limit, for example, we said, hey, the weather.in URL is available, and if it would require an API key, we can define it here. And then what happens when it makes that call, we catch that call and place the dummy header from what the Gemini or the sandbox has with the real API key. So the model thinks it has a valid key, but the key is never available for it, which is a very good solution in this case. It can go back to our model. Okay, it's currently creating our dashboard. It has already written another file. Since we only have a few more minutes left, we can look into a pre-run example. So at the end, it generates a response like, hey, I have fetched the real-time data, real-time weather and the 3-day forecast for London and Ankara, and I have created some files that use the Python file, but also a dashboard. And in AI Studio, we can like directly click on this file, which basically downloads the file from our sandbox, makes it accessible for us. We can see the raw code, but I mean, my HTML is not as good to fully validate if that's the correct dashboard or not, but we can view it in preview, and we can see here it's like the dashboard with the model created. We can switch between Celsius and Fahrenheit. We can switch between Ankara and London. And all of that was done via a single API call. Of course, it's not the most beautiful dashboard, but one API call, 3 minutes of waiting, and we get our result. We can also quickly go back to, okay, it's still running. And there's another very cool example. So let me open a new AI Studio. In addition to AI.studio, we also have AI.dev. So if you don't like the domain AI.studio, you can use AI.dev. There's another prompt which asks it to create a very basic anti-gravity game with Free.js where I can like fly through an anti-gravity space. And it already worked on it earlier. So very similar, the model thinks about it, lists some files, writes stuff to the game basically, makes sure that the game is available and runnable for me. So it verifies its own work, returns it to the user, and I can download it again. And very similar to the dashboard, I can render my HTML, and I can click play. And now I'm like running my small little game, which Anti-Gravity has created for itself directly in AI Studio, which is very fun for me at least to play around and to experiment. Okay, now let's go into creating our own agent, right? Most of the developers don't write too much code anymore. We use coding agents for it, and to make it very easy for coding agents to use the Gemini managed agents, we created a skill and we created a CLI for the Gemini API, because at the end it's all just an API call. So what I have done before the session, I installed the Gemini API CLI skill and the interactions API skill into Anti-Gravity, but we can test it with like, what skills can you use? And of course, we use the new Gemini 3.5 Flash model, so we have an Android CLI skill available, which someone else might have installed. We have the Gemini API CLI and the interactions API skill. And what we can now do is like, we can ask like, hey, create a new Gemini agent that is very good at emoji creation in SVG. Okay. Now it reads our CLI skill. The CLI skill has a specific section on how it can interact with this new managed API. We want to, yes, allow the commands. It lists our agents. We say yes. You already can see I've tested this, so let's see if it creates a new agent. Okay, working. Okay, we got a plan. We have a plan. This plan's out loud how to create a new agent. And if we scroll down, we see we have an agents.md file, which defines a system instruction, a helper method to Python script to call when a new agent is deployed. Okay, sounds good. We see the CLI being used. So in the Gemini API CLI, you have an init command which scaffolds your agent. You can create it, you can list it, but you can also test it. That looks good to us. Now let's create it. Okay, we allow the command. And now when we look into our files folder, we have this SVG emoji generator. It has a skills folder, it has a workspace folder, and it has our agent YAML. The agent YAML basically is the same shape. Let me move that a little bit so it's easier. So it's the same shape. We have our ID, we have the base agent, we have the description, we have the tools it can use, and then our environment. If you want to like specify source it, it also has like an example on how to do it. And then we have our agents MD. And the agents MD has an instruction. You are world-class SVG designer, specialized. Okay, of course we can now edit it, adjust it, correct it, either manually or using our coding agent. For now we allow it. Okay, looks good. We created it. Thinking, testing. Okay, no, we do not want to use Python. We want to stop here, and we tell it, test it, give us a test command using the, so that's what we take. So we go into our terminal, very similar. So we can either now like tell the agent to run our CLI, or we can run it ourselves. We run it ourselves, and now we should, or we are doing the same as we have done in AI Studio. We start our request, a single API call. We have some thinking. We should also see soon some file being generated. In this case, create rocket. We do more thinking. Waiting. Okay. While this is running, we can go maybe back to our other run we started in the beginning with the weather dashboard. Nice, that finished. So that's like the request we started in the beginning of the session, and also very similar here. Now we have a different dashboard with some nice icons. We have the weather forecast. I would say this version looks better to me than like the previous one. But of course, you can now like say, hey, make it light mode. And what's very nice is like we use the same environment. So it has the context of like, hey, we created this dashboard. We can see as a follow-up turn, it read our weather dashboard file. And it's now thinking, let's see what it does. Okay, I examine the template, specifically styling. Okay, investigating the theme application. And it's now like changing the file. So it not only has the context of the iterations we are running, it also has access to the files, which makes it very unique to use. Let's look back to our model. Okay, we are now like streaming our SVG. It should be done. Okay, so that also completed. And if we look into, we can say no. I run that in my terminal. Download the file. Now we give it the environment ID. Here is the env ID, and hopefully it still knows. Yes, we can now use Gemini API files download. We say okay. It downloads our file. We have our rocket. We copy the rocket. Yes, and here we see the rocket the agent has generated, which looks like a very decent emoji for me inside an SVG. I'm sure I could not be able to do that. Okay, and if we quickly go back to our other agent, okay, I've redesigned the dashboard. Let's take a look. And nice, it's in light mode. So as you can see, it's like very flexible in terms of like what you can do. You have like now 2 states you can like use to manage context with the model. You have your environment where you can persist file. It's very interesting when you start to working with like bigger files, videos, audios, or if you want to work or have agents working like the same environment, or even if you are doing like some coding work, being able to run things asynchronously and remotely allows you to like set up trigger and think about, okay, what if I get a new GitHub issue? I always want to start a managed agent which looks at the issue. Is it able to reproduce the issue, or do we miss some kind of information? If we miss some information, maybe the agent can go back, add a comment to the issue, and then like ask for more information, all hands off, all without needing like to create any infrastructure to manage any like sandboxes for you. Awesome. We have some time for questions, so if you have any questions, you can go like to the outside. We are very happy to answer about the live API, about the audio models, or especially your managed agents or the interactions API. Do you
want to say thank you?
Thank you, but then we don't. Yeah, thank you. Thank you.
Good morning, everyone. Welcome to day 2 of Google I/O. Hopefully, you all are as excited as we are about the announcements from yesterday. Lots of cool stuff. This is going to be a ton of fun. I feel like sort of the theme, at least my takeaway, and I'm curious for you all as well, about yesterday was sort of, the agent era feels like it's really in full swing with Gemini. And so I've got lots of questions about the details of that story. And I'm joined by a bunch of wonderful guests. Josh leads the Gemini app team, AI Studio, and Google Labs. Koray is our CTO inside of DeepMind and Google's chief AI architect. Liz leads search, which is an incredible responsibility and privilege. And Jeff's our chief scientist and also one of the co-leads of Gemini. So this is going to be a fun conversation. Maybe we can sort of just start with Gemini 3.5. The agent era. Koray, what did it take to sort of like make that happen?
Okay, first of all, thank you very much. It's great being here with everyone. Wonderful environment. 3.5 Flash, like we started with the 3.5 series with Flash. The biggest thing that we really wanted to focus on was like, getting coding and agentic workflows much better. We see a huge improvement from like where we were 6 months ago, September, when we released 3.0, and the model had really high levels of reasoning and multimodal understanding. And together with these agentic capabilities right now, I think like we have a system that is really enabling this like agentic era, as you said, for everyone. Right? Like we are enabling that for developers, we are enabling that for businesses through anti-gravity, through Gemini Spark. I think an exciting era is coming. A lot of focus went into really understanding like those workflows internally, us using the model very intensely, right? Like for coding and non-coding tasks as well. I think like to me that has been the main driver of understanding where the real bottlenecks are, and then getting that feedback into the researchers, into the model builders to like extract that information and like find the solutions that's gonna make the model scale up. Because like there are hard technical challenges in terms of going long and solving long horizon tasks. But like I'm very happy and proud for the team.
Yeah, no, I love it. The team did a great job. I think one of the threads that Sundar talks about a lot is this like full stack AI approach that Google has, and I feel like an interesting like observation of that is that it feels like you actually need in a lot of ways this full stack AI approach to pull off agents like and actually make it work. And I think there's this like symbiosis between, we were talking earlier this morning about like the symbiosis between like the model, the harness, the product, and actually Jeff, like maybe the hardware as well. And like you need hardware in order to scale this up. And I'm curious any sort of reactions to the obviously the 8th generation TPU available and sort of powering a lot of these experiences in anti-gravity, maybe in the Gemini app, which is super exciting.
Yeah, I mean, I think we've now got pretty significant track record of doing many generations of TPUs, and we've been refining kind of the designs of those systems for, initially we were just focused on making them awesome for training and inference, and I think now we've got a bit of a separation of the design so that we focus on both training, which is a somewhat different problem than inference, and have reasonable splits in the actual chip designs for those two different use cases. And I think it shows in the inference speed of these models. Right, that starts from having really good hardware that can run very large scale models very quickly, and with great interconnects and all these kinds of things. But it also is the focus of a lot of people on the inference serving team and the software stack above that to make this all kind of come together. But we know when you use a model and it's super fast, it's a much more delightful experience than when you're using it and it's slow. And that's true even if it's agents using it on your behalf.
For sure. Yeah, and Liz, I think like maybe the search team feels this more than anyone. The sort of like obsessive sort of like look at latency and sort of getting users the answer as fast as possible. I'm curious actually, like I feel like there's a lot of like balancing that search has to do. You want to get users an answer quick, but obviously search has agents now and it's sort of becoming an agentic product experience as well. I'm curious sort of how you're thinking about finding that balance. And also like the headline of search is like biggest upgrade to search stocks in 25 years. I love that. It's super exciting.
Yeah, I think it's been a really close partnership with Koray's team on this. One of the things that's been interesting, we've always known that latency matters a lot to people, but it actually requires quite a deep understanding of how difficult does the user find the task. And like how much value are you providing, right? And so people's willingness to wait is in part based on how much work are you taking off. So I was talking with someone yesterday who was like, well, how much time can you spend? Like, well, it depends on what you're asking, right? If the question in the user's mind is quick, then you better be lightning fast, right? Otherwise they're like, why the heck am I waiting? On the other hand, if the user would have spent 15, 20 minutes doing it, you can have 10 seconds for sure, right? If you can do something amazing. And so we actually have been continuing to evolve over time. What is the amount of time required? And then you take something like we talked about bringing agentic coding in. If you're going to create a weekend planner for me, that's good, I'm going to use for the next several weeks, I might be quite happy to wait a minute, right? Because I can go, I can set it up, I can go do something else, I can come back and I can use it. And so we really need to build that level of adaptation with something like information agents. It's working behind the scenes. So you can think about latency in a totally different way. It's important that when the change happens, you're really quick to respond to the user. And so it's constantly going to this question about what is valuable to the user. And as the models get better, that's great because it used to take a long task and now you can do it with a smaller model. That's really exciting to see. And then at the same time, you come with harder tasks to give the larger size model.
Yeah, I feel like there's so much alpha in trying to find this like right balance of like how long should you actually take to do a task. And Josh, I asked you right before we got on stage. Yesterday, the Gemini app launched sort of to trusted testers and hopefully for Ultra subscribers next week.
Yeah, next week.
Gemini Spark, which is sort of always on 24/7 agent. I was asking you sort of like what are the tasks that you have Spark sort of kicking off for you? I think it's a good like I think we're all going to be trying to answer this question of like what would I be willing to sort of let the agent go do on my behalf for some extended period of time? What are the things that I'm like actually I kind of need the answer right now? And I'm curious for Spark how you're thinking about this with the Gemini app in general, but also like any insight for Spark specifically.
Yeah, it's fun as we've been testing Spark. It's one of the things we've been finding. Each day you use it, you find more things it can possibly go do for you, and that's what's really exciting. When I first started using it, this was a way back. I was doing kind of regular scheduled things. So every morning it might go through a bunch of stuff for me. Then I started doing a bunch of things where I would set up triggers. So for example, like if I got an important email from Sundar, label it P0 and do a bunch of research about his question and like prepare the draft.
Then, don't send the email.
Don't send the email. Yeah, exactly. Very important. Don't send the email. It respects that, which is good. Then I've gone through a phase where there's a lot of kind of information-related things. For example, I'm a huge Oklahoma City Thunder basketball fan, and I have it where I get just like a daily nice surprise. Actually, I'm getting updates anytime the team has an update, but it's talking to me in a way like a diehard OKC Thunder basketball fan would talk to me. And so it's almost like you're like at the pub or something chatting about your basketball team. There's all kinds of other things we're doing on the team, and we talked about this one too, where it'll go out and create documents for you or slide decks. That was some of the stuff I showed on stage yesterday. That's been really helpful too. You can go in. Usually what I'm finding is the first draft quite good, and then it gets me started. I can go edit it and sort of do kind of revisions as needed. So it's quite fun to see. I can't wait for all of you to try it. And yeah, we're going to try to scale it as quick as we can next week. So stay tuned.
Yeah, I love it. I feel like it's one of the challenges of like these new capabilities landing is actually like deploying them across the product surfaces. And Corey, I'm curious sort of like the tension you feel like we built a great model, and I think historically it was like not easy, but it was like a little bit easier because there's a few products that were using it. And I think now like the success cases, we take our models, we build them. They're built for all of Google's products and sort of the external ecosystem to build on top of. And it's like a much there's thousands of people now who are involved in like taking the model and delivering it across Google. And I'm curious, there's also thousands of people saying, I wish the model would do this thing. And from a model perspective, Corey, I'm curious like how you're finding the balance of like where we going in the world where like everyone wants Gemini to be everything. How to find that balance.
I also have my own wish list of. It seems like it's always the least priority when I talk to the people.
Talk to the chief product officer here.
I think it is like from my point of view, I think it is important that we actually get all this feedback. Like yes, like, is it a challenge because like with where we are when we release a model, like when you look at what is happening right now, we release Gemini 3.5 Flash, Gemini app, Spark, Search, and Anti-Gravity, and API. So like this is reaching pretty much everyone in the world on day one immediately. So yes, of course, like you end up making some decisions in terms of making sure that there are minimums that you want to satisfy all the way across the surface. But it is important that at the end of the day, this is always a journey for building intelligence. And the steps that we take there is what everyone is asking for in intelligence, whatever surface it is. Right? So there is that common factor that either it's Gemini app or Spark or Search, but every one of us want, and what every user, developer, or businesses want is more intelligence. Yeah. And that is common. And that's the main driver for everything that we do, right? Like that's always the highest priority. And that intelligence comes in like different forms. Of course, like reasoning capabilities is important, understanding the world is important, agentic actions is important. So like our first priority is get the fundamentals right, and then like together with that, make sure that the model is customizable. The model is like interacting with the user in the right ways. I think like that kind of strategy where we look at the model as a product itself, I think that is really important, so that we work with all the internal and external products and interfaces to develop the model. But that's the reality. We are sort of in that in between of not academic research anymore. It is but not a real product that like there's no innovation. There's not a stale product. It is in that really exciting space of it is a technology that is going out in the world, and you need to find that balance where you both push the technology forward and make it useful at the same time.
Yeah, I feel like one of the points of tension that people always say is like, and actually something that makes these types of events like I/O really difficult to sort of have empathy for the model teams is to echo your point. I think like building the model today is like not sort of traditional like software development, building a product development. Like it really is research, and like sometimes it's research. You should be taking bets on things that maybe aren't going to work, and we don't know how it's going to play out, and it makes delivering a model on a specific day to the entire world an exceptionally difficult problem. And I think we pulled it off, which was awesome to see. And actually we pulled it off with like something that I was like surprised and super excited to see was like 3.5 Flash actually available to everyone inside of Search, which I think is I don't know if that's the first time that we've delivered like our frontier model to everyone, but I'm curious like also what the increase in intelligence is enabling for search. That like you actually like it's changing the way that people think about like I think the tagline which I love is like Google Search is AI search, which is awesome.
I think we were seeing with 3.5 that the reasoning and instruction following really helps. Like you think of search, you can think of it as one thing, but behind it there's often a lot of different tools. For instance, right? We're asking the sports backend, we're asking the finance data, we're asking global, we're asking travel, and so you want to pull all of that together into an experience. And so as the model gets better at reasoning and understands how to think about those better, how to pull the information together and make trade-offs better. I think one of the things that's been really great about being able to make progress in search is collaborating back and forth with DeepMind, where we go and say, okay, well here's the problem we're facing, but rather than could you please make this specific thing work for search, it becomes a brainstorming back and forth between the teams about what is the underlying thing. Okay, what are we learning about what's challenging about tool use broadly? Okay, how can we partner to go make that right? What are the right types of valves that push the limits? And so that we try and find a way that you expand the model in a general way for everyone, but understanding search's needs or Gemini app's needs, where we're sort of finding the opportunities or the challenges of the model and pushing it forward.
I think that is really the key. That I think we ended up establishing that relationship both with app and search. That like we try to go into the roots. I think Liz put it really well. That like you can't fix individual problems. You always need to go to the root cause and try to solve those.
Yeah, I love that. One of the interesting threads, Jeff, you and I were having this conversation probably like 3 or 4 weeks ago, sort of as the model progress continues, where the new bottlenecks arise. And I think you had an interesting perspective on this that I think is like something that folks should be thinking about sort of as they build with the tools, as they use the tools. So I'm curious for your
thoughts. So I mean, I think one way of viewing agent-based work is the agents are going to be built on powerful models that hopefully are running on super fast hardware and themselves are sort of lightweight enough to be sort of fairly fast and capable. But if you start to think about maybe new techniques and new hardware that make the time in the model actually shrink dramatically, then all the tools that these models are trying to use, many of them are built for sort of human level interactivity, right? Like list the files in the directory, go get this file and open it up and do stuff. And if you make the model infinitely fast, Amdahl's law says if you're spending half your time in tools, you're not going to get anything better than 2x speed up in that, even if you had magical hardware that doesn't exist.
Which I hope we did. I would love magical hardware.
So I think we're going to have to, as we start to use agents for more and more things and build out a broader set of suite of tools that these agents rely on, those tools themselves are going to need a lot of attention in terms of like how do we make those as fast and robust as we can? How do we have like maybe approximations to what the tool would really want to do, but maybe it can do a lighter weight form of whatever it's trying to do that is much 10 times faster? Because I think that's going to be really important for building. If you start to have long running tasks that write this code and it's going to take a week, you'd really rather have that code take half a day to do.
There's a really nice cycle here, right? Like I mean, we are in a really nice position of inside Google. It's so automated, the whole engineering environment, thanks to Jeff and others, of course, like creating this environment. But like many things are designed and built for like human frequency and human cadence. So like it's an initial amazing step to be able to have this. But now we are getting into this exciting stage that we can actually now use our own models to actually go through the stack and adapt them to this new agentic world. And then tools get faster, and then the models work better. And then that is another cycle that I'm excited about.
Yeah, I can give you a good example, actually. We had a bunch of internal tools that the models were trying to use, and many of them were written in Python because that was easy and a good way to do it. But Python is not the speediest of programming languages, and so even the startup time of the tools was actually quite slow. But the models are now capable enough. When you're asking a model to write code with a natural language prompt, that's ill-specified in many ways because the model has to fill in a lot of details. But if you ask the model, here's a Python program that does something with a whole bunch of tests that test its functionality, please translate that entire system into Go. That's a much more fully specified problem because now you have actually a fully functioning spec in Python and you just want it to be in another language. And we've been able to, people have been able to rewrite many of our internal tools to be 10, 20 times faster with just one night of work with a capable model.
And I think one other interesting thing about this is there's the part of how the tools get faster and making the tools kind of run at machine speed, maybe not human speed. The other side of it, we found building new products in Google Labs is around the context. How do you kind of prepare the context in a way that's not just human readable, but machine readable? So we have entire teams now that haven't written PRDs in months because that's sort of the old way of doing it. You're sort of writing in a way, whether it's an ND file or other things, where basically one of the models can just pick it up and go with it. And even we showed yesterday on stage, Stitch is another example, one of our labs experiments. They kind of introduced this whole idea of a design.nd file, which is now open source, where you can just codify, here's the design language for our app, and the model can just take it and run with it and sort of obey it. And so I think it's both the tool velocity as well as the context. Making both of those human and machine readable is really, really interesting.
Yeah. Were you going to add something, Corey?
I mean, I think like all this transformation, I think is going to really transform like the way we do software engineering is changing. And like, we see this inside Google. I see this as an opportunity for us to also understand what are the next frontier of developments we need to do in the model. This is why I'm always excited about working with products, external, internal as well. But like that experience, that first party experience that like model builders, researchers need to have, I think is irreplaceable. That is always the main driver. So like, I expect a lot of folks here as well are going through similar kinds of things. Like why coding is important. Like I mean, we test the models that way. But in a way, like, a big part of the transformation that we see today that is going to happen is transforming like our infrastructure that is very much designed like with the constraints that we had until now. And with this new agentic world, we can actually transform all of our software infrastructure in a much faster way to adapt to the new world. And I think that is going to be one of the biggest drivers of agentic coding.
Yeah. Speaking of agentic coding, Cora, you mentioned yesterday in a conversation that we were having that actually you personally reviewed all of the DeepMind code before Google.
In the early days,
you were personally the one reviewing every single pull request and changed that.
And at some point I realized that doesn't make sense. But, but I did that for a while. Yes.
Yeah, I'm curious, like through that lens, and like obviously thinking like your job is very different, and actually all of your jobs have like changed in different ways over time. I'm curious, like for you all personally, how sort of like this advent of AI tooling and like the way that we all work has like shifted what you do, how you spend your time, if it has at all, or if you're still sort of operating the same way. And I don't know if anyone wants to go first or feel strongly about this, but it feels like the renaissance is happening. And for myself, like I was doing a lot less coding before I joined Google. I was doing a lot of coding before I joined Google. I stopped doing coding for a little bit, and then actually this whole AI coding revolution has like brought me back to writing software every day, which has been really cool.
I feel the same. I used to write a lot of code, and then like my career took me in a path where like it slowly degraded and like not much. And then nowadays I feel like when I see something and I'm like, okay, I mean, this could be done in a different way, or I have an idea I want to try. It is easy for me to do it because just like I'm having all sorts of conversations on like different things that we are doing day to day, I just have conversations with agents about, okay, I'm trying to change this part. Can you start looking at it? And I don't need to. I can do it very asynchronously, right? Like that is what is enabling me because like even if my time is split between many things, like, at night I can come back to it and say, okay, like what did the agents do? And like see, I like the result. And I love that. Like I mean, that gives me a more productive feeling, to be honest with you.
Who's reviewing the code though? Is it Jeff? That's the real question. But sorry.
I think one of the things that's interesting is just to watch the blurring across jobs. Because there's a lot of cases where people have some familiarity, but the startup cost is so high. Like, okay, I want to understand this data question. I don't know where the tool is located previously, so then I would go bug the data scientist who should really be doing a more advanced task to please find this information for me, right? Okay, but why do I need that? It's just because I don't actually know where the data is located, what's actually the case. Okay, well now I can just go work with the agent and it can do that. Now I can do this. Okay, can I lean on the product? Can I change code, right? I hadn't written code for several years. Now I can write code again. Because a lot of the startup costs or a lot of the sort of knowledge about where something was or how that was difficult to be good at everything, especially like a code base as big as Google or Search. But you had the ideas, okay? And I think you see this like at my level, but you see it at the levels below. Instead of a PM trying to then go talk with the UX designer that doesn't quite look right and then trying to figure out how they explain this to the engineer who then tries to code it, can the PM change the scale of the design file, see it, realize their idea was not what they wanted, try again, and when they finally get something good, then they can go work with the engineer to make sure it's performance enough or other things like that. And so I think it's amazing because it empowers people to take the parts of their job that might have been a small percent, but that they had to rely on somebody else to do, and unlock it. And so that more people can feel like they're builders again, and not just coders or not just designers or not ones, but they actually get to sort of partner with other people to build something whole.
I mean, one thing I would say is it really accelerates the ability to do software development and experimentation, and particularly in parts of the code base where you're not necessarily familiar because you didn't write large parts of it. So sometimes I'll dive into some performance issue and start to look at, why is this, this particular thing taking a lot of CPU cycles across the fleet or whatever. And sometimes it's in parts of the code base that I'm not that familiar with, but you can actually look at what the performance problem is and express at a very high level. Oh, it'd be different if we use this particular kind of locking scheme instead of this one, or this particular kind of data structure instead of this other one. That would probably improve it a lot, but it's actually quite a lot of work for you to manually go do that change. But now you can just rattle off these ideas, ask the agent to measure the performance impact, run all the tests, and you can be much more productive. And as Cora said, you can do it asynchronously as well, which is quite nice. Yeah, I'm finding that's one of the big changes. I do a lot more asynchronously now, and I really try to guard and protect the time when I do something kind of synchronously. So that time has gotten more valuable, I would say, just in my calendar. I also do a lot more on my phone. I also do a lot more with my voice. And so those are other areas I would say, just like things that maybe a project didn't feel possible before, but now it's like you can even just do that project on your phone. So I think those are things that are kind of changes in my day-to-day.
Maybe just a little plug. Like Spark is really designed for this kind of asynchronous interaction. Like as opposed to when you go to the Gemini chat or Search, you expect to have this conversation ongoing. But Spark is really for these kinds of asynchronous interactions where the agent is gonna go and do something for you, and then you can come back and check, or it will notify you that I'm done, or things like that. I think that is a big enabler.
Yeah, this is a perfect tee up for my question about sort of like the future of interfaces and sort of as the models change, as the capabilities change. We launched Gemini Omni yesterday, and sort of the ability to take in any input and produce any output, which is really exciting. We launched a bunch of new audio interfaces across the suite of Google products. Josh, I think the labs team is sort of like often at the helm of trying to figure out like what do we do with these new capabilities? What do we do? Like what does the next interface look like? That's like voice native and sort of solves all these problems. So I'm curious if y'all are cooking anything that you can share. Well, we are cooking a lot. We'll see if it's any good. I mean, that's part of what we're trying to do though is figure out if you take something, say like voice only interface, and you dial that all the way to 11. What do you get on the other side of that? Like what kind of product, what kind of experience? Because at this point, I feel like the models with voice, we tried to show some of that yesterday, whether it was what Sundar showed with Docs Live, where you're just creating the document, or some of the stuff I tried to show with Spark, or even some of the stuff you'll see throughout the festival here on site. I think that's one area where we'll try to go explore. I do feel like, just building maybe a little bit on Cora, I said, so much of how we've used
computers for the history of time has been synchronous in a lot of ways. And maybe it didn't always like you type in, you get an answer in milliseconds. You may have to go make a coffee or something for some of the large systems and other things when they first started. But I think this idea that you'll be able to just toss things over your shoulder changes how we're gonna have to think about the design. So our first design of Spark is a little bit more of a dashboard view. I don't know if that'll be the ultimate design. I'd be surprised if it was the ultimate design, to be honest with you. So I think there is gonna be some notion. People talk about it. Is it like a dashboard or a command center? Or like where are you orchestrating these things?
Mission control.
Is it mission control?
It's gonna look like the NASA.
Yeah, that seems hard to read though.
You got 1,000 monitors and 20 people.
That's right. I do think though there is like sort of maybe an arc towards interfaces that do feel more and more natural though. And I think that's probably also why I'm very excited about voice, is because we know that just around the world, that's how we've all grown up learning how to talk to people. And so I feel like that maybe there's some unlock here where voice plus some notion of kind of a status that gives you a sense of where things are, where they need your help. Feels like there could be something there, but we're gonna try to experiment a lot. We'll see where it goes.
Yeah, I feel like the dashboard view is kind of a good one that'll scale to a limited level, but it might be good for 10 things, but it's probably not gonna be good for 100 things you're trying to do. So then you introduce some sort of hierarchy of these tasks are all related, or maybe you have like stand-ups among your agents or something every day. Who knows? I think that question is, if every person has 30 virtual interns working with them, how do you coordinate that?
Or maybe we'll just do what Liz does, like search and let the agent design the interface.
Yeah, that's right.
I do think there's this interesting question about whether the interface is the same for everybody, right? And actually, is the way that you think about processing the task different than the way I might think about processing Jeff might? And so, should you actually, if you truly have an agent, can the agent organize the people the way you want, not the way somebody else wants? So how does that affect?
Definitely should be different, I think, right? Like, I mean, in education settings, people learn in different ways, and so a podcast describing something versus an interactive tool that people can play with versus a textbook chapter are all different ways of learning things, and they're differently appropriate for different people.
Yeah. One of the things that I would love y'all's reaction to, just because we're all so close to the action, and so I think it's interesting to see your perspectives about like anything that surprised you that we sort of launched at I/O or in the last couple of weeks or months. And I'll give my really quick one, which is something about Omni. And the part that surprised me, actually, we were talking this morning, like I sort of like academically got it. I was like, oh, the model's powerful. It's nano banana for video. And then we sort of had that podcast intro clip of what we were doing, and sort of the example was like a bunch of people talking in a podcast, and then like I'm holding a cat and a plant, and there's like things flying all over, and I was just like, it made sense, and it like it clicked for me. I was like, I get it. It's like it was surprising that what I was surprised by is like that use case was what sort of like clicked for me, and that maybe is the application of like taking videos and sort of doing interesting things too without actually like changing the core content, maybe to like make it more engaging. Jeff, to your point, for like educational context or add some like supplemental stuff. So I'm curious for you all. Anyone have any interesting things that they've been surprised by from a launch model capability perspective?
Well, I got one maybe real quick. Google Flow was on stage yesterday. It's a tool we've done for filmmakers, and one of the things that was kind of snuck in there, and everything flies by so fast in the I/O stage, but we've got a new area in the product where you can make tools. And to me, it could be, we'll see if it works, but one of the really more big jumps in how we think about product design, because we're essentially carving out an entire part of the app where we're saying, you as a filmmaker, as a creative using it, vibe code your own tool. And so it's taking advantage of all the 3.5 Flash advances in sort of reasoning, coding, and people, I think, are going to be able to make, actually, to this point, their own software right in the tool. And I think for us, it was a big shift the first time I saw it as we were headed into I/O, because now, as a product team, we're kind of building almost a thin shell with the space to let people that use the tool really make the tool their own. And I think that's very empowering, but also a whole different way to think about, I have to design every tool and every feature. It's actually, no, just put the tools on the table. And these are very creative people. They're going to go create the shaders and the text overlays and the lighting effects and everything they're going to want. And so I'm very excited to see how that, hopefully takes off today as people started using it. Our Discord is kind of throbbing with cool, creative ideas. So that was one for me.
I love that.
For me, the operating system demo that Warren showed, that we did in anti-gravity, like it was surprising to me. Like we worked on this model for a while, we worked on these agentic capabilities, code capabilities for a while. But the capability of just saying teamwork, go build an operating system, and then it just goes and hundreds of agents work for like a day and a half, and they come back with something that is actually functional and working. I was still when I see that, I'm impressed. I'm surprised. I think I always in a way find myself in a position of take a step back. This is to be able to do this impressive. To be able to do this at scale is impressive. To be able to do this at the speed is impressive, and to be able to actually give this to everyone who's using anti-gravity, and being able to do it at that scale. I'm excited.
I love it.
Yeah.
I think for me, we started looking at how do we bring some of the agentic coding capabilities into search, but initially we were working with the model. And then partway through we said, oh, well, maybe for some of these more advanced use cases, let's look at using anti-gravity. And then that worked so well, they're like, well, actually, maybe we should use it for more things. Maybe we should use it for more. And sort of, I don't think if we had told people 4 months ago, we're going to take anti-gravity, we're going to put it in the heart of search, they would have said, like, what are you guys talking about? Like search and developer, like these things do not go. But you sort of do it, and you see how it unlocks the power to sort of create these experiences. They're very information at the heart, but transform them in a very personal and customizable way. And so I think we've only realized more and more how we can bring it in. That's been pretty exciting to see.
Just to open a little parenthesis there, like when we say anti-gravity, we mean multiple things. So anti-gravity, there's the user interface that we give to the developers, but there's the harness. Yeah. There's the SDK that we gave that in SDK as well. So the same capability that search is using, building on top of that SDK to build those agents into search, we are enabling all the developers and businesses to use that exact same SDK that is really co-developed with Gemini to build applications for anyone who wants to use them.
Love it.
Yeah, I mean, maybe I can tie together a few of these themes because I think collectively they are a really exciting sort of vision. So in the past, software has been kind of something that is created that has to be kind of standardized and then used in lots of settings where maybe it's not the perfect fit for this particular setting or the perfect fit for that setting, but because the creation cost was very high, you sort of settled on this kind of does the job and it's good. But I think now you're seeing with long-running agents that can go off and create bespoke software, you can actually get very customizable systems that do much more closer to what you actually want in any sort of environment, be it your own personal setting, be it in the middle of search, you get some nice visualizations that are created by the system, be it in tool creators for media generation. I think that's kind of a really cool aspect of what these long-running tasks will enable is you can just say, I would like this thing to exist. It will go off and hopefully autonomously make that thing come into existence, and then you can use it.
I love that. We have 2 minutes, so we're going to do a lightning round of fast questions. Jeff, and I think you're uniquely qualified to answer this, the most important developer skill in 2026?
Learn how to use coding tools and agents to be much more productive and build awesome things.
I love that. Liz, something you hope that search can take off people's plate sort of in the next few months, year, that sort of it doesn't do today?
I think for each person it's probably a little bit different, but it's sort of what is the part of sort of research and searching and gathering information that feels drudgery to you, and you feel like you can just get rid of that, give it off, and then you can spend your time exploring and learning about the things you want to learn about.
I love that. Josh, something surprising that Gemini Spark has done for you in the last month or so.
Ooh, it's very good at looking at your calendar and suggesting meetings you can cancel. And it will even. What's amazing about it too is it'll tell you why, and can even suggest a reply if you want to.
Otherwise, Logan, who cares? Cancel, not important. I love that. And Korai, maybe when do you think we'll get a Gemini Ultra model? No, I'm just kidding. Obviously, like huge amount of progress. What do you think? What do you think comes next?
What do I think comes next? I think from the developers, users perspective, a lot more agents, because I think now we are at the place where we are figuring out what is the right way that we can actually surface agents for people to use in many different places in their lives. This is all about giving user the control, making sure that we get it right. I think we're going to see a lot more of this happening. And I think from the technology perspective, again, I think we're going to see a lot more technology frontier being explored, not just solving today's problems, but also pushing the technology so that we are building intelligence, that we are building something that is learning and thinking and understanding how to be creative, how to push the boundary. So I think those two things will happen at the same time.
I'm excited. I/O 2027. We'll see. This was amazing. Thank you all for joining us this morning. Thanks for those who are tuning in on the live stream. We're going to take a short break, and then James Manika is actually going to be on the stage with our Google Quantum AI founder, Hartmut Nevin. Hopefully I said that right. Hartmut, join me in giving Josh, Korai, Liz, Jeff a round of applause. Thank you.
Good morning, and thank you for coming to this session this morning. My name is James Manika. I'm the president for Research Labs, Technology and Society at Google and Alphabet. And Google has an incredible track record and history of pursuing very ambitious problems and challenges and moonshots. Some could argue that, in fact, search itself is a moonshot, has been a moonshot. The work in AI arguably has been a moonshot. Some of the earliest examples of this at Google were back in 2001, when Google started to do things like autocorrection using machine learning. And then you could also think about the work on Waymo, driverless cars. It's been a moonshot that's now turned to reality as we start to ride Waymos. Hopefully, we've all done that. And then quantum is one of those too. We focused on trying to build the idea of quantum computers for quite a long time, and that's what we're going to spend time talking about this morning. I should say that the foundations on which we're building quantum computers go all the way back to the 1980s, when researchers at Berkeley, Michel Devereux, John Martinez, and John Clark started to work on this idea of how do you do superconductivity. Because up until that time, the understanding was that quantum phenomena was only observable at the micro level. And so the question is, could you ever make observations at the macro level? So they made these incredible experiments and breakthroughs that led to the idea of circuits you could actually build at the macroscopic scale, and that's been the foundation of how we think about building quantum computers. I should say those three individuals, Michel Devereux, John Martinez, and John Clark, were awarded the Nobel Prize in Physics last year. And I'm actually glad to say two of them, Michel Devereux and John Martinez, have actually been part of our quantum team at Google. Well, John Martinez is no longer with us at the quantum team, but Michel Devereux is actually our chief hardware scientist on the quantum computing team at Google. I'm going to be joined in this conversation by Hartmut Nevin. Hartmut is the leader and founder of our quantum AI team. Hartmut founded this team back in 2012 with the idea that, how can we build and achieve this moonshot of building quantum computers? So he and I are going to have a conversation. We work together, so this is also a pleasure for me to chat with Hartmut. And we'll talk about where we are, first of all, what quantum computing is, where we are, what progress are we making, and what are some of the challenges, opportunities, and things that we're excited about, and what can we look forward to. So Hartmut, thanks for joining me.
Oh, a pleasure. Thanks, everyone, for coming.
Well, let's start, quantum computing or quantum mechanics is one of these very complex topics. How would you describe quantum computing? Give us some basics. What are some of the basic things that one would have to understand about quantum computing?
So if you want to understand where the superpower of quantum computers comes from, the one concept we need to grasp is the concept of superposition. So let me give you a quick quantum computing 101 and explain you what superposition is. Essentially, quantum physics states that any system can simultaneously exist in many configurations. That's what is called a superposition. So to help you visualize it is the following. Let's look at the system we are forming here right now in the room. And we are sitting here in one specific configuration. But you can easily envision another one. Now, like the two of you could switch seats, you, James, and I, we could switch seats, so there are other configurations. But a reading of quantum physics would suggest that all these, or many of these constellations, configurations, are realized right now, and they evolve together in time. And that is what we take advantage of in our chips.
But I think one of the things that often, so how would you describe, because we go from, we can try to build physical qubits, and then logical qubits. Explain the idea of qubits, and how should we think about that, what that is?
So a qubit is short for quantum bit, and it's essentially a bit, or qubits are a number of bits that I can put into superposition. So I will later show you, or maybe we do this right now, I show you a chip that contains qubits. I'm not sure the camera can see this. So this is a Willow chip, one of our more recent chips, and it has 105 qubits in there. And now that you know what a superposition is, you can envision the following. Those qubits can be in a superposition state. So a single configuration for 105 qubits is just a string of zeros and ones. We call it a bit string of length 105. But similar, as we envisioned before, you can just flip a few qubits and you get a different bit string. You flip a few more, you get a different bit string. How many bit strings can there be? Now, if there are 105 quantum bits in this chip, it's 2 to the power of 105. And then, as amazing as this may sound, in just one clock cycle of this chip, we can touch 2 to the 105 different objects, 2 to the 105 different strings. That is an enormous number. And therefore, you arrive at these situations where this tiny chip can do certain computations that the largest factory-sized data center would need an inordinate amount of time, 10 septillion years in a recent demonstration.
In my opening, thank you. In my opening remarks, I mentioned the idea that we're building on breakthroughs that our colleagues Michel Devre and others made in the 1980s. And one of the key things that they worked on was this idea of superconductivity, as a way with the ideas of how do you do kind of, if you like, quantum tunneling with Josephson circuits to be able to do superconductivity. That often requires that we actually cool these things down to a few degrees above Kelvin. And so in the lab, describe the fact that you're actually building these extraordinary fridges so you can cool things down to a few degrees above 0 Kelvin. Why are we building it that way? How does that work?
So the different ways how you can make qubits. In quantum mechanics, famously, you might think of quantum mechanics as a physics of the very small, the thing that describes electrons, atoms. But it's actually incorrect. Quantum physics is the law of the land at all scales. It's microscopic all the way to the universe as a whole. It just happens to be the case that quantum effects can easier be controlled, managed, and observed on microscopic scales. So a natural choice to build a qubit, therefore, would be to just use an atom, to use, let's say, the states of a spin, of an electron, or of a nucleus. But these things are tiny and hard to engineer with. So the ingenious inventions that got the Nobel Prize, as you explained, was to essentially make macroscopic qubits. So using a loop of superconducting wires, you can have the same property of quantized energy levels and other hallmark features of atoms. You can have this at a macroscopic scale, much easier to put into a chip and work with.
Yeah, and in fact, one of the things that you always like to say, Harman, is that your lab is probably the coldest place in our galaxy. Can you explain that?
Yeah, so to work with these artificial atoms made out of superconducting material. Many of you may know that right now, to get superconductivity, a macroscopic quantum effect, you have to cool down the metals or the materials to a very low degree. So we work currently with aluminum qubits. You could have used niobium, tantalum, there's some choices, but all of them have to go down to about 1 Kelvin, so that's pretty cool. But we don't stop there, we go even further down to just 10 millikelvin, because temperature is really the physicist's term for noise, and we don't want to have noise in our chips, so the colder we can make it, the better.
Right. So talk a little bit about what's difficult about building quantum computers. What are some of the key challenges you have to solve if you're trying to build these systems?
So in the very beginning, I explained to you that sort of the key ingredients, the key resource is superposition states, and we need to keep these superpositions of different constellations alive. And the times that measure, there's an important time, we call it the coherence time of a quantum computer. It essentially measures how long these superpositions survive. And you want to make this the longer, the better. And initially, we all thought, oh, this is a key battle to fight, the key engineering challenge to get right. But it turned out, in this area, we made rapid progress. We went from 20 microsecond coherence time to 10 times more, now over 250 microsecond, pretty much enough for what we need for useful quantum computing. So it's not the key physics challenge anymore, it's more mundane system-level issues that hold us back.
So why would anybody want to build a quantum computer? What are some of the useful applications, assuming we get there? We'll talk a little bit in a little while about where we are, but why would you want a quantum computer?
Yeah, so on the application side, there are various areas. One thing that's important for the audience to understand, quantum computers, as far as we know, will always be sort of a specialist tool. It will be very good for certain applications, not so useful for others. So what are some of the useful applications we can think of? The first one is, we call it Richard Feynman's killer app. Feynman was the first one to realize that if you want to simulate a system where quantum effects are important, you run against this combinatorial challenge that you have to consider all these different constellations, and that's just impossibly hard for classical computers to do. So he coined this out in the initial video that if you want to make a faithful simulation of nature, you better make it quantum mechanical.
But I think often when people think about quantum computers, we often think about the speed-up benefits, that it will be able to run things much faster. But also there's some problems that are inherently quantum that you can only work on. So can you make a distinction between where are we mostly capitalizing just on speed-ups versus when we're actually working on things that can only be worked on with quantum computers?
Yeah, let's say a few examples. So I just gave you this general overview, Richard Feynman's killer app, the simulation of quantum systems. So that is actually a task that is necessary more often than you might think. Let's pick a nice one. Batteries. Sounds a little bit boring, but we would all feel so much better if we could fly in an airplane that is powered by batteries, not by kerosene, when we do vacation. So now there are things like lithium-air batteries, which, if you could, they have a higher energy density than kerosene. So you could perfectly do that. Unfortunately, they're very brittle. They have various material science issues, so that's why we don't use them today. But a quantum computer would be a marvelous tool to simulate various designs for lithium-air batteries, and then we can have them not just in cars, but in airplanes too.
Right. Yeah, since you're commenting, maybe you can correct me. I think there's currently something like 70 plus kind of algorithms and problems that people in the community have actually identified as things where a quantum computer would be the most useful way to tackle those. Right? Is it still 70, or is that list kind of growing?
Yeah, thank you for mentioning this number. I should have checked up on the website, because when we started talking, it was like 60, now it's 70, and I hope that in a few years there will be 700 important, sometimes more, important algorithms where quantum computers give you a decisive advantage.
Right. So Simon, let's talk about where we are at this stage. I remember when you and I first started working together, I guess 5 years ago, you had a roadmap which had kind of 6 milestones. First of all, can you describe the roadmap you've had for progress towards building a quantum computer, and where are we on that roadmap? What progress are we making?
So originally, and if anybody has watched the work of the Google Quantum AI team, you may have seen we typically show it first thing whenever we give a talk or presentation, is our mission is to build a useful quantum computer for otherwise unsolvable problems. To get to that, we had set out a roadmap with 6 milestones to build such a machine. And the first 2 milestones we cleared a few years ago. So our very first one was in 2019, where we showed for the first time that a quantum computer could compute something quickly in minutes that would have taken many, many years on a classical supercomputer to do. So that was milestone 1. And milestone 2 was there is a technique called quantum error correction. That is essentially the technology you need to keep those superposition states alive. And that was understood in theory well since the 90s. But then in 22, for the first time, we reduced this to practice and built a machine where quantum error correction successfully reduced the errors in a machine in practice. And we are now ahead of, hopefully, fingers crossed, we solve it later this year as milestone 3. This would be one very good module out of which you can build a large modular quantum computer.
And so, but by the time we get to hopefully milestone 5 or 6, hopefully we'll have useful applications. But let's talk a little bit about some of the recent breakthroughs. I mean, you showed the Willow chip. This is a chip we showed the world back in 2024. And I think there are two key breakthroughs associated with that. One is the fact that it was able to do in a few minutes what would take the world's fastest supercomputer 10 septillion years. That's one with 25 zeros next, which is extraordinary. But the other one, in some ways, more important demonstration was this idea of below threshold error correction. Can you explain what that is and why that matters so much?
Yeah. So quantum error correction is the technology you need to keep the important superposition states alive. And for the very first time, as I said, we cleared that hurdle in 22. But the community wasn't too impressed because the errors just came down by a few percent, and people said, well, even though before, so how do you do error correction? You use redundancy. Now that's what we use in engineering to make things safer. So you take a number of physical qubits, as we call them, to orchestrate them into one more stable logical qubit. That is what error correction does. And then, when people tried it, they introduced more redundancy, but there was more stuff now, more qubits, more wires, more measurement devices. So the error always came down. So in 22, for the first time, the opposite. The error went up. And then in 22, we made it come down for the first time, but an unimpressive few percent. And then with Willow, we just redid this. And in 24, we basically did the same experiment again, but now it was already much higher quality chip, and the error came down by a factor of 2. And then the field for the first time was, oh, this seems to really work for good.
Right. So that was an important breakthrough. And then last year, we had another big breakthrough, but maybe to set up that breakthrough. All these typical benchmarks we've been using, such as the 10 septillion years and so forth, we're talking about using a particular benchmark mechanism called random circuit sampling as a way to kind of measure. But it's not a very useful computation, but it's useful to measure progress. But the breakthrough last year with quantum echoes was actually the first time anybody, I think, had shown a useful algorithm. Can you talk about quantum echoes and why that breakthrough was important?
Yes. So you said it nicely. So the initial demonstrations that quantum chips can do something impressive was done on exotic mathematical benchmarks where essentially problems that you or people in the real world don't have. Good for benchmarking. Right. And then the criticism was, okay, show us something that I would care for. And quantum echoes was the answer to this. It was the first quantum algorithm that can do a useful task.
Talk about the task, because we had a demonstration where we worked with researchers at Berkeley and others to actually show a useful use of quantum echoes. Can you describe that work?
Yeah, so quantum echoes is essentially the quintessential quantum machine learning algorithm. It allows you to learn from readily available data. It's data that comes from nuclear magnetic resonance imaging, so on NMR machines that pharmaceutical companies use, or if you go to a hospital and do an MRI scan, that's also nuclear magnetic resonance imaging. So to get out of these devices more information, that's where the quantum echoes algorithm applies.
Yeah, and I think in that example, what you were able to observe was to show that you were for the first time able to measure these kind of dihedral angles of these very hard to understand molecules. I think was it a couple benzene molecules?
Yeah, we then. And typically, when you have such a new algorithm, there are a few steps to really lodge it in practice. So initially, we showed it on some proof of principle problems, and then you go closer to what chemists care for. So it's called a diphenyl. It has 2 benzene rings, and chemists didn't know how are these 2 rings rotated relative to each other. So we computed this angle using quantum echoes and showed, look, you can answer real open questions in chemistry with that algorithm.
One of the things, so the quantum team at Google is actually called Quantum AI. And we should talk about that. Why that name? And there's always a question about, so which, do these two things need each other? Does quantum computing need AI, and does AI need quantum computing? Can you explain the origin of the name Quantum AI for the team? And then I'd love to maybe debate you a little bit on this question of AI and quantum. Why that name?
So why is our team called Quantum AI? And that was, I worked in AI for most of my career. I actually did self-driving cars. My PhD was on self-driving cars. I joined Google doing computer vision, visual search. But at the time, it dawned on me that a real powerful future AI wants to have access to the most potent, capable computational substrate we can think of, and currently that is quantum computing. So I thought quantum AI should be able to do tasks that AI running on classical machines will never be able to do. And then in 2012, we set out, based on the thesis, to show that this is really true.
And I think one of the contributions that quantum computing can make to AI is in particular data sets.
Yeah, so maybe we should advertise this, James. So this, for those of you who want to know more details, there will be a special issue of Daedalus coming out. You're the editor. Right. And there we put an essay that is called Quantum plus AI equals Quantum AI, and it speaks about this bidirectional acceleration. How do we use AI today to accelerate progress in quantum computing, and how, starting now and even more so in the future, quantum resources will help AI solve novel tasks.
Yeah, and I think one of those examples which was incredible was to see was how there's a deep collaboration between the DeepMind team and the quantum team around this idea of alpha qubits as a way to think about how to use AI and machine learning techniques to actually help the progress we've been making on error correction. It was one example where AI was actually benefiting quantum. Have there been other examples like that?
Yeah, let me give you also your previous question. I hadn't properly answered yet. So how can quantum help AI? There are probably a dozen different ways. Let me give you 1 or 2 examples. Right. So AlphaFold, a resounding success. Used in labs all over the world. To train AlphaFold, we needed data sets that started to be collected in the 1970s. It took 50 years to make things like a protein database to train AlphaFold. Very painstaking work by many PhDs, lots of government grants. So a quantum computer would be able to produce very valuable training sets in many settings where it's difficult to make those training sets otherwise. So we expect this to be the very first contribution of quantum to AI, that we say, look, here's a great data set that you should use. And actually, as a late-breaking piece of news, just last week, we had first data sets relevant to material science, where we thought, oh, wow, they have the quality. Good enough, we should ship them to our colleagues at DeepMind.
That's fantastic. One of the things that I find pretty exciting about, even though, of course, we're on this moonshot journey to build a fully error-corrected quantum computer, there's a lot of great science and discovery that's actually happening along the way. Can you give a couple of examples? I mean, my favorite one was the holographic effect, which goes back to something a conjecture that Einstein had. But talk a little bit about some of the examples of the incredible science you and the team are able to do along the way.
Yeah. So now that we have chips with a few hundred qubits, we can make good on Richard Feynman's dream and simulate quantum systems and study their properties and learn new things. Right. And you mentioned already a few. There are one very exotic one, which was created quite the firestorm in the scientific community, was it would be hard to explain fully the science behind it. You might have heard of the effect of quantum entanglement, that two quantum particles can be correlated at long distances. You may also have heard about wormholes, which is a connection through space or between two distant space points. And there is a field in physics that's called holographic duality that claims that these two processes are the same. So if that's really true, then we can use entangled qubits, which we can produce on our chip, to make wormholes. And we essentially created a wormhole. And I use the word created, not simulated, because strictly speaking, if the string theorists are right and this duality exists, then it was actually a tiny, don't worry, it wouldn't have fallen in, but a tiny wormhole was actually created.
Yeah, I mean, this gets very exotic pretty quickly. I mean, you've also been doing experiments on quantum gravity as well, and you've also been doing, even understanding deeper questions about electromagnetism that we didn't fully understand before. So there's a lot of incredible science going on along the way.
Yeah, so one thing we're proud of is that our team produces this dense string of high-impact publications that discusses exactly that, discoveries made through this process, a quantum simulation of interesting systems. Right. Now, others, just the names, we won't explain, but time crystals, we made time crystals. That's the closest you get to, the physics lets you get to perpetual mobile. It's essentially a system that stays in periodic motion forever without needing to exchange any energy with the environment. Or another exotic thing was nonabelian onions. I know that's a mouthful, what is that? But it's something also goes seemingly against common sense. It's essentially a situation, imagine you build a little house out of Lego blocks, and there are, let's say, two bricks that look the same, and you switch them out, you look again at your house, because they were the same, nothing should have changed. But in quantum physics, there was a prediction that this may be different, that even though you swap two identical particles, the overall system changes properties, and that we showed in practice that really, yes, that exists.
You know, often when people think a lot about quantum computing, I mean, you and I can talk about all these extraordinary applications in biology, in chemistry, in materials and so forth, but I think the one application or use that most people think about is encryption. Ever since, for example, Shor's algorithm, the idea that most of our cryptographic encryption systems rely on the fact that these are incredibly hard problems for classical computers to solve. And so therefore we rely on the difficulty of those computations as a way to think about our encryption systems. But if you had a quantum computer, you probably could crack those systems. And so recently, you made, and the team made some news recently to suggest that in fact the ability to build systems that can crack RSA encryption and also elliptic curve cryptography systems is not that far away. Can you talk a little bit about what the news was and what the progress has been on building those kinds of systems?
Yeah, so fortunately, many of the natural applications for quantum computers are these very humankind-friendly things, like design drugs quicker, better batteries, fusion reactors, and many important humankind challenges. But one of the more problematic applications of quantum computing is it can be very powerful for cryptanalysis. Right. And indeed, in quantum computing, it's not just that the hardware has made progress, it's also the algorithms have made progress. So we were able to show that you need less and less resources to do simulations, but also cryptanalysis. And therefore, indeed, the timelines are moving inward. It's not that you can wait till late 2030s before you have to worry about it. Actually, Google put a blog post out saying, hey, we need to move to more powerful post-quantum crypto schemes already by 2029.
Yeah, and maybe to put this in concrete terms, I think back in 2019, I think the view in the field was that if you wanted a quantum system that was capable of cracking RSA 256 encryption, you'd need at least a 20 million qubit system. And then we showed about a year ago that that threshold had actually come down because of the progress to where you'd need perhaps about 1 million qubits. And then 2 months ago, we showed that in particular with the elliptic curve cryptography systems, which are mostly used for cryptocurrencies and other things, the threshold had come down even sooner, come down even further, which suggests that the day in which we have to move to post-quantum cryptography system is not that far away. It's not that far away. I mean, talk about how you think about our responsibilities when it comes to making sure the world is ready for the arrival of quantum computer systems.
Yeah, you're exactly right. So last year, we have a very gifted quantum algorithm designer on our team. His name is Greg Gidney. And last year, he showed, you can do cryptanalysis on RSA 2048 with just 1 million physical qubits. And then he went on to show ECC 256, which is important for digital signatures. You need only a few 100,000 physical qubits. By the way, earlier when we described the roadmap, I should have added this. I said our roadmap had 6 milestones. And number 6 was essentially build a physical chip or a set of physical chips with 1 million physical qubits. But because of these advances in algorithms, we now think that a commercially relevant machine would only need about 100,000 physical qubits. So our meme there is milestone 5 is the new milestone 6. That's when we really would see commercial impact.
So Hartman, as you look ahead, what are you most excited about, and what are you most kind of concerned about with quantum computing?
What I'm most excited about is that right now, for many algorithms, quantum algorithms, to argue that they are useful in real life, you have to prove it by pencil and paper because you can't run the algorithm yet. At the end of the decade, we won't have to do this anymore. There's a cool quantum machine learning algorithm, and rather than painstakingly trying to prove it, and we can't prove these things typically for classical neural networks either, but then you would just demonstrate by running it. So that will be a so much more fun period when empirically, heuristically, you can test out and develop new algorithms.
But I do know you're excited about a few other things too. Maybe I can throw you out on this. I mean, you've been thinking about the intersection of quantum computing and creativity, for example. Can you talk about some of the experiments you've been running?
Yeah, we recently did some very fun experiments. Many of you may know that a key tool to generate nice images, audio, video, is with diffusion neural networks. They essentially take a noise tensor and then have been trained to sculpt a nice image out of this noise. And we had the idea, one of the things we can do today is we can represent noise distribution or probability distribution, I should say, on our chips that are outside of the reach of classical computers. So we asked, hey, if we use our chip to make the noise tensor, will this make a more vibrant, better looking image? And we produce those images. And actually, you're going to see them. We try to find ways to release this tool so you can play with it and judge for yourself whether this hypothesis is correct.
But you actually showed some of this at some exhibitions in Europe recently, I think, right?
Yeah, we had collaborations with known artists. So the earliest was with Fik Anadol, where in 2020 we did the same process. We used output from a quantum processor, a quantum noise tensor, to this artwork was called Quantum Memories, and was actually that successful. It was seen by 1.3 million viewers, but not clicking on YouTube. Physical, came into the museum, so very successful. There were 2 other shows in Berlin, and one I was a bit proud of. There was like a show that drew a crowd that long. There was a 1 or 2 mile long line in Berlin in the middle of the winter to get into the Kraftwerk exhibition to see this quantum art show. So that was very nice to see.
So Harman, as we wrap up, I know we're at the end of our time. If we're having this conversation a couple of years from now, what kinds of things would you hope we'll have achieved, and what new results would you be able to show?
Yeah, I hope to show, and because our team is very motivated by this, to demonstrate that this basic thesis is correct, is that quantum AI is a more powerful form of AI.
Yeah, well, actually, maybe I can sneak in one other question. I think, at the very beginning of this conversation, we very much obviously focused on the fact that you've been pursuing superconductivity and superconducting qubits as a way to build quantum computers. But that is clearly not the only way to build quantum computers. There are other mechanisms. People talk about neutral atoms, talk about, if you like topological qubits and a whole range of possibilities. You recently started a new team focused on neutral atoms. Can you describe that as a different alternative way to build these systems?
Yes, so there are 5, 6, 7 ways that are being explored to represent quantum bits, qubits. And I earlier explained to you how superconducting is a very good strategy to do this because you have these macroscopic atoms easy to deal with. Now, it turns out that people who work with the natural atoms, they also made nice progress to the point where we thought, maybe they might get to certain applications earlier than the superconducting path. So we added a second thread, and so we have now an emerging lab in Boulder, Colorado, where we pursue a second thread called neutral atom approach to quantum computing, and we will see how this goes. And of course, both threads can benefit tremendously from the common expertise we have in algorithms, error correction, control electronics, others.
And they both have very different properties. That's why they're very complementary, I think. Right?
Yeah, they have both their pluses and minuses. Superconducting will always be much quicker. Neutral atom systems have maybe an easier way to be connected to sensors. That's something we haven't talked about. In quantum enhanced sensing, it literally gives humanity new eyes to see features of the universe we so far were blind to.
I think we're being told we should wrap this up. But thank you for the conversation. I hope this was useful and informative to everybody. But good to see you, Harman, as always.
Yeah, that was a fun conversation. Thank you, Dan.
Hey folks, taking a break now since I have been at it for approximately 6 hours since the morning. My brain is completely fried. I think so I will have to get some coffee to start over. But before that, let's open up the EA Sports FC26 and look at the rewards that we have from squad battles today. Remember, I finished in Elite 2 due to I losing one game, which I shouldn't have lost, since it is all custom difficulties that you choose, and to achieve a certain set of points, you need to win every game with a huge goal difference. So, and the other game, there was some power issues and internet disconnections. And due to that, the number of points that were awarded to me in that game was nil. So that's why I finished in Elite 2. As I have alluded earlier, in the dark web, there are many hackers that are using the publicly available win hacks and tactical breakdowns where they nerf the opponent's certain attribute like strength or your ball control, so your touch goes wild or your player isn't able to hold the ball, and the tactics as well. So since I have raised a FIR with those attributes, so I need to be careful with that. That's why I'm streaming everything, every game I play, with recording of everything secured, so that I can directly contact EA in the case of any mishappenings. Also, there have been cases in which the overall attribute or in the prime heroes or those posters that come out that we see on the main sub window, they have been altered to fool me. Or like, so I think so this goes a couple of level deeper into the EA FC26 app. I don't know, many people must have taken some coins or something like that, or players that weren't visible for some time or something like that. Like, you hide certain web links or web pages that you do not want others to see. you completely wipe it off the social media or something. So that kind of hacks and complete breakdowns are common in the corporate world, in which you want to hide in information or deter someone from making a good decision. I don't think so. I will be able to play a game right now. He is from 5-star weak foot, 4-star skill moves. Eredivisie, Netherlands, PSV, CDM Cam and CM, Weerman, Patterson, the styles are finesse, play styles plus are finesse, intercept and technical. Finesse shot plus, intercept plus, and technical plus. Yeah, so he can be a good box-to-box midfielder. Uh, the road to finals for PSG will land on, I think so, Wednesday or Thursday or Tuesday. I don't know what will be the date, but there will be some SBCs that will also come out. Showdown Berbatov. Robert Lewandowski is on. I need to do this. Just for FC Barcelona. 87, 87, 88. This 83. I don't think so. I have a POTS player in my squad other than that left back. Manchester City left back. 87 rated with a weak foot. Upgrade. This is Crystal Palace. Box. What we got? Worklog 13. Arnold. Oh, she's here too. Battery. Watkins. Germany. Open the Ultimate TOTS player pack. USA. And the USA. Partisan, okay. I think so. These are the top 3 that are being offered to everyone. 88 or 89 rated. 88 rated. His price must have dropped. Ah, it's again up. People are not finding Hazard as good as he. He has a controlled, I think so. The body type is styles. Explosive. Acceleration type is explosive. Bruno is going for 2.2. Mbappe is costly because of the 183. Yeah, he's going for 289, 299. So let's look at the Evos that have come in. They're making the case, Dash and Dazzle. This is technical quick step and first touch improvements. Goalkeeper. History in 10. That is why Mbappe is selling like anything. Grounded and that and centers. Baldi's strike. This is for a left wing player. I think so. Baldi's strike. I think so. I can use Pina or data DOTS max 89. Smooth operator maximum 89. Couple of players that come to mind: Vinicius Junior, this guy here, Rafael Leo, and Pina. Base versions of those cards. So you only get plus rapid. Sorry, plus skill moves. Did you see the glitch? The couple of menu items back? So that's the kind of glitch is that I was talking about. That can be done by the people who hack into your machine. And since this is a completely open one, so anybody can come in and do their things, but there are few safeguards that I have removed so that it is easier for everyone to come in on, and that's why I've been raising a FIR and 3 grievances over the past three years for this to stop, but now let's go back to the SBCs to see if yeah, here there was this issue with this. My AFIR isn't being reflected here on this. Routing special pairs generated based on the price. Yeah, this looks good. This looks good again. Yeah, this looks good too. Rare gold player items. Other than gold, I won't be getting anything, so not doing that. Prime Heroes challenge. Let's do this. Yeah, it was rating 89. And I need to replace a couple of players with 89. I don't know if I have them. Yeah, slot player. Submit. So I don't have 90 rated or 89 rated players in my squad. That's why. These three are being utilized right now. pixel duplicates. Done. No. And remove or add word player. Words will do. And remove to show. $89.2. 89.02. Swap this player with $89.79. We'll have to swap this player with gold, Pedri, 89.91, and one more. This should be replaced with 88 rated player. Or black will do. Yeah. Let's do 89 rated squad. Three players are being used right now. No, Bruno. Replace. Exchange players. Oh, back. Damn it. Exchange means submit. I didn't take that into account. Let's add from our transfer list. That's my transfer list. Send to club. 34 sent to club. I have 2 Lorenas and 2 lead Tessiers available right now. This is quick sell, and these can be used later. Quick open, store one club, send to transfer list. Yeah, he is also 2 stiff. The meta rating 93.3. Yeah, I can replace him. I can keep him in the squad. Arena. $90.27 and swap with a bold player, I think. That won't work. Let's try for the other 90 rated fodders that I have in my squad. Yeah, I can sell him. What's the 89.96? Yeah, that's right. Submit. Then trying the other 90. Yeah, Cucurella is not up to the mark too. At left back. Then replace this guy with a 90 rated player. Oh, 95. That is my 95. Data cell. I can sell him too. I think so. Oh, I won't be able to do it. He is. Let's swap this player for a 90 rated one. Or a 91 rated 22. Yeah, Timber can go. 89.96. Yeah. Next. Let's open a couple of packs. I didn't get anyone good. Excel, and to transfer list. Got to buy a couple of rotary. Transfer. Sorry to transfer. I think so. Yesterday he was around 7, 10. Currently, because of those SBCs, he's 8,500. And that too is not attainable right now. What about Kotwa? $8,000, 7,900. Let's buy one this and how much is Van Dyke? $8,600. Open the back. Store on top. Excel, duplicates. SBC, Sala. Transfers, transfer list, send to club. One Lorena latency remaining. Let's complete those SPCs which require TOTW or TW. Take this plans first. Like 89 rated players. Autocomplete and rate. Some exception context invalidated. Yeah, this has happened before. Lorena, remove this guy and D1 rated CM Saga. Idiot 198. What about him? Ansuba. Yeah, he can be. Complete. Not him, not him. Not him, never him. Latest here. And he can be replaced with not him too. Yeah, Saka can be gone. Not him. West Hall, he is good for. He has been good for me. He has been a good player for me. Other 90 rated players. Yeah, I can send Garner here. 89.45. Okay. Another 91 rated. Or Scala 89.03. Eighty-nine point 36, 85 rated. Thing is, I do not have 88 or 89 rated players in my squad, so this is a bit expensive right now. Completed 10 SVCs, so I should call it a day right now, because Salah has I've completed 27 of 36. Still got 9 to go. The number of days that are left is 12 days. So yeah, that should be doable.
mam ciebie tylko.
Mira, si tengo que quedar en mi... 6 jugadores nos presionan, no creáis que son 16. 6 jugadores solo. 6. Y no somos capaces de llevar el balón a estos. Mira, si tengo que quedar eliminado de la Champions, quedo eliminado de la Champions. No pasa nada. Me parece jugar al fútbol. Jugamos al fútbol. Sí. Corrección. Centrales abiertos. Laterales abiertos. Los dos interiores. Más cerca, Juan, más cerca. Y cada vez que tenemos el balón, jugamos. Juegas todos los balones para atrás. No juguemos. Hay que perder. Perdemos, chavales, perdemos. Llegamos a la Real. ¿Qué pasa? No pasa nada. Pero intento jugar. Si veo 6 tíos, somos 8. 8 contra 6. 6 jugadores.
Terrible footage. Anyways, time to end the stream. I think I should call it a day because I have to be at an event from 4:30. And that's a Agentic AI premier event. Let me try to search those socials for you if you guys are interested. Yeah, I have stopped subscribing to LinkedIn Prime for enterprise since I did. And they still haven't stopped the subscription. Like from my end, I have stopped the payment and cancelled the subscription, but from their end, there are some issues, and that's why I'm still in the premium part of LinkedIn. But anyways, this is the event that is happening today. So we from the Google Developers Lucknow community have had Agentic Premier League finals in which we are the students and the participants are pitching, building, and battling for the trophy. And so this is in with concern to the kind of a plan for solving issues and working on projects that are local to my city, that's Lucknow, and the community there, the G3G Lucknow community. So this was an interesting plan as to use agents to do some work and build, innovate, and these are some of the event highlights that we have up until now, like watching IPL and building. So like this is from New Delhi, but this is a similar kind of event that we think we should be having in Lucknow today. So that's what we are creating and building on. I am one of the mentors here, as you can see here. Yeah. With that, I think so I will end, and we will continue with the playlist of the Google I/O 2026 sessions, and will give my views on top of what we have had, and talk about the agentic AI premiere experience tomorrow. Until then, ciao. Have a nice day. Be good, and we'll catch you later.